Welcome to what I promise will be the most comprehensive, most practical, and most life-changing program on algorithmic trading ever created on the internet. I say this with 100% confidence because what you are about to learn is not just another collection of tutorials. This is a master framework, a structured system spanning over 23 plus hours of carefully designed and highly valuable content. And let me make this clear, this isn't theory you will never use. Every single concept, every strategy, every line of code in this program has been battle tested, optimized, and perfected over years of experience. I have poured in everything I've learned over the past 9 years working with algorithmic strategies, quant research, and financial technology. This is the condensed wisdom of nearly a decade delivered to you in one place. Do you know that 80% of global market trades are executed by algorithms? Hedge funds, prop trading firms, and institutional players all rely on algorithms. If you are not leveraging algorithmic strategies, you are playing a completely different game and you're losing. This course is your chance to step in the same playing field as the world's smartest traders. Before we dive in, remember what Elon Musk says. Have a bull's eye view before you start anything. You need to see the big picture first. So here's your roadmap to succeed in this program. The exact blueprint that will transform your learning curve. This roadmap has 3 phases, which I have followed in multiple times. Whenever I need to learn a new skill, I follow exactly this blueprint, and it has really proven very effective for me. So I would recommend you to please follow this system and you will see huge difference. Phase 1. Watch the entire video first. All 23 plus hours. It might take 3 or 4 days or even a week. But don't write a single line of code in this phase. Don't. Your only job is to understand the flow, the big picture. This is where you build your mental blueprint. Phase 2. Reinforce your learning with the multiple choice questions. You will find the link in description for all the multiple choice questions. So in this phase, watch the entire video again, this time paired with highly researched, expertly crafted multiple choice questions. These aren't basic questions. They are designed to test your conceptual clarity and simulate real-world problem-solving scenarios. By the time you finish this phase, your understanding will be unshakable. Last but not the least, phase 3. Build real systems with mini projects. And this is the game changer, mini projects. These projects are not just random exercises. They are industry-grade problems, carefully chosen to mirror real trading challenges. By completing these, you will gain hands-on experience and you will be building systems that are almost ready for the live markets. And here's the bonus that makes your learning experience unstoppable. My book, Practical Python for Effective Algorithmic Trading. This book is the distilled essence of 9 years of experience, covering everything from the absolute basics of Python to advanced data handling, API integration, and live execution. It's not just a book, it's your reference guide, your quick lookup, your lifelong companion as you grow in this field. And combined with the videos and the projects, it creates the perfect triangle: theory, practice, and reference. You have both the options. If you want the ebook, the link is in description, or if you want the hard copy, then you can order from the Amazon. Now let me tell you something critical. 95% of beginners in algorithmic trading quit within 3 months. Not because they are not smart, because they lack structure, discipline, and the right roadmap. This program gives you all three. You have 23 plus hours of pure value, 500 plus MCQ questions, and 50 plus mini projects, and one powerful book, all in your hands. But here's the truth. This knowledge is only valuable if you act on it. Imagine yourself 6 months from now, building your own trading bots, automating strategies, analyzing market data like a pro, and executing trades in milliseconds, while others are still placing manual orders. That future starts with this single decision to commit. You can absolutely do this. whether you are a beginner or an experienced trader. This course is built to take you from zero to mastery. But mastery demands one thing: hard work. There will be moments when you feel stuck, push through. That's the difference between those who succeed and those who quit. And remember this: knowledge is leverage. One good strategy can change everything. So, here's my advice: commit fully and follow the roadmap. Watch the entire course once, reinforce with multiple choice questions, build the mini projects, and use the book for your lifelong reference. If you do that, this program will give you an edge that 90% of traders only dream of. This is the best investment of your time and energy you will ever make in your trading career. Are you ready to take control, master algorithmic trading, and step into the future of financial markets? Then let's dive in this awesome algorithmic trading journey. Okay, so what is the definition of Python? So Python is a high-level interpreted programming language known for its clear syntax. What is the meaning of interpreted? Basically, there are two concepts. One is compiler and second is interpreter. So compiler generally compiles the whole program in one go and it executes this. And in interpreter, what it does, it executes the program line by line. So we can say Python is an interpreted programming language. And also it's known for its clear syntax. The code is very beautiful and it supports multiple programming paradigms. Means you can code in procedural, object oriented and functional programming. So we will be learning object oriented programming shortly after a few videos. And also with the help of Python we can do multiple things, like it can be used for web development, it can be used for data analysis, and also you know that we can use this in artificial intelligence, scientific computing and much more. So one question arises: why Python? Because of its design philosophy. As I have already explained, the syntax of Python is very clear and because of its readability, correct? And second is batteries included, means it has so many functions which makes our life so easy. For example, to reverse a string, it has a single function. But in other languages like C, C++, Java, we have to write a longer code, right? So that's why there are so many functions which you can use straight away and it reduces your lines of code. And third is general purpose programming language. As I already explained, we can use it for web development, artificial intelligence, data analysis, and so many things. And almost anything and everything we can use Python. And the fourth is libraries and community, because it has so many libraries, so you can straight away use those pre-coded libraries and you can make your any application way faster than any other language. And also it has a huge community, so whenever you are stuck in any condition you can always ask for help, and also you can contribute from your side also. So why Python for algo trading? The first is easy to learn. Python is very easy and anyone can learn in just 1 or 2 weeks and they can start coding. And second is proximity with maths, because it has so many pre-built modules and libraries which you can directly use whenever you want to perform any mathematical operations. So it makes your life so easier. And also the community is very huge and there are so many people who are always eager to help you. So that's the basic reason behind that. So let's quickly move to the Python print function. So whenever you find this curly braces, you can assume that it's a function. And what the print function does in Python, that it is used to output data to the standard output devices, which we can say screen. And it can be used to print strings, you can print numbers, and you can print any other printable objects. So this function is often used for displaying information or debugging. So let me show you quickly. So what happens? So how it works? You just have to call the print function. Okay, and type like this, and here you can type like hello world, which is very basic in every language, and when you enter shift enter it will be printed out. So here we have printed a string, but if you want you can print any other printable objects, like if you want to print a string and then you want to print a number. So number, we let's say 100 days, so let's say 100. And if you want to print a list you can do that also, 1 2 3. And also if you want you can print a float which is 1.2, and like you can print anything here. Okay, you can also print a dictionary like key value, so we can say this is key and this is value. Okay, So when you hit shift enter, you can see that how powerful the print function. It has printed a string, a number, a list, a float, and a dictionary. And now if you observe that we have a space between each object, right? If you check here, this is a string and this is a number and we have a space. So why this space is coming? So in print function, when you go here and just wait for a second, then you will see the documentation of this print function. And here you can see that there is a parameter which is /n, and /n stands for the next line. If you have done the HTML coding, then you know that. So when I type here /n, and when I hit shift enter, it show me the same value. But what if I don't want the space between these and I want a hyphen? Okay, so you can just type a hyphen, and when you hit shift enter again, you have to type here SEP. Okay, and then you hit shift enter and you can see the results. Now if you observe here that there is a space between these objects. So what if I want a hyphen instead of this space? What can I do? If you go here and just wait for a second, then you will see. Okay, so here you can see that this print function has so many default parameters. Like for example, there is one parameter which is separator, and when you see there is a default space between these double inverted comma, right? And another is and, so there is default parameter and there is default value, that is /n. Okay, so if we change these values, we will be getting our desired output. So here we wanted a hyphen instead of these spaces, right? So what we can do, I'll just go here and I'll type SEP and enter. Then I will just remove the space and enter a hyphen. So now when I hit shift enter, I can see that there is a hyphen instead of space, correct? Similarly, as I displayed you that there is another parameter, that is and. So what you can do, and similarly, like when we have multiple print functions, for example, hello world, this is Kuldeep, and okay, this is Kuldeep, and we are the unstoppable. Okay, when you hit shift enter, you can see that all these print output are on the different line. And when you go here and you just hover on it, you can see that there is the and parameter and the default value is /n. /n stands for the next line. If you have done the coding in HTML, then you know that, right? So if I change this value, I can get my desired results. So what I can do, I can just go here and type and here I'll give a value hyphen. So instead of next line now, and here also I can give and hyphen. So instead of next line, now all these three results will be displayed in a single line separated by a hyphen. And so here you can see the value, right? So this is about the print function. You will be using it extensively at everywhere, right? So now the next part is Python data types. So in this we have integers, float, strings, booleans, then again some complex data types like list, tuples, sets, and dictionaries. You can read this definition, but let's go with the practical. Okay, so the first is integers. So integer is what you can say, like let's print. Okay, so let's print this, and integer is like this. Okay, and what we will be doing, we will be also printing the type of this data type, so it will be better for your understanding. So when you check, you can see that we have printed 1 and the type of this 1 is integer. So always when you want to check the type of that particular data type, what you can do, you can just check with this type function. Okay, next is float. So I will just quickly copy this and I will type float. And here how we define a float, 1.2, and when I type here 1.2, it will be printed out like this. You can see here 1.2 and the class is float. Now the next is boolean. So what are the booleans? So what I will do, I will just paste here. Okay, so true and false are the boolean data types, and make sure that Python is case sensitive. So you are typing as capital T, not the small t. It will not detect, right? So you have to type like this, capital T, and when you print the type of this, you can see that it is the class is bool, right? The boolean. Next we have strings. Strings you know very well. So you can type 100 days of hell with Python algo trading. Okay, now fine. And instead of it, what we can do, we can just assign this to a variable. So that is the common practice. So what I will do, like I'll assign strings, and here I can just pass this variable. Okay, strings. And here also I can check the type strings. And now you can see that it has printed the strings and the type is str. Correct. Now the next is complex numbers. The complex is used very rarely, but it's better you know that, right? Sometimes it might be required somewhere. So I'm just explaining it quickly. So I will change it to, we can say, complex. And here you can give a number, like you know that how we define the complex number, 2 plus 3j, and here 2 is real number and 3 is the imaginary number, right? And here what can I do? I can just change it to complex from strings, and when I hit shift enter, we have the value, right? This is the complex number and this is the class, correct? And what if I just want the real number? So what you can do, you can just type like this, complex.real. You will be having only the real number. And if you want the imaginary number, what you can do, you can type like complex.image and you will be getting the imaginary number. Next is list. List is one of the most important data types. You will be using it a lot in the algo trading. So you have to understand these concepts very clearly, because if your fundamentals are strong, then you will be having an edge over all the other algo traders for sure. And I'll be explaining all these in the future videos very extensively. This is just the introduction. So just quickly have a look. What is a list? So I'll just copy and paste it and I'll change here. Okay, so now I will quickly change this to list. So I'll give it the name list. And how we define a list, you just give a square bracket here and then you mention your list items. Okay, so for example here I'm mentioning 1, 2, and then I can also mention a string in the list, 1, 2 Kuldeep, and also a float. Okay, 1.2, you can mention almost anything in the list. Okay, and when I print, I will change here the value as a list, and here also I will check the type of this variable. So when I hit shift enter, you can see that this has printed the list and also the type of this particular variable list, correct? So now the next is tuples. So the list and tuples are almost similar, just a small difference, which is we are using parenthesis instead of square bracket. Okay, so remaining, okay, I'll change here also tuples, and I'll just copy that here, tuples, and here also tuples and tuples. There are more differences which I'll be explaining in the upcoming videos. For now, we are just having the overview. So just in list we are using a square bracket, and in tuples we are using a parenthesis, right? And when I hit shift enter, so you can see that we have a tuple. Otherwise the values are almost same. And the next is sets. So in sets also the difference is not much. If you have studied in your high class about the sets, the concept is exactly the same, the sets in mathematics. And but here the style of representation is a little bit different. here you have to use a curly braces, right? So I'll just change the values to set. Here also I'll change it to sets, and here also set. When you hit shift enter, you can see that the values are printed and the class is set, right? And last but not the least, we have dictionaries, one of the most important data type which you will be using a lot like list in the algo trading or data science, right? It's very important, and our fundamentals should be very strong in this basic concept, right? So here I'll just change it to dictionary. So what does a dictionary do? I'll just change it to dict. And here in dictionary, we have two things. One is key and another is value. So a key value pair. Okay. So let me change it. So I will type here key 1 equals to 1. So I can give it and instead of equal you are using a colon here. Okay. And the same goes for everything else. So I will just copy it and I'll make it key 2, and again this will be the key 3. So and we can make it as a key 4. So now you know that we have 4 items here, right? Key 1, key 2, key 3, key 4, and the value of key 1 is 1, which is integer, and the value of key 2 is 2, which is also an integer, and the value of key 3 is Kuldeep, which is a string, and the value of key 4 is a float, which is 1.2. Okay, and when I print this and when I print this and when I print this and when I change and print this, so now you can see that we have a dictionary printed out and the class is dict, right? The dictionary. So what if I only want to print the values, the 1, 2, Kuldeep, 1.2? What I can do, I can just type dict dot values and parenthesis. And when you hit enter, then you can get the values 1, 2, Kuldeep and 1.2. Correct? And if you want only the keys, you can type like this, keys. And you will be having only the keys, key 1, key 2, key 3, key 4 in a list. Okay. And also the type you have seen in all the data types, right? So this is how the data types looks in Python, a very basic explanation, and we will be learning these in detail because these are very important to learn the bigger things in Python. Now we move to the next part, which is Python variables. The definition is variables in Python are names attached to a particular object or values. They are created through assignments and don't need explicit declaration. Python is dynamically typed, which means the type of variable is determined at runtime. Unlike the other languages like C and C++, where we have to explicitly mention that this will be an integer and this will be a character or a float, whatever the value will be, right? So here we have already used the variables, like in here also the set was the variable name, the tuples was the variable name, list, and all these were the variables name, right? So how to declare a variable? It's very easy and straightforward. Like if I want a like a equals to 1, and here a is the variable name, and for example b equals to the we can say a string, maybe apple stocks, and here b is the variable name. Correct? So now there are a few concepts like the dynamic typing and dynamic binding. So what is the meaning of dynamic typing? So in dynamic typing, what happens? The Python interpreter automatically detects the type of that particular object. For example, in other languages like C or C++, you have to type like integer a equals to 1 or character b equals to, let's say, Kuldeep, right? But here you don't need to do that. You can just type a equals to 1. Python will automatically detect that it is an integer, and if you type b equals to Kuldeep, it will detect that it is a string, right? So that is the concept of dynamic typing. Now the next is dynamic binding. So what is dynamic binding? So what happens in other languages like C or C++, you have to mention like integer a equals to 1. So now we have explicitly mentioned that a will be an integer throughout the program. So now we cannot tell that character a is Kuldeep. it will not work. It will throw an error, right? But in Python, it is very flexible. If you want, what you can do, you can just give like a equals to 1, an integer. Then in next line, you can give a equals to Kuldeep, which is a string. So it's so flexible. Even if you can assign a list or dictionary or set, and there is no boundation of that, you can do like that. So you can do like that. There is no issue and you will not get any error. So now there are few techniques through which you can reduce your lines of code. So what you can do in other languages, you have to type like integer a equals to 1, then again integer b equals to 2. I'm not telling that any other language is bad. Every language has their own pros and cons, but as we are learning Python, we have to compare, right? So integer c equals to 3. But in Python, if you want to achieve this whole thing in one line, what you can do, you can just type a comma b comma c equals to 1 comma 2 comma 3, and this is it. It's so easy. And also, and if you want to assign the same value to different variables, so what you can do, you can give like a equals to b equals to c equals to 1, and it will be assigned the same value to all these three variables. So it's that simple in Python. Now the next is Python comments, which is very straightforward. Comments in Python are used to explain Python code and make it more readable. They are ignored by the Python interpreter. Single line comments start with the hash symbol, and multi-line comments can be enclosed in triple quotes. Okay, we are already using these comments, like here is also a comment. Like whenever you want to explain the code, make sure that you have a habit of commenting, right? It will be better for your teams. So how we can mention a single line comment? For example, you are declaring a variable a equals to 1, and you want that your teammates should know what this variable does. So what you can do, you can just type this is a, which is equal to 1, and you can type anything, why you are declaring and why you are giving this name here, so it will be much easier for the other people. And again, if you want like multiple line comments, so for that you have to give triple quotes, and then you can type your comment like this is Kuldeep, and here is the example of multi-line comments. Okay, when you hit shift enter, you can see that we have a multiple line comments, but generally we always go with the single line comments. But if you require, you can use it, right? You have an option. So the next is Python keywords and identifiers. So the keywords are the reserved words in Python that cannot be used as ordinary identifiers, that define the syntax and structure of the Python language. Example include if, for, and while. Identifiers are the names given to entities like classes, functions, variables, etc., and must start with a letter or an underscore followed by letters, digits, or underscores. So these are the three simple rules. So like if you are assigning a variable a equals to 1, or defining a function, like defining function, you can say stock market, stock data, or a function. And also if you are like for a class also, if you are, so you can say market analyzer. So these all are the identifiers. A is also an identifier. Stock data is also an identifier. Market analyzer is also an identifier. You cannot use if, because it's a keyword, it's a reserved keyword. So you cannot use this as an identifier, right? This is the basic difference between keywords and identifiers. So again, quickly, keywords are those words which are reserved by Python interpreter. You cannot use those reserved keywords as your identifier. Means your variable name, your function name, your class name, you cannot use those. And now, what are the rules for identifiers? These cannot start with a digit. Like if you want, here you cannot give like 1a, it will throw an error. Also, while defining a function also, you cannot start with any digit. Also, you cannot use any special keywords, which we have explained already. Here it will be characters, special characters, except, what will the spelling for this? Except underscore. You can use underscore, but other than this underscore, you cannot use any other special character like hash, at the rate, or any other special characters. So these are three simple rules. I cannot start with the digits, cannot use any special character except underscore, and identifiers cannot be keywords. So that is a simple concept of keywords and identifiers. Now we move to the next, which is Python user input. So generally there are two type of applications. One is static, another is dynamic. So in static, what happens? We only get the information. So like Wikipedia or any blog. So in that, we are only getting the information, right? We cannot communicate with that application. But in dynamic, we are able to communicate. Like YouTube, in that we can search, we can give comments. Also, we can give like. So all those are inputs, right? So to take the input from user, you just have to call the input function. And here, so if you just press shift enter, you will see a box. See here, if you are using Jupyter Notebook, you will see here only. But in Visual Studio, we are seeing a input box here. So here you can type anything you desire, like Kuldeep Singh, and when you hit enter, it will be printed out here. But this is not a good practice. So what we should do, we should always give some kind of information here. So we can ask here, what is the current price of Bitcoin? And give a question mark. And now when you hit shift enter, you will see the information here. What is the current price of Bitcoin? You can type like 62,000, and when you hit enter, it will be printed out. So this is how we take a basic input from the user. Now what we will do, we will just create a simple program in which we will be taking the inputs from the user, and we will perform an operation, and then we will print the result. So what we can do, we can like ask again the same thing. So we will just cut paste, and I paste here. So we can say, we can give it a variable name like current price. Okay, so current price, and we can also ask like earlier price. Like you can say yesterday's price. We can say YD price. Okay, yesterday price. We can say yesterday price. What is the yesterday price of Bitcoin? Okay, then what we will do, we will just check. Let's say today is the 62K and yesterday was 60K. And when you hit shift enter, it will not display, right? Because we have assigned this to another variable, and in order to print that, we have to print that variable also. Let's perform some operation. So we can say difference between yesterday's and today's price. So how we can do that? We can like subtract from current price to yesterday's price. Okay, and now you can, in like Jupyter Notebook, you can just type diff, it will be printed out. So when you hit shift enter, it will first ask you current price, then it will ask you yesterday's price, and then it will say unsupported operand type. So you just quickly type why we are getting this error. And now the time is out. I'll just explain you, because in Python input function, it always takes the default data type as the string. So in string, we cannot perform the mathematical operations. So let me show you the what we can do. We can just like, let me show you first the type of these. So the type of these variables. So I will just call the type function as we have already studied. Type, and type of this variable also. And let me remove this, and also this, give it a comment so it will not throw an error. So when I hit shift enter, it will ask me today's price, then it will ask me yesterday's price, and when you see here, it has printed out the string, right? Okay, here I have to give the print to both these to display. So print, and again and again print. So like give any value here, 62 and 60, and you can see here that it is a string. So in order to resolve that issue, you have two options. One is to, while performing this operation, you can convert this string into an integer. Okay, you can just like call, you can just mention here the integer function, here also the integer function, and now when you give any value, it will not throw an error, right? But one more thing, when you change the data type, it will not change the original data type, correct? It is only changing in that particular operation. So another option is to change the type of data while taking the input. So here you can take, and when you hit shift enter and give any value, now you see that we have the integer data type, right? So this is how you can perform this, and when you print this difference also, you will see that when you hit shift enter and when you enter today's price and then let's say yesterday's price, and the difference is 2000 input. So this is how the input function works. And now we have the Python type conversion. So what is this? We have just did that. Here the default is string, but we have converted that into an integer. So that is the type conversion. We are converting the type of that data, right? So there are two ways. One is implicit and another is explicit. So what is implicit? So in implicit, Python automatically converts the data type, and in explicit we have to mention. So here we did the explicit type conversion, right? Because it was default string and we have converted that into an integer. But okay, let me show you an example. So for example, we have the price here 100, okay, and let's say price 1 is 100 and price 2 is 200, and I want the total price. Okay, so what I can do, I can just give price 1 plus price 2. So here Python knows that price 1 is an integer, price 2 is also an integer. So when we are performing any operation in this, it will implicitly convert, so it will not throw any error, right? So when I print here total and hit shift enter, it will display the 300. So this is the implicit type conversion. But instead of this integer, I just gave it a string. Okay. Now when I hit shift enter, you type in the comment any error or it will run. So when I hit shift enter, so it will throw an error, unsupported operand types. In order to resolve this issue, what I can do, I can just perform a type conversion here from string to integer, and when I hit shift enter, it will not throw any error. So this is what that Python type conversion. Sometimes it helps us. So we have to convert the data types. It helps sometimes. Now we are moving to the last topic of this day, that is Python literals. So first let's understand what are the literals. So while declaring any variable, for example, we declared here price 1 equals to 100. So here price 1 is the variable name, which is also known as the identifier, correct? Then it equals to 100. So 100 is the value of the price 1, and this is also known as the literal. Means what is the literal value of that particular variable? So this is the identifier and 100 is the literal, correct? There are various kind of literals in Python, so we can just go through the definition. Literals in Python are data items given in a variable or constant. Python supports various types of literals, including string literals, numeric literals, boolean literals, and collection literals. So let's quickly go through all those. So in binary, what happens? It starts with 0b, right? So if you print this, I will just give it shift enter, and here I will print a. Here I will print a. So here it is 9, because this is binary equivalent of 9. So it starts with 0b, then the decimals which we always use generally. So I can print b also here. So quickly print B and it will print 301. Then we have octal literals which starts with O, right? So binary starts with 0B and octal literal starts with 0O. And when I print this octal, so here I will print C and it is 209, means this is the octal representation of 209. Then we have hexadecimal which starts with 0x, so you can print this also, and this is 539. So we can say that 0x21b is the hexadecimal equivalent of 539. Then we have float literals which we have already studied, like e equals to 1.2 when we have a decimal, that is the float. And in complex also we have studied. So like if you are typing like 1 plus 2j, this is the complex literal. 1 is a real number and 2 is the imaginary number. In string literals we can type like h equals to string 1. This is the string, and here also we can represent it with a single quote, double quote, or a triple quote. So this triple quote is used for multi-line strings, and this double inverted quotes and single inverted quotes are used at various places. Like you can represent this string with single quote also. But if you have a situation like it's a string, so in that case it will get confused, right? So to resolve that issue, what you can do, you have to use the double inverted comma. You have to use the double inverted comma. So this is how you can use this. Then we have the Unicode strings. So in Unicode nowadays, like sometimes we have to print emojis and so many special characters. So you can use the Unicode string. So in Unicode string, what you can do, you can just print it, and you can see that we have the emojis here. And in row string we have like /n, /tab, and all those things are the row strings. So you can also print those also, and when you hit shift enter, it will give me an error because I haven't typed the correct one. And here you can see that we have a row string. So let's understand what are the operators. So operators are these special symbols, or you can say keywords, which are used to perform some operations on variables and values, right? So you can say the symbol between variable and value. So for example, so like we say, sum equals to a plus b, right? Here sum is the variable and a plus b is the value of that variable, correct? And here this symbol is known as the operators. And Python supports various kinds of operators. For example, we have arithmetic, in which we perform addition, subtraction, division, multiplication. Then we have relational. In that, we calculate the less than, greater than, correct? And then next, we have logical. And in logical, we have the and, or, not. Then we have bitwise. So bitwise operators are used to perform bit level operations, which also have and, or, XOR, and left shift, right shift. We will shortly understand all those. Then we have assignment operator, which is the equal to sign. And last but not the least, we have membership operators, which is in and not in. Okay, so let's try to understand them one by one. Okay, so the first type of operators are the arithmetic operators, correct? In this we have addition, which is plus, then subtraction, which is this sign, and then we have multiplication, division, integer division, then modulo, and then power of. So how does this work? For example, we have a equals to 5 and b is equals to 2, correct? So if we try to perform addition on this, then the results will be 5 plus 2, which is 7, which is basic maths. Then when we perform subtraction, which is 5 minus 2, we will get 3. Then we perform multiplication, which is 5 multiplied by 2, we will get 10. Then we have division, we will get here 2.5, correct? A float value. Then we have the integer division, which is very useful and very important, right? So here what we will get, when we perform 5 integer division 2, then we will get only 2, because it will ignore the 0.5, which is not an integer, correct? So we will only get the integer value. Sometimes it's very useful. I'll just show you in the example. Then we have the modulo. So in modulo, we get 1. We only get the remainder of that particular operation. So here we will get 1. And then we have power of. So for example, if I perform like 5 power of 2, then I will get the value as 25, correct?
So these are the basic understanding of the arithmetic operators. So let's quickly understand them in the code. So now we quickly take a real life example. So for example, I have these values here. What I will do, I'll quickly copy and paste them in the Python code, and I will remove these values. Okay, then I'll just hit Shift Enter. Okay, okay, now I hit Shift Enter. Okay, so here, if I want that total price, right? So what I'll do, so here first we perform the addition operation. So let's say we want the total price. So what we will do, entry price plus exit price, correct? So we will get the value. See here 305, because 150 plus 155, obviously 305, correct? Then you perform the subtraction. In that, what we can do, we can just change the value from plus to minus, and when we hit Shift Enter, we get the value -5. Then we have the subtraction, then we have the multiplication. So similarly, you just put a star sign there and we get the multiplied value. Then we have the division, and in division we just place the sign and we get the value 0.96. Now you tell me in the comments what you will get when we perform the integer division, which is double slash. Just pause the video and comment down to check your understanding. And still, if you're not able to answer, and then go back to the explanation and watch it again. Okay, so when I hit Shift Enter here, I'll get the value 0, correct? Because it's less than 1. But if I change this value just like 156, like just more than 155, then I'll get 1, correct? Then we have the modulo operator. In modulo also, you just pause the video and try to answer yourself, so that your learning increases, so that you are able to analyze whether you have understood the topic or not. In modulus, we will only get the remainder, right? So when I hit Shift Enter, I get 5, because 160 divided by 155, we are left with the remainder, that is 5. And then in last, we have power of, correct? In power of, what we can do, we can take the exit price. Okay, so here, when I like power of 2, so here it means exit price and then square. So square of the exit price. When I hit Shift Enter, I get the value 24025, which is 155 multiplied by 155, correct? So now let's quickly move to the second type of operators, which is the relational operators. So here, now we have relational operators. For example, we have the entry price, which is let's say 100, and we want to exit at 150, correct? So entry price is 100 and exit price is 150. So first, if I want to check the greater than, so if you write a line of code like entry is greater than exit, correct, then you will get the output as false, because relational operators always gives the Boolean value, true or false. So here we will get as false, right? If I replace it with this sign, the less than, then we get the value as true. What if I replace this with greater than equal to? So let's say if I do like this, then also I will get the value as false, correct? If I replace it with less than or equal to, then I get the value as true, because it is less than. And when we have the equals to operator, and here of course it is false, but if I change the value, this value to 150, then I get the value of this as true, correct? This one. Now if I replace it with the not equal to, then you tell me what will be the answer. Just pause the video and write your answer below. Because here we know the entry price is 150 and exit is also 150, so here we will get the result as false, because it is true, because both the values are equal, right? Now what we do, we first complete the explanation, then we will take example of each type of operators and we will perform on Visual Studio. Okay, now we have the logical operators, and these are used to combine the conditional statements. Let's see how. For example, let's take the same example, like I have the entry price as 100 and exit price as 150, right? So now we have two variables and we want to apply the AND logical operator on these two variables. So how we can do that? We can compare the two conditions, and if both the conditions are true, and then only we will get the output as true. If any one condition is false, then we will get the value as false. So in AND operation, all the values should be true, then only we will get the output as true, right? So let's say we compare if entry is greater than 50, and so here we are applying the AND operation, and exits price should also be greater than 100, right? So these are two conditions. If both the conditions are true, then only we will get the output as true. When we check that entry is 100, which is greater than 50, it is true, right? Then exit, which is 150, which is also greater than 100. So means both the conditions are true, and we will get the overall output as true, correct? And similarly in OR, what happens? If any one of the condition is true, then we will get the output as true. So let's say I remove this, I add OR here. So here let's change the condition from 50 to 150, correct? Now I know that the entry price is 100, and I'm checking the condition that 150. So entry is not greater than 150. So this condition is false, right? This is false condition. And in the second condition, the exit, which is 150, is greater than 100. So I can say, yeah, this is true. This is true. So here one is false and second is true, but still we will get the output as true. Because in OR, if any one of the condition is true, you will get the output as true. In the last, we have the NOT. We have the NOT logical operation. So in NOT, what happens? It will just invert the real condition. For example, if we have a condition which is true, and if we apply NOT on that, then we will get the output as false. It will just invert the real condition. Okay, for example, if we apply on this, so I'll just remove these all things, and here I apply the NOT function. Okay, so the NOT function is NOT. Here I know that entry, which is 100, so 100 is greater than 150, which is not true, means it is false condition. In reality, it is false condition, but I have applied the NOT here, so the output will be true. It will just reverse the real output. Now we quickly move to the bitwise operators. So bitwise operators are used to perform bit level operations. We have two bits, right? 0 and 1. So in bitwise also we have the AND operation. Okay, how does this works? For example, you have two values, a equals to 2 and b equals to 3, correct? So Python internally converts these values to bits and then perform the operation. Then it performs the operation and gives us the value in decimal. Okay, so let's quickly convert these values in bits. So the binary equivalent of 2 is 0, 1, 0, and the binary equivalent of 3 is 0, 1, 1, right? So now if I perform the AND operation here, so now we have a and b. So first we will apply the AND operation here. Okay, so what will be the output? So now we are applying AND on these 2 and 3, right here. So 0 and 0, 0, 1 and 1, when, so in AND we know that what happens, if both the values are true, then only we will get the output as true, which is 1. So which is 1, then 0 and 1, here 1 is false, so we will get the false. So 0, 1, 0. So means we can say we get the value as 0, 1, 0, which is equal to 2. Here the output will be 2. So now let's apply OR here, right? So I will apply OR on these variables. So now let's recalculate. So here 0 or 0, 0, 1 or 1, 1, 0 or 1, 1, because in OR, if any one condition is true, we get the output as true. So here the output will be 0, 1, 1, and we can say that is equal to 3. So here the output will be 3, correct? So now the next is XOR. So let's apply XOR here. Okay, so in XOR what happens? Whenever both the conditions are true, then it becomes false. Otherwise the rest is same like the OR operation. Okay, let's suppose here we apply the OR operation. So if both the values are not 1, then we apply the simple OR operation. Okay, here it will be 0. Now we know that both the values are 1 1, so we'll get as 0. And in next we know that both the values are not 1, so we will apply a normal OR operation which is 1. So we will get the value as, and that is equivalent to 1. So here the output will be 1. Correct? So it is that simple. And if you just practice few multiple choice questions and then a task, and then all of your doubts will be cleared. I promise that. But if you still have any doubt, then feel free to reach us via the comments or Discord or Telegram. Now we have the NOT operation. In NOT, what happens? It just invert all the bits. Okay. So for example, we have a variable a which is equals to 2, and the binary equivalent of that is 0 1 0. Correct? If I apply NOT operator on this, so we can apply that with this symbol and a, then I will get the output as the invert of these bits. It will just invert these bits. So 0 becomes 1, 1 becomes 0, and 0 becomes 1. So 1 0 1. Correct? And which is equal to, I'm not sure, let me check. I guess let's quickly write 0 0 1 0 1 0 0 1 1. Then I guess 4 is 1 1 0, 5 is 1 0 1. I guess it is 5, right? Let me quickly check. Binary. Yeah, 5, correct. So it's been a long time. In college time we have read these, right? So I have forgot already. So you get the idea. It will just invert all the bits. So this is how this works. Now we have left shift and right shift. Okay. For example, we have a value a equals to 5. Okay. In this we write 8-bit, right? So we have 1 0 1, and then we add 5 zeros here. Okay. Now we want to shift it left with 1. So we write like 5 left shift 1. Correct? Means here these values will be shifted to the right side. Okay, to the right side. So here what we will do, first we will discard this leftmost 0 and we will add another 0 here. So what it will become, after discarding these, we are left with 4 zeros. So 1 2 3 4, then we have 1 0 1, and we have added another 0. It becomes 10, right? So here we will have the output as 10. You can quickly pause the video and try this in code. Okay, now we have the right shift, and the concept is same here. We will right shift the value by whatever the value we have mentioned. So for example, we have a value a is equals to 2, and the binary equivalent of that is 10 1 0 0, and we will apply 3 zeros here. Okay, now the same concept applies here. We will discard the rightmost value. Okay, we discard it and we add another 0 here. Okay, so what it becomes, so now what we are left with, we have this value, that is 1 0 1 0, and then we have these 3 zeros 0 0 0, and we have added another 0. So this is the value we are left with, and which is a decimal equivalent to 10. We will get the value as 10. So it was a long session, but it is very crucial. So now we quickly move to the next part, which is assignment, and that's very easy. We always use that. We have, this is the assignment operators, and we use this assignment operator in conjunction with other operators like the addition, subtraction, multiplication. For example, we have a value a is equals to 2 and b is equals to 2. Okay, here what I can do, I can write like a equals to a plus 2. So instead of this, I can write, here we are using the assignment operator. We can also write like a equals to a multiplied by 2, and so this syntax can also be written as a multiplied by equal to 2. So it just shortens the code. Here we don't have like in C++, we used to have a plus 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 a, because that is sometimes becomes very confusing. Hope you have understood it, and if any issue, then just practice this, and still issue, then ask us. Now we have the last, the membership, which is very interesting and very useful. And the example of this is, let's say we have a string as Singapore. Okay, so make sure this is a capital string. Okay, now I want to check if this string contains the capital S. So what I will do, if I write S, in Singapore. So it will give me the value as true. Okay. If I just change this value to small s, right? It's small. Then it will give me the value as false. Okay, so this is how we use the in, and it helps a lot because instead of applying a loop here, we are just getting the value in just single line. So it can be a long string, and it's really very useful. Similarly, we can use the not in also. So how you can do, you just write not in, and when I run this as, so it's a small s, right? So as not in Singapore, it will give me true because the small s doesn't exist in this string. But if I just change it to capital S, okay, and when I apply this, it will give me false because capital S is existing in Singapore. So this is how we use the membership operation. It just check whether particular character or any particular value is a member of the larger group or not. So that's how it works. Let's quickly move to the screen and perform some real life examples. Okay. So now let's quickly take an example of relational operators. So here we take the same value, and when we come here and apply the value and apply the operators. So what I can say, like entry price is less than the exit price, but we know that both are equal. Okay, so it will give me the false value, correct? See here, false, correct? And the next is greater than. So if I apply that, so it will also give me false because we know that both are equal, correct? Then next we have greater than or equal to. So if I apply that, then it will give me the true value because we know that it is not greater, but it is equal. So when we hit shift enter, we get the value as true. And the same goes for the less than equal to, and the same goes for the equal to because it's equal to. But the interesting thing is when I apply it to the not equal to, it will just invert the real operation. Here we know that it is equal to, but when I apply the not equal to, it will give me the value as false. See here. So that simple the relational operators are. So now let's quickly check the logical operations. So in that also, we will take the value entry and exit. So entry and exit. Okay. And we apply the AND operation here. So in AND what happens? Both the conditions should be true. Then only we will get the output as true. So for example, if I check that entry price is greater than 100, which is true, and exit price is greater than 150, which is also true. So means both the conditions are true, and when I hit shift enter, we get the value as true. Okay, and when we apply OR here, so in OR, if any one condition is true, then we will get the output as true. So here what we can change, I will just make the value as 15. So here we know that the entry price is not greater than the 100 because it is 15 now, but we know that the exit price, the second one, is true, right? So when we hit shift enter, it still gives me the true answer. Next we have not. So in not, it just inverts the real output. Here we know that the output is false, right? But here if I apply not, then I get the value as true. So this is how you can use these, and when we will create the big problems, and then you will see a lot of use of these operators. And you can also perform the MCQ and task given in the description for your practice. And please work on the mini project which I have given in the GitHub repository notebook. It will definitely improve your understanding. Now we quickly perform the bitwise operations. So in bitwise we have like a equals to 1 or b equals to 2, right? So if I type a is b, we get the value as 0 because I have already explained you 1 is equal to 001 and 2 is equal to 010, correct? So in AND both the values should be true, then only we get the true value. But here we can see here that two values are true, so that's why we get the value as 0. Similarly, if I, okay, let me keep this and comment it out so it will be better for your understanding. So let's apply OR here. But in OR, we know that we just want one value as true. So here 00 becomes 0, 10 becomes 1. So 011 is equal to the decimal 3. That's why we get the value 3. Then we have the XOR. So in XOR, you just think that if both the values are 1 1, then it inverts to 0. Otherwise, the rest operations are all exactly same as OR operation, right? So here, if I apply the OR operation, the XOR operation, we get the value as 3, as we have already seen in the example. And now we apply the NOT. In NOT, what happens? It just inverts the bit values. So if I apply the NOT here, I get the value as -2, right? So why? Because 0 becomes 1, 1 becomes 0, and 0 becomes 1. And the 2's, and it gives us the value of 2's equivalent. You can just test in your machine. Now we have the left shift and right shift. For example, we have a equals to 5. And when we want to left shift the bit values of 5, so what we can do, we can write 5 left shift 1. When we hit shift enter, we get the value as 10. So now for the right shift, for example, we have b equals to 20, and we want to shift b to the right by 1. So when we hit shift enter, we get the value as 10. So you can just practice these things. Let me know if you have an issue. Next, we have the assignment operators. For example, a equals to 2. Okay, and you want to print that a equals to a plus 2. Okay, so instead of this, you can write like a plus equals to 2. Okay, so this is the basic assignment operation, and you can like try with multiple things here. And here we have like membership. So membership, for example, I take a string as, let's say, India. India. Then I want to check whether I in India or not. So it will give me true because I exist in India, and yes, I exist in India, but currently in Singapore. And now if I check small I, so it will also give me the value as true because small I also exists in India. But if I check with capital A, it will give me false because in India we have so small a, correct? Now similarly, we have the not in operations. So when I apply a not in India, which is true, right? So it will give me the value as true. So this is what, so these are the operators, and we have given enough time. If you watch the video with full concentration and attend the MCQs, and then you perform the task with the mini project, then I can vouch that you will never need to read this topic again in your life ever. Okay, just one time with full concentration. Okay. Now we have the conditional statements, which are if else, if elif. So now quickly understand them, and then we will proceed with the examples. For example, we have a entry price which is equals to 100 and a exit price which is equals to 150. So the syntax of if is if entry is greater than exit and then a colon, then print. Okay, so here we can print our statement, whatever it is, you will just learn. Here we have else again colon, and then print another statement here, right? Whatever it is. So it is how if else work. And for example, I have more than 2 conditions. Okay, for example, let's say we have one more variable, we can say stop loss. Okay, so stop loss is, let's say, 80, correct? So if I want to check if entry is greater than exit, which is not true here, then we can give another statement here. Okay, here like if elif, here also I can give that if exit is greater than stop loss, here also colon, and then in last we can give else. So whatever the else condition, we can print it out here. Here also we can print something. This is how this works. And what about the nested if else? So in nested if else, what happens? Like in the else condition, we can compare few more conditions. Okay, for example, in else we are giving else if, like if you're writing a code for a strategy, so here you can write like if trade executed, if trade executed means trade is equal to 1, then you will print here that trade executed, right? Else just print here Not successful, correct? Not. This is how a nested if else works. Means another if else condition inside the already existing if else condition. So let's quickly take an example, and then we proceed with the multiple choice question, and then you proceed with the multiple choice questions and the task. Now we quickly proceed with the example. So first we check the if else. So here we write if entry price is greater than the exit price, then it should print that entry price is greater than exit price, right? Else it should print, I'll just copy and paste this print statement here. Exit price is greater than entry price. Okay, here we have the value of entry price is 165 and the value of exit price is 155. Means here I have to write as greater than, then only it will make sense. So when I hit shift enter, so here it will give me the first statement. If I just change the value to less than, then it will print the second statement, which is exit price is greater than entry price. So this is how the simple if else works. And now let's check the if elif. Okay, so in if elif we have more than two conditions. So first we will check if entry price is greater than exit price. Second, we will check elif entry price is greater than stop loss price. Okay, and in third we can check for any other statement. So let's so in second we can write, so we can print here that entry price is greater than SL price, correct? And in the else statement, we can just write like anything, right? We can say that both the conditions are not true. So I'll write like this, and here like this, both the conditions are not true, right? Are not true. So when I hit shift enter, we get the value as entry price is greater than, I'll make it entry price is greater than the exit price. But what if I want to execute this second one? So we can make it as 145. Okay, and stop loss we can make it as 144. So when we do that, when we hit shift enter, the second statement will be executed, right? And what if I want to execute this third one? Both the conditions are not true. Means entry price is also not greater than the exit price. Here I will make it as 148. So when I execute this, we will get the result as both the conditions are not true. So here how the if elif works. Now the last is nested if else. So in nested we have if else condition inside a if else condition. Here I wanted to check if elif if shares count is greater than 5, then print, I'll just copy and paste, then print you can say share count is greater than 5, right? Else you can print else you can print share count is not greater than 5, right? So for that the second condition has to be executed, right? So in elif, to execute the elif, what we will do, we will make the entry price should be greater than the stop loss price, so 144. And then okay, so now when we run this, we get the statements like the entry price is greater than SL price, which is true for this case, and then it will print that share count is greater than 5 because we have the share count as 10. So this is how the if else, if elif and nested if else works. I highly recommend you again that please go for the multiple choice questions. Those questions are well researched, and once you're done with those, then just head to the GitHub repository where you will find task and the mini project. So once you are done with that, you will be the pro in Python algo trading in 100 days. I can vouch for that. Okay. Now let's quickly start with the Python module. So first of all, what are Python modules? For example, when you write a piece of code and in that code you have multiple functions, multiple classes, but what you want that once you have written the code, then anyone can use this. So what you will do, you will just submit that code into the Python official repository, and then if it gets approved, then they will add this in the official Python package. If not, then you can also host your own code at your repository or somewhere else, and if anybody wants that, they can just import and use that. In short, we can say modules are the block of codes written by someone else and using by someone else, right? So it makes our life very easy that we don't need to write the whole code again, and simply we can just import and use that. For example, here I am just showing you these 4 modules, but there are a lot of modules for everything, right? Virtually you will be finding modules for each and everything. Okay, so let's start with the first module, which is math. So in order to import the math module, you just need to write import math. Okay, and whenever you want to import any module, you have to write import, and then you write the name of that particular module, and when you hit shift enter, and if there is no error, that means that module has been imported. Then you can use that. So what we will do, we will just type math, then dot. After that, it will display all the functions in that module. So you can see here we have a cos and then a sine, like all the trigonometrical functions. Then you can see the degree, exponential, factorial. So let's check the factorial of 5. When I hit shift enter, we can see that we have the value 120. But when we write the code for factorial, it becomes lengthy, right? That in just a single line of code, we can do many powerful mathematical operations of this. Let's try one more thing. For example, floor. And in floor, what happens, like if we have a value 6.5, it will give me 6. Like when we want to round off the values, so if I select the floor, then it will select the less value. For example, if I select here seal, so in seal it will select the upper value, right? So that's how the floor and ceiling works. Then again, we can test math dot square root. So if you want to check the square root of 25, then you can see that it is 5, and you can take any number here. For example, 196, it is 14. So this is how you can use the math module here. And now we check the keywords. So for keywords also, you have to import it. So what you will do, you will just type the import, then the name of that module, that is keyword. And when you hit shift enter, if there is no error, means it has been imported. Then what you can do, if you want to see the list of keywords in Python, so what you can do, you can just write print, and then you type the keyword dot kw list, right? And when you hit shift enter, you can see a list of all the keywords in Python. So means these keywords you cannot use in your code. Next, we have random module. So in random module, what happens? You can generate random numbers. So there are multiple functions in that also. So let me show you a few of them. So similarly, we import random, and when we hit shift enter, there is no error, means it has been imported. Then I type random dot. Then you can see all the functions of this random module. There are multiple functions, but for now, I'll just use the rand int. So in this, we have to give a range. So I'm giving a range here from 1 to 100. So every time I run this code, it will generate me a random number between 1 and 100. So let's press shift enter. You can see we have 46. Then when I again press shift enter, I have 24. Next 87, and next 93. Okay, so this is how the random module works. Now I show you the last module for this session, import date time. When I hit shift enter, yeah, it's working fine. And now, for example, I want to check the current time. So what I will do, date time dot now. So it is also very useful a lot of times. Let's print this. So when we print it, we can see that the current time is 14th of May, 5:54 a.m. and it gives you the exact timing. Here also you have multiple functions and you can use as per your requirement. You can see here we have date, then time delta, time zone, TZ info, UTC, and multiple options. So you can explore later on. Now quickly we take an example. So in this we will try to check the initial stock price and volatility. So let's consider that we have a stock. So let's take a new cell here and let's suppose we have initial price of any stock $150 and then we take the volatility as 0.5%. So I'll take 0.05, correct? Because that is the percentage value. So now as we know that in volatility, we don't know, right? Whether it will go up or down. For the sake of this example, what we will be doing, we'll just take the random module here. So we will import the random module. Then what I will do, we can take a variable and give it a name like volatility change. Okay, then we will use the random function here. So random, and here we can use the choice. In this we will give two lists. So one will be negative volatility, then another will be positive volatility. Why we have chosen this? Because we don't know the volatility, right? For the sake of this example, we are taking this. For example, let me show you quickly how it will work. I'll first print the volatility change. So when I print shift enter, it will show me 0.05. Next again 0.05, next again 0.05, again 0.05. So now you can see that it will randomly choose negative of 5% or positive of 5%. So as that happens in the real life example. Okay, so hopefully you have understood the random function here. So I'll just remove it. So now I will take another variable, that is daily price change. So what will be the daily price change? So first we have initial price, which is 150, then the percentage of volatility change. So what it will be the initial price multiplied by volatility change, right? And now when I print it, print daily price change, and when I hit shift enter, you can see now I have 157.5. For example, one day I have my price as 157.5, then next it is 142.5, same, and again shift enter, because it is taking randomly, right? So we cannot say when will be the value, when will be the positive and when will be the negatives, and that's exactly happens in the real life. So this is how we can use the random module. Now we take another variable for the today's date. So what we can say, today equals to, now we will be importing the date time module. So date time, today equals to date time dot date time dot today, right? Let me check it. Hopefully it is correct. Let me just quickly print it, and today, yeah, it is correct. So now we have today's date, and then we have the daily price change and the volatility change. So what we can do, we can print out these values. So first I will print today's date, okay, which is, we can say, today. Okay, then we will print, okay, let me quickly copy and paste this instead of writing. So then I will print the initial price. Okay, so it will be initial price, so it will be this. Then I can print the price change. So let me remove these. Okay, then I will print the new price, so which is the daily price change, correct? And when I hit shift enter, you can see we have today's date is 14th of May, 6:05 a.m. Then the initial price is 150, and then the new price is 142.5. Then when I again hit shift enter, it is same, but the time is changed. Now you can see that we have the new price, because randomly it is taking the percentage volatility change. So this is how it happens in the real life trading. Then we quickly move to the modules. Then if you want to know the number of modules, the name of modules in the Python, what you can do, you can quickly type help and then modules. Okay, and when you hit shift enter, you will be displayed a list of all the modules in your Python. Okay, so this is very basic. Now we move to the today's main topic, that is loops in Python. This is absolutely important because you will be using loops everywhere, right? And if you have a good understanding of loops, then it will always benefit you and it will help tremendously in your logic building. It is super important. Okay, so now we quickly discuss why we need loops. So first of all, so many people don't even understand why we need loops. So in short, I'll give you a simple definition that whenever you want to repeat a same process, a same activity multiple times, then you have to use loops. Otherwise, your program will be inefficient and you have to write same code for same thing multiple times. So for example, let me show you one real life example. So let's quickly open an e-commerce platform. So let's say I'll open Lazada, which is a Singapore based e-commerce platform. So let me open the Apple iPhone 15 and okay, let me search first. Okay, so I'll search iPhone 15. Okay, so here you can see that we have multiple results for the keyword iPhone 15. And precisely if you see, there are 10,557 items found for iPhone 15. But here if you observe, there is a similarity in each of the results displayed here. And if you have observed already, here you can see first we have the image of the item, correct? Here is the phone and then this is the phone case. It doesn't matter what is the item, but you can see the similarity, which is first is the photo of that item. Then we have a carousel of multiple photos. Here the seller have put the 4 photos, but here only one picture and here no picture. So that is the second similarity. Then there is the name of that item. Here is the Apple iPhone 15. Next is the military grade shock proof transparent TPU phone case. Then we have the price. Then we have the off, correct? And then the number of items sold, and then the review, and then the location, the origin of the item. So here it is Singapore and here it is China. Here you can say that there are few functions which have some variables and methods, and those are exactly the same, only the value is changing, right? Means the programmer have written only one loop and he's running an iteration over that. He's not writing each code for separate item, right? And if you go for that, then you have to write 10,557 block of code for only for the iPhone 15 keyword. And here we can see we have million of items, and it becomes absolutely disaster for anyone to write that much longer code. So instead we use loops, means we have written a single piece of code, then we are using that multiple times, correct? So let me quickly show you with an example. So in Python, majorly we have 2 loops. One is while loop and another is for loop. So in while loop, what happens? So when we use a while loop, it is used when the number of iteration is not known beforehand. So we don't know how many times we have to run the loop. And again, the loop continues as long as the condition is true. So for example, if any condition is true, then it will keeps on running. It will not stop until and unless that condition becomes false. And for the loop, it is used when we know the number of iterations or when we have a sequence like from 1 to 10 or any sequence, and the loop continues for each item in the sequence. Okay, so like we have 10 items, then it will run for only 10 times. Okay, so let's quickly take an example of while loop. So for example, we have current price, which is $150. Then we have a target price. So target price is 155, right? So we want to check whether the current price is greater than the target price or less than the target price. So normally we can use if else conditions. For example, if current price is less than target price, print, then print price is still below the target price, correct? Else print, now the price is above the target price and you can sell the stock. So now if you check with the if else condition, it will show that price is still below the target price. But the problem is it will just check for one time and it will stop, right? But in real life, when we are trading, the price is always going up and down and up and down. So we have to always check, and we want to know that once the price is hit our target price, we will execute the trade, whether buy or sell. So in order to achieve that, we need to use the while loop. Okay, so what I will do, I will write while the current price is less than target price. I will remove this, not needed. Okay, so if the current price is less than the target price, it will always display that price is still below the target price, correct? So what I will do here, so I will use a while statement here. Okay, so I will just write while the current price, is less than target price, I want to print, I will remove this if because it is not required as we have already checked the condition here. So until and unless the current price is target price, it will always print that the price is still below target price, correct? But in real life, the price is always keeps increasing or decreasing. So to simulate that, what we can do, we can increment the current price with 1 in each iteration, correct? So what it will do, it will first check the current price is less than target price. Yes, it is. Then it will print that price is still below the target price, and then it will increment that price with 1. So next time it will become 151, correct? So when the condition is not true, then it will print that so now the price is above the target price and you can sell the stock. Okay, so what I will do here, I will run the program. Okay, and you can see that it printed 5 times that the price is still below, then it incremented, and then in the 6th time we know that 151 plus 1 plus 1 plus 1, it keeps on increasing, and when it reaches 155 it comes out of that loop and it prints the statement. Okay, so this is how the while loop works. It's very easy. We will take a few more examples and then you can attempt the multiple choice questions, and then you should go for the task. These are well researched and well curated and it will help you a lot. Okay, so now we quickly move to the while else. So in Python we have while else also. It is also useful sometimes. So let me show you when and how. So now we quickly take an example of while else. So what we will do, let's define a list for price. So here I will give few prices like 110, 112, 114, 116 and 118, and then I have a threshold price. Okay, so threshold price, let's say we take it as 115. Now I want to check that whenever the price reaches above the threshold price, it prints out the first occurrence, right? For example, here when we run the program, so it should display that 116 is the first price above the threshold price, right? Now we break this example into pieces. So what we can do, we will use a while else loop here, and we only want to check the conditions inside this price list. So 1 2 3 4 5, only 5 times, right? So what we can do, we can first check the length of this price. So what we will do, we will assign variable index and we declare it to 0. Okay, then we run the loop while index is less than the length of price, correct? And then we give the colon. So here what is happening, initially index is 0 and length of price is 1 2 3 4 5. So the while loop runs only for 5 times, right? Then what we need to do, we need to increment the index also in every iteration. So index equals to index plus 1 by 1. Okay, so now what we need to do, we need to apply if and else condition to check whether the price greater than or less than the threshold price. So here we will apply if the price of index is greater than threshold price, then what should it do? It should print that the price at will print out the, so we will just format it. So the price at price index breaches the threshold price which is correct. So what it will do, it will print that the price, it will display the price breaches the threshold and it will display the threshold price. If you want, you can also display the index number also. So you can just type here the index, correct? So it will print out that, right? Then we go to the next line. So if the price breaks the threshold price, it will break it. It will break the while loop and then it should print that search, and then it should print that search is completed, correct? So here, so let's try with this and then we will improvise further. So when I hit shift enter, you can see that the price that is 116 breaches the threshold price 115 at 3, because the index of 116 is 3, 0, 1, 2, 3. Correct? Now I want to display the else also, correct? So in case when there is no breach, it should also display that there is no breach. So how we can achieve that? Now we will be using the else statement. Else means when there is no breach. So print there is no price breach, correct? So when this will happen? When the value is never above the threshold price, correct? So I can make it any other value, like ones, okay, 111, okay, no problem, 11112 also can. Okay, so now when I hit shift enter, you can see that there is no price breach, right? Until and unless if the price is anywhere greater than the threshold, it will display that. For example, on the first index also, if I make it 120, and then it will show that the price 120 breaches the threshold price 115 at index 0. So this is how the while else works, and it will be useful sometimes. So now if you have any doubt, just comment down or join our Discord community where we will discuss all the queries. Okay, now we quickly move to the for loop. So as we have already discussed, what is for loop? It is used when the number of iteration is known. Now we know the number of iterations, or when iterating over a sequence. We already have a sequence. It can be a list, it can be a dictionary, or it can be any sequence. For example, alphabets, any counting, it can be anything, right? Then the second condition is the loop continues for each item in the sequence. Okay, now we quickly take an example where we will calculate the average closing price over a 5-day period. So what we can do, instead of that, we can just take the earlier example, and here we can make it the closing price, right? So let's say this is the closing price of day 1, 120 is the closing price of day 1, and 112 is the closing price of day 5. So we want to calculate the average closing price of this time period, right? So in order to calculate the average price, we should be having the total price divided by the number of days, right? So what we can do for now, we can declare a variable and give it the value 0 as the total price. So now what we will do, we will run a for loop on this. So for I in closing price, correct? Then total price is equals to total price plus I, right? So what will happen? First the total price is 0, then equals to total price, which is 0, plus I, which is 120. So in first iteration it will be 120. So now in the second iteration, total price becomes 120. Okay, so then 120 plus 122. So it keeps on checking it, and finally after 5 iterations it will calculate the total price, and then we can print it out. So but here we want the average price, right? Average closing price. So what we will do, average closing price equals to total price divided by the number of days. So the number of days is length of the list, correct? So this is the average price, and now we can quickly print that the average closing price for 5 days is this average closing price. And when we hit shift enter, we get the value 113.8. So this is how the for loop works. So first we understand what are Python strings. So Python strings are the sequence of Unicode characters. What do you mean by Unicode? So let me quickly explain. So the earlier languages used ASCII characters. Okay, but Python uses Unicode, correct? What is the exact difference between ASCII characters and Unicode? As both the ASCII and Unicode are the character encoding standards, but they differ significantly in terms of their scope, functionality, and capacity. So let's quickly understand that. Okay, so ASCII standards can hold only up to 128 characters, whereas Unicode characters can hold a significantly large number of characters, which is 143,000. ASCII standards are limited to English alphabets and digits and some control and special characters. Okay, so some control and special characters. Whereas Unicode is a comprehensive encoding standards designed to support the characters from all the writing systems in the world, as well as symbols, emojis, and various control characters. So we can say all writing systems, emojis, and so many special characters. Okay. When it comes to the encoding size, it uses 7 characters per bits, whereas Unicode has variable sizes and multiple encoding forms like UTF-8, 16, and 32, which can be 1 to 4 bytes per character. And then we can say ASCII was historically used for basic text representation in English, and Unicode was universally accepted for modern text processing, supporting multiple languages and symbols. Now we will learn various things on Python strings, like how to create a string, how to edit a string, how to delete a string, and there are multiple operations, functions of strings. So we'll learn all those one by one. Then we will quickly move to the screen and we'll code some examples. Okay. So first of all, we have how to create strings. First is creating strings. We can create strings with single quotes, double quotes, or triple quotes, right? In single quotes, like we want to create a strategy name. So what we can do, we can just write strategy name, right? It's underscore. And the same we can achieve with double quotes also. So strategy name, that also, right? And when we have multiple line of strings, right? So how we can write that? So what we will do, we will write like hello algo traders, we are here to learn algo trading, correct? And then you will close the triple quotes. So these are the various ways. And again, like why we need to use these two different type of notations, like single quote and double quote. So for example, when we have something like, let's say we are writing a string like it's a string, right? So now we know that we have a single quote outside, correct? But inside also for its we have one quote, right? One single quote. So the Python will get confused and it might select only this part, right? So in those cases, when we have a single quote already inside the string, then we have to use a double quotes, right? So in that case, you can use the double strings. So that's a basic difference. So now what I'm doing, I will quickly explain you this, then we will move to the coding part. So second, we have accessing strings, right? Accessing strings. So for example, we have a string and which is like moving crossovers strategy. Moving crossover strategy, right? So here if you think, then we can say that this m is at the index of 0, correct? And this is at the last. So now we don't know what is the index, but we know that it is at the last. So in Python, when you have a large string, so you can just simply say that the last character will be at the -1 index. So you can blindly say the first will be 0 and last will be -1. That is the indexing system of the Python, correct? So let's say now you want to access the first character of a string. So what you can do, you can just write a variable name, then you give a square bracket, okay? And inside that you write the index position of that string. Here we know that we want to access this m, right? So here I will write 0. So when I write this syntax, I will get the m. I will get the m as the output. And similarly, if I write as negative of 1, if I write negative of 1, then I will get the last character, which is s, correct? So this is called the positive indexing when we are going from left to right, and when we are going from right to left, it is known as the negative indexing, right? And this is how we can access the characters. Similarly, if you want to access O, then you will write here 1. For V, you will write here 2, correct? And similarly, when you write -1, you will get the S, and if you want to access R, you will write -2. For E, -3, V, -4, and similarly it goes up to here. So this is the positive and negative indexing. Now we go to another important concept, that is slicing, correct? So as we know, if I just write like print s, I will get this whole string, correct? And if I write like s and in square bracket, when I give the index position, I will get the single index. But what if when I want more than one characters, right? What if I want the whole string? What if I want the reverse of that string? What if I want only 3 characters of the string? But what if when I want, let's say, the initial 3 characters, the last 3 characters? So in that case, we have to apply the slicing here. So how does that work? Let me quickly remove it. So now we have this string, okay? So for slide, say, I write same s and then in the square bracket, I give 1 colon, correct? If I just give a colon without any values, it will output the whole string, okay? If I write 0 at the starting position and blank at the end position, still I will get the whole string. Now I know that you are started to getting the idea. So how to access a string in various ways. For example, if I want only this part, correct? So now I know that m is at the 0th index and this g. So 0, 0, 1, 2, 3, 4, 5, correct? It is at the 5th index. So if I want to access this particular part from the string, so what I will write here, 0 means it will 0, then this 5, right? If I write 5 here, then it will give me output up to this only, this n, correct? Because in the end position, it is always -1, correct? So you have to write +1. So we know that this is at the 5th position, so we will write +1. So here we have to write 0 to 6. So when we write 0 to 6, then we will get this whole character. Then we will get this whole moving part, right? We will just cover some examples. You will get more idea. Now there is another concept, that is step size. So in step size, what happens? You want the output in the steps. Like you want m, then you want to skip o, then you want v, then you want to skip I, then you want n, correct? Means you want this part, but in that also you don't want these characters, correct? You only want m, I, n. So how we can achieve that? As we already know, this m is at the 0th index and this g is at the 5th index, correct? So I will write like s, then the starting index, then the last index. So we have to give +1, right? I will write like this. Then I want to give steps here, like I want to skip this 1 character, so I will just write 1. So it will just skip these characters, correct? And it will give me the output as m, then v, and then n, okay? If you want to skip 2 characters, you can just give here 2. So this is how the step size works. So now let's take some example of negative indexing. So now, for example, if I want this whole string but in reverse order, so what I can do, I can simply write s And as we know that we want the whole string, so we will just leave the starting and end positions as blank. And if we simply write this, we will get the whole string, but in the normal order. But here we want in reverse order. So what we can do, we can just mention here -1. So it will give me the whole string in reverse order. Now we move to the next part, which is editing and deleting in strings. So in editing, what happens, for example, if you want to modify this string, right, this m, so what you can do, you can simply write s add 0 index, and you can make it maybe small, correct? If you want to change this one, so what you can do, you can write the s and the index position, which is 5, and if you want to make it small, so you will write like g, correct? But this will not work. This will throw an error and you should avoid it, correct? Because now you will be learning one of the most important property of string, which is immutability, You have to remember this, that Python strings are immutable. You cannot modify them. Once they are created, they are created. Then you can only delete the whole string. You cannot modify in between the string. Right? So instead of that, what you can do, if you want to delete a string, you can use the del keyword, del, and then you can write s. So it will delete the whole string, but you cannot modify a string. Now we quickly move to the screen and perform some examples. So now we quickly start the example. So first we will create a string. So how we can do that? So we'll just write a string inside a single quote or double quote. So we can write like a momentum strategy, and you can give it a identifier or variable name. So we will give it as strategy name. Okay, so when we print this strategy name, we get the results. So now if I want to access this string, so this is the first way. We just write the name of variable, it will print out the whole string. But if I just want the first character, so what can I do? So I'll just write the index position of that character. So I want to access this capital M. So I will write strategy name, then the square bracket, and then I'll mention the index position of that character. So when I hit shift enter, it gives me M. As we have already learned, if I want the last character, I'll just write -1 and it will give me the Y. And now if I want this whole momentum, okay, I think it's not correct. So I just correct it and now it's fine. So if I want this whole momentum, what we have to do, we have to count the index. So it's 0, 1, 2, 3, 4, 5, 6, 7. So it's 0 to 7, right? So if I write like this, you tell me what will be the answer. Just pause the video and write in the comment. It will test your understanding. Okay, when I hit shift enter, it gives me up to U only, because if you remember, I have explained you already, you always need to give +1 of the character you want to access. So here it is 7, but I will need to give 8 because it will not print out the last position. So when I hit shift enter, it will give me the complete momentum word. Okay, so this is the positive indexing. So if I want to access this momentum with the help of negative indexing, what I can do, I'll just count. So as we have discussed, this Y will be at -1, right? So 1, 2, 3, 4, 5, 6, 7, 8, then space 9, 10, 11, 12, 13, 14, 15, 16, 17. So it will be -17 up to here, right? So it will be again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 10, right? Up to 10. And when you write this, you will get moment. And again, as we discussed, we have to give +1. So -10 + 1 will be -9. And when you do that, you will get the whole momentum. Okay, and again, if you want the whole string as reverse, you just give 2 colons as empty and then give the step size as -1, and you will get the whole string in reverse format. And now I think that you are able to understand the power of Python. With just one line of code, we are able to reverse the whole string. But in other languages, we have to write the full code, right? And then it will reverse the string. Now we perform the adding characters to the string. As we have discussed already, that strings are immutable. So you cannot add or edit a string. Once it is created, it is created. You cannot modify that. So if you want to add, then you have to create a new string. right? For example, if I want to add here something, so what I will do, I'll just write like the new strategy name. What I will do, I will just write here the variable name, okay, and then my new character. So for example, it is latest. So for example, I have created a new strategy. I would like to give it as a new name, and then I will also have to give it a new variable name. So it will be latest, and when I hit enter and when I print this, I get the result, right? Momentum strategy latest. So here you can give a space and you will get the results. If you try to add something in between, you will not be able to, and it will throw an error, right? Let's say like this is your string, and if you want to change the value at 0, and if you try that, like let's say small m, it will throw an error that string object doesn't support item assignment because it is immutable. Okay, then we can only delete a whole string. So how we can achieve that? We can use the del character, del, and then the variable name. So when we do that, and now when I print it, it shows me name strategy is not defined, correct? Because it has been deleted. Okay, now we have the next part, which is operations on string. So now let's quickly start with the operations on string. So in this, as usual, first we will understand on the blackboard, and then we will quickly move to the Visual Studio for the coding part. Okay, so let's first see that here we have 4 type of major operations. So first are the arithmetic operations, then we have relational operations, then we have logical, loops, and membership. So in arithmetic, we only have the addition and the multiplication. Okay, in relational, all type of relational operators works on the strings, like less than, greater than, equal to, not equal to. Okay, then we have logical operations. So in that we have and, or, and not. So and, or, and not. Then loops also works on the string. And then we have the membership operations, which is like in and not in. Okay, so let's quickly understand. For example, in arithmetic, we have a string. Let's say we have a string s1 is equals to price, and s2 equals to, let's say, stop loss, right? Because that is the most important thing, right? So if I want to perform addition operation on this, which will ultimately concatenate these strings, so how I can do that? I can just write s1 plus s2. So it will give me the results as price and stop loss. Okay, this is just for the explanation purpose. We will also perform some examples, and also you can perform the multiplication. So how you can do that? For example, this is your first string, and then you are multiplying it with, let's say, 5. So what will happen? This price will be, for example, this price will be printed 5 times. Price, price, and price, and price, like this. Okay, so you can only perform the addition and the multiplication on strings. Then we have relational. So in that, all operators work. So for example, you have these two strings. Okay, and if you write like s1 is greater than s2, so you just pause the video and write down the answer, what it will be. As we have already studied that relational operators gives true or false, right? So here, when we perform this, s1 is greater than s2, then it will print out false. Why? Because here the Python comparing those strings based on ASCII standards. So like we have a dictionary. So in dictionary, whatever the words come later, it is bigger, right? So here, as we know that in alphabets, P comes before S, so P is smaller and S is greater. So that's why we are getting the value as false. So we can say that in relational operators, it is comparing as lexicographically. And then we have logical operators. It is not of that much use, but it's very interesting. And it also shows a very weird property. So how does it work? For example, we have the S1 and S2, right? And if I write S1 and S2, and then I perform and logical operation on these two strings, right? So what will happen? It will give me an output as stop loss. Now you tell me why it happens, why it behaves like this. So in order to understand that, we have to understand another concept, that is in Python logical operators we have two values, right? One is true and another is false, correct? So if any string is not empty, means if there is anything in the string, whether it's 1 character, whether it's 1000 character, or whether it's 1 million character, okay, if there is anything in the string, it becomes, so I'll write here anything, right? And then it becomes as true, correct? And if any string is empty, okay, then it becomes a false. So that's a simple idea. And now let's perform some more operations. Okay, so here, as we perform AND operation, it gives me stop loss. Why? Because it checks both the values. So first price, so price is not empty, so it is true, correct? Then it checks S2, which is also not empty, means it is also true. So in AND operation, as we know already, that both the values has to be true, then only we get the output as true. So it will be a stop loss and it will give us the last value, which is stop loss, right? If I write like here S2 and S1, then what we will get? We will get the output as price. Okay. Then let's say we are performing an OR operation here. Okay. So in OR, so it will first check the S2. So S2 has some string and so it becomes true and it will directly give us the result as stop loss. Correct. But let's say it is empty. S2 has no value, it is empty string. Then what it will do? So it will first go and check S2. S2 is empty. Then it will again check the next, which is S1, and it will give us the output as price. Right? And if I perform AND operation here, so what will happen? Let's say the output of this will be S1 is true, right? S1 is true. Then it will check the S2, which is false because this is empty. So we will get here as the value empty. It's that simple. Okay. Then the last we have is not. So in not, what happens? Not will like apply on only one. So let's say we have S1 and here we apply the not operation. Okay. So here S1 is not empty, means it is true, right? Means it is true. And as we know that not logical operation always reverses the real output. So here it is true, so it will give us as false. Correct? And if we apply the same on S2, so S2, as we know, it is empty. So in reality it is false, but as we apply the not operation, it will give us the value as true. So this is how the logical operations work. Okay. Then we have loops. So loops are very simple here. So for example, we have a string as S and Singapore. So in strings, we can even perform loop operation on strings. So how it will work? We can write a code like for I in S. Okay. And if I write like print I, then we will get the output as like S, I, N, and until S. So it can perform the loops also. So we will be performing some examples also quickly. And just let me explain you the last one, which is membership. So in membership, what happens? So like we have this S string. So if I write like N in S, so S is the string here, this one, right? So it will check whether capital N exists in this string or not. So here we can say that yes, N exists, correct? So it will give us the value as true. Similarly, if I write like small n in S, so we will get the value as false because it doesn't exist. So now let's quickly perform some examples and then we will move to the next, which is the functions on strings. So now we will quickly perform all the 4 operations. So let's say we have a string as Singapore and S2 as, let's say, India. Okay. So here, if I want to perform the addition operation, so what I'll do, I'll just like write S1 and S2. So it will give me Singapore and India. So if you want to make it a little bit more good looking, so what you can do, you can add some space. Okay, and here also plus. So here just give space and hit enter. Okay, here we have to remove this. Okay, now as you can see, we have a good looking Singapore, India, right? You can also perform some multiplication. So how we can do that? You can just give like S1 multiplied by 5. So you will get 5 times Singapore. Okay, and you can also give here space like plus space. So this is how you can get a formatted string. Okay, then we perform some relational operations. So S1, S2. So if I write like S1 is less than S2. Okay, so if I write like S1 is less than S2, so you just pause the video and so write down the answer, because it will test your understanding and it will enhance your understanding. So just check that lexicographically, means in dictionary what comes first, S or India. And when you hit shift enter, you will get the false because I comes first. So it should be like this, and then you will get the true because S comes later, and whatever the value comes later, it becomes greater. Now we can also perform the logical operations. So let's take it, let's copy and paste it here. Let's say, okay, so here if I write like S1 and S2. So again, what you do, you keep on pausing the video and write down the answer and then check your understanding. So when you hit shift enter, we get India, because in AND it checks both the values. So first is true, second is also true, and then it gives us the India. And when I write over here, so it will give us Singapore, right? Because the first string itself is true, so it doesn't need to check the next value. But if I empty this, then it will check the next value, India, and it will give us the value as India. So this is how the logical operations work. And again, like you can take not also. So in not, what happens if I write like not S1? So as S1 is empty, so it is false, but we have applied the not, so it will make it as true. Correct. So we are done with logical operation. Then we move to the loops. So loops also very easy. So let's say we have the string S2. So what I can do, I can just go and like for I in S2. Okay. And when I print I, it will print the whole string separated by a line. If I write here like Singapore, then what will be the answer? You tell me. So it will print, oh, we have to make it string. It's not a variable, right? So Singapore will be printed 5 times. So this is how loops works. It's really fantastic. It's really amazing functionality. Then we have the membership operations. So membership also very easy. We can like check the conditions. So let's say if I check whether capital I in India, so whether capital I in S2, and when we hit enter, it says true. But when I make it as small I, it is also true because we have this small I. But if I write like any other value, let's say X, then it will give us the false because it doesn't exist, right? So we are done with the operations, and you perform all the tasks, all the MCQs. And if you face any issue, just feel free to let us know. We are here to help you. Okay, so let's quickly move to the functions. So functions are also very easy. What we will do, we will just copy and paste these strings, and now we start the functions on strings. And here I have divided the functions based on their functionalities. So I have grouped them on the basis of how they works. Okay, so first set of functions is the common functions. It means these functions works on everything like strings, lists, dictionaries. So once you have a good understanding here, it will help you in the future also. So for example, we have a string as Singapore, and let's say it is S1, and S2 as India, correct? So when we apply len function, it will count the number of characters in that string. So if I apply len on S2, like len on S2, it will give us 5, correct? Similarly, if I apply on S1, then it will give us like 2, 4, 6, 8, 9. So for Singapore, we will get the value as 9. If I apply the max, so when we apply the max function, we will get the biggest value based on the ASCII characters, as we have already learned in previous section. So it will compare lexicographically, and so here when we apply, we will get the answer as S because that is the last. I guess I am correct. If not, then you can just go and check on your system. You will get the answer. So similarly for the min function, you will get the answer as A, right? Because it comes the first. Then we have sorted. So in sorted, so as we have these two strings, so first of all, what we will do, so we will make it as a one string. So let's say f friends equals to s1, then we will give some space plus s2, correct? So we will get, so what we will get, as you already know, we will get a string that is Singapore space India, correct? So now we apply all these functions on variable f, which is Singapore space India. So if I apply len here, so what it will do, so it will calculate the number of characters including the space, and it will give us the results. So what we will get when we apply the len function on the f, so f is equals to s1 plus s2, which is equal to Singapore space India. So if I apply len f, then I get the value as like 2, 4, 6, 8, 9 plus 10 space, then 12, 14 and 15. So I'll get the result as 15. Okay, then if I apply max, so in max what happens, for example, I apply like max on f, so then it will compare that string based on the ASCII standards, which is lexicographically, that we have already studied. So in that we can see that here we will get the result as s, right? Because s comes last in alphabets, so we will get the result as s. And when we apply the min, so when we apply like min on f, so we will get the result as space. So we'll get a empty string, correct? And when we apply sorted, okay, so sorted on f, so what we will get, we will get a list. So we will get a list and all these characters will be splitted and it will be sorted based on the ASCII character. So for example, this space will come first, so it will like give us result like this, then comma, and then we will get the capital. Okay, so as all are capital, so no issue. So then we will get A here, correct, based on the ASCII standards. Then we can just test on the screen. Just wait for a few minutes and I'll show you how. Let's first quickly cover all the functions. Okay, now we move to the next set of functions, which are capitalized, title, upper, lower, and swap case. So here it's also very simple. In capitalize, it will capitalize the first character. So for example, we have this string as like s3 as like this small India. Okay, and when I apply the capitalize here, so it will give me the output as capital I and then the rest. So it will just capitalize the first character. Okay, then in title we have a bigger string like Singapore plus India, then it will just capitalize the first character of every word like Singapore space India. So what it will do, it will capitalize S and I. Okay, then we have upper. So in upper, you know that it will completely capitalize the whole word. Okay, like we have a word with small I and dia, then it will reverse that. It will give us all the values as capital. Similarly, in the lower, it will make all the characters as small letters. Okay, then we have swap case. So in swap case, whatever the character is, whether it's upper, whether it's lower, it will just reverse that. So it will swap from upper to lower and lower to upper. Then we have count. So count, what it does, so it just counts the number of times any character in a single string. For example, we have a string as s1 India. So for example, if I apply count here, s1 dot count, and here let's say I say capital I, so it will give me the value as 1 because I is only one time in the India. And if I give here small n, then also we'll get the value as 1. It will count the number of times that character is in that string. Then we have find. So find will find that particular character and it will give us the index position. Similarly, that same goes for index, but in index, when the value is not there, it will give us an error. We will check shortly in the example. Then we have ends with and starts with. So if I write like s1 ends with, for example, a, small a, right? So we will get the value as true. If I write here capital A, then we will get the value as false. It is that simple. And same goes with starts with. If any word is starting with that particular character, then it will give us the true and false based on that condition. So in format, what happens? For example, I have two strings s1 and s2. S1 is equals to Singapore, s2 equals to India. For example, if I want to print out like print I will say hello, this is Kuldeep and I am from, and then I will give a placeholder for a function. Okay, and then I can write currently I am working in, then again I can give a placeholder for a function. Then I can close this print statement. So here, as this is a multi-line string, so what you can do, you can give it triple quotes and then you can close this print function. Okay, so for format you have to write a dot here next to this string dot, then you can write format. Okay, here you can pass your values, so here s2 and s1. Okay, so because of that mistake, we are able to explore one more functionality of this format. So here we can say that order matters. So whatever the order you mention here, it will be printed out like that only. And again, here also you can mention the index number. If you mention here 1 and here 0, so what will happen? So here we know that S2 is 0 and S1 is 1. So here it will be printed out as S1. So it will be like, hello, this is Kuldeep and I am from, S1 is Singapore and currently I'm working in India. Okay, so we can say order matters here. Then we have is elnum, is alpha, is digit, is identifier. In elnum what happens? It checks whether it's alphanumeric value, and in is alpha it checks whether it is an alphabet. In digit it checks just for the digit, and in identifier it checks for a correct identifier, like it should not start with any other special character except the underscore. We will just test these functions on the code also, so just wait a minute. We are just left with 3 functions, and now we have split. So split, what it does, it split any character or any word into a list, and it can also split based on the character you mentioned. Like, so by default, if you apply split on any string, it will just split based on the spaces. So for example, we have a string like that, hello, this is Kuldeep and currently I'm working in Singapore. So it will split based on these spaces, and it will give me a list, and all those words inside the string will be given as separate indexes. Then join is inverse of the split. Okay, and replace, we can replace a character, and in strip is very important and you will be using it a lot. So how it works, for example, we have a string Kuldeep. Okay, and by mistake, for any kind of reason, there was some space added in my string, so like Kuldeep becomes like this. Okay, so the real value is this and this all is space. So what it will do, when we apply strip on this, it will remove all the trailing spaces, whether it's in front or back. It will remove all the trailing spaces and it will give us a clean value. Sometimes it's very useful while user is inputting a value and you want to store that value in the database. So sometimes what happens, if the user's keyboard is not working fine, then it might happen that they enter some unnecessary value in that, and so it might happen that they are inputting some unnecessary value and we don't want to store that value in the database, so we just want to store the clean value. So here you can use the strip function. Okay, now let's quickly move to the screen and perform some examples. So let's quickly start the example. So as we have S1 as, you can say, Singapore, then S2 is equals to, and S2 is equals to India. Okay, so if I want to apply the len function, so what I can do, I can apply len on S1, and when we hit shift enter, we get the value as 9, and when I apply same on S2, we get 5. Correct? So now we have the max. So when we apply max on, let's say, when we apply max on S1, we will get the value as R, because in ASCII characters, let me show you quickly how it works. So let me open the Google, and in Google ASCII table, and Okay, so for example, here you can see that we have this ASCII table. In this, first the decimal values hold the priority, then we have the hex values, and then we have the characters. So in characters also, first the capital characters. So in characters also, first we have the capital and then the small. So whatever that comes last, it is bigger. You can also have some look and you can perform some operations and you will be good to go. Okay, so that's why here when we apply the max on S1, this R comes the last, right? Because that is a small. Then again, when we apply minimum on this, so in minimum it will give us the smallest value based on the ASCII characters. So when you hit shift enter, so you get the value as capital S, right? Then in sorted, it will sort the values and give us a list. So you can see based on the ASCII characters, it has sorted and given us a list. So it's very useful a lot of times. Then we move to the next. So we will just copy and paste these here, and here it's already capitalized. So we'll make it smaller first. And okay, so let's say now I'm applying capitalize on S1. So it will just give me the value with only the first letter capitalized, right? And when I apply the title, so title, what it does, for example, we have combined this S1 with S2. Okay, and when we apply the title on the F, so what will happen? F dot title. So what it will do, as we have learned already, that it will capitalize the first. So it will capitalize the first character of each word. Okay, then uppercase all the letters. So you can see, then the lowercase all the letters, Singapore, India. So in swap case, what will happen? It will swap all the values. It's like understood, right? So you can see here that these all values were smaller, so it has made them capital. Let's make it like this. It's capital, and then it's also capital. When I hit shift enter, so now when I apply the swap case, you can see the results. So this is how it works. And now we move to the count and find. So here I can take this also, maybe useful. Okay, now we have this. When I hit shift enter, now we apply the count on this. So f dot count. Okay, we have to give any character here, right? So let's say I give, okay, let me first print the value of f also here, so it's better for your understanding. So here we know that the f is equals to Singapore space India, and when I check here that how many times the I comes in this sentence, it will show us that only 2 times, because one is this I and second is this I, right? The small I only. And similarly, you can check for capital I also. When you hit shift enter, it's only 1 time, right? And if you apply any other value, then you get 0, right? Then we have the next function as find. It's also similar. It will give us the index position of that character. So when you hit shift enter, and when that character is not existing in that word, it will give us -1. And if it is existing, then it will give the first occurrence. So here you can see that I comes at the index position 1, because S is 0 and I is 1. And now we have index. So basically find and index are same. They works exactly the same, except for one thing, that is if that character is not existing, then it will not throw any error. But in index, if that value is existing, then it's fine. It's same like find. But if that value is not existing, it will give us an error. So when I check for capital S, it gives me 0. But if I apply here the small s, it throws an error, because that substring not found in that particular string. Now we have the ends with and starts with. So we just copy and paste same thing here, and let's check. So f dot ends with. So okay, let's first print this. Okay, let's print f. Let's print f, and now check that whether f ends with What is the last character? A. So we check whether f ends with a, that is true. And if I change the value to any other character, let's say s, then it will give us the false, because this string doesn't ends with the s. Okay, same you can check with starts with. So if the Singapore is starting with capital S, but if you give small s, it will give us the false value. But if you make it capital S, it gives us the true value. Okay, so this is how it works. So now we move to the next function, which is format. So format is very useful. You will be using it a lot. So how does this work? For example, if I want to print like print hello world, this is Kuldeep and I am from, okay, so here I will give a placeholder for a function. Okay, then what I will write, hello world, this is Kuldeep and I am from placeholder, and currently I am working in, again, a placeholder. Okay, now you have to apply here the format function. Okay, so format, then here you have to provide some parameters. So as we know that Singapore is S1 and India is S2, so what I can do, I can give here first the S1 and then S2. First the S1 then S2. Okay, and let me make it a little bit smaller. Now it's fine, I guess. So now when I hit shift enter, I get the value as hello world, this is Kuldeep and I am from Singapore and currently I am working in India. So here we have made a mistake. Why? Because I am from India and currently I'm working in Singapore. So what you can do, you can just make some changes here or here. You have like multiple options. So that's the benefit of format. So here we know that S1 is equals to Singapore and S2 equals to India. And S1 is at the index position 0 and S2 at the index position 1. But what I want here India, which is S2. So what I can do, I can make it 1 and here 0. And when I hit shift enter, I get the right value. That is, I am from India and currently I am working in Singapore. So what you understood now, that order matters in format function. Okay, otherwise what could you have done? You could have just changed these, like you could have just changed this. Okay, when you hit shift enter, still we get the same desired output. So this is how powerful the format function is. You can use it in multiple ways. Okay, now we move to the next function, which is alnum. So what we will do, we will again paste the values here. Okay, so these four functions is alnum, is alpha, is digit, or is identifier. So is alnum checks whether this string is alphanumeric, and this is alpha check whether it's alphabetic, or is digit checks whether this is a digit, and is identifiers checks whether this is a correct identifier, right? So let's quickly take an example. First we check for the S1 and we apply is, okay, let's make it 1 2 3. Okay, so and percentage. So S1 is alphanumeric, S2 is alphabets only, and S3, we give a 1 2 3. Okay, so let's quickly make this S1 as alphanumeric. So we'll just add 1 2 3 here, or when we hit shift enter, and now we check whether S1 is alphanumeric. So L, okay, is alnum, right? Is alnum, and when you hit enter, it is true, right? Now we check for the S2 whether it is alpha. When you hit shift enter, it gives us true. But if you check this, that if it is digit, then it will give us false because it is not digit. And now you can check for S3. So in S3 is only digit. So you check here, S3 is digit. And when we hit shift enter, yes, it is. And if I check it as is alpha, and when I hit shift enter, it gives me the false value. So this is how you can use these functions, useful sometimes. Then we have split and join. So I'll quickly copy and paste these here. Okay, so first let's check for, I'll copy and paste this also here, f s1 s2, and let's add it here also. Okay, s3 also. So when I hit shift enter and when I print f, we get the value as Singapore India 123. Okay, so now let's apply the split function here. So f dot split, and when I hit shift enter, I get a list with the sentence splitted based on the space. Okay, so it just detect the space and then it's make it a separate item in a list. So we get a list, right? The interesting thing about this function that you can mention anything here. Like if you mention that I want to split a string based on I. So if I write I, then it will find I and it will split from that character. So you can see here it was S, it has removed S and it has split it. Then again, here it was I. So one list item is this, second is until this, and third is until this. So this is how we can use that. And now let's take an example for join. So let's say we have a list which contains these items and I want a single string. So what I can do, I can just write like space dot join, and I can give this list inside that function. So like this. So you can see that we have joined that list and this is the output of that. So like you can perform many operations on this. Make sure that you are practicing the MCQs and also the project on each and every session. So by the end of this course, you will be having a set of 100 mini projects. And you think that if you follow along with me, then how much powerful you will be after 100 days. Okay, now we quickly move to the next function, which is replace. So here what you can do. So first you can print out this, and now let's say you want to replace 1 2 3. So what you can do, you can write 1 2 3, okay, and then give a comma, and here you write a string. For example, Singapore, India are really close friends. When you hit shift enter, you get the output that this 1 2 3 has been replaced with this string, are really close friends. That's how simple it is. Now we move to the next part, which is strip. For example, here by mistake my keyboard was not working fine and I have given some spaces, okay, before Singapore and after Singapore. And India also same, like this. Okay, and 1 2 3 also like same, I have given a lot of spaces. Okay, and when I hit shift enter, I get the value like this. You can see, right, the space, again a lot of space. But in real life, when you are taking inputs from user, so many times the user makes mistakes, but you don't want to include those spaces in your database. So what you can do, you can quickly apply strip function on those inputs, and then you can get a clean input and then you can store that in your database. So what we can do, we can just apply s1 dot strip. Okay, when you hit shift enter, you get a clean Singapore, right? Similarly, it goes for these also, s2 and s3. So now we are done with the strings. So in this session, first we will cover the introduction, then we'll compare the list with the arrays, and then we will see how lists are stored in the memory, right? Then the characteristics of Python list, and then we will see some examples with all the operations, and last but not the least, disadvantages of the Python list. Okay. So now we quickly understand what are the lists. So list is a data type where you can store multiple items under one name. Okay, I'll just quickly explain how. Then more technically, lists act like dynamic arrays, which means you can add more items on the fly. Then we'll understand why lists are required in programming. Okay, so let's create an example of list. So let's say we have a list which contains the details of any trade. So we will name it as trade logs. Okay, this is hyphen. So in that list, we have, let's say, the opening price, then a string. So the name of the stock, Apple, correct? Then we can say the selling price. Okay, so it could be 110.6, which is a float, and then let's say we have a boolean value, so which can be true, right? For example, if the buy was true or false, so it can be true. So this is integer, this is string, this is float, and this is a boolean value. And this list is able to store all those data types, right? So which makes it so flexible and so adaptable. Okay, now let's compare the list with arrays. So let's say we create a table. Okay, so the first is for arrays and this is for the list. Okay, then now let's compare it. Okay, so the first point is fixed versus dynamic. Why? Because when we create an array, so how do we do that? We have to give the size beforehand. For example, let's say you are creating an array of int and the size is 50. So here you have to mention that we will be creating an array with the size 50. Means it is fixed, correct? We can say it is fixed. But in list, you don't have to do that. You can create an empty list or you can create a list which consists multiple values. There is no restriction like that. Then the second point is the arrays are homogeneous. Means these can store only one data type. So here we know that this is integer. If we want an array with a string values, then we have to create another array. Similarly for float and so on and so forth. So means these are homogeneous. The second difference is these are homogeneous. But in list, you can store all data types, right? As we have seen in this example. So let me quickly copy and paste this one. So this is the second point, correct? So I can write it second point. These are homogeneous and lists are heterogeneous because these can store integer value, these can store string also, we have float and we have boolean values. So there is no restriction like that. So yes, the lists have these two benefits for sure, but the benefit comes with some disadvantages. And what are those? Let me quickly give this a green color. So we can say these are the pros, we can say, correct? And now let's we go for some cons. Okay, so in cons we have the third is the speed of execution. The speed of execution. So here the arrays are fast, but lists are slow in terms of speed. And then fourth point is memory size. So arrays occupy less size, whereas lists occupy more sizes. So we will just understand these 4 points with an example right now. So for that, we need to understand how arrays get stored in the memory. Okay, so let's create an array. For example, int array 50. Correct? Here I want to store these values 1, 2, 3. So how does it work? So in a memory, we have a continuous memory block 1, 2, 3 and up to 50, right? And if I want to store these values, what will happen? This 1 will come here, 2 will here and 3 here. So here also these are the binary patterns. So it will not store in the decimal, it will store in the binary value, and the bits depends on the binary pattern. So it may be like 0, 0, 1, and then the next, the 4 will be of 1. Okay, and here it will start with the 2. Okay, and so on so forth. It will store the values. Okay, and again, if someone asks what is the memory address of the arrays, okay, so what it will be? It will be the memory address of the first item, which is 1, right? So whatever the memory address of 1 will be the memory address of array. So this is how the arrays get stored. Okay, now we have to understand the list also, right? So in list, what happens? Let's take the same example. I want to store 1, 2, 3 in a list. So how does it work? So what will happen? This one will get stored somewhere in the memory, and let's say the address of that memory place is 500. Again, this one is getting stored somewhere, and this 2 and the memory address is 600, and this 3 is getting stored somewhere and the address is 700. Okay, now what will happen in the list? These addresses will get stored. Okay, here it will be 500, here it will be, let's say, 600, and here it will be 700. correct? And those address will have their own addresses. So let's say it has 1000, this has 1001, and this is 1002. This is just for example. So now we can say that in the list we are not storing the actual value, we are storing the memory address of those values, right? So here a new term comes, which is referential array, or you can say pointer address, right? So here we are storing the reference of that actual value. So now when you compare, so now you can say whenever you want to fetch the values from the array, you can directly fetch the value by just giving the address. So it is definitely fast. But in arrays, first you have to call this memory address of the address, right? First stage, then this address will call this address, second stage, and then this address will fetch the value. So it becomes a multi-stage process. So definitely it will be slower than the arrays. And again, the fourth point also is true here, because we are storing two values here. So definitely it will be bigger in the size, right? Slower and bigger. It will occupy more space, right? And arrays will occupy less space. So yeah, we can say that lists are powerful, flexible, but comes with some disadvantages. We will learn in the future that how we are able to mitigate these issues with the help of some libraries. And let me also prove this point to you with the help of some example. So let's quickly move to the screen and let me show you how it works. For example, we have a list, and let's say it is the trade logs. Okay. And here I'll give the values. So let's say the buying price 100. Then let's say the name of the stock, it was, let's say, BTC. And then the selling price, so it could be 1110.9. Then a boolean value, so it will be true, right? So we can store multiple values, and when I print it out, it will give me the list. But what I'm trying to say here, that when we want to check the address, so what we can do, you can just use the function id, right? So when you apply id here, and when you hit enter, you will see that you have the address, right? This is the memory address. So I will print this. So first I am printing the memory address of the whole list. Okay. So when I hit shift enter, it gives me the address. Then let's say I'll print the addresses of the list values. Okay. So 1, 2, 3, 4. And the first will be this 0, this 0 index. So it will be 100. Okay. I'll just copy and paste these values also. Okay. Then second, third. Here I'll change the values 1. Then it will become 2. It will be 3, right? So 0 is 100, 1 is BTC, 2 is 110, and 3 is true, right? So when I hit shift enter, it gives me a few values. You can see the last is 5184 for the whole list. Then these are the values for each objects. So now what I will do, I'll just copy and paste these values and paste here. So here, instead of the index, we will just take the values. Okay. So here I'll paste the 100. And next I'll paste the BTC string. And then we can copy and paste the float. And last we have the Boolean value. Now what we want to do, we want to check the memory address of these variables and the values. Okay. So when I hit shift enter, so now when you check that the memory address of this float 110.9, here you can see it is different. Okay. 5424, and here we have 7984. Here the memory address is different because the Python uses a technique which is known as the string interning. Okay, and that is out of the scope for now. If you want to explore more, you can go and Google. But now let's understand that because of the string interning, the address is different. Okay, it's only for the floats. Okay, then we have again the 352 boolean, which is equal to 352, right? So now we can conclude that in list we are storing the memory address of the values, not the actual values, right? So this is how it works. Now we quickly understand some concepts, and then we will jump on the examples. So now generally we have three types of list. So one is 1D. So how does it work? So for example, we have a list which contains the trade prices. So 100 and then 110, 120. Okay, and again we have another 1D list which has all the logs of the trade. So for example, we bought the stock at 100 and it was a buy position, and we can also store that we sold it at 120.5. okay, and then also we can say yes, it was a profitable trade, so we can store a boolean value, right? And so here you know that we have an integer here, then we have a string, then we have a float, and we have a boolean value, correct? So the difference between these two lists, that we can say that this is a homogeneous list and this is a heterogeneous list. That is the basic difference. Okay, now we quickly move to the 2D list. So in 2D list, we have a list inside a list. So for example, we can take the same example, this one, and let me quickly copy and okay. So as we already have a list, okay, and we can say we have another list. So let's say we have these values 2 and 3 and 4. So what we can say here, this is the main list, right? This is the outer list, correct? This one, and inside that we have 4 values of this list. So first value is this, which itself is a list. Second value is 2, third value is 3, and fourth value is 4. Let's say the identifier of this list is L. So you can say this is at 0 index L0, this is at the index 1, this element is at the index 2, and this is at the L3. Now you just pause the video and answer me this question, that whether this list is a homogeneous list or a heterogeneous list. Let me give you the answer. So here, as we know that we have 4 elements, correct? Out of 4, these 3 are integers, correct? Out of 4, these 3 are integers. This also integer, this is also integer, this is also an integer. But this element is a list, and list itself is a different data type, correct? We can say this is a heterogeneous list, correct? I think it should be clear now, and I'll also add some multiple choice questions and tasks. So once you attempt those, you will be good to go. Now we have the 3D list. Similarly, it's also not different. First we have this list, which is a 2D list. So we will just copy and paste that. So let's say this is 100 and 120. This is a 1D list, correct? And that list is inside another list. So this becomes a 2D list, correct? Now when we say about 3D list, so we can say that we have a list of lists, right? So here we have another 2D list. So for example, which contains some other values. So let's say we have some strings here. So we can say it was a buy. Okay. Again, some float values, 2, and I'll close this, and some elements here, right? So 4 and 5. So this is 2D itself, correct? This one is 2D, and when I close this, it becomes a 3D list. So the outer list is this one, correct? This one, and then we have this list. Then actually I forgot this. So then we have this one, correct? This. So this is the second. This is the outer list. So first list. This is second list, and now this one is inside that. So this one is a third list. So we have 3 lists, and it is the 3D list. Like we can have more dimensions, 4D, 5D also, but for now I think 3D is enough for you. And you can also identify the list with the number of opening brackets or closing brackets. So here you can clearly see that we have 3 opening brackets, and also the closing brackets are also 3. So you can think like that also. Here 2 brackets, and here is only 1 bracket. So this is how this works. And now you tell me that whether this list is homogeneous or heterogeneous. This is the outer list, correct? This one. In that we have 2 elements. First is this element and another is this element, right? So this outer list has 2 elements. This outer 3D list has 2 items, which are a 2D list, and this 2D list has 4 items. So one is a 1D list and another are the integers. Similarly, this also has 3 items. This one is a 1D list and these are the integers. When we ask that whether the outer list 3D is homogeneous or heterogeneous, we can clearly say that this is a homogeneous list. Why? Because it has only 2 elements and both are the list. And you know that when we have same data type, it becomes a homogeneous. So these were the explanation of homogeneous, heterogeneous, 1D, 2D, and 3D list. Now I will quickly explain you how to access these items and how to add some items in a list. Okay, so first we'll quickly see here, then we will move to the examples. Okay, so for example, you have a list. Okay, I'll write it here, accessing items. So accessing. So generally, we can access any item of the list with the three ways. The first is positive indexing. Second is negative indexing. And the last is slicing. Correct? How does this positive indexing works? So for example, we have a list as trade logs, correct, which have the items. Let's say it was the opening price, then it has the name of that stock, so Apple, then it has the selling price, which is, let's say, 109.2, and we have a boolean value which is true. So here we can say this is a 1D homogeneous list, right? Now how do we access this with the help of positive indexing? So now what you can do to access these items from the list with the positive indexing, you can write the code like trade logs, and if you want to access this value, this is at the 0 index, correct? This is at 1, at 2, at 3. So if you want to access the first value, you have to write 0. Correct? Similarly, if you want to access the last item, you have to write 3 here. It will give you the boolean value true. This is simply the positive indexing. Similarly, we have the negative indexing. So what you will do, you will write as trade logs. Then you will give, and as we know that in negative, this is the value -1, this is -2, this is -3, and this is -4, right? So if you want to access this value, the last value, you have to write -1, correct? When you are using negative indexing. Similarly, you can access these value with the help of negative indexing, correct? Hope you are getting the idea. If yes, then please let me know that what improvements do you need. Then we have the slicing. Slicing is also very easy. In slicing, what happens? Let's say you just want these two values, correct? So what you can do, you can just write the code like trade logs, then it is at the index 0, right? So you will write 0 up to 1. So as we have already learned that whenever you write here, you have to write +1. So here we want the 1 index, so we will write 2, correct? So it will give us these two values. We will just see in the examples also, but for now you just understand the concept, okay? And here also you can use the step size. So for example, you want to access the whole list, but only with the indexes at the odd places. So you want only these values 1 and 3, correct? These are at the odd indexes. So what you can do in slicing, you can write like trade logs, then 0 to means 0 to last, right? So you just write like this and it will give you the whole list, but with the step size. So you will give here the step size, which is 2. So what it will do, it will first print out this value, then it will print out this value, and if you have more values, then it will print out like this 5, 7, 9, and that's how you can use the step size. Same goes for the negative indexing. So for that you can write like trade logs, and if you want the numbers from like Apple to true, so you know that this is -3, so you will write -3 up to the boolean value, so it will be -1, correct? But if you write -1, it will not print out that, so you just leave that. So it will give you the value from -3 to -1. So this is how it works, and we will quickly see example after this explanation. So now we have one small concept, that is adding items to the list, right? So I'll write like this, adding items, okay? So for that we have 3 functions. One is append, second is extend, and third is insert. That's it. So how does these functions work? Let's say we have this list and we want to append one item into the list. So whenever you want to append a single item, so you can write here a single item, you have to use this append. But whenever you want to extend the list, for example, you have to add the multiple values 1, 2, 3 here, you have to use the extend function. This append will only add one value and this extend will add multiple values. So with the help of this insert function, we can add any item at the desired index. For example, if I want to insert a value at this index, this is between 0 and 1 index. So I can use here insert, let's say insert at one position, I'll insert 200. So what we will get the new list, and that list will be having 200 at the index 1. Okay, so that's how it works. And now we will jump to the example, so you will be having a good understanding. Okay. Now, as we have already understood the concept of list in detail, so we will quickly move to the examples and we'll finish it off. So first, I'll copy and paste this list. Here you can clearly see that this is a heterogeneous list. Why? Because you can see this 100 is an integer, this BTC is a string, this is a float, and this is a Boolean value. And when we have different types of data in our list, we call it as a heterogeneous list. But what if you want to make it as a homogeneous? You have multiple options. You can make all these list items as a single data type. And how you can achieve that? You can just make it a string, this also a string, and this Boolean also a string. So once you have done that, you have made a homogeneous list. Similarly, for 2D, you have a list inside a list. So let me take this example here and I'll print it here. And what I'll do, I'll add an outer list here like this. And I'll add few more items. So now we know that this is a heterogeneous list. Why? Because the first element of this list is a list, and the second element is an integer, and third is also an integer. So it becomes a heterogeneous 2D list. Correct? You can also count the opening brackets, which is 2. And so that's why we call it as a 2D list. Similarly, you can make a homogeneous list out of this. And now we quickly move to the 3D list. So in 3D, what you can do, you know that this is a 2D list, right? So we will add another outer list here like this. Okay. And then also in the second element, I will copy and paste this exact that 2D list here. So it becomes a 3D list, right? So we know that the outer one is 3D and inside we have two 2D lists. So it becomes a homogeneous list because this 3D list contains two items and both these items are a 2D list. So when we have same data type, it becomes a homogeneous. Similarly, you can make a heterogeneous. It's very easy. So now we have type conversion. So what we can do here, we can convert any string or any other data type into a list. So how we can achieve that? For example, first we have a string here. So what I'll do, I'll just print it. So when we see that this is a string, and you can even check the type of this. So it will show that it is a string, right? Now, if you want to convert this string into a list, how you can achieve that? You will just write list and pass a function and then the list symbol. Then you will insert that particular string inside this. Okay. And when you hit shift enter, you will get a list here. You can even check the type of this. When you check the type, this is a list, right? So this is how you can use the type conversion. It will be very useful in your upcoming projects or the questions. So now let's understand how to access items from a list. We have three options. One is positive indexing, another is negative indexing, and then we have slicing. Let's quickly go through the examples. So let's say we have this one, right? So what we can do when we print the whole list, it will give us this output, right? But we know that this is a 2D list and this one is the first item. That means at the 0 index, correct? Then we have 200, which is an integer, and then we have 300, which is also an integer. So 0, 1, 2. So if I want this whole list, so what I can do, I can give here the 0, right? The 0th index position. And when I hit enter, I will get the first item, which is a list. But if I want the BTC value from that, So we know that this is also a list, and when we want to access an item from a list, we have to give the position of the index. So here the BTC is at the index number 1. So again we will mention the 1 here, and then we can get the BTC string, correct? So that's how we use the positive indexing. Similarly, if I want the same results with the negative indexing, so how we can achieve that? So for that, what we can do, we can quickly write here the same thing, and now let's remove. Okay, so now let's achieve the same results with the negative indexing. So what we can do, we know that this 300 is at the -1 position, right? So -1, -2, and -3. So we have to provide here the -3. So when we hit shift enter, we get this item, which is a list, but our desired result is this BTC, correct? So we know that inside this list, this is at which position? -1, -2, and -3. Same, right? So when I give here -3, I'll get the same result, right? With the positive indexing and then with the negative indexing. Now we move to the slicing. So how we can use slicing here? So if you have understood correct the strings, it is exactly the same. The indexing, positive, negative, and slicing, it's exactly the same. So that is the benefit of the Python, because everything in Python is very consistent. So if you learn one thing correctly, it will definitely help you in another things. So that's why I always say your fundamentals should be very strong, because the devil is in the details, right? So for that, what you can do, let's say we have the same list here, and I'll just comment these out so these doesn't bother us. Okay, so for slicing, let's say you want only these 2 items, right? So what you can do, you can print trade logs, and you want only these 2 items, 0 and 1. So what you can do, you can give here a slice. First is the starting position, which is 0, and then you also want this 200, right? So what you can do, you can give here 2, because you have to give +1 index, right? So when you hit enter, you will get both these values, right? 200 and this first list. Now the same thing can be achieved with the negative slicing. So what you can do, you can print it here, and we know that we want these values. So this will be -1, -2, and -3. So we can put it here -3 up to -2, correct? But we need to add +1. So what we will do, we will add -1 and we get the same results, correct? So these are very basic, and if you attempt some questions, it will be very easy for you. So just go and attempt all the MCQs and all the tasks and then mini project. Now we move to the next topic, which is adding items in the list. We have 3 options here: append, extend, and insert. So first we check the append here. So let's say we have this list here, which is a 2D list. Let's say we have this list and I want to append a single item. As we have already discussed this topic in the starting, so if you're getting any issue, just go to the start and watch it again. Okay, so what we can do here, I want to add let's say trade logs dot append. Okay, so I'll give here any string, let's say let's give my name here, and when I print the trade logs, I'll get the Kuldeep appended at the last. So by default, this append function adds a single item at the last. Okay, similarly, the extend function can be used to add multiple items in a list. For example, you have the same list again and you want to add another list. So what you can do, let's say you have a list with the name by condition, right? For example, and there you can say that a by parameter string, then a boolean, which is true, and let's say you have float, which can be a price, so 112.8. So now you want to extend the original list with this second list. So what you can do, you can just apply the function extend. So trade logs dot extend, and here you can give this list, right? And when you print the trade logs again, you will get a new list with the values appended. But here is a catch. You have to make sure that append is used only for a single item and extend is used only for multiple items. So if you get confused and instead of giving multiple values here, you just give a string here. So for example, instead of multiple values, you have given a single string here. So now pause the video and let me know the answer in the comments. I'll just wait for a few seconds. Okay, let me show you. When I hit shift enter, I get the values like this. So what we can conclude that extend has an inherent property which always adds multiple items to a list. Okay. Similarly, this can happen to append also. So here, instead of a single string, you are providing multiple values, right? So let's say we are adding this list again here. So what I'll do, I'll just provide here a list instead of a string. And when I hit Shift Enter, you will get a new list like this. So you can see that only one item has been added into that list, and that whole item is itself another list. So that's how append and extend works. Please practice these. These are very basic but very important. Okay. Then we have insert function. So with the help of insert function, you can add an item at your desired index position. So how it works, let's say you want to add another string at the index position 1. Currently, BTC is at the index position 1, but you want another item. It can be a string, list, anything. So let's say I want to add at tradelogs.insert, and so here you have to first give the index position. So I'll be giving 1, and then I want to add ETH. Okay. So when I print this list, it will give me a new list and it will look like this. Correct. So what if I wanted to add something here? Here we know that this whole list at the 0 index, 0, 1, 2. So at the 1 index, it was 200. So what we did, ETH has been added to this position and we have given a new list. So with this mistake, we have another very interesting concept, that is, what if I wanted to insert an item in a 2D list? So let's say here we want to insert this ETH. So with this way, we cannot achieve that, right? We think that it will be added in the first list. So for that, what we need to do, we need to access this item first. So for that, you will add 0 here. And when you hit Shift Enter, you will get the desired results. So this is how it works, and you have to attempt some questions, then only you'll be able to grasp the concept. So now we move to the next concept, which is editing item in a list. We have already done the adding of item is also an editing. So here we will see editing with indexing and editing with slicing. So let's take this same list again. Okay, let's say I want to edit this value, correct, 200, and I want Ethereum here. So what I can do, we know that this is the item of the outer list, right? And this is at the index 1. So what we can do, we can simply write trade logs, and then you have to give the index position 1 and just provide ETH. And when you print this again, you will get ETH at the place of 200. So what if I wanted XRP at the place of BTC? So for that, what you can do, first you will access the first item, correct? So it will be accessed. Then again, you will access this BTC, which is at the index 1. Then you can give here the XRP, correct? And when you print this list, you will get XRP at the position of BTC. So that's how the editing with indexing works. Then we move to the next, which is slicing. So for slicing, what you can do, I'll just comment these values because this might create problem. Slicing is simple. We have already done in the indexing. So let's say you want to change all these 4 values, correct? So what we can do, first we will access the first item, which is 0. So we'll be able to enter in this list. Then here we can give an index. So it will be the whole list, right? So you can just give a single column and then equals to, and now you can give your values. So it will be a list. So I'll give 300, and then at the place of BTC, I can give, let's say, XRP. Then at 1110, I'll give 120, and at true, I'll give false. Okay. And then I'll just print this list. So I'll get the values as 300, XRP, 120, and false. So this is how you can use slicing while editing. Then we have the next topic, which is deleting items from a list. So here we know that we can edit, we can delete the items from a list because lists are mutable, whereas strings are immutable. We cannot make changes in the strings. But as we know that lists are very flexible, so we can edit any item on the list. So if I want to delete a list, so what you can do, you can first, I'll print the list. So here you can see we have the, let me remove this, let me copy this one. So let's say I have this list and I'll print it first. So print and trade logs. So here we get the whole list. But if I delete the list, delete and trade logs, and when I again print it, it will throw me an error, right? Because it is not existing, it has been deleted. So that's how the delete works. And if you want, you can use indexing also here. So I'll just comment these out, and I'll copy and paste this list here. And here I just want to remove, let's say, this value 200. So what I can do, I can give delete and trade logs and the index position, which is 1, right? And when I again print this trade logs, you can see that 200 has been removed. Similarly, we have slicing, so that's also very easy. So for slicing, what we can do, we will remove these BTC and 1109. So del, then trade logs. First, we will access the first list, then we will give the index position. So from 1, because BTC is at the index position 1, from 1 to 3, right? Because we have to give +1. So when we print this, we have to remove this. So we get the value as, because these values has been removed. Now we have removed pop and clear. So these also have some interesting functions. So let's learn them one by one. So in remove, what happens? You can remove any item with the value. So let's say here we don't have the index position. So what you can do, you can just give the value here. So trade logs, remove, and let's say I don't want this value 300. So you can just give here 300, and then you can print this list again, and you can see that 300 has been removed. But what if you wanted to remove this BTC? So for that, what you can do, first you have to access this list, so which is at the 0th index. So here I'll give the index 0. Then here I can give a string, which is BTC. And when you hit shift enter, you can see that BTC has been removed. So this is how remove works. Generally, it is used when you have dynamic data. So in trading, the data is always dynamic, and you want that some kind of stock name or some kind of price you don't want to trade, you can just mention here and you can make it work, correct? So now we have pop. So for pop, by default, it removes the last item in a list. So if you just write trade, and if you don't give any index here, so it will remove the last item of a list. So when you print it again, you can see that 300 has been removed. But if you give an index position, let's say we want to remove this true here, right? So first we will access this list, then I can give the index position of this. So it is 0, 1, 2, 3. And when I give 3 here, you can see that true has been removed. You can also use the negative indexing here. So you can just give -1. For that also, you will get the same results. Clear. Now we have clear. So for clear, it's very simple. You can clear a list, means you can clear the items of a list. Instead of deleting, you can just make a list empty. So let's say we have this list, and first I'll print the list. Okay. Then I'll apply the clear function on the list. So clear, and then again I'll print that list. So trade logs. Okay, now it is printing, correct? Let me give here a print, and because if you don't give print, it will print out the last value. So that is important to apply. Okay, now you can see that first it printed the list with the values, but when we clear, it is giving us an empty list. So this is how clear works, and these all functions are very useful. You just practice few questions and you are good to go. Now we have the operations on lists. So we have 3 operations: arithmetic, membership, and loop. And these are exactly the same which we have learned in the strings. So let's quickly understand them. So for arithmetic, okay, let's copy and paste this list here. Okay. So in arithmetic, we have only 2 operations: addition and multiplication, correct? So let's say we have another list, and the name of that list is stock details, and let's give it the value 100 and 120. Now if you want to use the addition operation here, so what you can do, you can create a new list equals to trade logs plus stock details. And when you print the new list, it will be printed out, and you can see that it has been merged, or you can say it has been concatenated, correct? And for the multiplication, that's also very simple. Like you have this list here, and let me just comment this out. Like you have this list, and when you apply the multiplication, okay, so you will get the same value multiplied. So we have one list, and when we multiply it, so you will get two values. So if you want the same list like 10 times, 20 times, you can do that. Like this is one of the use case of the multiplication. Sometimes it's also used. Then we have loops. So in loops, let's say we have again the same list, and what we can do here, let's say we apply a for loop. So for I in trade logs, and we can print I here. So it will print out all the items, and here we know that this list is also an item, so it will print it as a single value, correct? But if you want to print these values also, you can apply another function inside this, and you can do that, correct? So for example, for trade logs, and you will give an index of 0, and when you print that, you will get all the values inside this first list. This is how the loops works in list. Now we have some functions. Basically, we have covered most of the functions already, but there are few functions which are also used in the list. So let's take them one by one quickly. With the help of length function, what you can do, let's say len, and then you give a list. So the len function will print out the total number of items inside that list. So when we hit shift enter, it will give us 3 because 1, 2, 3, right? Similarly for the minimum, when you apply this minimum function here, it says not supported between instances of, okay, so yeah, it's also a good idea, because here we know that this minimum max works only on the homogeneous list. So here we know that this is a list and these are integers, so it will not work here. For that, you have to take another list, and let's say we have this list, and I'll remove this, and now it becomes a homogeneous because all are integers. And when I apply minimum here, it will give me 100, and same goes for the max also. So it will give me the max, right? 300. Sorted. So for sorted, it will just sort the values inside a list. So when you apply this, you will get all the values sorted. So by default, it sorts in ascending position, but you can make that reverse by applying the reverse equals to true, right? So when you give this, you will get the values in descending order, correct? Then we have the count. So in count, what happens? Let's say we have this list, and we have multiple values. So I'll just give a comma here, and okay, so we have 100 4 times, like we have all these values 4 times. So when I apply the count function here, trade logs dot count, and I'll just give a value 100. So the count function will give us the number of times that item exists in the list, right? So we know that 100 exists 4 times. So 1, 2, 3, 4, right? Then we have the reverse. So reverse is also very interesting. So what you can do, you can just apply the reverse function here. Trade logs dot reverse. So when you apply reverse function, you have to be very careful because it permanently reverses the value. So when you hit shift enter, it doesn't give any output. So in Python, there is a thumb rule that if you don't get any output after applying any function, that means that that thing has been applied permanently. So you have to be very careful before applying this reverse function. And now when you check the trade logs, you can see that it has been reversed, that too permanently, correct? But we had the sorted, it was just doing that temporarily, right? But the reverse function reverse the items permanently. So make sure that you know that. Same thing goes with the sort. Okay, now we have another function, the sort. So let's compare this with sorted. So what happens? Sorted perform the operation temporarily, but sort make the changes permanently. So let's see it live. Let's say first we will apply the sorted, and then we will apply sort, and then we will print both the outputs. So let's say we have this sorted, and we'll apply the function here, and then we will print the original value of trade logs. Then again we apply the sort here, and we print it again, correct? So, and when I hit shift enter, you can see that first it applied the sorted and then we printed, so we get the original value because it didn't make any permanent changes. But when we apply the sort function here, you can see that it printed out the new value, which is permanently changed. So that's how it works. So what we can do in order to avoid these problems, so at that place you can use copy function. So what does copy do? It will just make another copy of a list at some different memory address. So how does it work? Let's say we have this trade list. So we can print the list, and then we again print the memory address of this list. So print and print ID of this, right? Okay. Now what we do, we make a copy of this trade logs. So trade logs dot copy, and let's say we assign it to the new variable, new trade logs, correct? And again we print this. We print this new trade logs, and now we print the memory address of this, correct? So ID, and when we hit shift enter, we get these value. See, both the list have exactly the same item, same value, correct? The trade logs and the new trade logs. But when we print the memory address of those lists, you can see that the trade logs is stored at this location 0864 and the new trade logs is stored at 1120. So that's how these works. So generally when you want to make some changes, you should be using this copy function. It's very useful and very helpful, correct? Now let's start one of the most important concept of Python list, which is list comprehension. So what is list comprehension? List comprehension provides a concise way of creating list. Means we can create complex list in just a single line of code. So we have few advantages of list comprehensions, which is it is more time efficient and space efficient than loops. So means Python recommends that you should be using list comprehension instead of for loops. It requires fewer line of, like you can create a complex list in just a single line of code. And it transforms iterative statement into a formula. So let's see how does it work. So for example, we want to create a list, right? What we can do, we can give a new variable name. So let me give a name, a new list. Then you have to provide the list symbol, which is the square brackets. So inside that, first you have to write the expression, right? So expression, I'll just explain you in a bit what does it mean. Then you have to write for, right? For, then any name. So you can give here, like generally we give I. So for I, then in your iterable, right? So it could be anything, your iterable. Let me delete this and we will add it later on. Your iterable, then your condition. Okay, so here it will be condition. So let's say we have a if condition. So if, and then you can write the condition. Condition. Okay. Let's say equals to true. Correct. So this is the basic formula. I know it's look very difficult, but let me quickly make it so easy for you guys. Okay. So for that, we have to go to the screen. For example, if you want to add 1 to 10 numbers to a list. So you want a list which contains the numbers from 1 to 10. First we declare an empty list. Then we apply the for loop. So for I in range of 1 to 11, right? Because it will not include the last number 11. It will just give us the one value less, right? So that's why we are writing 11. Then what we will do, we will append this I, right? So append and I. So the first time the I will become 1, then 2, 3, 4 and up to 10. Then what we will do, once it has done the append, we will print the final list. So we can see that we have a new list which contains all the numbers from 1 to 10. But what if when I tell you that we can achieve this same result in just a single line of code? So how we can do that? We can take help of lists. So first, as per the formula, we create a list, and inside that, how I do this, first I will run the for loop, right? So for I in range of 1 to 11, the same like the general loop. Then here I will give the expression, right? So I'll just give a space, and then here what I'll do, I'll print I. Okay, so in the first iteration I will be equals to 1, then 2, 3, 4, and so on and so forth. So now if you just hit shift enter, you will get the same result, right? So we have achieved this code with just a single line of code, and that's really powerful, right? Because when we have thousands lines of code, it really makes a difference, right? It really makes a difference. So that's how you can do this. And so next example, we have scalar multiplication on a vector. So what we can do, we have a list, and let's say it have the vectors as 2, 3, and 4. Okay, and the scalar, let's say we have negative of 3, and what we want, that we get a result with 3 into 2, 6, negative 6, negative 9, and negative 12, right? So if you just do like v into s, you will get an empty list, right? But to achieve that result, what you have to do, you have to run a for loop. So for I in v, correct? Because this is an iterable. Then what you will do, you will multiply I with s, and here also you have to declare an empty list. So let's say L equals to empty list, and then you will append that value to the list, and here you can print the new list, right? So let's say we have this L, and when you hit shift enter, you have the values. But instead of this, we have the list comprehension. So how we can do that? You can just go and write first the empty list, okay? Then you run the for loop. So for I in this vector, right? So for I in v, then what I want, that the value of s should be multiplied with the I, right? So here I can just give I multiplied by s, okay? And when you hit shift enter, you have the results, right? See the power of list comprehension. Just a simple line of code, and it makes our life so easy. Now we have add squares. Now for example, we have this list, and what we want a new list with the number squared. So what we can do, so generally we declare an empty list. So let's say s is an empty list. Then for I in L, and I multiplied I square, and then we can add this to the empty list, right? So s dot append. Now we can just print the s. Oh, I have to give it capital S, and we have the new list with the number squared. But now we know how to apply the list comprehension here. So what we can do, we can create an empty list, then we will run a for loop. So for I in s, oh no, for I in L, because that is a list, and then here I can just give I square 2. That's it, guys. When you hit shift enter, and you will get your desired values. Now we have the two ways to traverse a list. So one is item wise, another is index wise. So what we can do, let's say we have this list, right? This one, I'll just copy and paste this here, and or let's take the list above, right? The RL list, this one, right? The trade logs. So here we will traverse a list item wise. So we have trade logs equals to this list, and so now let's traverse this list with item wise. So how we can achieve that? For I in trade logs, and then print I, correct? So if you hit shift enter, all the items will be printed out, because you know that this list itself is an item. It will be printed out as an item. So we have 3 items in this list, and we have those values. And let's say if you wanted to print only the items of this first list, so what you can do, you can just give here 0, and all those items will be printed out. Next we have to traverse a list index wise. So what you can do, you can simply copy and paste the same list here, and now you want to traverse index wise. So what you can do, you can write like for I in range of 0, then length of this list, right? So that is trade logs, correct? And now if you print I, okay, you have to print like this. You have to give the trade logs and then I. So you will get the same value. So this is how you can traverse item wise and index wise. Okay, it's very easy. Just practice yourself and you will be good to go. Now we have another very important concept in Python, which is zip. So the zip function returns a zip object, which is an iterator of tuples, where the first item in each past iterator is paired together, and then the second item in each past iterator are paired together. If the past iterators have different lengths, the iterator with the list items decides the length of the new iterator. So let's see how does it work. For example, you have two lists. Let's say L1 equals to 1, 2, 3, 4, and L2 equals to, let's make it negative, right? So -1, -2, -3, and -4. So now what I want to do, I want to add these items. So the first item of L1 to the first item of L2, the second item of L1 to the second item of L2. So similarly, it will apply for the rest of the items. So for that, you can apply the zip object. So what you can do, you can just write zip and then you can pass the list inside it. So L1 and L2. And now when you hit shift enter, you will get a zip object, which was written here, right? The zip function returns as zip object. And now if you want to check the values, what you can do, you can just assign a list function here. And now when you hit shift enter, you will get the values in a list of tuples, correct? But still we have not achieved our target, which is to add these values. So for that, what you can do, you can apply the for loop or the list comprehension, right? So here we'll be applying the list comprehension. So what we can do, let's say we can store this value in any other variable. Let's say z equals to the function. So now what we will do, we will apply the list comprehension. So first we will declare an empty list, then for I in, now we have two items. So what we have to do, we have to write two variables. So for I comma j in z, correct? And here you can simply print those values however you want. So let's say if you wanted to print with the comma separated, what you can do, you can write like this. And when you hit shift enter, okay, you have to write a bracket here and you can get the same value, right? But it doesn't make any sense. So what you can do, we wanted to add these values. So you will just assign a addition operator here. And now when you hit shift enter, you will get the values as 0, 0, 0. And then you will get the values as 0, 0, 0, 0. So that's the functionality of zip function. And it is also very useful. So just practice some questions. I'll be giving an MCQs and task. Now we have the final topic of the list. And I think we have covered almost all the topics in very detail. So if you cover these topics, you will not be having any issue with the list in your future again. Okay, so what are the disadvantages of Python list? Actually, we have already covered this, but let me quickly explain you again. Lists are slow. We have covered this in the starting, correct? So Python lists are slower because these store the memory addresses, not the actual values. And second is risk uses, because lists are mutable. So unlike strings are immutable, we cannot change them, but lists are mutable and we can make changes. So it becomes very risky. So we have to deal with the list diligently, carefully. Then again, eats up more memory because these are slower. Definitely it will consume more memory, right? And also these stores both the values and addresses, so it consumes more memory. So in order to resolve these drawbacks, so we came with the library, which is NumPy, and there we have ND arrays. So with the help of ND arrays, we can mitigate these drawbacks at some extent, not fully, at some extent. So let me just explain you how this is risky, right? So let's say we have a list A equals to 1, 2, 3. Then what we will do, we will assign B equals to A, correct? So now when I print A and print B, I get two lists, right? And when I print the memory address of both the variables like ID A and then ID B, so you can see that the address also same, correct? So now let's say what I did, I made some, let me print it again before. Okay, so before printing I made some changes. So what I did like a delete A0, means I deleted this item, correct, the one from A. So now when I hit shift enter, you can see that it made changes in B also. So that's the issue, correct? Sometime when we have a bigger code and we are making changes in some other variables, some other list, and that is reflected into some other variables also, and it becomes so risky. So to resolve that issue, we have already studied a function. So you let me know in the comments how we can resolve this issue. So just think and let me know. What are the tuples? A tuple in Python is similar to a list. The difference between the two is that we cannot change the elements of a tuple once it is assigned, whereas we can change the elements of a list. In short, a tuple is an immutable list. This is very important. A tuple cannot be changed in any way once it is created. It's same like strings. Strings are also immutable and tuples are also immutable. We cannot make any changes once we have created strings and tuples. Whereas in list, we can make changes, right? So that's the fundamental difference between tuples and lists. Now let's check the characteristics of tuples. These are ordered, same like lists. Lists are also ordered and tuples are also ordered. So we can say that apart from the immutability, all properties of list and tuples are similar. This is unchangeable because these are immutable, so we cannot make any changes. And then it allows duplicate. So same like list, we can also have duplicate items in tuples. Now let's quickly jump to the Python tuples examples. So first of all, same like list, let's create an empty tuple. So how we can do that? Let's say t1 equals to just parenthesis, the bracket. So when you hit shift enter and print this t1, you will get tuple, the empty tuple, right? And how you can verify that? You can just go and type id here and you can see that the class is tuple, correct? Then let's create a tuple with a single item. So similarly, what we can do, we can write t2 and let's write tuples, correct? And when you hit print t2, you can see that we have a tuples. But how do you know that this is tuples only? It could be a string also, right? And in fact, it is a string. How? Let's check the type of this. And you can see that we have a class str. So how do we create a tuples with a single item? For that, what we can do, instead of this, you can just add a comma here. And when you print, you can see that we have a tuple. So to resolve that confusion, the Python has added a comma here. So we can differentiate between a single string or any single integer here. So when we add a comma here, it will become a tuple. For the tuples with more than one item, there is no issue like that. And similarly, for homogeneous tuples, same like a list, what we can do, I'll just copy and paste it here. So the first item is a string. So for homogeneous tuples, we have to have all the items as single data type, right? So this also I can have like any string. We can say like, let's say BTC, then ETH. And when you print this out, you can see that we have the tuples BTC ETH, right? This is homogeneous. And similarly for heterogeneous, what you can do, you can change this value to any other. It can be an integer, then string. Then you can change this to a float. So a float could be 1.5, then Boolean value, correct? It will become a heterogeneous tuples. So when you print it out, T2, it will be printed out as a heterogeneous tuples, correct? And again, using type conversion, this exactly same like we did in list. So for example, we have a string, let's say BTC, correct? And when we check the type of this, it will be the string, right? But what you can do, you can just convert the type of this. So you have give here tuple, okay? And when you check the type, you can see that it has converted to tuples, right? So now as you can see that almost all the properties are same except the immutability, because tuples are immutable, so we cannot make any write changes. So like adding an item, editing an item, we cannot do that. So now let's quickly check out how to access items from a tuple. So let's say we have this tuple. Let me copy and paste this here. Okay. Same like list. What we can do, we can access like T2 and 0. The 1 will be printed out. And if I go T2 with the index 2, the float will be printed out, and with the 3, we will be having a Boolean value. Same for slicing. Slicing also works exactly same like strings and list and then in tuples. So how you can do that? Let's say you want to print only these values, BTC and 1.5. So we know that this is at the index position 1 and 1.5 is at the index position 2. So for that, we have to write 1, the starting position, then 3, right? Plus 1. And when we hit shift enter, we get both the values, correct? And same you can achieve with the negative indexing. So this is -1, this is -2, and BTC is -3. So you have to write -3, then up to -2, but you have to write +1. So it will become -1. And when you enter, you get the same value, right? Next is editing items. So let's try some editing here. So we'll just copy and paste the same tuple here. So let's say I want to change this value BTC to ETH. Okay, so what I can do, I'll just write T2 and the index position of BTC, which is at 1, and I will try to change this to ETH. So when I write ETH here and shift enter, it gives me tuple object doesn't support item assignment. Of course, because these are immutable and we cannot make any changes. So that's the difference, right? That's the major difference between list and tuples. And same goes for adding items. As these are immutable, we cannot do. So let's try to do that. For example, if I append here, so append will not work, correct? Also, adding items is not possible in tuple. So there is no function for adding item. Same goes for deleting. So if you try to delete any item here, it will not work. So let's try to delete a single item from a tuple. So what we can do, we'll write delete, then T2 and the index position of that item. So let's say we want to delete the first item. So I'll type here 0, and when I hit shift enter, I get that tuple object doesn't support item deletion. Same, it doesn't support item assignment, and it also doesn't support the item deletion because these are immutable. But we can delete the whole tuple. That's possible. So when I check that, you can see that now it doesn't exist. So when I try to print T2, it will say that the name T2 is not defined because it has been deleted. So that's how the deletion works here. Then we have operations on tuples, same like list. So let's copy and paste the same tuple here. So let's say we have another tuple T3, which has the values like 2, then ETH, and let's say 2.5, and this is false, correct? So when you try to add these two tuples, it will be printed out. So we can say that only the addition and multiplication arithmetic operators works on tuples, same like list, right? If you want, you can also use the multiplication here. So when you multiply T2, you will get the value like this because it will be printed out 2 times. If you want, like, let's say 4 times, then you can do that also, and you will get the same tuple 4 times, correct? So let me change it. Then we have the membership operation. So what we can do here, let's say I want to check whether BTC is existing on T2. So let's say here I want to check whether BTC string exists on T2 tuple or not. So what I can do, I'll write BTC in T2, and when I hit shift enter, it gives me true because it does exist. But if I change it to T3, but in T3 it doesn't exist. Similarly, we can use the not in. So when I check not in BTC, not in T3, so it will give me true because it doesn't exist in T3. It exists in T2. So here it will give me false value. So it is false. So it's very same. It's very simple and similar like the list. And for iteration also, this works same. Let's say we want to print all these values, T2 and T3. So we can apply a for loop here. So for I in T2, print I, and again for j in T3, print j. When you hit shift enter, you get all the values. So we can say iteration also works exactly same like list. So now we have the same functions: len, sum, minimum, maximum, sorted. So let's quickly perform that. So let's say I apply the len function here on T2. So len T2, it will give me the length of this tuple. If I apply sum on this, what we will get? Pause the video and give me the answer. We'll get an error because here we have multiple data types and some function cannot work on that. We need to have a homogeneous tuples for that. So let's say we have another tuple which consists of 1, 2, 3, 4. And if I apply sum on T3, it will give me 10, right? The sum of these values. Again, we can apply minimum also, but only on the homogeneous tuple. So here, when you apply, you will get the minimum value. Similarly, max. Sorted also, you will get the values in ascending order. And if you want the value in descending order, you can just write reverse equals to true and you will get in reverse order 4, 3, 2, 1. So now we have a count function here. So count also print out the number of times any item existing in that tuple. So let's say we will copy and paste this 3 times. So again, and when I check that t2 dot count, and let's say we check for the BTC string, correct? So when I hit shift enter, I get 3 times because BTC, 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 it exists 3 times. Similarly for the index, if I apply here, so it will give me the index position of BTC, the first occurrence, right? So we will get the first 0 and 1. So let's say if I add another value here, 2, 3. So now the index position of BTC is 0, 1, 2, 3, right? So when I hit shift enter, I get the 3. So that's how it works. It's very simple. It's very easy. If you have understood strings and lists, then you should be having no issue here, right? So now let's check the difference between list and tuples. The first, of course, syntax. So the syntax of list is we write with the square bracket, but for the tuples, we have to write the parenthesis, the round bracket. So we have to write like this. Then the second difference is mutability, correct? Lists are mutable. We can make changes in that. We can add, we can edit, we can delete the list, but in tuples, we cannot make any changes. So it becomes immutable. Then we have the speed. So for the speed, what happens? You can think that all the immutable data types are faster and mutables are a little bit slower than the immutable, correct? So we can say strings, tuples are faster than list, correct? Then we have the memory. Of course, same like speed, tuples occupy less memory than the list. Next, we have built-in functionalities. So almost all functionalities are same except the writing operation. So in tuple, we cannot perform the writing operation because we cannot make any changes. We cannot edit, we cannot delete. So you can say except all the writing operations, we have similar functionalities on both the list and tuple. Then the next is error prone. Yeah. So as we can clearly understand that lists are more error prone because as we understood in the last session, list, we took an example that how lists are error prone because lists can be changed, lists can be edited, and lists can be deleted. So lists are more error prone than tuples because tuples cannot be changed. These are immutable. So we cannot make any changes. So in short, we can say lists are more error prone than usability. So when it comes to usability, so in usability, you can use tuples where you don't want to change the data. For example, we have a strategy and we want to set the parameters to strategy parameters. So here I want a short window of 50 and the long window of 100 for SMA and EMA. Correct. So these should be same. I don't want to change this throughout the program. So in that case, you can use tuples. It's that simple. So now we will take an example where we will measure the time taken for various operations like creation, access, and iteration. Then we will compare the memory size of list and tuples. So first we will import the time and sys library, and then we will quickly create the number of elements to use in list and tuples. So here we will take the number of elements as 1 million, and here we will generate the sample data. So the range will be from 0 to 1 million and it will create a list, and that list is being stored in the data variable. Now we start with the major memory sizes. So here I am creating 2 variables. First is data list and second is data tuple, right? Now when I check this get size of function will check the size of that particular variable. It will print out the size, correct? So here it will be printed out. Then we check the time measurement. So here what is happening? here we check the start time of that operation, and here we are performing the operation, and then we are checking the end time of that operation. Here we will print out the end time minus start time, so it will give us the seconds, how much time it took to perform that operation. Similarly, it is for list. So that was for the creation, and this part is for the access. So how much time it takes to access the elements from list or from a tuple. So it will be measured out, and then we will print it out. And then next we have the iteration. So how much time a list take for the iteration, and similarly for the tuples, correct? So, and then we have the time measurement for append, which is only for list, and again for the extend, that is also for only list, because tuples doesn't support any write operation, right? So we cannot append or extend the tuples. So when we hit shift enter, we get the value. So now here you can see that the size of the list is slightly bigger than the size of the tuple, correct? Again, the list creation time is slightly more than the tuple creation time. Similarly, for the access time, tuples are slightly faster. So when we have a large amount of data, it makes a huge difference. So while dealing with HFTs, high frequency trading, it makes a lot of difference. Then you can see the list iteration time and the tuple iteration time. Tuples are slightly faster. And last, we have the list append and extend time. So here we cannot compare because tuples doesn't support that. So after this session, you can go through this document and you can read more on the tuples and list. Now we take this example where we will try to append some value in the list, and then again we will try to append some value in the tuple. So here you can see that we have a list which has the items 1, 2, 3, then b equals to a, and when I append 4 into that list, we can see that we have change in both the variables a and b. Similarly, when we check for tuples, a equals to a tuple which has 3 values 1, 2, 3, and b equals to a. So now b and a points to 1, 2, 3, and when I add another tuple here 4 and shift enter, so here we can see that only a has been changed. There is no difference in the b. So that's how we can compare the list and tuples. Okay. So now we have a question, why use tuples? So in algo trading, you can say that when we want the immutable data structures, we can use tuples. When we want efficient memory storage, we can use tuples, as we have seen in the above example. When we want hashable keys for dictionaries, we can use tuples. We can use tuples at fixed and unmodifiable datasets. And again, improved performance for read-only operations, because write operations we cannot perform on tuples. So that's where you can use tuples in algo trading. So now the next topic is special syntax. So here we have tuple unpacking. So let's say we have a tuple which has date, open price, and high price. So we want that these all should be assigned to date, open price, and high. So in this way, in this syntax, you can write and the values will be assigned to each one of them. The date will be assigned to this one, the open price will be 100, and the high will be 110. You can even check here, you can print the values, print. Let's take all these together, and you can see it says too many values to unpack. Okay, yeah. So, but here we have to see this one, correct? It has printed. The error is for this one. So let me comment it out for now. So now you can check that we have the date here, the opening price, and the high price, correct? Now, for example, what you did, you have 3 items in the tuple, but you assign only 2 variables here, then it will throw the error. So let me comment out this, and when I hit shift enter, you can see that we have this error, value error, too many values to unpack, expected 2. So here what you can do, you can add another variable here, or you have to remove one value from here. So let's say we remove this 110. Now we have only the date and the open price. So now if you hit shift enter and print out these values, print, and you have the date and the opening price, correct? Now let me comment it also. So this example is for the use case of tuple unpacking in the algo trading. So let's say you have the trade data, which is a list of tuples. Okay, this is a list, and in that we have the items as tuples, right? So here you can iterate over trade data, and you can see that we have assigned date, which will be the first item of tuple, then the open price, then high, the low, close, and volume. And when we run that, we will get all the values. So that's how you can use the tuple unpacking. Next is this. Similarly, we have a tuple which has 4 items. Let's say here we just have 2 variables, a and b, and rest we want to store in the other variable. So far we don't know what is the name of that variable. So this way we can assign AB equals to 1, 2, and the rest items will go to the others. So when you print it out, you can see that we have 1, 2, and in the others it will be 3, 4. You can have as many as you want, and when you hit shift enter, the other will have all these values. Okay, similarly you can check this also. So when you print it out, this is a use case of tuple unpacking. Let's say I print this, so let me print these in other for better understanding. Print open price, and then I will print the others. Let me comment out these. So you can see that in date we have this one, and open price which is 106, and the rest values is inside the others variable. So that's how you can use this. Now we have the last zipping tuples. So we have already understood the zip function in list, that is exactly the same. So here we have two tuples, one is trade log and another is trade log 1. So we will zip it first, and then okay, so you know that when we apply the zip function we get a zip object. So when you hit shift enter, you will get a zip object, and then you have to pass it to tuple, right? So when you hit shift enter, you will get the value. If you want, you can also pass it to a list, so you will get a list. So it's just the difference of name and syntax, otherwise everything is same. So first of all, we understand some theory of sets. So a set is an unordered collection of items. So pay attention to these words. Every set element is unique and must be immutable, right? However, a set itself is mutable. We can add or remove items from it. Sets can also be used to perform mathematical set operations like union, intersection, symmetric difference, and many more. Then we have few characteristics: that sets are unordered, these are mutable, no duplicates, and can't contain mutable data types. So let's take an example. For example, we have a set A. So how do we represent sets? With a curly braces, correct? So let's say we have 4 stocks in that set. So Apple, then we have Google, then we have Tesla. Okay, let's make it 3 only. And in set B we have, let's say, Tesla, then Amazon, and then we have Microsoft, correct? So let's create some Venn diagrams. Okay, for example, we have a set A, then we have the set B, right? So here we will write the set elements. So in set A, I'll represent this with A. In set A we have Apple, so I'll just write the first letter. Then we have Google, right? And another we have is Tesla, correct? Then in set B we have Tesla, so Tesla is also in this set B, so I'll just leave it. And we have Amazon, so I have to write let's say AM to differentiate. And then we have the Microsoft, correct? Here we can see that this is set A, which have Apple, Google, and Tesla. This is set B, which consists of elements Tesla, Amazon, and Microsoft. So now basically we have 4 operations on this. So first is union. The first is union. We have first operation, which is union. That means we combine all the elements from set A and set B and create a new union set. So how we can do that? Let's say we have AGT. So let me create a union set. So I'll just represent this with U is equals to a new set, which consists of Apple, then Google, correct? Then we have Tesla, then Amazon. So Amazon I'll represent with red, and the last is Microsoft, right? Now pay attention here. See, these elements are from the set A, correct? And these elements are from set B, correct? As we have already seen that sets do not have duplicates. Even if there are duplicates, it will get ignored, right? So the Tesla was duplicate here, so it was ignored. And in the union of sets, we have these 1, 2, 3, 4, 5 elements, correct? So in short, you can say union is the combination of all the elements from both the sets, and you can ignore the duplicates. So that simple the union is, right? So the next is intersection. Intersection is very easy. You just have to consider the common elements. So here we can clearly see that we have only one common, that is Tesla, correct? Only this area. So what we can do, I'll just go ahead and write a new set intersection, and it will be only Tesla. So I'll just write here second, which is intersection, correct? Next we have is difference. Difference is also, as the name suggests, we just take the difference of the elements. So let's say if we are taking the difference of like A minus B. So in difference, first of all, we will check that if there is any common element. If yes, then just remove that. And then you check what are the remaining elements in the set A. For example, if I did A difference B, then I know that T is the common element. Just remove that. We are left with Amazon and Google. So I can write a new set. In that we have Amazon and Google, correct? If I write B difference A, B minus A, then again we will remove the common element, which is Tesla, and we are left with Amazon and Microsoft. It was Apple here in the A negative B, right? This was Apple. So I can write Apple. And when we perform B difference A, we will ignore this T element, and we are left with Amazon and Microsoft. So MSFT. That's the basic idea of difference. Next we have is also very easy, that is symmetric difference, right? So we can write like symmetric difference. So in symmetric difference, what you do, you just ignore the common element and then you write all the remaining elements. So here, when we check that Tesla is the common, so we ignore that and we are left with Apple, Google, Amazon, and Microsoft. So we'll write A, symmetric difference B, and then we will write the remaining elements, which is Apple. Then we have Google and Amazon, and we have the Microsoft. So that is the symmetric difference. So now we have few more properties, like if someone asks is disjoint. So in disjoint set, what happens? If there are no common elements, then we can say yes, true, right? But we know that this set is false. So if we have a question whether these sets are disjoint, so we will say false, correct? A Boolean value false. We have another property which is its subset. So when we have is as prefix, we just have to think in terms of true and false. So when it is asked that is subset, in that what happens, like we have two sets. First is Apple, second element is Google, correct? Then the second set we have is Apple, Google, then let's say Amazon, correct? So if someone asks whether A is subset of B, then we can say true. Why? Because all the elements of set A are existing in set B, right? Next we have superset. So if we have a question is superset. So similarly, if someone asks B is superset of A, then we can say true. Why? Because of all the elements of A are existing in B, correct? So it's very easy. Yeah, we can say that B is the superset of A. Similarly, next we have unique. So is unique. In this, what happens? For example, we have this set B. So I'll just add another element in this, and let's say this is apple. If now someone asks if B is unique, then we can say it is false because it is not unique. It contains the apple element. So when we have duplicates, we can say that that particular set is not unique. So with that being said, that is the basic theory of sets. And I hope that you understood it very well. And if you still have any doubt, you can connect with us. Now we quickly perform some examples and then we'll proceed with the dictionaries. Now we quickly perform some examples so it will be better for understanding. So let's say we want to create an empty set. For that you have to write the word set and then you can leave it. So when you hit shift enter and when you print s1, you can see that we have a set and then the parentheses, right? And when you check the type of this, you can also see that this is from the class set. So we know that this is the set, right? Then again the same 1D and 2D sets. So for 1D sets it is same like the list and tuples. For 1D sets you only have one curly braces. So when you, I'll just comment these out. So okay, so when you print this, so when you print s1, you get the elements from the set s1. And for 2D sets, what you can do, you can like just have a set inside a set, right? So I can write like this and then I'll give some elements inside this that set. So it can be msft and then we can write meta also, correct? So you just pause the video and you let me know whether this will work or not. Okay, so when I hit shift enter, let me comment these out, and when I hit shift enter it says unhashable type set because we have already seen that it cannot contain mutable data types, right? But we know that a set itself is mutable, so we cannot have a set inside set. So instead of this you can have a tuple, right? And when you print that out, let me print the s1 and you will be having the elements. And here you can also observe another property of sets, that here we had the order like Apple, Google, Tesla and then another tuple, but here when we print out we get the tuples first, so there is no sequence. So we can say the order doesn't matter here, which was another property of sets. See here it is unordered, right? So which element will come first we do not know. It's completely depends on the hashing. Then we have another properties which is a homogeneous or heterogeneous sets, which we have already seen in previously in list and tuples. So it's same. So you let me know whether this set is homogeneous or heterogeneous. Let me comment this above. So we know that we have 4 elements. The first 3 are strings and this 4th one is tuples. So we can say that this is heterogeneous. But if you wanted to make it, first let me print this s1. I'll print s1. Okay, so when we print it we get this value, right? Again the order has been changed, the sequence has been changed. And now when I want the homogeneous, what we can do, I'll just write s2 here and I'll give it s2 also. Okay, so here I'll just remove the tuples. Okay, and now all elements become strings, and when I print this I get 1 2 3 4 5. I get the 5 elements, which is true, and these all are strings. So we can say this is homogeneous set and this is heterogeneous set. Next we have using type conversion. For example, we have a string. So let's say this is s3 equals to apple, correct? And we can also print it out. So I'll just copy and paste here and make it s3. Okay, and I will also again print the type of this. So let's say type. So, and we can comment the above ones. Okay, when you perform the examples, you can remove the comment and you can proceed. So now when I print this, we can get the output like the S3 is apple and class is string, but we want to make it a set with the help of type conversion. So what we can do, we can simply write here the set, right? And when we hit shift enter, you can see that the string apple has been splitted into multiple elements, and we have got a new set with 3 elements. And because these two AA were duplicates, so it just gave us a single element. So we have converted a string to a set, you can see here. And the second one is duplicates are not allowed, which is true because we have 2 A's here and that is not allowed in sets, so it will ignore the second one. Correct. Again, set can't have mutable items, as I already mentioned and explained here that we cannot have a list or a set itself here. So let's again check it. I'll just comment it. When I print here now, we have the output of set, which is okay. But if I change it to a list, let's say I change it to a list, this element, and when I hit shift enter, we get the error unhashable type. And even if you make it set, it will not work. So I'll just convert it to a set, and when I hit shift enter, the same error we face. So these are the basic properties. Now let's move to some operations, like how to access the set elements. So as we know that when there is no order, the elements are unordered, then we cannot assign any index to them, right? So accessing by index doesn't make sense here. Then how we can access the elements of any set? Then we have a question that if we cannot assign any index, then how we can access the set elements? So there are a few other ways, like you can convert a set to a list. We can access it by like iterating, and we can also access the elements by iterating. So let's see all the other methods. So for example, if I try to access the set elements with the index, so let's say I give t2 0. So of course it will throw an error. You can say set object is not subscriptable. So similarly, we have editing items. So in editing also, when we don't have the index, it becomes difficult, right? So let's say if I write same t1 is equals to, let's assign it Ethereum, right, t2. So when we hit shift enter, it throws the same error. The set object doesn't support the item assignment. But we know that the sets are mutable, so we can add or remove the values. So how we can do that? For example, if you want to add something to a set, so what you can do, you can just write t2, the name of the set, then add. And here, if you write like eth and a string, and when you print t2, you will get the value, right, eth. So with the help of add, you can add. We have another function which is t2.update. So update, and you can add eth. So, and again, when you print t2, you will get eht. So if you remember, in list we have seen two functions, append and extend. So similarly, the same thing is happening here. The append is equals to add. It will only add one value, but update always try to add multiple elements. So even if you passing here a single string, it is splitting that string into multiple elements and it is adding. So for single element, you have to use the add function, and for multiple elements, you have to use the update function. So here what I'll do, I'll just make it a, let's say, a list. Then I can give like eth and btc, and let's say xrp, correct. Okay, now let's hit shift enter here. So you can see that we have btc, eth, xrp, and of course the property of sets that it will ignore the duplicate values. So it has ignored the btc and eth, correct. So this is how we can add items in a set. Now we have the next topic, that is deleting items. So for deletion, if you want, you can delete the whole set. So like we have this set here, and let me first print it. So t2, we can see that we have the set elements, and if I delete it, del t2, and again print it out, then it will throw an error that t2 is not defined. right? Because it has been deleted. And similarly, as there is no index, you cannot delete any single element with the help of indexing, right? So if you try to do that, it will throw an error again that set object doesn't support the item deletion. Item you cannot delete, you can delete the whole set. So now we have the next function, discard and remove. So for example, if I use the discard function here and I write that 50. So in discard, what happens, as we know that we don't have any index, so we have to write the value, the item value. So here, if I write s.discard, let me make it t2 because the name of set is t2. So if I discard 50 from the set and when I hit shift enter, it doesn't display any output, and I can print the t2 again here, and we have. Now you tell me that why we do not have the true as output here. Okay, that is a question of the day, and you just go and pause the video, you check the answer, and you let me know in the comments that why the true boolean value is not displaying here. Okay, so now we check this one. When we try to delete the value 50 from this set, it will not display anything and it will not display any error, right? But if we use remove and same 50 and I would try to print t2 again, so it will throw an error. So the main difference between discard and removes is that discard doesn't throw any error when the element is not existing in the set, but remove will throw an error if the element is not existing in the set. Otherwise, both perform the same operation, correct? So what you can do, you can check that I will remove the BTC with the discard and I will remove the 1.5 with the remove. So when I hit shift enter, we are just left with the 1, right? So because discard remove the BTC and remove the 1.5, and we know that we have this 1 and true, but I don't know why we are getting the error that I'm only getting 1. So it's your question, it's your challenge that you have to let me know why the true wasn't displayed here. Okay, now let's move to the next topic, which is, let me copy and paste these here, S1 and S2. I'll just comment these out, and what we can do, we can add this S1 and we can have another S2. So in that, what we will do, we will, let's leave the Tesla and we add another values like Microsoft, and we can add Meta, correct? So here we can say that in S we have 3 elements, Apple, Google and Tesla, and in S2 we have Apple, Google, Tesla, Microsoft and Meta. So as we have already understood these topics in the starting of this video, so if you are having a little bit confusion here, you can just go back and watch the video and come back. It will be very easy for you. Okay, so for union, so what we will do, so in union we can perform with the 2 ways. One is we can have this pipe, so it also represents the union in the sets. So when I hit shift enter, it will give me the union of both the sets, S1 and S2. So you can see that we have Apple, Google, then Meta, then Microsoft and Tesla. Okay, and now you can see that we have 3 plus 5, 8 elements, but we are only displaying 5 elements. Why? Because the first property, we cannot have duplicates, so it ignored these 3 duplicates. Okay, only one time it printed out. Then the next is unordered, so there is no order, it will display in any order the Python wants. Okay, next we have the intersection. So you know that in intersection it displays only the common elements. So when we hit shift enter, it will give us the Apple, Google and Tesla as per the Venn diagram we have seen previously. Now we have the difference, so S1 minus S2. So from S1 it will remove the common element and it will display the S1 minus S2. So here you pause the video and you comment down the answer that what will be the S1 difference S2. So when I hit shift enter, I get an empty set because these 3 elements were common in both the sets and it removed all the 3 common elements and we are left with an empty set. Similarly, when we perform that S1 minus S2, so what it will do, it will remove these 3 elements and we are left with Microsoft and Meta. So when we hit shift enter, we get as Meta and Microsoft, right? In like unordered sequence. Then we have the symmetric difference. So in that, what it does, it will take the common and it will remove the common items and it will display the leftover elements of both the sets. So when we hit shift enter with the symmetric difference, you can use this sign here, upper arrow, and when you hit shift enter, you can see that these three were the common elements, right? And we are left with only Microsoft and Meta. So that is the symmetric difference. Then we have the membership test. So it's also the same, the in and not in. If the element is existing in set, then it will print out that it is true, and if not, then it will print out that it is false. So it's very simple. We can say that whether let's say Apple, and I'll print not in S1. So when I hit shift enter, we get false because Apple is existing in S1. But I just makes a spelling mistake. Let's say Apple. So when I hit shift enter, it will give me a true answer, right? And when I check for in, so Apple in S1, it will be false, right? So you can see here. Now we have the loops. So you can access the elements of any set with loops also. When I write like for I in S1 and print I, so it will print out all the elements of set Apple, Google, and Tesla. So these were the basic operations of set. Now we move to the next, which is set functions. This is also exactly the same, the len, sum, min, max, sorted, which we have already learned in list and tuples, right? So let's say we have a set which contains these values and we want to find out the length of this. So of course it will check the length, which is 1, 2, 3, 4, 5, 6, and it will print out that length, so which is 6, right? Then we check the sum of this, so it will sum all these values and print out the answer. Next we have minimum, so of course it will give us 1 because that is the minimum value. Next we have max, so it will check which is the maximum number in the set, so it will output 7. And similarly we have sorted, which is also the same. So when we hit shift enter, it will sort the values and it will make reverse as true. So it will sort in descending order, 7, 5, 4, 3, 2, 1. Now, as we have already seen the union, intersection, difference and symmetric difference with the help of Venn diagrams, so these will be very easier. So let's say I want to, let's copy and paste the earlier sets here. So S1 and S2. Here we have the S1 and S2. So if I want the union of S1 and S2, so when we hit shift enter, it will give us these values, of course. But if I want to update it permanently, so what you can do, you can just write as, let me print it here below, and I will write update, correct? And when I hit shift enter, okay, so as there is no output, and we have discussed this already multiple times, that when there is no output in Python, it means that that value has been changed permanently, right? So when I check the S1, you can see that the value of S1 has been changed from Apple, Google, Tesla to Apple, Google, Meta, Microsoft, and Meta, which is the union of both the sets. So that is the difference between union and update. If you just want to see the value, you apply union. But if you want to see the updated union value in any set, you write like update. You have to use the function update. Similarly, you can even perform this also, S2, S1. So then the changes will be made in S2, not the S1. So when you write shift enter and then you print S2, you can see that this is the updated set. So here there is no changes because S2 was the superset of S1. So we'll just discuss what is a superset. What we can do here, we can add another, let's say BTC, okay? So now when we check, we can see that we have another element which is BTC. So that's the difference between union and update. Similarly, we have intersection. That is also exactly same. So if I want the intersection of S1 over S2, so it will just print out the common values of S1 and S2. So we will get Apple, Google, and Tesla. And if you want to make the changes permanently, so what you can do, you can write intersection update and S2. When you hit shift enter, there is no output, means you know very well. So when I check S1 again, you can see that it has been changed from Apple, Google, Tesla, BTC to Apple, Google, and Tesla. And that is the intersection update. Similarly, difference and difference update. So I'll first check the S1 difference. We get the BTC because when we check that we have subtracted the common values and we are left with only BTC. Similarly, you can check the S2, S1, and you will be left with MSFT and meta, correct? And if you want to make the changes permanently, what you can do, you can use the difference update and S1. So when you hit shift enter, you will be left with nothing. Why? Because you will be definitely left. You have to print the S2. So when you print S2, the common values has been removed and you are left with only meta and Microsoft. Similarly, we have the symmetric difference. That's we have seen already with the help of Venn diagram. So when you perform the symmetric difference, so what you can do, you can write like S1 dot symmetric difference over S2. So you can see that we have BTC, meta and Microsoft, BTC, meta and Microsoft. So what it will do, it will remove the common values and then it will give the remaining elements from both the sets. And similarly, same, if you want to make the changes permanently, you just have to write symmetric difference update and S2, and we'll get no output. So for that we have to print S2, and you can see that, okay, we have to print S1, and you can see that we have meta, MSFT and BTC, correct? Then we have few Boolean functions. So is disjoint, is subset, or is superset? So if we check, S1 is disjoint of S2, means if there is no common value, it will be true, otherwise it will be false. So here it will give us false. Of course, S1 is subset of S2. So if we check is subset, and when we hit enter, it will be, you let me know in the comments, pause the video. So when I hit shift enter, we get false because this BTC is not existing in S2. So when we remove this BTC and when we hit shift enter, we can see that S1 is the subset of S2, correct? Then again superset is also very easy. So when we check that is superset, so S1 is not the superset, but we know that S2 is the superset of S1. So when we check, we have the true answer, right? That's very easy. Just perform some multiple choice questions, then you go for the task and the mini project, and you will be good to go forever. Next we have the copy function. So copy is also the same exactly which we have seen in list. So when you do not want to make the changes in the original set, you can make another copy of that set and then you can perform the operations. So what we can write like S1 dot copy, and if you want, you can assign it to S3, right? S3 equals to copy. So when you check the values of S1 and values of S3, you can see that you have exactly the same, but the difference is that the memory address of both the S1 and S3 is different. So you can check that with the function ID, right? ID, and here also we will check with the ID. And when you hit shift enter, you can see that it is at 32 and it is at 80. So you can use it also, sometimes it is useful. Next we have frozen set. So the frozen set is just an immutable version of a Python set object. Means we know that the sets are mutable, but sometimes we want the mutable set. So we call that as a frozen set. So we have here fs1 equals to frozen set 1 2 3 and fs2 equals to frozen set 3 4 5. So when we perform a union on this, so we will get the value as 1 2 3 4 5, correct, which is true for the sets. So what we can say here, that all the read functions will work, but any write operation will not work here. So what were the write operations here? So if we try to update this, so fs1 intersection update, you can see that there is no function like that in the frozen set. Even in update also we cannot use here. And let's say we have difference, so difference also we only have the difference but no update, which we have seen previously. So we cannot write anything here, we can just read, and it's also very useful sometimes. So, and definitely you'll be using it in future. Okay, so please attempt some questions on this, you will be having a lot of benefit. Then the last topic of the set is set comprehension, which is exactly the same which we have seen previously. For example, we want the square of the numbers from 1 to 10, but the number should be greater than 5. So what we can do, first we will write the for I in range 1 to 11, correct? So it will print out up to 10. Then we will apply in condition, so I is greater than 5, and then we will square that number here. So I squared, so here we will get the value as, you know, the squared set. So this was all about sets, and we have covered set very comprehensively, and we have covered so many questions, and I'll also attach some MCQs and the task with the mini projects, so then you will be good to go. So now we move to another super important concept, that is dictionary. So let's quickly deep dive in dictionaries. Dictionary in Python is a collection of keys and values used to store data values like a map, which unlike other data types which holds only a single value as an element. For example, we have an integer, so a equals to 1 is holding only one element. Again, in list, we have the elements like 1, 2, 3, and all are single elements, correct? In tuples also same, and in sets also same, right? But in dictionary, we can hold multiple values. And again, in some languages, it is known as map or associative arrays. So let's understand how it works. So we can represent a dictionary with curly braces. In sets also it is same, curly braces, correct? The only difference is in this we have only single value as an element, but in dictionary we can hold multiple values. So let's say we have this dictionary, correct? In that, this is considered as one item, okay? And this is a key, and this is the value of that key. Again, Google is the key, and this price is the value of that key. And similarly, it goes on. So we have 1, 2, 3, and 4. We have 4 items here, or we can say we have 4 key value pair in this dictionary. Now let's see some characteristics of dictionary. So dictionaries are mutable like dictionary and sets. Same like sets. In dictionary also there is no meaning of indexing because these are unordered. Again, keys can't be duplicated. Means we cannot have another key with the same name Apple. Again, keys can't be mutable items. Means at the place of this key, we cannot have a list or a set or any other mutable item, right? So if you remember these 4 characteristics, I think you will not make any mistake. So again, dictionaries are mutable like sets or lists. Indexing has no meaning. Means dictionaries are also unordered. Keys can't be duplicated. Means you cannot have the same name in 2 keys. And again, keys can't be mutable items. You can have a tuple as the key, but not a list, right? So these are the 4 very important characteristics of dictionary. And now let me show you one empty dictionary, which is this. Unlike in set, it was like this, right? So don't get confused between the empty set and empty dictionary. And when we hold an item in a dictionary, we hold like this. For example, we have a stock named Apple, and the price of that stock is, let's say, 1, 2, 3, 4, correct? Then again a comma and the next key value pair. Let's say this is BTC, and the price of BTC is $65,000. So these are 2 key value pairs. This is key, this is value. Again, this is key, this is value. This is first pair, this is second pair. While in sets, we have like this. Let's say we have the Apple, then we have BTC, correct? You can differentiate easily, right? Okay, now we quickly move to the coding examples and see how dictionaries operate. So to create an empty dictionary, we have to write like this, the empty curly braces, and when you print this, I hit shift enter, you get an empty dictionary, right? Again, for the 1D dictionary, what you can do, you can write a key and value, again second key and second value, third key, third value, and fourth value. So when you print these, shift enter, you can see that we have 4 key value pairs here. So here we have seen that these are the single key and single value, but we can also have multiple keys. So here at the place of a key, we have a tuple which consists of 3 elements. So when we hit shift enter, we get the value like this. As we have already seen that we cannot have a mutable item as a key. So here tuples are immutable, right? These cannot be changed. So we can have a tuple as the key. Then we proceed and take some example of 2D dictionary. So similarly, like a list and tuples, we can have 2D dictionary also. In 2D dictionary, what happens? We have a dictionary inside a dictionary. So if there are two opening and curly braces, we can also identify that this is a dictionary. So you can see here that in the outer dictionary, we have 4 keys: Apple, Google, Tesla, and Microsoft. So here we can see that the value of the key Apple is another dictionary, correct? And which has the 2 key value pairs, a price and volume. Similarly, same goes for Google, Tesla, Microsoft. So when we print this stock data, and let's print it here, and here you can see that we have the 2D dictionary output, which has the 4 keys: Apple, Google, Tesla, Microsoft, and the value of those keys is another dictionary, which consists the data of price and volume. Now we can also create dictionary with the dict function, same like the previously we have seen the type conversion. So for example, we have a list of tuples. So this outer is list. Inside we have 2 items as tuples, correct? And inside the tuple we have the strings as item of the tuple. So if we want to convert this list of tuples to a dictionary, we have to use the function dictionary, and when we print it out, you can see that we have a key value. Stock is the key and Apple is the value. The price is the key and this float is the value. And again both the key and value can also be the same, no problem with that. So that's how we can convert a list to a dictionary. And when we have 2 keys as the same value, see here, the name is Kuldeep and again the name is Singh. Let's hit shift enter, and what it will do, it will update the key. So it will take the last occurrence. Then we have the mutable items as key. So we have seen in the characteristics that keys can't be mutable items, correct? So for example, if I store here, like if I have a list, right? So list is mutable, right? When I hit shift enter and print D6, it will throw an error, unhashable type list. But if I just convert this list to a tuple, correct? Okay, I have to remove this also, or as type conversion we have seen, let's utilize that here. So tuple, and you can see that we have the output without any error. So this is how you can convert sometime the list to a tuple in order to avoid the mistakes, the errors. Now we see the example of accessing items from a dictionary. So what you can do, we have a dictionary with the 3 key value pairs, and if you want to access the value of the apple, so you have to write stock data, then you will write the key, right? So when you hit enter, the value of that key will be printed out. And similarly, if you want the Google here, so you can write Google and you will get the value of the Google key. Then for example, if you want to add another key value pair in this dictionary, so what you can do, you can just write another key and you can assign the value to that. And when you hit shift enter, you will get the output as updated dictionary. So you can see that we have another key value pair, Microsoft, as the value 299.35. Then similarly, you can also remove the key value pair. So here, let's say we have this dictionary and you want to remove the Tesla. So you can use the pop function here. So when you hit shift enter, and you can see that the pop has been removed. So in pop, you have to give the value. And similarly, if you perform like a stock data dot pop item, so, and when you hit shift enter, and okay, now when you print it, you will see that you have only one key value pair, because the in pop item it randomly removes any key value pair from the dictionary, right? And then we have the delete function. So let's say stock data, let us just comment it out again. So we have, okay, comment, okay, now we have the complete dictionary. So we will use the delete function here. So delete stock data, and here you can give the key name, right? So let's say I want to remove Google from here. So when I do that and when I hit shift enter, you can see that Google has been removed, right? Similarly, we have clear, and this is also very clear that clear just clears the dictionary, right? So for example, if you use like clear and then you print it again, so you will get an empty dictionary. So that's how we remove key value pair from a dictionary. Now we move to the next part, which is editing key value pair. So if you want to update the value, let me comment these out. So if you want to update the value of any key, let's say we have the Apple 145.09 and you want to update it to 150. So you can just hit Shift Enter. Let me first run this cell, and when I hit Shift Enter, you can see that the value of Apple has been changed. So this is how you can update the value of any key in a dictionary. Now we have dictionary operations. These are also exactly the same which we have done previously. So let me copy and paste this here. So okay, let me copy and paste it here, and okay. So in membership, we have in and not in. So if I print that Google in stock data, so we have Google. So when we hit Shift Enter, it will give us true. But if I just change the value to any other, and when I hit Shift Enter, it will give me the false value. So it's same, right? There is no difference in that. Similarly, for the iteration, if you want to print all the items, what you can do, you can write for I in stock data. And here you have to write items, correct? Then you can print I, then you can print I. So when you hit Shift and you will get all the keys and values. But what if you only wanted the values? So you can do like this, you will get only values, and for only keys you can write like this, so you'll get only keys. So that's how this works. And you can also use get. So instead of like writing sometimes stock data Apple to get the value of this, you can also use the get function to get the value. So for example, if I run this one, I'll get the value of Apple, correct? But not found is not existing in this, so it will not give us the value. And similarly, when I want to print out the not found when the key is not existing, what I can do, let's say I'll just write AYPL, so it is not in this dictionary. So when I hit Shift Enter, it will print out not found. And so this is how you can use the get function to print any message when the key is not existing in the dictionary. Now we have the functions of dictionary. So these are also exactly the same we have already studied. So let's take the same example, and here I print this. So if I check the len of this stock, so len and stock, so it will output the number of key value pairs in the dictionary. So it has 3 key value pairs, correct? 1, 2, 3. And if I apply the sorted here, so sorted, and when I hit Shift Enter, it will give me Apple, Google, and Tesla. Of course, if I give any integer here, then it will get confused and it will throw an error. So while applying sorted, it has to be a single data type. It may be an integer or it may be a string. So let's change it to again Apple. Then we have the items, keys, and values. We have already seen this, but again let me show here. So if I write stock items and items, so it will print out both the keys and values. Okay, so when I hit Shift Enter, it will give me the whole dictionary. But if I wanted only the keys here, so I'll write key and hit Shift Enter, so it will print out only the keys. And similarly for the values, you can write only the values and you will get the value of those keys. That's how it works. Now we have update. So for update, what you can do, if you wanted to add multiple key value pairs, so in that way you can use this update. So for example, I will write like stock data dot update, and inside that I'll pass a dictionary, right? And when I hit Shift Enter, nothing will be printed out, means something has done permanently. So now when I print stock data, you can see that we have Apple, Google, Tesla. But as we have seen the property that the keys cannot be same, so it will ignore the duplicate keys. So if I change this to like the small something, then when I hit Shift Enter, we can see that we have 6 key value pairs. So this is how you can use the update function to add multiple key value pairs. Now we have the dictionary comprehension. So that also works exactly the same like we have seen previously. So for example, it says print first 10 numbers and their squares. So what you can do, like in list, we will first display the dictionary sign, so that is curly braces. Then for I in range 1 to 11, right? Exactly same. Now we need the numbers and their square. So there is no condition, right? So what we can do, I and I square, right? So if I hit shift enter here, we will see that we have a dictionary with the number and the square 2, 4, 3, 9 and 10, 10. So this is how you can use the dictionary comprehension. Now we want to perform the dictionary comprehension with the existing dictionary. So let's say we have this dictionary, and here what we will do for symbol and price. So symbol will be this and price will be this, correct? In stock data dot items, what it will do, it will multiply the price by 1.05. So when we hit shift enter, we get these values. So you will be using this a lot in your algo trading endeavor. Then we can also use the dictionary comprehension with the zip function. Now, for example, we have these two lists, one with the keys and another with the values. And we want to combine this to a single dictionary, right, with the keys and values. So we can use the dictionary comprehension here. So first we will run the zip function. So it will give us an zip object, right? Then we have symbol and price list. So what it will do, it will combine both these and it will print out a dictionary. So you can see here. And what if when we have a if condition? So we only want the values in that the price is greater than 1000. So here only Google has the price more than 1000. So when we hit shift enter, we will get this, right? Only Google key value pair. Now we have nested dictionary comprehension. So here we have three lists: symbols, dates, and prices. So we are applying the first dictionary comprehension here. And then this whole dictionary comprehension becomes the expression for the second nested dictionary comprehension. So let's understand it in chunks. So what we can do, I'll just comment it out and let me show you. For example, we write historical prices, then we will create a dictionary, empty dictionary, then we will write the simple for loop, which we write for list and tuples, everything, right? So like for, let's say, J and date in enumerate in dates. So we will apply an enumerate on dates. So this enumerate will return a counter, right? So then I'll print the prices and then J, and here we can give the date, right, which was the enumerate counter. So when we print this historical prices, we get this dictionary, right, with the date and the prices. Next, we make this dictionary comprehension as another expression for this one. So here what we can do, we will write another dictionary symbol here, okay, and then we will apply again the comprehension. So for now I and symbol in enumerate, which will return a counter in symbols, right, in symbol, and here I want to print the symbol. So and I can write a colon. So now when I hit shift enter, we will get the value as this, the symbol name and the date and the prices. Again, symbol name, date and prices. This is how we can use the nested comprehension. And still, if you are facing any issue, you can let me know. So first of all, what is a function? So a function is a block of organized, reusable code that performs a single action. So what we do generally, until now, we are writing only the lines of code and those lines are not organized. So in function, what we can do for a single purpose, like for addition, for multiplication, we can create different functions. And then they will perform only that action. So we will just call that function and that function will perform the operation inside and it will returns us the value. For example, we want to perform a 2 plus 3 plus 4. Okay, so what we can do, we can just call the function which performs the addition operation and we just provide these values 2, 3, 4 and it will return us the sum. We don't need to take care how the addition works, right? So that's how it works. And once the function is created, you can call it multiple times and you can use it again and again. So that's why it is known as the organized and reusable code that performs a single function. Okay, the function provides better modularity and high degree of code reusability. Modularity means when we have a big problem, right, and we can split that problem into few functions. For example, let's say we are creating a Python code for calculator. In calculator, we have addition, subtraction, division, multiplication. So what we can do, we can separate all those operations in 4 functions, right? One function for addition, another is for subtraction, and the next is for multiplication and division. So that's why it provides a better modularity and a high degree of code reusability. So once those 4 functions are created, we can use them again and again. We don't need to write the code again, right? We can just call and we can use that now. So how to define a function? So let's say first we define the def keyword. So it will always be there whenever we are defining a function, def keyword, right? Then followed by the function name. So function name, as we have already studied, that is also an identifier, and we have to make sure that all those conditions are meeting here. So we can write a function name. Let's say we can define the function name with addition calculator. Okay. Then a parenthesis. So we will write a parenthesis which can include parameters and colon. So inside that we can have parameters, which we will learn shortly, and then we have to write a colon here. Okay, so you can say a def keyword, then the function name, then a parenthesis and a column, and inside that parenthesis we can have different parameters, which we will learn shortly. Then the indented block of the code following the colon is the body of the function. So once you have typed this, you just hit enter. Okay, so the Python interpreter will automatically take you the right indented place. So let's say your cursor is here. So make sure that in Python, indentation makes a lot of difference. If you do not indent your code correctly, it will throw an error. So it has to be correctly indented, right? So let's say when you type this colon, you hit enter and your cursor will be here. So from here, you start writing your further code. Okay, so this is the basic thing, what is a function and how to define a function. So let's say we define a function for addition again. So what I will do, I'll just remove these things from here and I'll write colon again here. So how does addition works? For example, I have 2 variables here. A is equals to 2. For now, we are not taking any input from user. We are just, for the sake of example, we are writing our own variable. So A equals to 2 and B equals to 3, correct? Then let's write addition equals to 2 plus 3, right? And one more very important concept, that it returns a value. So here what we can do, we can return the add, right? Add, that is a complete function here. So what will happen now, I will call this function. So maybe like I have written a code, a long code, and anywhere in the program I can call this function. So I'll call the function with this name, the name of the function. So I'll write add colon and then this. When I write the function name, this function will be called and it will return the addition. So addition will be 2 plus 3. So actually here we have to write a plus b, a plus b. So the addition will be 2 plus 3, which is 5. So it will return the 5, correct? We can write print here and the output we will get will be 5. Now let's see some terminologies in functions. So first is defining. So we have seen that we have to use def keyword to define a function. Then to call that function, we have to use the function name followed by parenthesis to call a function. So here we call the function with the name and followed by a parenthesis, correct? Then, so I'll just highlight the name and parenthesis. Then parameters. So function can accept parameters to make them more flexible. So for example, these parameters we have declared inside that. So let's say I removed those from the function, and what I can do, I can write those here. So I'll just write here A and B. These parameters can be anything. Okay, so while calling the function, the addition and calculator, you have to pass 2 and 3, correct? So this A will become 2 and this B will become 3, correct? And then it will add like 2 plus 3, because here A equals to 2, B equals to 3. So we have arguments here which becomes parameter here. Now it will add those and it will return us the 5. So we can print here. So this way we can print. Hope you are able to understand, and if not, don't worry, we will perform so many function examples that it will be cemented in your mind forever. Don't worry about that. Okay, let's just focus on these things. So parameters we have done. So the function can accept the parameters also, right? Then we have return values. We have seen that already, correct? Here we have to write return and whatever the value we want to return. Okay, so we can say that function returns a value. So it is also done. So I will just tick. Defining, you have understood. Calling a function, you have understood. Parameters, you have understood. Returning a value, you have understood. Now default parameters. Sometime what happens, like passed parameters here, a and b, but somehow this user who is using this function forgot to pass the arguments here, right? He just called the function, correct, but without any arguments. So if you don't write any default parameters here, the function will throw a very dirty error. Dirty means it's not good looking. Okay, so in order to avoid that error, because you are the programmer and you are responsible for your function, so you have to make sure that whatever the inputs get, you always have to handle all those errors. You have to anticipate that what a user can make mistakes. So in order to avoid that, what you can do, you can pass some default parameters here. So let's say I have given a equals to 1 and b equals to 2. So now if user passes the arguments, that's fine, it will use those parameters. But if user forgot to pass the arguments, so what it will do, it will just take the default parameters. So it will add this 1 plus 2 and it will return the value 3. So that's how the default parameters work, right? So it is very useful in error handling and you should be always using them. Now we have keywords arguments. So keyword arguments are nothing, but we are already using them. What we can do is passing the arguments as 1 and 2. What you can do, you can give them some keyword. So I can give here like a equals to 1 and b equals to 2. So then these value will be assigned to these parameters and we will get the return. We can also have some readable names, like if you are going for sum, addition, multiplication, division, then you can give a good readable name so your program becomes more readable. Okay, we will understand all those with the examples. Don't worry about that. Just focus on this theory. Okay, now we have variable length arguments. We can use star args and star keyword args for variable length arguments. So for now, you just think that we can use these and I'll explain you with the help of an example. Now we have the docstrings. We use docstrings to document your functions. So while creating a function, inside the function, you write a docstring. So the docstring is nothing but the explanation of your function. So what this function will do, what operation will this perform. So you can write that clearly in a short and simple format, so that if anyone is using that function, they are able to know that what it will do, correct? Now the last point is functions are a powerful feature in Python, allowing you to write modular, reusable and organized code. It helps us to write a modular, means the code in chunks, a readable code and a reusable code. So that's how we can define a function. Now we have a question. What is the need of functions? So the first is it promotes code reuse, then reducing redundancy, means when we have to write the line of code again and again for a particular operation, that can be reduced with the help of function. If you write a function single time, then at every place when we want to use the function, we just call that, right? It enhances the modularity, making complex problem more manageable. So when we have a very complex problem, we can just divide that problem into multiple functions and then it becomes very easy. It improves readability and maintainability of the code, means we are writing docstring, we have separate functions. So if anyone who is using our code, then he can easily understand that what this function does, what this code does, because of the functions and the docstring inside that. Now we have, it provides abstraction, hiding implementation details, because as we just call the function, so the caller doesn't know what is written inside the function. He will be just able to use that function but not see the code, right? So he will not know what is written inside that, because when he will pass the arguments as 2, 3, 4, so he will get the sum as 9, but he will not know like it is written inside sum equals to a plus b plus c, until unless you don't share your code. Next we have, it provides easier testing and debugging. So whenever we have any issue, so the error will show that in which function we have the issue, so that we can quickly test and debug. Then it encapsulates data and functionality. Encapsulation we will learn again in the classes, so you can just say that it is a topic of the class, so we will learn in the next. For now, you just think that it's a way of hiding your main functionality. Okay. Next we have, it enforces the drive principle. Don't repeat your code, means it helps you to write less code, right? Then next we have, allows for parameterization and increasing flexibility. So we have seen that we can pass arguments, we can pass parameters here and we can use that. So it becomes very flexible. So by leveraging these benefits, functions enables you to write cleaner, more efficient, and more organized code. So now we are done with the theory. Now we will jump to the coding example of function, and we will perform so many examples so that you will be the pro in functions. And after that, you know that you have to attempt the multiple choice questions, and then you have to go for the task and the mini project. So now our course will become more interesting. We will solve bigger problems, and as we have spent a lot of time in basics, the fundamentals, you will see that how it helps you to build your concepts, and you will be able to solve any questions quickly. So let's start with some examples of functions. So in that, first of all, we will see how to create docstring. So what is a docstring? So in docstring, we just document the functionality of that function. So what does that function do? The docstring can be for functions, for classes, for modules, and for anything, right? So in docstring, we clearly mention that what this function will perform, right? For example, the input parameters, the output, and the return statement. So let's say we create a function to calculate the SMA. So def calculate SMA, right? Simple moving average. So in that, the parameters will be a list of prices, correct? And then the window size. So we'll add a column here. Then the docstring can be enclosed within a triple inverted comma. So I'll hit enter. Here I'll explain the functionality. So we can say it will calculate the simple moving average. So we will write simple moving average. Then in input parameters, we can say parameters. So first we have prices. So the prices will be a list of the price. And in window, we have window size, and you can mention that it will be an integer. And here also you can mention the list of float prices, right? Float price. So this is how you mention the parameters. Then again, in return, you can mention that in return it will return the calculated list of float SMA, correct? So that, for example, you have created this function, and if someone else using this function, so they will be able to know that what this function will do and what kind of parameters this function is expecting and what you will get in the return, right? So then we will write the function. So let's say if length of prices is less than window, correct? For example, if you wanted to calculate SMA for a 10-day period, and if the list contains only 9 values, then this function should throw an error. So you will print that value error, correct? You can print that value error. The length of list items is less than the window size, right? And if the price is equal to or greater than the window, then we will simply calculate our SMA. So SMA is equals to, you have to take the sum of the list. So sum of the prices, and here you will take negative window. For example, you have a list of 100 items and you just want to calculate the SMA for the last 10 items, right? The last 10 prices. So in list, we have already learned that whenever we want to access the last value, we have to use the negative slicing, or we can say negative indexing. So for that purpose, we are using negative window. Then we can enclose this in a bracket, and here we can give the window to calculate the average, correct? Then it will return the SMA, right? Now just hit shift enter and check whether this is working or not. So it is working fine. So now let's call this function. So calculate SMA, and we will provide the list. So for prices, I'll write here, and window, let's say I want to calculate for 5 days, and I will declare my list here. So what I'll do, I'll write prices equals to a list which is having the values like 10, 11, 12, 13, 14, 15. So it can be float also. So you can have 16.5, 17.5. Correct? And when you hit shift enter, you get that int object is not iterable. So we are getting some issue here. Prices, if I remove the float here, it should not make any difference, but let's try this. We are still getting the error. Let's check this. What is happening here? Let me remove this. Okay. Now let's try. Okay, that's working. So prices window, and then we need sum of this, right? So I'll just write sum and still it's working fine. Okay, so the issue is here. Okay. Slicing use नहीं हुई यहाँ पे proper. Actually, we forgot to add this colon here because we are doing slicing here. So once you do that, and then you can divide this with the window, right? And then you can see that we have the SMA, correct? Return SMA, which is equals to 15.0. And let's say if you wanted to print this doc string here. So what you can do, you can write like the name of the function and then dot underscore, and then you have to write doc and just hit enter. So it will display you the doc string, but this is not readable, so you can print this out. So when you print this out with the help of print function, you will get a clean and readable doc string that we have given here. So this is how you can use the doc string and you can print, and you should always be having the habit of adding a doc string inside your function, inside your class or modules. So it becomes easier for you and for your team to know that what this will do. Now we have the 2 point of views. So what happens generally? So while creating any function, you should be assuming that the end user is just a noob. He or she doesn't know anything. Means they can input anything and everything. So your function, and it should be capable enough to handle any kind of error. And ultimately, you will be responsible for your function, right? Because in the doc string, in companies, you have to write that who created this function and on which date. So the people will know that you have created this and you are responsible for this. So ultimately it will come to you that why you were not able to handle these errors. So make sure while creating function, you keep in mind that the input could be anything. You should be, and your function should be able to handle that. So that's a basic understanding. Now we have another very important concept, that is parameters versus arguments. And I'm sure that each one of us have read this concept multiple times, but still we get confused between parameters and arguments. So let me show you again. So here you can see that while creating the function, we have given some keywords here, and these keywords are known as the parameters, correct? And while calling the function here, we have given these values, and these values are known as the arguments. So you can remember in this way that while creating the function, these are parameters, and while calling that function, these are known as the arguments. So that's a basic difference, and you can remember that with any analogy, like you can say the speed of the fan. So while creating the fan, the manufacturer set the parameters as 1, 2, 3, 4, and now when you are using, you are giving the arguments, like you want to use the fan at the speed 1. So those are the arguments. So I hope you are able to relate with that, and you can also think of so many examples, because programming is nothing but it is just the expression of the human emotions, the human thinking. Whatever we are thinking, we are putting that thoughts into programming. So it's just that. So this is the basic difference, the parameters versus arguments. So the definition is, parameters are the variables listed inside the parenthesis in the function definition. So while defining the function, right, defining the function, we have listed some parameters inside this parenthesis, and the arguments are the values passed to the function when it is called. So here, when we call the function, we pass the values, the list of prices and the window size. Now we have the type of arguments, the default argument, the positional argument, and the keyword argument, right? So let's take this example again. What we can do here, for example, you have created this function, correct? And now the end user is using this function. So what happened? The end user came, and without even looking at the documentation, what he did, he just called the function and passed the prices as a list. So, and when he hit the shift enter, let me comment this out. And when he hit the shift enter, he gets an error, that is calculate SMA function missing one required positional argument window, correct? So in order to avoid this issue, what we can do, we can give default arguments. So if the user is forgot to pass the number of required arguments, then this function should not display this kind of very bad looking errors, right? It looks very bad. Let's say if you're running a very good and branded application or website and you hit with an error, it gives a very bad impression. So you cannot afford that. So in order to resolve that issue, what you can do, you can just give some default values here. So now let's say the user forgot to pass any arguments. So what will happen now? You have the empty list as the default argument and you have window 1 as the default argument, right? So when you hit shift enter, and here also I'll remove these prices. So when I hit shift enter, and now you get the value as 0, 0, correct? Because we already have given the default values, default arguments. And also this if statement was executed. Why? Because we know that we have given a condition when the length of prices is less than window. And here we know that the window is 1 and the length of price is 0. So it will print this statement, value error. So this is how the default arguments work. So now we have the next, which is positional argument. The arguments that need to be included in the proper position or order. So for example, we will remove this for now and we do not have any default arguments. And I'll also, so here we will keep it same, prices and the window, which is 5, right? Now when I hit shift enter, we know that we are not getting any error and we are getting the correct value. But what if I just change this like 5 to the first order and price to the next? So for example, when the user is calling the function, but he doesn't know the correct order, right? So he just provided the 2 arguments, which is 5 and prices. And when he call this function and you can see that we again have an error, that is object of type int has no length, because here we have to clearly mention that this 5 is belong to the window and the prices list belongs to this prices parameter. So what we can do here, we have to give the correct order. So these are known as the positional arguments. This is nothing new. This is just the interpretation of the things we are doing since the start of this session, right? So we have to give the correct order. So I'll mention 5 and when I hit shift enter, this is working perfectly. Correct. And the third is keyword argument. So let's say as we were facing the issue, right? So if I mention the 5 on the first position, we are getting the error, correct? So in order to resolve that issue, what we can do, we can provide keywords. Because what happens sometimes when there is any module or any function which have multiple parameters, it could be 10, 20, 30, and this is not practically possible for anyone to remember all those parameters in that exact sequence or order. So in that case, you can just have an idea that what could be the parameter and you can just provide the keyword. So here, if I just write here that window equals to 5 and prices equals to prices. So here you can have any other name also. You can say list price, right? And you will say here list price. So, okay. Now when I hit shift enter, we get the correct value, which is 15. So that is how you can understand these different type of arguments. This is very simple, very basic, but it's very important to know, right? Now we have args and kw args. So these are very useful and very important. So what happens here? Args and kw args are special Python keywords that are used to pass the variable length of arguments to a function. And args allows passing a variable number of keyword arguments, which means args only allows non-keyword and kw args allows only keyword arguments, right? So whenever we add a star, so Python will detect that this is the args and it will convert that to a tuple. And whenever we add a double star, the Python will detect and it will convert that double star argument to a dictionary, right? So let's see how does it work. For example, we have this function. So first we will see why we need this, right? Then only you'll be able to understand clearly. So let's say we have this function and here I'll remove the docstring from here. And also let me remove this. We just want a simple function. And let's say we remove this also. Okay, fine. Now what is happening here? Let's remove this also. We'll just calculate a function for sum. So let's say sum of the prices and then it will return the sum of the prices. So what is happening here? We will provide some values. It will calculate the sum of those values and then it will return us, right? So let's say instead of prices, I'll add prices 1 and prices 2. Then what it will do, it will just add them. So let me copy and paste this here and I'll add an addition here. So now what we do, we just hit shift enter and then we call this function. So calculate and we'll pass 1 and 2. So when we hit shift enter, we get the sum as 3. And if I pass like 10 and 20, we get the sum as 30, right? It is working fine without an issue. But what happens sometime, like you are a programmer and you have created this function, but someone else is using. So if he came and what he did, he just added one more value. Like he wants to calculate the sum for 3 values. And that is obvious, right? So when he called the function, he gets this error, which is very bad. It says, takes 2 positional arguments, but 3 are given. Means there is no use of this addition function because it can calculate only 2 values, which is not practically correct in this real life scenario. So instead of that, what we want that we can enter any number of arguments here and we get the sum. So that is the ideal situation, right? So in order to resolve that issue, what we can do here, we can use args, right? So what we will do, we'll just remove these 2 and I'll add a args parameter. So I can add like this, and if I want, I can also add args. So this is just a notation. We can mention any kind of parameter here. Let's say I'll add prices. Okay. Then what I need to do, I need to calculate the sum of that. So I'll use the sum function here, sum of the prices. Correct. So what Python will do, whenever Python observe any star, it will convert that argument to a tuple and then it will calculate the sum of that. So let's say now I pass these 3 values here. So when I hit shift enter, I still get the error. Why? Because we didn't run this cell. So when I run this cell and when I hit enter, I get 60 as return because this function now has variable length arguments and it can take any number of value we are giving it. Let's say I'm giving 40, then 50, then 60, 70, 80. Then when I hit shift enter, I get 290. So that is the ideal condition and we want that, right? Similarly, instead of this, we can use star star kwargs. So this is known as the keyword arguments. So for example, when we have a key value pair, so at that time, we can use the keyword arguments here. So let's take an example here. So what I'll do, for example, I want to create a function for trade logs. So what I'll do, I'll go here and I'll create a function and define, then describe trade. Okay, so describe, then trade, and here we can use kwargs. So I'll write kargs. You can change this to any kind of keyword you want, but generally people prefer this kwarg, so I'll keep it here. Then, so what we know that whenever Python sees the 2 star, it will convert that to a dictionary, right? So for I, okay, so in dictionary we have key and value, right? So for key and value in kwargs, and here I'll give items because to fetch the items of any dictionary we have to write dot items, right? Then I'll give a colon and here I'll print this. So print, or we can return also. So return, let's say key, and then, and we can use this sign here, and now we'll give the values, correct value. Okay, now we can execute this function, and when we call this, let's say describe trade, and we'll give some value. So for example, symbol. So now we will give this a key value pair. So let's say symbol is equals to apple. So symbol is the key here and this is the value apple, right? So when I hit shift enter, I get the value as symbol and apple. So here now I can provide as many number of keyword arguments I want. So let's say I want to provide like the trade type. So trade type was short. So I can mention short, and whether it was profitable or not. So we can say result. So result was, we can say profitable, profit. And when we hit shift enter, we get only one value. Why? Because we are returning only one value here. So for that purpose, what we need to do, we need to print it here. So print and print. So that's how you can use keyword arguments, right? It's very easy, but very important. So now few points to remember. Order of the argument matter. So generally when we have like all the arguments together, so in that case, the first preference will be given to a normal argument, then this star args, and then we have the star star kw args. So for example, if we have here this, so we can say like prices, price, and then logs, price, and args, and then we have kw args. So the order does matter here. So we have to make sure that we are providing the correct order, right? And the words args and kw args are only a convention. You can use any name of your choice. So here we have used already, right? We used prices. Here also you can use any keyword you want, correct? Now we have another very important topic, that is how functions are executed in memory. So for that we have to visualize the function, right? Quickly first tell you how it works. So first we have to define a function, then the memory is allocated to that function, then we have to call the function, and then the arguments are passed, and then the function will be executed and we will get a return value, correct? And that's way it will happen, the execution. Now let's quickly visualize the function. So we'll take this function, and for that what you can do, we have a very good tool, online tool, Python tutor, where you can visualize all the functions, and you should be doing that because then only you'll be getting the idea that how functions are being executed in the memory. So let's open that. So let's say I'll click here, edit this code, and I'll pass my function here. And also we need to call the function, right? So what we will do, I'll go and copy and paste the function call. So that is here. So I'll just copy, and now I can add it to the Python tutor. So let me add. So this is the function definition and this is the function call. So when I click on visualize execution, now you have this, right? So here pay attention. So first of all, this red arrow is at the line number 1, which is the function definition. So when we click on the next step, it skips the whole function and it goes to the last line, which is the function call. And also you can see here, there are two things created. One is the global frame and another is the objects. So in Python, everything is object, correct? So here, this function call is in the global frame, correct? So you can see here that here the function call is happening and that function call is calling the main function, that is describe trade. And you can see here, and when we hit next, an object is created, and this is the key value pair. Symbol is the key and apple is the pair. Trade type is the key and app short is the value. Result is the key and profit is the value. So now again, the red line returns to the definition, and now it will start the function execution. And here also you can see another frame is created. So now we have two frames. One is global frame, which is the frame of whole program, and another frame is created, which is the frame of function, and that is known as the local frame. So we can say the global frame and local frame, correct? Local frame of function. So now here we have the kwargs values, which are these, and when we hit next, it goes to the for loop. So now the for loop is being run. So when I hit next, it will give me the trade type. When I hit next, it will again go to the for loop and it will print the symbol apple, right? The next, it will go to the second key value pair, that is trade type, and it will print that trade type and short. Then again the third value, and it will print the third value. And now when I hit next, you should observe that it returns a value which is none. So now here we can conclude that it is printing the values which are the key value pairs, but returning nothing visually, right? But here we know that it is returning a value which is none. Now when I hit next, the local frame is diminished, that is gone. So here we can say that the life of the function is only while calling the function and returning from the function. After that, the frame is get destroyed and we have only global frame, correct? And that's how the function is finished. And you should also perform some examples here in order to visualize the code, and it will like improve your understanding. Okay, you can go through this document and read. I'll just post this on my GitHub, and please perform the multiple choice questions. Those are very, very important. And before that, what we will do, we'll visualize another function there. So let's take any other function. So let's say take this one. So I'll copy and paste it here. I'll click on edit code, and what I'll do, I'll just remove this doc string which is not required. And we can also, let's make this a little bit shorter so it will be good for you. Let's remove this also, and I'll remove. Okay, let's make this price 1 plus price 2, and here also price 1 and price 2. So here what is happening, we have a function which calculate the sum. Let's write here sum. Okay, sum of the prices, and it will return this sum here. So what is happening here, we have a function which calculate the sum which takes two parameters, price 1 and price 2. Then this is the formula for the addition. Sum price equals to price 1 plus price 2, and then it will return the sum prices. So we will just go here and call this function, calculate sum, and we will provide two values, let's say 2 and 3, right? And now what we will do, we will click on visualize execution. So now let's see something interesting. So here we can see the first of all, the Python code executes line by line. So first of all, it will go to the first line, and when it observes that there is a def keyword, it will skip the whole code. So now when I click next, it will skip the whole code and it will go to the function call. So here we have given 2 and 3, and this side also you can see that we have two things. One is frames and another is objects, right? So in frame, we have two types of frame. One is the whole frame of the program, and another is the local frame, which belongs to the function only, which will created when this function is being called. It's very easy. You just perform few more examples here and you will get to know. So now you check that the function goes to the calculate sum, and here we have two values. You can see here the object price 1 and price 2, because from here we are calling the function. So when I click on next, it will go here, and from here the two arguments are being passed, and which is 2 and 3, and those are in this local frame only, the function frame, we can say. Now when I click on next, the arrow goes to the second line, which is sum prices equals to price 1 plus price 2, and when I hit next, we get the sum prices equals to 5. Now it goes to the return sum prices. So if I click next, then it will return the value to this, and this will print the value. So next, and it says the return value 5, but nothing gets printed. Why? Because we have to add a print statement here. So in order to do that, what we can do, we can just write here print, and then we will be getting the print. So next, and next, and next, and you can see here the print output 5. So this is how you can visualize the code, and it will definitely help you in understanding it more. Okay, now let's quickly move to the next topic, which is the without return statement. So this is also very interesting. Let's go back to the Python tutor, and what we will do, we have done that recently, so we'll do it again. So here what we'll do, we'll just print this value. Okay, so here instead of return, I'll add a print statement here, and I'll write print, and I will remove this print from here. Okay, now let's run this. So what we are doing here exactly, we have removed the return keyword, and instead of that, we are printing that sum prices in function itself only. When I click on this, it says, okay, I think indentation is not correct. So what we will do, okay, when I click, it says unexpected indent. Okay, we need to correct this. It should work now. Okay, in this line. So okay, it should work now. Line 3 still. Okay, now when I click next, it goes to the last line, which is the function call, and you can see we have frame, global frame, and now when I click next, another frame is created, which is the local frame of this function, and now it will calculate the sum and it will print the 5. So when I click next, you can see that in the print we have the 5, but in return we have none. So we can say that even when we are not mentioning return, the function will return a value which is equals to none. So function always return a value whether you mention or not, and if you do not mention, then it will return a none value. So that's how you can understand this, and you can have more examples here and visualize. Now we have the next topic, which is variable scope. So we have seen it already somewhere. Let me show you. So here we have the function, and you can see here that when we executed this program, we had two frames. One was global frame and another was local frame. So the local frame belongs only to the function, and the global frame belongs to the whole program. Similarly, let's quickly copy and paste this function, the above function here. So let me take this only and I'll paste it here. So, and let's change it to somewhat simpler, which is price 1 plus price 2, and here also I'll provide these values. Okay, and now let's verify whether this function is working or not. So let's call this calculate SMA, and we'll give two prices, 2 and 3, and we get 6. So, and even you can write here sum, so you don't get confused. Okay, so now we have 6 here. So let's say I have another variable here, and which is, let's say, okay, let's give some function here only. So we will give it the name outside function, func. Then I'll give I'm from outside of the function, correct? And the same thing we will print inside, let's say after this, and here we can give the name inside function, I'm from inside of the function, correct? Okay, and now I think it's fine. Let's take this to the Python tutor and we will try to visualize this, right? So let me click edit code, and here let's also copy this function call. I'll write it here. Now I click on visualize execution. Now you see here that, okay, so what happened here, it says calculate SMA is not defined. Okay, because we have to write sum here, so we'll just go and change it to sum. And now we click on execution. So now you can see the function is at the first line, and when you click on next, a global frame is created, and inside that global frame the function moves to the this line, outside function equals to a string which is I am from outside of the function, correct? And when I hit next, it will get printed out outside function, right? Then the line goes to the next, which is the function call, and it will call this function. So when I click next, a new frame is created, which is the local frame. Make sure you remember this, right? And also in that we have price 1 equals to 2 and price 2 equals to 4, which we passed here as argument. Now let's click on next. So this will go to this line, sum prices, and it will calculate the sum, and now it will print the inside function I am from inside of the function, correct? Then it will return the value which is 6, the sum prices. And now when I click next, you observe here that it will get diminished. So we are left with nothing actually. If we wanted to print the 6, we need to add print here. So the motive of this visualization was that the local frame always get diminished and we are left with only the global frame. And if you want to print this return value here, so what you can do, you can just go and you can add a print statement here. So I'll write print and I'll close this in a parenthesis. And when I hit on visualize and click on next, and you can see that we have printed 6 here. Now you can say that this outside function is a global variable, but this inside function is a local variable, correct? And also this inside function can access this variable and use it, but cannot make any changes, okay? And sometime if you require in any case, then Python is so flexible that it will give you an option, but it is not ideal. You should never change this global variable. It's not a good programming practice. So with that being said, so here hope you have understood my point that this is global variable and the variable inside the function is the local variable. And also this function can access this variable and can use this, but cannot make any changes. That is not the ideal condition. So you should not be making any changes to the global variable, correct? So now we have the next topic, which is nested functions. So nested function is nothing but a function inside a function. As we have already seen in the list and loops, we had nested loops, nested lists, and now we have nested functions. So let's quickly move to the example, which is like this. For example, we have a function for trading decisions. So define, and let's give it the name trading decisions. And inside that we have two functions. One is buy decision, let's say, and another is sell decision, right? Sell decision. And let's close this function. Okay. and also we can give some return here. So now we have three functions. The main function is trading decisions. Inside that we have two functions. The first is buy decision and the second is sell decision, right? So whenever this first function, which is buy decision, executes, will return a value which is, let's say, a string, and whenever this sell function executes, will return a string which is sell. Hopefully it's very easy and it should be very clear, right? Okay, so let's give some conditions, and what we will do, we will give here a parameter which is price. So if price is less than 50, let's say 50, then what will happen, we will call the function by decision, right? Else we can call the sell decision, right? So now let's just hit shift enter and call the function trading decisions, and let's give it some value, so which is, let's say we give 40. Okay, and when we hit shift enter, okay, we have to print this return value. So for that, what we need to do, we will just print here. So hit shift enter, it says none. Okay, we forgot to return this, so here we have to return these functions. So my bad. So what we can do, I'll just hit shift enter, and so now you can see that we have a price which is 60 and that is greater than the 50. So the sell function will execute and we will return as sell. If we have a value less than 50, let's say 40, then a buy decision will happen. So this is how the nested functions work, a function inside function, and you will be using a lot these kind of functions. So what you can do, you can just go to MCQs, you can attempt those MCQs, and then you should go to task where you have multiple good algo trading based tasks, and then you have a mini project which will definitely help you to build up your functions concepts. And still, if you have any doubts, you can connect with us on any social media like Discord, Telegram, Instagram, and even YouTube comments. Next, we have one of the most important concept of Python, which is functions are considered as first-class citizens. This line seems a little bit different, right? But when you understand the real meaning of this line, you will be blown away, because Python functions are so powerful, so flexible, which makes the Python a very powerful language, a very flexible language. So let me show you quickly why Python functions are considered as first-class citizens. So let me show you few pointers. The first is assignment to variables. We can assign functions to any variable like we do in string, integers, list, tuples. So it helps us to call a function with the help of a variable. So functions can be assigned to variables. The second point is functions can be passed as an arguments. It can be useful for higher order functions, which can take function as an input and also can return them. So you can say functions can be passed as arguments to other functions. The third point is the functions can be returned from other functions. The fourth point is the functions can be stored in data structures like in dictionaries, tuples, or list. And last but not the least, function can have attributes to store metadata or configuration options. And so why this behavior of functions is useful? So the first is we can create higher order functions so that we can manipulate other functions and which can enhance the modularity and reusability. The second is callback and event handlers. Generally, this is used in GUIs, so we can use this in response to certain actions. We'll be also having a quick session of how to create GUIs in Python. And the third point is this behavior is really useful in the functional programming. And this is also useful in the dynamic behavior. So let's quickly understand this topic with the help of few examples. As we have discussed multiple times that in Python, everything is object, right? So we can say that functions are also objects in Python. How? Let me show you. So let's define a function and give it any name. So let's say define, and let's give the name trading logs. Okay. Then what we will do, we'll just pass it. Okay. So it doesn't give any error. And then here, what we will do, we'll print the type of this function. So type and trading logs. And then we will also print the ID of this. So with the help of ID function, we can print out the memory address of that particular object. So here we have the object as a function. So let's give trading logs. And when we hit shift enter, we can see that the class is function. So earlier we have seen that for all the other objects like list, tuples, dictionaries, it was showing here the class list, class dictionary, class tuples. Similarly, here we have the object as functions, in that we have the class as function, and this is the memory address of that, right? Now let's see an example where we can reassign the functions to any other variable, right? So let's take this example again here, and what I'll do, I'll define this, and here I can say that we are getting some values here. So let's say price 1 and price 2, and what we can do, we can print the sum, so we can return the sum, right? So return the sum of this price 1 and price 2, correct? So here what I'll do, I'll just call the function in the second line. So here when I call the function trading logs, and I'll give two values, let's say 2 and 3, and we get 5 as a return, right? So if I want, what I can do, I can assign this function to any other variable. Let's say I'll assign it to a variable named sum of the prices, so sum prices. And now when I call this function sum price, and here also I can pass the arguments, and when I hit shift enter, we get the value as 5. So here you can see the flexibility of Python, that we can assign a function to any other variable, and it becomes really useful. We'll be seeing some use cases in the future when we start the algo trading live examples and live projects. So it will be very useful in that. So now let's take an example where we will be deleting a function. So let's say, let's take the same example here again and paste it here. And what I'll do, I'll just add another cell, and here we can print that analyzing a function deletion. Okay. So when I hit shift enter here, and when I call this function, and let me remove this price is not required for now. I'll just remove and hit shift enter. And when I call this function trading logs, we can see that we have a string named analyzing a function deletion, and which is returning from this function, right? So if I delete here the function delete trading logs, and after that when I print this function, I can add print here also, it's not an issue. So what I'll do, I'll just print here. Okay, so here you can understand the scenario that first we are calling this function, and it should return this string which is analyzing a function deletion. Then we will delete this function, and then we will again try to call this function. So what happens? So here you can understand the scenario that first we are calling this function. So ideally it should return this string which is analyzing a function deletion. Then we will delete the function with the help of del operator, and again we will try to call the function. So let's hit shift enter. So here you can see that it says cannot delete a function call. So when we add this parenthesis in front of the function name, that means we are calling a function. So we cannot delete a function call, but we can delete a function with the name. So what we will do, we'll just remove this, and when I hit shift enter, you will see that it says name trading log is not defined. But before that, first it printed this value analyzing a function deletion, then it deleted, and now when we try to print, it will throw an error. So that's how we can delete a function, and it is also very useful sometimes. I'll show you how in the future when we are performing a live trading. So here let's see how we can store a function in any object like a list, tuple, dictionary. So for example, we have a function with the name define by stock, and we have a parameter with the name stock. Here what we will do, we will return. So whenever this function executes, it will return a string which says by and stock. So for stock we will give this, and here we can give a formatted string, so f. So means whenever this function executes, it will return a by and whatever the name of the stock. So here we can see that whenever this function executes, it will return a value, this is string, and it will display by and whatever the stock has been passed as an argument. Again we have next function, and we can name it as cell stock, and here we can change from by to cell. Correct. Now we'll execute this, and here we can have a dictionary. So let's say actions, and in action we can store the values like the by is the key and value is this by stock, right? So by stock, and again the next key value pair is cell. So in that the key is cell and value of that key is this function called cell stock. So here what is happening, whenever we fetch the value of this key, this will be called, right, the by stock, and when we fetch the value of this cell key, this cell stock function will be executed here. So now how we can proceed? So let's say what I'll do here, I just fetch the value of this key by, so actions, and here I'll give by. And here now I can give the parameter of this stock. So here I have to give a string because here we are returning a string, a formatted string. So what I'll do, I'll just give that by apple. I hope that you are able to understand this logic here. So when I hit shift enter, I get this string by and the value of the this by key, correct? And if I call this cell key, let's say cell. So whenever we fetch the value of cell, we get the cell stock value, and that cell stock value is itself a function here. And when this function executes, it will return as a string, which is cell and stock. And here the argument of this stock parameter is apple, or we can change, let's say BTC. So when I hit shift enter, I get cell BTC. So this is how we can store the function as any object. Now we will see how we can return a function. So what we will do, so let's say we have a function. So define strategy selection, right? And here we can give the name as strategy name, and inside that strategy selection function we have another function, that is another strategy, that is define, let's say this is momentum strategy, and it will return a string, and that is momentum strategy, right? Momentum strategy. And we can define another function, let's say mean reversion strategy. So if this function executes, it will return a string, that is mean reversion strategy, right? So now we give the condition. So if the arguments passed to this parameter strategy name is equal to a string, that is momentum, then it will return this function. So now we are returning a function itself, correct? Else it will return the mean reversion strategy. Hopefully you are able to understand this. It is very easy and very simple. Just practice yourself 2-3 questions and you will be good to go. Okay, now what I'll do, I'll just hit shift enter, and in the next cell we'll call this function. So what we'll do, let's give a name, strategy is equals to the call of this function, and we will give a string momentum, right? Momentum. And then what we can do, we can print the strategy, and we can correct this also. I'll just add another y, and now when we hit shift enter, okay, it will call this function, and when we have the momentum, it will return the momentum strategy. Okay, and okay, actually we have to add here, okay, now when we hit shift enter, we get mean reversion strategy. So actually we are calling a function, so we have to add here a parenthesis, right? And let's say if I give here any other value except momentum, let's say mean, so it will give us the mean reversion strategy. And if I give here momentum, it will give us momentum strategy. So except momentum, if there is any other value, it will always return us the mean reversion strategy. So that's how you can see that how we can return a function also, correct? So now the last example we have as the function as argument. So let's create a function, define moving average strategy, and here we'll have a parameter with the name price, correct? And it will return us the moving average. So what is the formula of moving average? The sum of the price, correct, and divide by length of the price. So let's say it will be a list, so length of the price. So now let's create another function, that is define execute strategy, and here we'll be having two parameters. One is a function itself. So let's say a strategy function, and another we can have the price. So here I can return strategy function, and inside that we can have the parameter as price. Correct? Okay, now we hit shift enter, and here let's say we have a list of prices which contains price as 10, 20, 30, 40 and 50. Let's 60. Okay, and now we will print. So what we will do, we'll call this function execute strategy. Inside that we will pass two arguments. The first is strategy function. So we want to execute this function, right? So we can pass this as an argument here, and then we will pass this price list. So I'll write price, and when I hit shift enter, we get 34. So now you can see that how powerful the Python is. We can use the functions however we want, and that's why it gives us a flexibility to use Python in multiple ways, and it really becomes very useful for us. So that was the detailed explanation of why functions are considered as first-class citizen. And now we will quickly see what are the benefits of using a function. As we have already explained this, it is for the code modularity. So we can break down a code into smaller functions and makes it easier to manage and understand. So the first benefit is code modularity. For example, we have a big application to create, and inside that we can break down that applications to a smaller functions, right? And each functions can be created by our different team members. So in that way, we can execute any task very quickly and very efficiently, right? Then we have the code readability. So instead of having 1,000 lines of code, we can have different sections of function, and in that function we can even define the docstring, so it becomes more readable. If anyone is reading that code, they can able to understand that what this function do and what this part of that code perform, right? So for the code readability. And the third we have is code reusability. So once the function is created, we can use that function in multiple ways, as we have seen recently. So these are the big benefits of using a function, and that's why we consider function as a first-class citizen. I think that was a really comprehensive explanation of the functions, and that is it. Now we are moving to the last topic of the functions, which is super important, super easy, and super useful. That is lambda functions. So let's understand what are the lambda functions. A lambda function is a small anonymous function. You have to pay attention to these two keywords. Small anonymous function. A lambda function can take any number of arguments but can only have one expression. So there are three keywords. First is small anonymous, second is any number of arguments, and third is can have only one expression. So now let's see how we can define a lambda function. So first of all, we have to write the keyword lambda. Then we write the arguments, or we can say parameters. And I have already explained you the difference between parameters and arguments. And we can have one or more parameters are supported. And all these parameters must be separated by a comma and no parenthesis. Correct? Then we need to give a colon here, and in the final we can have an expression. So it must be a single valid Python expression. It can be only a single expression, right? So now there are a few key points which we need to keep in mind while creating a lambda function. So let me write key points. The first one is anonymous. Means lambda functions are anonymous and they don't need a name. So we can write like don't need a name. Correct? The second key point is single expression. So let me write single expression. So we have seen that. Let me show you it again. See, there is no name. We only write the lambda, and also we can have only single expression in a lambda function. So this is only a single expression. We can have it a negative, we can have it a multiplication, and we can have any other valid Python expression. Correct? Means we can say they are limited to single expression, and for more complex logic we should be using a regular function. And now the last but not the least, we have inline uses. So in short, you can say use and throw. So in short, we can say these are one-line functions and they are used for a very short period of time. So that is the theory of the lambda functions. Okay, one more point I forgot to add, that they are used with HOF, higher order functions. I'll just show you quickly what are the higher order functions with the help of some examples. But you can simply say the map function, the reduce function, and the filter function, and also the sorted function. These all are higher order functions. Means they can accept any function as an argument and they can even return any function as a return statement. So that's how you can define lambda functions. And now we will quickly move to the coding examples of lambda functions. As we have already understood the theory that lambda functions doesn't have any name, lambda functions has no return value. In fact, it returns a function. And also lambda functions are written in one line, correct? And then the last is lambda functions are not reusable because these are use and throw functions. And also they are used with higher order functions. So let us quickly understand the lambda functions with the help of some examples. So let's say we want to calculate the moving average of the last two prices. So let's say we have a function define moving average. So moving average, and so here we are providing a list, let's say. So we can say prices, and then we will provide a window as a parameter here. So window, then the moving average. So we can say simple moving average is equals to sum of the prices, correct? Sum of the price divided by the window, correct? And then it will return the SMA. Hopefully you are getting my point. This is a normal function. So when we hit shift enter, and in the next cell we will call this function. So moving average, and here the prices. So I'll write the argument prices, and window I'll provide is, let's say, 4. So and here I'll declare a list. So in that I'll be having, let's say 1, 2, 3, 4, 5, 6, 7, 8. I have a list which is having 8 elements of prices, but I want to calculate the SMA of only the last 4 prices, correct? So what I can do here, I can go here and I can write like window. So what it will do, so we know that this is slicing, right? So, and then I will give a colon. So it will start from the whatever the window we have given, which is 4 here, and it will calculate for only those, right? So when I hit shift enter, and here also shift enter, it says price is not defined. That is true. We have to give this as prices. And now when I hit shift enter, I get the value as 40. So let's see, we have these 4 values, the last one, right? So 8 plus 7 is 15, yes, and 21, and that is 26. So sum of that and divide by window. So it should not give this value actually. This is something wrong here. Sum of the price of the last 4. So from here to here, the sum, and then what it did, it divided that with the window. Let's say I want to calculate for the last 2 prices. So 2 is giving me 55. If I give 1 here, then what I'll return 60. 60 is the sum of this one. 21 up to here, 26, 30, 33, something is okay. Actually we missed S here. We have to give S. And now when I run, actually my bad, I'm really sorry for that. So when I run shift enter, I get 8. Why? Because the last value is 8 and 8 divided by 1 is 8. So of course I have to change this. I'll take 4, and when I hit shift enter, I get the value as 6.5, which is true. So now how we can achieve this whole functionality in a just single line of code? What we can do, as we have seen in the lambda function theory, that first of all we have to write the lambda keyword. So lambda keyword, then we have to provide the arguments. So here we know that we have only one argument, that is prices, the list of the prices. So I'll write the prices, and now we have to provide a colon here. So a colon, then we have to provide the expression. So it will be a single expression. So here what we will do, we have this formula, right? So what we can do, we can simply take this or just write it here. So sum of the prices, and we know that we want only the last 4 prices. So I'll write negative of 4. Okay. Then we have to divide that with the window, which is 4. Hope you are getting my point. Correct. Now you have 2 options. Either you can provide here the list, or you can give the list in like different variable. It is much better for readability. So what we will do, we'll just copy and paste the list here. And now when you hit shift enter, you just get a single object. But in order to print this, what we can do, we'll print and the moving average. So when I hit shift enter, we get an object, correct? So we have to provide here the parenthesis, and now when I hit shift enter, I get an error. This is because we haven't given here the colon, because as we have already understood in the list, tuples and dictionary, that we have to provide the colon here for the indexing or slicing. So now when I hit shift enter, I still get that missing one required positional argument, prices. Yes, of course we have to give here the prices, and when I give it here, and now when I hit shift enter, I get the value as 6.5, which is exactly the same which we get from a regular function. So that's how you can use the lambda function. Now we will use lambda functions in higher order functions, that is map, filter, reduce. So let's start with map. So let's see this question, using map to calculate the square of a list of numbers. So we have a list, let's say we have a list, price equals to, let's say 2, 3, 4, and again -5, again -5, -6, and -7. So what we want to use the map function to calculate the square of a list of numbers. Okay, so for the regular expression, we know that we can do that, right? But we want to achieve that functionality with the help of lambda functions and map, and in a single line. So what we can do here, so first of all, we'll start with the lambda function. So as per definition, we have to write the lambda keyword first, then we will write the arguments. So the arguments will be here x. Let's say we want to calculate the square of the x, then x power of 2. That is a formula to calculate any square, right? So that is the lambda expression, as simple as that. So if I give like 2 here, we'll be getting 4 for this. But here we have a list. So what we can do, we can use the map function here. So I'll just enclose this within a map function, and map function expects 2 things. The first is the lambda expression here, and the second is it expects a list. So here we will provide the list. So the list is price, right? Now what I can do, I'll just hit shift enter and we get an object, but we want the list which have the square of these numbers. So what we can do, we can again enclose this in a let me enclose this in a list, and now when I hit shift enter, we get the squared of these numbers. So that's how this lambda works, and it's super easy and super flexible and super useful in so many of your situations. Again, the next question is using map to label prices as high or low. So how we can achieve that with the lambda function? So let's say we have a list. So what I'll do, I'll copy and paste it here, and we will just comment it out so it doesn't create any issue like the last program. And I'll give here the values as like 200, 300, 400, -500, -600, and -700. So what we want here, that if the price is greater than 200, it should be labeled as high, and if it's lower than 200, it should be labeled as low. Let's write the lambda function first. So lambda, same, we have to pass the argument here. So let's say x, and now we want to print high, and then condition. If x is greater than 200, correct? Else you can print low. It's as simple as that, correct? Now what we will do, we'll just hit shift enter, so we get an object. But here we have a list, and we also want the list as an output. So what we will do, we will use map function again here. So we'll enclose this in map, and here we'll write map function. And as we know that map expects two arguments. The first is the lambda function, and the second is a list. So here again the list is the price, and now when we hit shift enter, again we get an object. But as we know that we want a list, so we'll again enclose this in a list. And when we hit shift enter, and here we can see that the first value is low because it is less than 200. The second, it is greater than 200. The third is also greater than 200. Then we have last three values which are negative values. So of course these will be labeled as low. So the next example is fetch names from a list of stock information dictionaries. As per the question, we have a list which contains stock information dictionaries. So what we can do, let's write a dictionary. So stocks is equals to a list of dictionaries. So let's say we have two dictionaries here, right? Two elements and two dictionaries. So the first dictionary contains the information of one stock, and the next is contains the information of another stock. So let's say we have the first stock, which is a symbol and then a colon, and we have this as apple, and name of that stock is name and stock is apple, correct? Then another, so let me quickly copy and paste this, and here I will change to BTC, and the name is Bitcoin. Okay, so now we'll use the lambda function here. So as usual, first of all we will write the lambda function here, then the argument, and what we want, that we want the value of that argument. So here x is the key, and we want the value of that key. So value is name, right? We want the apple, correct? And now when I hit shift enter, we get a object here. But what we will do, now we'll map it. So map, and again in map we know that it expects two arguments. First is lambda function, and the second is it expects a list. So here we have a stocks list, stocks, and then we hit shift enter and we get another map object. But we know that we want this in a list. So I'll again enclose this in a list function, and when I hit shift enter, we get apple and Bitcoin. So this is how you can use lambda functions with higher order functions, and it's really useful. And now we quickly take some examples of filter and reduce. So in filter, the filter price is greater than 100. So again, let's say we have a list. So prices, and there we have like 50, 60, 70, 100, 1110, 120, correct? As usual, first we'll write the lambda function, then the argument. So argument is x here. Then what we will do, here is a filter condition that we want only the prices which are greater than 100. So x is greater than 100. Okay. So now when I hit shift enter, we get an object. So what we will do, we'll use the filter function, and similarly, filter also expects two arguments. The first is lambda function, and the second is the list. So now when I hit shift enter, we get an filter object. But as we know that we want this in a list, so I'll just go and enclose this in a list. So we'll get 110 and 120. So that's how it works, and it's very easy. Now we have filter strokes starting with A. For example, we have a stocks, a list, and in that we have few stocks, let's say Apple and Microsoft. Then we have Amazon, and let's say we have Meta, correct? So what we want, that we want to filter out only the stocks starting with the A. So as usual, lambda x, then colon, and x should starts with A, right? So when I hit shift enter, we get an object. So again, we'll use the filter here, the filter function. So filter, and as usual, it expects a lambda function and a list. So here we have a list stocks. And when we hit shift enter, we get another object, but we want this in a list. So we'll enclose this in a list and we get Apple and Amazon. So this is very useful and you should be practicing some questions of MCQ and task. So now we have another higher order function, which is reduce. So to use reduce, we have to import this from a module. So it is from the func tools import reduce. Okay. So now let's say we have a list. This was the culprit of that issue last time. What I did, I assigned a list with the list name, and we know that list is a keyword, so I cannot use that, and because of that I was getting issue and I had to restart my program. So I'll just give it a number, and numbers equals to, let's say we have few number 1 2 3 4 5 6 7 8 9, okay, and 10 also. Okay, so now what I want to calculate the sum of this list. So what I'll do, as usual, I'll write the lambda function. So lambda, then here we have two arguments, right? We want a sum. So while using reduce, we have to give two arguments. Okay, then we'll give a colon and x plus y. So when we hit shift enter, we get an object as usual, and then we will enclose this in reduce to use the reduce function. So when I hit shift enter, it says reduce expected at least two arguments, quote one, because we know that these all higher order functions expects two arguments. The first is the lambda function and second is the list. So in list we have these numbers. So let me go and give the numbers here, and now when I hit shift enter, we get the sum of this whole list. So that's how powerful it is. So what is happening here, let me show you what it does. It will first calculate the sum of this number 1 plus 2, then 3 plus 3 6, then 6 plus 4 10, then 10 plus 5. So what it does, it will like go from left to right and it will calculate the sum. So that's how it works. We can also use in some other examples. Let me show you. So I'll just comment it here that for sum calculation, and let's say we want to find the minimum price. So what we can do, find the minimum price. So here again, let's say we have the same list. So I'll give here and let me give it numbers 1 and numbers 2. So as usual, we'll write the lambda function. So lambda keyword, then the arguments, which is x and y, because reduce expect two arguments, make sure, because it will perform operations on two variables, x and y. And then again, the sum of this will become x and the y will become 3. So the colon, and then if what it will do, it will go and it will like x equals to 1 and y equals to 2, and it will check which is smaller. So if x is smaller, it will print x, right? If x is less than y, else it will print y, correct? So now we have a lambda function. What I'll do, I'll just hit shift enter and we'll get a lambda object. Then we want to apply reduce here, right? So reduce, and we know that reduce expects two arguments. The first is lambda function and the second is the list. So the numbers, and when we hit shift enter, we get the 1, right? If let's say if I write this at the last place, it will still calculate and give me the answer, that is 1. So this was the comprehensive explanation of the functions, and now we are done with the functions. So now the question arises, what is object-oriented programming? So you can simply say it organizes our program as objects. So now let me show you what are the main concepts in object-oriented programming. So let me draw a circle here. This is object-oriented programming. The first concept here, class. The second concept here, objects. The third concept here is encapsulation. Fourth one is inheritance. So I'll just write here inheritance. The fifth one is abstraction. And the last important concept is polymorphism. So now we'll be learning each concepts one by one, and you'll find out that how easy these concepts are. Now the next question is why we need object-oriented programming. So let me write here. So you can simply say, like, when we have a very messy, very spaghetti code, it can convert that into a very neat and clean code. For example, so here we have multiple variables, you can say, and multiple functions. Like you have a very big application, and these type of blocks like variables and functions, we have multiple of them. So it becomes very difficult to manage all those functions and variables. So in order to resolve that issue, so what we can do, we can take the help of object oriented programming. So you can simply say it will convert a messy or a spaghetti code into a neat and clean code, or you can say organized or readable code. So that's the basic understanding of why we need object oriented programming. So the first of all, what we will do, we will understand the theory of these concepts like class, objects, encapsulation, inheritance, abstraction, and polymorphism. Then we will move to the code. So it will become so easier for us to understand this concept. So let's take the first concept, that is class. So in simple word, you can say that class is a blueprint. Correct? Which tells us that how this object will behave. Don't worry, we will also understand shortly that what are the objects, but for now, just focus on class. So the class is a blueprint which tells us how the objects will behave. How the objects will behave. Very simple and short explanation. So for example, we have a class and we can name it as human. Correct? So in humans, what we have? So in humans, we have some properties, or we can say attributes, and we also perform some actions, some functions. So let's say this human class have some properties, or you can say some attributes, and it also performs some actions, some functions, right? So you can write functions, or you can say behavior, right? So now we can say that we have a human class which have some properties or attributes, and also that class performs some functions, right? So let's say in properties or attributes, what we have two hands, right? So we can say we have two hands, two legs, two eyes, right? One head. So here this human class have one head, two hands, two legs, and two eyes. And we know that these attributes or properties perform some functions. Correct? We can say the head performs some important task of the human class, right? Which involves decision making and many more. Then we have hands, which also perform some actions like to pick up anything and to hold anything. Then we have legs, which helps the human class in walking. And the human class also have two eyes, which helps in watching or viewing anything. Or we can say the function of the eyes attributes is to watch or to help in the vision of the human class. And here we also know that this class is just a blueprint. Correct? Now, this class is applied to all the human beings, whether these are males or female. Whether male or female, everyone follow this blueprint, right? So philosophically, we can say that God created this blueprint, right? This human class blueprint. And now all of the human beings which are created, or we can say which are born, so those are the objects. And all those human beings follow this human blueprint or the human class created by God. Hope you are getting my point, what I'm trying to say. So simply, God created the human class, and now all the human beings, whether male or female, follow this blueprint, that is the human class, when they are created, or we can say when they are born. And when they are dead, the object is also dead. And that is the real life analogy of the object oriented programming. And in fact, we know that all these concepts are derived from the real life only, correct? So now we will say that this is the data or variables, correct? Or variables. And these are the functions which are also known as the methods. Now you have to make sure that you do not get confused. And also known as the methods. So in short, the variables inside the class are known as the attributes or the properties, or the functions inside the class are known as the methods. I hope you are getting my point. So this was the class. So now let's move to the objects. So what are the objects? So here you can simply say that the instance of this class, so let me write it. So objects are the instance of the class. Or philosophically, the God created this class, human. So now whenever a human being is born, he or she is an object. Simply. So let's understand this with the help of an example. So let's say the God created this class. So how we write a class? We just write the keyword. We just write the keyword class and then the name of that class. So here the God created the human class, and then we have to give a column. So let me enclose this in a box so you are not confused. So this is the syntax of the class. So what I'll do, the name of the class is human and the class is a keyword. Okay. So here when the object is created, so what will happen? So let's say a new human being is created, Kuldeep, my name. Then what happened? As soon as the object is created, and in this scenario, the humans are objects and Kuldeep is one of them. So when Kuldeep is created or born, the God already knows that he have a blueprint. What he will do, he'll just assign that blueprint to that human. So the class name human, so what he will do, he will write Kuldeep is equals to human. And here you have to give this parenthesis, right? So simply you can say here, this was the class name human. And when the object is created, the name of that object is Kuldeep and it is assigned a blueprint, which is human class. So means all of the properties of that class and the functions of that class, which is like the properties means the hand, the legs, the head of that class, and the functions, which is walking, thinking, watching, all those functions will be given to this object. Because God don't want that every time a new object is created, he will create first the hands, then he will create the legs. It's very difficult, right? So instead of that, what he will do, he know that he have a blueprint, so he will just assign that blueprint to the new object. So now it doesn't matter that how many objects are created. He only needed to work only one time, and now he can simply assign the blueprint to the objects. So now I think you are able to understand the power or the usefulness or amazing feature of the object-oriented programming, that it helps us to reuse a single code multiple times. But if you try without object-oriented programming, similarly, like if the God try to create all the human beings manually, each one of them, it will be absolutely hectic task for the God. So he can just assign a blueprint. So that was my analogy, and I tried my best to make you understand this concept. First visually, practically in real life, then if we see any code, it will become very easy for us. Let me know in the comments whether this example was useful or not, and then we can move to the next concepts, which are encapsulation, inheritance, abstraction, and polymorphism. Now we will quickly take some examples to understand the class and objects. let's say we have a human class. So in that we have to first write the keyword class and then the name of the class. So here in example we took the human, so let's say human, and then you have to give a colon here, correct? Then here you will write your code, so I'll just write pass for now. And when an object is created, like the humans in analogy, so for example, when I was created Kuldeep, I was given a blueprint from the god, that is the human class. So human, and we can say that this Kuldeep object is known as the instance of this human class, correct? And again, this step is known as the instantiation of the class. And we already understood in the example that this class contains some data, or we can say attributes, or we can say properties, all are same. And we can also say that this class contains data, or you can say properties, or you can say attributes, all these are same. So let's say hand equals to 2 and legs 2 and head equals to 1. In general, these are the variables, but here we call them as the attributes or properties, or you can say the data. And this class also contains some functions. So let's say define, and we'll say vision, right? So I'll just pass here for now. And human class also can walk, so we'll say define walk, and let me pass it. Like this human class has so many functions, but we'll just mention here few of them. And humans can also think, so let's say think. So we have some properties, which are the variables, and we have some functions, and the functions in class are known as the methods. It's same, but whenever the functions are inside class, they are known as methods, and the variables inside the class are known as the attributes. Now let's press shift and enter, and this will be executed. And here also, when I press shift enter, it will be executed. So now let me create another cell. So now let me write Kuldeep, which is the name of the object, and then dot. And when I type dot, and you can see that we have few suggestions, which is the hands, the head, leg, think, vision, and walk. And here you can clearly see that hands, head, leg, these are the variables, or you can say the attributes of this human class, and the think, vision, and walk are the functions of that class, right? Hopefully you are able to understand what I'm trying to say. And similarly, if I want to execute this vision function here, I'll just write here vision, and that's it. I can access all the functionality of this vision function, and that's how it works. Let me show you another analogy here. So let's say, as you already know that in Python, everything is object, right? So let's say we have a list. So L equals to a list, which is 1, 1, 2, 3, 1, 3, 4. We have done this multiple times, right? And when we write L dot, here you can see these are all the functions of the list class. See these, the append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort, and add. So these are all the functions of the list class. So now you can say that someone from the Python team created a class named list, and we are using that class. So what we are doing here, we are creating an object, and then we can use all those functions inside the class. It's same exactly like what they did. They created a class named class, and they gave it the name list, or whatever the different name. And inside that they have different functions. Like we have here vision, walk, thing. So similarly, they have here append, clear, copy, and count. And whatever the function we want to use, we will just write that function, append, and we'll give a parenthesis. So that is the analogy. And I think now you are able to understand the whole concept clearly. So here you will say that the append is the method of the list class. It's not the function. Although they are both same, but in this scenario, we will say that append is the method of the list class. And we also know that when we have a string, let's say string and Kuldeep, correct? And when I type s dot, so means string is also in class, and inside that we have capitalized, case fold, center, count. But here we do not have the append function, correct? Because the creator didn't create the append function in string, because strings are immutable, so we cannot add anything. And that's how you can use this analogy to understand the object and methods and functions. So means you can say that the functions inside the class are known as the methods, and the variables inside the class are known as the attributes. Let me show you another example. So okay, so we have the string s. So when we type s dot something, we are displayed all the methods inside that class. But when we type like length, len, and s, and let me type it again, s dot lower. So now we know that, let me do it upper because the string is already lower. So okay, so now I'll not answer this question. You have to type that. We have two things here, methods or functions. So len is a method or function. Again, upper is a method or function. You type in the comment. Just pause the video and think, and then you will realize that yeah, we have just learned this, and you will be able to answer this. And if you are still unable to answer, don't worry. Each one of us have different kind of abilities, and some of can understand any concept in one time, and few of us can take 2 or 3 iterations. That's easy. That's nothing to worry about that, because each one of has different attributes and different functions. So no need to worry. And each one of us are as useful as the other ones. So don't compare yourself to any other. Just focus on yourself, and you know that how many iterations you need to learn this concept or any other concepts in life. So just pause the video and answer in the comment. Okay, so let's understand this topic with the help of an example. So let me create a class trading strategy. So, and one more thing, this type of naming convention is known as the Pascal case. Means the first letter of every word is capital. That is known as the Pascal case. So then I will give a colon here. So what will happen now? There are a few things which you might not understand. Don't worry about that. I'm creating this example just to make you understand those things. So just don't worry about that. Okay. So let me define a function here. So define init. Yeah, don't worry about this. We will understand this. Okay. So in class, we have two things. One is attributes and another is, so this is a method named init method. Okay. And in that, I will write a word self. And I know many of us have issue understanding this self keyword. Okay. And then we will type 2 parameters here. So one is symbol and another is amount. Correct. And it's exactly the function we are creating here. Just the name is different because we are in class, and in a class, the function is known as a method. So I'll add a colon here. Then inside that, what I will do, I'll write self dot symbol equal to symbol. So what is happening here? The symbol parameter is equal to self dot symbol. Then self dot amount is equal to amount. Okay. Again, I'll declare another variable, that is self dot position is equals to 0. So don't worry about the self keyword now. You just assume that we have a normal function with the name init, and inside that we have 2 parameters. First is symbol and second is amount. Just ignore this self as of now. Okay, now what we will do, we'll define another function. Now you just pause and think that generally in any trading strategy, what things we need to consider. So the first is we think that what will be the buying conditions, correct? And the second thing we consider is that what will be the selling conditions. And also we can add the status, means what are the current open positions and how much amount we are left with. So that is a basic idea, right? So let's create another functions. So one we will create for the buying, right? So buy, and I'll close it. So let me first create the skeleton. So pass, then I'll just copy and paste this. So okay, let me give some space here. Okay, so the first function is for the buy, and the second is for the sell. Second is for the sell, and the third is for status. Okay, and now we can check with the shift enter whether this is working or not. So when we hit shift enter, it says there is a tick mark, means it is running fine for now. So we have 2 parameters, symbol and amount, and this will be passed as an argument from the user. So we know that we are getting symbol and amount from the user. So here what we will do, so whenever we are considering the buying condition in any strategy, what we need to think, we need to decide that at which price we will buy that share and how much quantity, right? So what I'll write price and quantity. So this will also be given by the user, right? Price and quantity. And in selling condition also, this will be the same, that at which price we will sell our stock and how much quantity. So I'll just write price and quantity, right? And one more thing here, that we have to add self here also and here also. As I told you, just ignore this self. Don't think about it. You just assume that it is not existing here for now. Okay. And in status method also, we'll just give self. Self has to be given to all the functions inside a class. That's a thumb rule. You just think that. Okay. Okay. Now finally we understand the self. So here we are using self everywhere. Here in this function also, in this function also, in this function also. So it feels like it's some kind of salutation which we have to add at every name, like sir, ma'am. So self function, self variable, everywhere we have to use the self. What is self? Before that, let's understand what is this init. So here, this init known as the constructor. And if you have studied JavaScript, in that we used to use this, right? This operator, if you remember. Correct. So here we have this function which is known as the constructor. And what are the properties of this constructor here? So if you remember these things and practice, this object-oriented programming will become very easy for you. Okay, so let's understand the properties of constructor one by one. So the first property of constructor is that whenever we create any variable inside class, we have to create that inside the constructor. So you can say variables will be inside constructor, right? Then the second property is that we have seen previously that whenever we want to use the functions like these ones, we have to call them, right? Like we have to write the name and then we have to call them. But these constructors are executed automatically. So as soon as the object of this class is created, this constructor function will be executed automatically. We do not need to call this. So what we can conclude here now in the second property, that no need to call the construction function. No need to call the second property, right? No need to call the constructor function because it automatically gets executed. Okay, now let's find out that what are the benefits of using this constructor and why we use this. So let's write benefits and why we use it, right? I'll just put a question mark here. Okay, now let's check them one by one. So the first thing is that, so we can say that we can use the constructor when we don't want to give the control to the user. Generally what happens, so for example, when you are going on a trading exchange and you go and when you click on buy or click on sell, so we can say that you have the control. So the buy or sell trade will execute it only when you click on that. But there are few things which happens automatically. Like when you click on buy and the trade will be executed, then automatically in the backend, the data will get modified in the database. There will be some configuration files, there will be some database files. So all those things run automatically behind the scenes, right? So in short, you can say that you will mention those things inside the constructor for which you don't want to give the control to the user. It should be automatically executed. Like if you go there and if you click on buy, and you should expect that automatically your balance will be detected and you will get a share. So let's say what happens when you have to click on the buy, then again you have to click on a button that which says that are you ready to modify your database? Then again it asks you that I'll add this entry in this column or this field. So it will become so hectic and very frustrating for all of us. So what we want that it should be executed automatically. So we can say that in real life example, we mention the configuration files inside the constructor. We can also keep the database files, the configuration files, and those files which should be automatically executed when the programs get started. So that's the simple definition. So you can write here the config files inside the constructor and the DB files, the database files. So here also we can take the same analogy of the human class. So what happens? Let's say God created a class of humans, correct? Then what happens? Whenever a human is being born, an object is created. Let's say when Kuldeep object was created, this class was instantiated, and I will write here humans. And inside that we have a constructor function. So let's say define init, correct? And inside that, the one thing is sure, and everyone know that it will happen no matter what you do. Whenever the human object is created, the human class gets instantiated, right? And a constructor function is executed automatically, right? Because this has a superpower. And you know that your death countdown is already started. So you can say that God don't want to give the control of birth and death to the humans. So they kept this inside the constructor function. So whenever an object is created, automatically the constructor function gets executed and the death count of that object is started. So that's how the real life example of object-oriented programming. I hope it's very clear, and let me know if you have any doubt in this topic, and we can discuss more in the upcoming lectures. Okay, now let's take this self. What is the story behind this self? So far we have understood this constructor, right? This one. And now let's understand the story behind this self. It's everywhere. So what we will do, we'll write here only. So what I'll do, I'll just remove all these things. You can take screenshot if you want. Okay, now let's understand the self. This is one of the most misunderstood concept in object-oriented programming. But rest assured that you will be able to understand this completely after this session, forever. Okay. So before that, let's understand one thing, that there is a golden rule of object-oriented programming. Let me write golden rule in golden color. Golden rule of object-oriented programming. And what is that? Please do not forget this. It's very important. If you keep this in your mind while solving the OOP problems, you will be very comfortable, right? So the rule is only and only, pay attention to that keyword, only and only, object, let me keep this in double quotes, let me give it underline also, so you will remember forever. Only and only object can access all the attributes and methods in a class. And let's close this. So this is the golden rule of OOP. Only and only objects can access all the attributes and methods of a class. Means even if you are inside any class, this by function cannot access the self function. Similarly, this status function cannot access this, like the symbol attribute, the amount attribute, or the position attribute. They cannot. Means even if you are inside the class, these attributes and functions cannot access each other. Then who can access? Only the objects. And we know that how we can create the object of this class. Let's say I'll create an object with the name momentum is equals to trading strategy, correct? And here we can give the symbol, let's say BTC, and amount, let's say 0.1. Here the momentum object is created, and only this momentum can access the symbol, amount, position means all the attributes of the class. Only this momentum can access, and this momentum object can also access these methods, which is by, sell, and status. That is the golden rule of OOP. So now with this golden rule, what you can infer that the self is nothing but the object itself. This one. This is hiding inside the class with the name self. And you can keep this anything you want. You can change it to others also. You can change it to your name also. You can have any name you want. But here it became a convention. So that's why we all are using self. But this is the object itself. It came inside and it's hiding as the self. So now when we have the self, means the momentum can access. So here what we'll do, we'll write momentum.symbol, momentum.amount, momentum.position, means the self is momentum only. And here also we have to pass the momentum here, then only we can access the by, the sell, and the status. So you know that outside of the class, how we access the inside attributes and the methods, what we do, we just write like this, momentum and dot. So when we write dot, all these are suggested. Let's quickly see this same in the screen. Without further ado, let's go. So let's see here, when I hit shift enter here, and when I go in the next cell, and there I'll write like an object name. So momentum is equals to the trading. Okay, this is a markdown. I have to create a code here, code cell. Okay, so here it will be trading strategy and this, correct? So when I hit shift enter, it says me missing two required positional arguments, symbol and amount. Here you can see that we have three parameters, but this error says missing two required positional arguments, symbol and amount. It doesn't count the self. Okay, because this is the object itself. So here I'll just provide the symbol, let's say BTC, then I'll give the amount, which is 0.1. So okay, I have to add this. Okay, so now when I hit shift enter, it works like a charm. So what I'll do in the next cell, I try to access these attributes. These are three attributes and we have three functions. So when I just write momentum and dot, so here you can see that we have some suggestions. The first is amount, the second is a by method, the third is position attribute, fourth is sell method, fifth is status method, and the next is symbol attribute. So here you can infer that only the object of that class can access all these attributes and the methods. Even the inside functions or attributes cannot access each other. If they want to access, they have to use the object, which is the momentum. And the name of the momentum inside the class is self. That's it. It is the end of this topic. That's it. You just go back and watch this video multiple times if you're getting any issue, and I'm sure that you will be able to understand this concept. Very easy. Now even a small child can also understand this topic for sure. Okay, now let's complete this example. So what happens in a normal trading strategy? For example, if I write if self.amount, the amount currently we are holding is greater than equal to the price and the quantity, correct? Of course, it's obvious, right? If the amount is less than, we cannot buy, right? So then we will execute our code, which is self dot position is plus equal to is equal to the quantity, correct? Means what will happen here, let's say we have given the instruction that I want to buy a share at the price of 10 and the quantity is 10, so 100, right? Means the total amount we will spend is 100. So here when this condition is true, we will increment this position with the amount of quantity, like we bought 10 shares, so the position will become 10. Else what it will do, will print out that not enough amount to proceed with the trade, right? So this is a simple buy condition. And one more thing, that when we bought any share, we spent some money. So what will happen here, self.amount negative equals to the price into quantity, because the amount we have spent on the buying shares, it will be deducted from the total amount, right? So the total amount is we will initialize with the constructor. Again, now let's move to the sell condition, which is here, and here we'll write if while selling the stock, what we check, we first check the position, whether currently we are holding any position or not. And if we are not holding, what we will say, else we'll print that what we can say, currently no shares to sell. Correct? Now we write our if condition. So if self dot position is greater than equal to the quantity, right? So for example, earlier we bought 10 shares and we want to sell 20, which is not possible, right? You cannot make full of the exchanges. So it will display this error, currently no shares to sell. But if the position is greater than or equal to the quantity which you have provided, what will happen? It will execute the sell trade and self dot position negative equals to the quantity, right? So like we have 20 shares currently and we want to sell 10 shares, so it will subtract those 10 shares from the current position. And also one more thing will happen, that now when we are selling the shares, we are getting our cash or amount back. So what we will write, we'll write self dot amount plus equals to the price multiplied by quantity. Correct? Just the reverse of this logic here. And also we can print some message here while buying and selling. So here we can say print and we can say successfully bought the number of shares, right? We can write here F for the formatted string. So we can say successfully bought quantity shares of the name of symbol, right? The self dot symbol. And also we can give the amount. So we can give amount at, and again here a dollar sign at the price. The same message we can print while we are selling the share. So I'll just go here and we'll print here successfully sold quantity shares of symbol at price. So that's it, I guess, for the buy and sell conditions. Now let's quickly move to the status. So if the user wants to check that what is the current status of the shares, the positions, so what we can print here, current position of shares, right? Of shares. And also we can print the amount, right? So we can say current amount, or we can say remaining amount, right? So remaining amount can be self dot amount. Correct? Now what we can do, we can just hit shift enter. So now what I'll do, I'll create an object of this class. So I'll write, let's say, for example, momentum equals to name of class. So trading strategy, and inside that we have to give, see here, a symbol and amount, right? So you can give symbol, let's say ETH, and amount you have to give the cash, the amount you have. So let's say I have $5,000, and when I hit shift enter, it will be executed, and you know that, and this function will automatically get executed when we create an object. Now what we can do, we can access all these attributes and these functions. So let me write again momentum dot, if I want to know the amount, right? So I'll just hit amount, and when I press shift enter, I get the amount. Correct? Similarly, you can also get the symbol. So let's say symbol, and when you hit shift enter, you get the symbol ETH. You can also access the position here. So position, which is 0 now, right? For now. So now let's say I want to buy some ETH now. So what I will do, again write momentum dot buy. Inside that we have to provide some arguments. So the first parameter is price and second is quantity. So what I will do here, I will give here that I want to buy at the price of, let's say, 1200. How many ETHs? I want to buy 3 ETH. The amount is 3 ETHs. So when I hit shift enter, it prints out that successfully bought 3 shares of ETH at 1200. I have to correct the spelling, successfully bought. Okay, and now let's again hit enter. So we can see that it has corrected, successfully bought 3 shares of ETH at 1200. And now if I check the position, let's print it again. And so let me add another cell, and here I will print the position. So you can see here that we have the position 3, means we have 3 shares of ETH. And now you can also check the amount. So momentum dot amount is equal to 1400, because for 3 shares we have given 3600 and the remaining is 1400. So that's how it works. You can also use this cell here. So let's say I'll go and I'll write momentum dot sell, and here I will give that I want to sell just 2 Ethereum at the price of 1300. So when I hit shift enter, it says me not enough amount to proceed with the trade and successfully sold 2 shares of ETH at 1300. So actually some logic error is there. So let's see what is happening here. So if self position is greater than equal to quantity, okay, actually the previous is also executing, so we have to execute this in another cell. And when we hit shift enter, it says me currently no shares to sell because it's already been executed. Now let's check the current position and amount. So we have the amount 4000 and current position also. Let's print it. Let's print both the things, print, and let's print the amount also. So as we have sold 2 shares, so we are left with only 1 share, and the amount is 4000 because previously after buying the shares we were left with the amount 1400, and now we have sold 2 shares, right, worth 1300. So 2600 plus 1400 is equal to 4000. So that's why we are seeing this. And now let's check the status. So instead of this, what we can do here, we can check the status also. So I'll just write momentum dot status. So, and here there is no parameters, so we can just hit shift enter. It will show us that the current position 1 of shares. So you can write here the symbol also in this current position of the symbol, right? So you can just copy and paste it here, so it will display off and give some space. Okay, when you hit shift enter, run it again, it will show that current position 0 of ETH shares, and actually we executed this function again here, that's why it is showing the initial position, but you get the idea, right? So that's how it works, and I hope you have understood all the concepts very well. So in previous session we have covered that what are constructor function and what is self keyword and what is the golden rule of object oriented programming. So today we'll quickly revise that and then we will see the next topic. So as we have covered the golden rule of object oriented programming, that only and only objects can access the attributes and methods of a class, right? And what are the objects? So let's see, this is a class, and when I create an object like strategy 1 is equals to the class name, right? Trading strategy and parenthesis. So this is the class name and this is the object name, correct? So when we create an object of this class, and this object is known as the instance of that class, correct? So as soon as we create this object, this constructor function of the class gets executed, right? And whatever inside this, it will be executed. So now the question is it possible that these functions can talk with each other without the help of self? You just let me know in the comments. Is it possible or not? The first question is that. And why we are using this self everywhere? So let's say in this constructor function, we have a self. Then again, when we have the variables, here also we have prefix as self. And again, in all these functions, we have mentioned the self as parameter. So the question is, what is the need of this self? So if we remove this self from all these functions, whether these functions will be able to talk with each other or not, and whether these attributes will be able to talk with other methods or not. The question is that. So in order to understand that, we have to run this program, and then you will see the answer. So let's go to the computer screen and run this program. Okay, so now we have to run this program. So what I'll do, I'll just go. So first of all, let's run this cell, and I'll hit enter here, and now again hit enter. So you can say that we have the output successfully bought 3 shares of ETH at 1200, correct? And now when we check the status, it is working fine, and it will show us the status that current position 3 of ETH shares and remaining amount 1400, right? That's working perfectly fine. So let's say what I'll do, I'll just remove these 2 arguments here, okay? And when I hit shift enter, it says missing 2 required positional arguments, symbol and amount. It says trading strategy dot the constructor function in it, and then it says missing 2 required positional arguments, symbol and amount. Okay, so now let's go to this constructor function and check. So here we have this constructor function, but when we check here we have 3 parameters, right? But here in the error it says only 2 required positional arguments. So that's some contradiction, correct? So in order to understand that, what we will do, let me remove the cell from here. Okay. And now again, when I hit shift enter while creating object, it says me missing 1 required positional argument, amount. Why? Here you can see we have 2 parameters, symbol and amount, but here it says me only amount. So that's some contradiction, and it becomes so confusing for everyone that how this is happening. Earlier we had 3 parameters, but it says only 2 is missing, that is symbol and amount. Now when I remove the self, it says me only 1 is missing. So now with this example, we can infer 2 things. And for that, you have to remember the golden rule of OOP, right? That is, only and only objects can access the attributes and methods of the class. And here, when we were trying to access this with the help of object, we were able to access. But when we remove this self from here, we are not able to access. So means we can say that the self was nothing but the object itself. So what was happening here, when we create this object, automatically this momentum becomes self, and it is being passed as an argument from this to this parameter, right? So when I add self here, okay, and again when I hit shift enter, and again, so now it says me missing 2 required positional arguments, means here the parameters are 3, means self is already here, right? So whenever we create an object, the momentum is automatically being passed to this parameter self. So means the momentum object is already there, because as per the golden rule, only objects can access the methods and attributes. Okay, that is the first thing. Again, if I remove this self, and when I hit shift enter, and again to run this cell, it says me missing 1 required positional argument, amount. That means the symbol is no longer required. Why? Because now the symbol is being treated as self. Means there is no need to mention the specific self. Instead of that, we can put anything here. So here, if I put symbol here, then it becomes this object, the momentum, and again, only amount is missing. So if I enter amount here, like 2000, it will say the self is not defined. So means I will just replace this self with its symbol, and this program will work fine. So means with the help of this example, we have inferred 2 things. The self itself is the object and is disguised as the object, and it is being passed as parameter in this constructor function. And the second is, it is not mandatory to specifically write the self keyword. We can use any word we want, correct? These 2 things need to be keep in mind while creating the classes. Okay, now what we can do, I'll just write the self again for the convenience, self, and here I'll pass the symbol. So let's say I'll pass ETH here. So when I hit shift enter, it says me perhaps you forgot a comma. Yes, we forgot actually. So I'll just add here. So it says takes 2 positional arguments, but 3 were given. Okay, we didn't run this cell, So, and now hopefully, yeah, it's working fine. So let's understand it with the help of another example. So let's say what I'll do here in this constructor function, I'll just print the ID of self. And we know that with the help of ID function, we can print the memory address of any object in Python. So what will happen here, whenever we create any object, the constructor function will get executed and then it will print the ID of this self parameter here, right? So let me hit shift enter and again, and here you can see that we have the memory address of this self keyword 5184. Now, what I'll do here, let me add another cell here. So here what we will do, we'll print the memory address of the momentum object. So let's print ID of momentum. So when I hit shift enter, we get another address and that is exactly same as the address of the self, right? And that shows that, yeah, both self and momentum object are same. And we can say that the self is nothing but the object itself, because the golden rule says only objects can access the methods and attributes of the class. So that was the thing I wanted to show you, and it's really crucial, and many of the people really don't know this concept. They are able to write the codes fluently, but the deep concepts which are very exclusive, they are not able to understand. So if you remember this, then definitely it will help you. It will give you an edge while writing the code. Correct? Now let's move to the next topic, which is magic methods. That is also known as the dunder methods. So let's see them. So first of all, let's define the magic methods. So I would say magic methods are special methods which holds some superpower. And what is that superpower? We have already seen in the constructor function that the init, that is also a magic method, and that do not need any function call to execute that function, right? So we can write magic methods do not need function call. Do not need function call, right? And we have already seen an example of the magic methods, like the init method, right? And one more thing, that whenever you see this double underscore, you can figure out that this is a magic method, correct? So in Python, we have multiple magic methods like the init, and again we have one str. We will just see them quickly. And we also have REPR representation. Then we have addition also. We have subtraction, we have multiplication, and we have multiple of these magic methods in Python. You can quickly go to the Google and search the list of the magic methods. But the main question is, what are these magic methods and why we need them, right? So let me quickly explain you again that. So whenever you see the double underscore before the name and after the name, these are the magic methods. And you can say, similarly, you can create your own data types with the help of magic methods. And we can also say that these magic methods define the behavior of your custom objects. And these makes your class more intuitive and more readable and more comprehensive. So in short, you can simply say, with the help of magic methods, we can create our own data types. So you can simply say, we can create our own data types. Or you can say, we can create our own custom objects. So custom objects, correct? And with the help of these magic methods, you can make your class more intuitive, right? So I'll just write intuitive. And also we can use these magic methods to integrate your custom objects with the Python seamlessly. So we can say integration. Hopefully you are able to understand the theory behind magic methods. And now with the help of these magic methods, we'll write a program and let's see how we can utilize these magic methods in our algo trading. So let's move to the screen. Now what we will do, we will create a new class, and with the help of these magic methods, we'll be able to perform many operations like subtraction between two trades, addition of two trades, right? So let's start. So first of all, what we will do, we'll write the class with the name trades. Then we'll define the constructor function. So define init, and inside that we will give 4 parameters. Okay, the first is self. We know this will be the parameter for the object argument. Then what we will do, the first parameter will be the symbol, right? And then it will be the quantity, and next will be the price. Means the user has to pass the arguments that what symbol he want to trade and at what quantity and at what price, right? So now what we will do, self dot symbol is equals to symbol, then self dot quantity is equals to quantity. Then we have self dot price is equal to the price, right? Now what will happen, as soon as we create an object, this will get executed. Why? Because this is a magic method with the name init, and this is a constructor function. So it will get automatically executed because magic methods do not need any function call to execute it, right? So let's see how these gets executed. So what we will do here, we'll just print that, yeah, I am done already. Okay, to verify that whether this will get executed or not. So what we'll do, we'll go here and we'll create an object with the name, let's say trade1 is equals to trades. And so here, if I create an object without any argument, then it will throw an error that name trades is not defined. So what we will do, first we have to run this, and then it will show me missing 3 required positional arguments, symbol, quantity, and price. Because this object is by default gets passed as an argument to this parameter whenever we create any object, right? So now we have to provide these 3 arguments here. So what we will do, we will provide the values. Let's say symbol is equals to BTC. Then quantity, let's say I want to buy 1.5, which is not possible for me right now. Price is, let's say 71k approximate, right? So now when I hit shift enter, you can see that, yeah, I'm done already, because this gets executed and all these values are assigned to self.symbol and self.quantity and price, the attributes, and then it will print this string that, yeah, I'm done already. And one more thing to remember, that whenever we pass these parameters here, this is known as the parameterized constructor, and when we do not have any parameter here, it is known as the unparameterized constructor. Let's proceed further. So what we will do, I'll just remove this, not required right now, and I hit shift enter, and now it is created, correct? So now what we will do, we'll define another function, and that is also a magic method. So define double underscore repr, and you know that whenever you see a double underscore at the end and starting, you should know that it is a magic method. Then I'll again add the parenthesis and then self. So why self? Because as per the golden rule of the object oriented programming, only and only objects can access the method. So here we have to pass this object, that is self. Okay, I'll just add a colon here, and now it will return a value. So here I can define a string, so a formatted string. Here what I'll do, I'll first write the symbol, that how does this work. So symbol is equals to self dot symbol, right? Then we can give a comma here, a comma. Then we have quantity. So quantity is equals to self dot quantity, and then we have price is equals to self dot price. Okay, we have to add here, correct? Now what we can do, I'll just hit shift enter. So now where we can utilize this REPR magic method. So let's say you are writing a program and you want to know which kind of arguments you should pass. So what you will do, you will just go and write, okay, let's take in another cell. So you'll write print then, and here you have to give REPR and the name of the method, that is trade1. So when you hit shift enter, you will get the value as symbol is equals to BTC, quantity is 1.5, and here we have to write price. So price is equals to 71k. So with this magic method you can use in debugging, right? Next we have another magic method, that is define underscore underscore str, and again we have to give the self. Here also it is almost similar. So return a formatted string, and here you can write like the quantity of shares. So self dot quantity of shares of, and then you can give the symbol, right? So self dot symbol, and then you can give the price. So at and self dot price. Hopefully you are able to get my point. So when I hit shift enter, now what you can do, you have two options. The first, it's same like the REPR. So you'll write str and then the name of the object, and then you'll close the parenthesis, and when you hit shift enter, you will see that you have two prints. So, and the second one is it says 1.5 shares of BTC at 71,000. So this way you can tell the Python that how your objects look like, right? So whenever anybody is using your class, and even if some different programmer is using this, they'll be able to know that how these objects look like, right? So that's how you can use the REPR or str, and you can these both as interchangeably, but these are the right way. And you can also remove str, and by default when you print any object, you will be returned with this function value. So when you hit shift enter, you can see that even if you don't write str, it will print that str. So whenever if anyone print the object, this will be displayed, correct? So we have covered three magic methods. Then what we will do, we'll move to the next magic method. So now we have another magic method, that is underscore underscore add, and then as usual we have to pass the self parameter. So self is the object itself, right? But now here we are trying to add two objects, so we have to write other. You can write any other word, no problem, but as per the convention, all write self and other. So what is this other? So other is the another object. So self is the first object and other will be the second object, right? So I'll just close this. I'll just add a colon here. Then here, first we will check that before addition, we have to check that both the objects holds the same symbol, right? Because we can add only the BTC trade, right? We can add only the Ethereum trade. We can only add the Apple trade. We cannot add Apple and Microsoft, right? So for that we have to write a condition. So what we will do here, if self dot symbol means the symbol, this one, right? Self is trade1. So trade1 dot symbol is BTC. If it is equal to the other dot symbol, other means the second object, right? So if it is true, then what we will do, we'll add the quantity of both the trades and we'll find the average, right? So what we can write here, new quantity, right? So new quantity is equals to the self dot quantity plus other dot quantity, correct? And again we will calculate the average, right? So now what we will do, we'll calculate the average price. So average price is equals to self dot quantity multiplied by the self dot price, correct? And again, other dot quantity multiplied by other dot price, right? And then we will divide that with the new quantity. So I'll write new quantity. So this way it should calculate the new quantity and the average price. And in return, what it can do, it can return the modified value. So a formatted string, we can say the latest quantity is and then self dot quantity with an average price of, and you can mention here the average price, correct? So let's test this. So what I'll do, I'll hit shift enter and I'll create another object here with the name trade2, and let me check. So trade2, and here I'll provide 0.5 BTC and at the price 51,000, right? So when I hit shift enter, here what we'll do, I'll just comment these, and now let's try to add these two objects, right? So trade1 plus trade2. So when I hit shift enter, we get the value. The latest quantity is 1.5 with an average of 66,000. So here we have made some mistake. Okay, let me debug this. So what is happening here? The average is fine, I guess. Yeah, but in this price, it added 1.5 and 0.5. So it should new quantity. Okay, here we have to give the new quantity, correct? We just gave the self, so new quantity, and we made a mistake, my bad, extremely sorry for that. And when we hit shift enter, we get the latest quantity is 2 with an average of 66,000. So that's how we can add. Now you can see that the flexibility of Python, you have multiple options, and now you can even add the objects, and it will open a whole lot of new opportunities and dimensions you can think while creating Python programs, right? So let's test this again. Let me give here 2.5 and the average price is 21, the lucky fella. When he hits shift enter, we get that we have 4 bitcoins with an average of 39,750. And so that's how you can use the add magic method. Again, let's check the next magic method, which is, now let's take another magic method, which is subtract sub, and we'll close this and we'll pass self and other, right? Or what we can do, we can quickly copy and paste this one. So I'll just copy and paste this here, and I'll just change some values. So at the place of add, I'll write sub, correct? If self symbol is equal to the other symbol, because it should be equal, otherwise it will not work, right? Then the new quantity will be, I'll just add negative here, and here average price is not required and we cannot find out that also. Okay. Now, the latest quantity is new quantity with an average, correct. And yes, one more thing, we haven't added the else condition. So in the first one, if self symbol is not equal to the other symbol, let's say first object is BTC and second is Ethereum, then it should not work. So else we can print or return a string, a formatted string, that both the symbols should be same, right? Similarly, in the else here also we can say the same thing. Just move it here. Okay, seems good. So let's hit shift enter, and again, so here what we will do, let's give it 0.5, and okay, let me give the negative one here, right? So here what we will do, I'll just go ahead and I'll comment it out, and okay, let me first copy and then let me comment it out, and here when I paste, and I will change it from addition to subtraction. And when I hit shift enter, it says name average price is not defined. Yeah, because we have to change here, because in subtraction we didn't added the average price. I'll remove this. So when I hit shift enter, it gives me the latest quantity is 1. So when we are subtracting, it will subtract 0.5 from 1.5 and it will give us the results. So this is just an example. With the help of these magic methods, you can explore so many things and you can create magic in Python, right? So this was the example of magic methods, and you can let me know if you have any doubt and we can discuss that, right? So now let's quickly move to the next topic, which is one of the most confused topic of object-oriented programming. Everybody think that they know encapsulation, but in reality, they are not able to explain. So let's get started with that. Okay, now let's see how objects access attributes. So we have an example here. In that we have a class trader, and inside that we have the constructor function, and in that we are taking inputs of name and trading style, right? Then we have a method greet, in which what happens, we have 3 types of trading and it will print out the greeting based on his inputs. So let's start that. So what happens here, let's say I just run this cell, and now let's create an object of the class. So let's say it is trade1 is equals to trader, right? And here we will provide the input. First will be the name, which is Kuldeep, and then I'll provide my trading style. So let's say scalping. And when I hit shift enter, it will not print out anything. So here, when I type trade1, it will print out the object. But what we want the name. So when I type dot, it will show me a greet method, then the name, and then the trading style. So let's say if I want to print out the name, so name and shift enter, it will show me Kuldeep. And when I type trading style, it will show me scalping. And when I type greet, okay, so it will show me keep it fast and precise Kuldeep, right? So this is how an object accesses the attributes and methods. Okay, now let's suppose I create another object with trade2, and in that let's say another name. It can be let's say Sandeep. Okay, Sandeep, and Sandeep is a day trader, so he will type day trading. Okay, now we would like to print out the value of trade2. So let's say I would like to print the name of trader2. So when I hit shift enter, it gives me the value. But what happens if you try to access any attribute which is not existing in the class? So let's say if I try to access, for example, the profit of the day, any random word, right? So when I hit shift enter, it shows me trader object has no attribute profit, right? But let's say if I write here trade2.profit is equals to $1,000. So now what happens? You tell me, just pause the video and think and type in the comment what will happen, whether the syntax will work or not. So let me show you. When I hit shift enter, it works without any error. So what happened now? It means another attribute with the name profit has been created inside the class. So we can say that we can access the attributes from the class, and even we can create attributes from outside the class. So let's try to print the value of trade 2. So when I hit dot and when I type profit, you can see that we have a suggestion profit, but this profit is not defined inside the class. We have created this profit attribute from outside the class. So when I hit shift enter, it will show me 1,000. So this is how we can access the attributes, and we can access methods as we have done here. And what happens when we try to access non-existing attributes? And also we can create attributes from outside of the class. So let me just copy and paste these here, and I'll also, let's say here we are accessing any random attribute. So I'll just give here loss. When I hit shift enter, it will give me a error. And what the methods, what we can do, I'll just type trade 2 dot greet. Let me type it correct. Greet. Hopefully it is clear. It was a small concept but very important, right? So first of all, let's understand the bookish definition. of encapsulation. So encapsulation is a key principle of object-oriented programming that bundles data, that is attributes or variables, and methods, which is functions, operating on the data into a single unit or class. It restricts direct access to some components, preventing accidental interference and misuse. Means we have a class in which we have attributes and methods, correct? The variables and functions. So we can say, in order to prevent misuse and accidental interference, right? So now let's see some key aspects and benefits of encapsulation. So the first one is data hiding, which is true, right? After this explanation, we will be understanding these old concepts with the help of an example, the real life example. So it will be much better for all of us to understand this in deep, right? So the first benefit, or you can say the key aspect of encapsulation, is the data hiding. Internal details are hidden from the outside world using access modifiers, which are private, protected, and public, correct? The next is public interface. So with the help of encapsulation, we can provide controlled access to data through well-defined public methods. We will understand that also. For now, you just understand that with the help of encapsulation, we can hide our important data and we can prevent the misuse, or we can say the accidental interface, right? Second is we can provide a public interface through which we can provide only the authorized data to the outside world, right? The next is modularity, right? So in which what we can do, we can make our objects self-contained, and that also helps in the understanding, right? And also in maintenance and debugging if we are having any error. So with the help of encapsulation, we can directly point that at which location in our code we are having the issue. The next is abstraction, which means like the program can be very complex from inside. But what is the end goal of a programmer or a company? The end goal is to provide the best solution to the user, right? So they do not have to check the complexity or anything. They will just get a simple interface and through which they can only access the authorized data, right? The next is maintainability. So it is T here. The system is easier to maintain and extend since each component is self-contained and interacts through well-defined interfaces, which means that like once we have written our application and after that we want to modify the code, so it becomes so easier because we just have to modify like a single piece of information, or we know exactly that what we want to modify. So it becomes so easy to maintain with the help of encapsulation, or we can say object-oriented programming. So that was the theory part of encapsulation. Now let's quickly move to the examples and let's see. So before diving in the encapsulation example, let me quickly show you one very small concept, that is instance variable. So what are the instance variable? For example, we have a class trading bot, and inside that we have a function, or you can say we have a method, constructor method, right? Or you can say constructor function. So inside that we have three parameters: the self, the name, the initial cache. So here we know that the self is the object itself. Then we are left with only two parameters. So let me quickly create an object of this class. So what I'll do, I'll just go ahead and write, let's say bot1. Bot1 is equals to trading bot and a parenthesis. Inside that we will provide the name. So let's say name is Apple, and we have initial cache. So it can be 1000 USD, right? So now we know that while creating this object, we have passed two arguments. One is the name of the stock and another is the initial cache, right? So if I want to access this name again, what I will do, I'll write bot1 dot name, correct? So it will print out the apple, right? If I write bot1 dot cache, it will give me an output of 1000. Until now you are clear, right? So we can say this bot1.name is the instance variable of this class. Again, this bot1.cache is another instance variable of this class. That is okay, right? But if I create another object, let's say with the name bot2, and what I'll do, okay, let me remove this dot, not required here. And what I'll do, I'll write as a trading bot, and here I can give, let's say Microsoft MSFT, and initial cache is 2000. So now if I want to access this name variable, so what I have to write? I have to write like bot2.name, and it will give me an output of msft. Correct? Similarly, for bot2.cache, it will give me 2000. So what I'm trying to show you here, that we can have multiple instance variables. For example, this was the first instance variable. Correct? This is the second instance variable. Means for a single class, we can have multiple instance variable. So whenever we create an object and we pass the arguments, a new instance variable will be created. But for the normal variables, we can hold only one value, right? So at a time, we can hold only one value in a variable, but in instance variable, we can hold multiple values. So that is the difference between a variable and an instance variable. And in the previous session, we have understood what are the reference variables, right? So you just need to have a clear understanding of what is a reference variable, what is an instance variable, and what are the variables. So that was a simple concept. So now what we can do, we will quickly visualize this instance variable in the Python tutor, and then we will proceed with the example of encapsulation. Now we quickly move to the Python tutor, and I will paste the code here. So what is happening here? We have a class, right? And here we have two objects of that class. So first is bot1. Inside that we have the stock as apple, and the initial cache is 1000. And in second instance, the second object, we have the stock as Microsoft, and the amount is 2000. So before that, what we will do, we will create instance variables. So bot1.name.cache. Again, let me quickly copy and paste this here. So here I'll just change to bot2. So now we can see we have a class, then we have two objects, and then we have two instance variables of each object. So when I click on visualize, so it will take me to this screen, and here we can see that we have 15 steps. So let's understand this one by one. So when I click on the next button, it will take me directly to the object creation code. So here we can see that a new frame is created, that is a global frame, and inside that we have the trading board class as an object, and you can see here it has been created. Okay, so now the interpreter is at the object creation line. So here when I click on next, you can see here that an instance of the class has been created with the arguments name and initial cache. Here the value is apple, and 1000 is the cache, and self also is there. Correct? That is the trading board instance. So now again the interpreter goes to the inside the class, and here we are at the constructor function. Correct? So when I click on next, and it will like assign these values to the self.name, it assigned the apple, and for the cache it assigned the 1000, right? Then when we click on next, it will go to the second object. Similarly, it will perform the same steps, and again it will go inside the class, and it will execute the constructor function without calling, right? So when I click on next, it will perform the same steps. So first the name, and then we have cache, and in return there is none, right? So we have already understood that when there is no return value, but still the function returns, and that is none, right? So now when I click on next, it will take me to the instance variable. So here bot1.name. So when I click next, so now the program goes to the instance variable. So when I click on next, it doesn't print out anything. Why? Because we have to add the print function here. So let me quickly go here, and I'll add print here. So now let's click again on the visualize execution, and here you can see that when we click next, and when we reach to the instant variable, here these are printed out: apple, again the name, and again the cache. So here we can say that instance variables can hold multiple values at the same time, unlike the normal variable which can hold only one value. So this was the concept of instance variable, and keep that in mind. It is very important. Now let's start the encapsulation example. So what we will do, we will create a trading bot that is capable of executing buy and sell orders based on the threshold value which we provide. So let's start that. So first of all, so let's create the class. And let's give it the name auto trading bot. Here as usual, we will define the constructor function. So def init, and inside that we have to pass the self. Then what we will do, the user will provide the threshold value. So threshold, and here what we can do, we can just like assign the variable threshold. Means the threshold parameter is there, and when the user passes it will become self.threshold. You can even change the name. There is no interrelation between this and this, so you can have whatever you want, right? Then what we will do, we will create two more attributes. So the first is self.position, and currently that is none. Let's assign the value as none, correct? And the third is we will create an empty list. So self.price data, right? And let's keep it empty for now. So here we have three attributes. The first is threshold, second is position, and third is price data. So what we are doing here, the threshold will be provided by the user, and for now the initial position is none. The price data is not date, price data is empty, right? So these all are inside the constructor function. So as soon as the object is created, this function will be executed and these all values will be initialized. Let me correct this also. I have to add another underscore. Okay, now we are fine, right? Until then, what we can do, we can just test it whether it's working or not. So what we'll do, we'll create an object below. So let's say I'll create autobot1 is equals to auto trading bot, and then we will provide the threshold value. So let's say threshold is 100, correct? And when I hit shift enter, it runs perfectly fine. And in the next cell, what I'll do, I'll try to access the variables inside. So when I click on dot, it shows me some suggestions, which are the price data, the position, and threshold. The price data is currently an empty list, and in position the currently is none, and threshold we have already provided, which is 100. So if I try to access the price data, and when I hit shift enter, it gives me an empty list. Similarly, if I try to access the autobot dot, let's say position, and when I hit shift enter, it gives me nothing, right? Because this is a none value we have assigned. And then we have the last one, which is threshold, which we have already provided. So when I hit shift enter, we get 100. So it's working fine so far, correct? So let's proceed again. So now let's move to the next part. So what we will do here, we will create the skeleton of this class. So what we can do, our main object here is to, so now our main goal is to analyze the current market and then execute the trades based on the current data. So in order to achieve that, what we need to do, we need to fetch the data from the market. Then we need to fetch the latest data. Then we need to evaluate that. Then we will execute the trade. That's how the flow is. So let's first create the skeleton of the class. So what we will do, we'll first fetch the data. So fetch market data, a function, right? We just pass it here. And similarly, let me copy and paste this, go here, and I'll paste all these. Let's do it one more time. So here we have to add the colon again and again, right? The first is to fetch the market data. Then we need to fetch the latest price. So fetch latest price. So I'll just write here the function name as latest price, right? Then we need to evaluate. So we can change it to evaluate price. Then we can give another function, which is to execute the trade, And last what we will do, we'll create a run function. So with the help of that, we'll be able to control all the above functions, right? So now we need to add self also here, because as per the object-oriented programming, we need to add the object here. So we'll add self in all the classes, right? So that's the skeleton of this class. Okay, now let's build the logic. Before that, we can hit shift enter and check that it is working fine. It is working fine. And here also hit shift enter, it's working fine. And when we click, like when we just try to check, so when I click on dot, it should display all the functions. So you can see here threshold, position, evaluate price, execute trade, fetch, latest, and price, and run. So means so far everything is okay. So like when you are trying to create a big program, you can divide that program into smaller chunks, and then you can work on small chunks, so it becomes so easy to write the code, right? So let's write the code. So what will happen here, we will get the threshold here. So let's write the code for the first function. So what we can do here, we'll first fetch the market data. So here in the real life scenario, we have to fetch the market data with the help of API. But here we'll just, for the sake of this example, we'll just simulate the data. So I'll just copy the attribute and I'll assign some value here in a list. So let's say we have 80, 90, 100, 110, and 120, and 130. Right. So now this function will return the self.price data. So self.price data. And then what we can do, we can also print that market data has been fetched, right? Fetched. So until now, it should be very clear. Let me change these value to the current price of the Bitcoin. So let's say we have 69140 currently, and I'll just copy this price and I'll paste here. So 2, 3, 4, 5, 6, correct? And let's quickly change these values. So this is 150, 160, 170, and 180, and 190. And what we will do, we will also change the threshold value. So let's say we keep the threshold as 69160. So here we'll change this threshold. So when I open the chart, so here you can see that these are the bars. So 1, 2, 3, 4, 5, 6. So means in the list we have given these 6 values, right? The opening or closing price, you can take any one. So for example, I am taking the closing price here, latest bar, right? Or we can say the last bar before the current bar. So these are 6 values, and we will take the closing price. So again, in the example, we want to check this value, right? The second last bar. So we'll open. So let me open it again. So in the second function, what it will do, it will check the self.price data is there or not. If it is there, then it will return the self.price data, correct? Else it will return none, right? So now what we will do, we'll just test these 2 functions, whether it's working fine or not. So I'll just hit Shift Enter, and here again I'll pass the argument as the threshold 69160. And now when I click here as dot, I can see we have all the functions and we already have this price data. So when I click here price data, let me comment these for now. So Shift Enter, and we get an empty list, correct? These value, what we can do, we can access this function. So fetch market data. So I'll try to autobot 1 dot fetch market data, and when I hit Shift Enter, we can get all the values, right? Okay. So, and here also we need to modify something, that we need the latest price, right? The last bar. So in order to get that, we have to add -1, because in list we know that the last item we can access with the help of negative indexing, and we can provide here the -1. So when I again hit Shift Enter and access the function autobot dot latest price. So now when I hit Shift Enter, we get the latest price, right? 69190. And you can see here the last element of this list is 69190. I'll just remove this comma from here. So this is how this function will work, the second one. So far we have confirmed that these 3 functions are working fine. So now let's go to the next function, which is evaluate price. So now here we will evaluate the price with the threshold price which we have given as the argument. So here what we will do, we'll create new variable, let's say latest price, which is equals to the self dot, we will call the function latest price and we'll enclose that. So what will happen here, when we call this function, it will return the last price, the latest price, right? So now we can apply the conditions. So if latest price is less than the threshold price which we have given here, so we have to write here self dot threshold price. So what we did here, so we know that if the latest price is less than the threshold price, so here we have given the threshold price as 69160, and here we know that the latest price is 69190. So if the latest price is less than the threshold price, we have to sell. So it will return a keyword, it will return as string, and we can write sell. Else what we can do, elif, if this latest price, instead of that what we can do, okay, yeah, let me just quickly copy and paste. Elif latest price is greater than the threshold price, then it will return the buy, right, a string. And else we can write like return hold, correct? So now we'll hit shift enter. And so now let's quickly write the execute function also and the run function also. So now what we will do, we'll write the code for the execute trade method, and let's start with that. So again we have to use the if else condition. So if it returns the cell, so we can write like if self dot evaluate price is equal to a string cell and the current position, this one, right, self position, and self position is not equal to the short, right, then what we can do, we can execute the price as short. So then what we can do, we can execute the short trade. So self position, I'll assign short to the self dot position, and we will return a string, and in which we can say sell trade has been executed and current position is, we can write short, correct? Similarly, so now what we will do, we'll just copy and paste the above function again, and here I'll just change the values to buy. If evaluate price returns the buy string and self dot position is not equal to the long trade to the self dot position, and here we can return buy trade has been executed and current position is long. Hopefully it is clear, and we will change it to elif. And the last condition we can give else if something different, then what we can return, we have one more return here, so we can use that also. Like we can write here if return is hold, so if evaluate price function returns the hold string, and we'll remove this because not required for now, then what we can do, we can assign the self position the hold, and here we can say the trade is on hold, for now, and current position is hold. Hopefully it should work, correct? So I think we are good to go. So what we can do now, we can test this. So when we call the execute trade, okay, now what we can do, we can execute this. So shift enter. Then one more thing, I think we have forgot to add parenthesis here, so we'll just add that, and let me add it everywhere where we have used this, so here also and here also. Now I think we are good to go. Okay, so let's call this function execute trade. So here I'll go and call this function print autobot dot execute trade, and so here it is returning us the none value. Why? Because in the latest price we haven't given anything. So let me execute this again. So now what we can do, let's try to run this program. So I'll just hit shift enter, and Okay, I'll just remove all this clutter first from here. Let me remove everything so it becomes easier for us to run again. And again, let me remove it. Okay, so now we have this class, right? Let's try to execute the methods one by one. So first of all, what we'll do, we'll create an object. So the name is auto trading bot. So I'll just copy from here and let me create the object. So let's say bot1 is equals to the auto trading bot, and here we can pass a threshold. So let's say we have this list. So threshold is, I'll give 69170. So what will happen now that we have given the condition here, right? Here you can see that if the latest price is less than threshold, then it will return a sell. And if the latest price is greater than the threshold price, it will return a buy, or else if it is equal, then it will return a hold. Let's run this and let me try to access bot1. So bot1 dot, now we have all these attributes and functions. So position, run, evaluate price, execute price, fetch market data. So first of all, we'll run one by one. First, we have this method fetch market data. So let me try to execute this fetch market data, and I hit shift enter, and it returns me a list, which is absolutely expected, correct? And let's do one more thing. We'll print all these. So correct. Now the next we have is the latest price. So let me print it, the latest price, bot1 dot latest price. And when we hit shift enter, it should return this last price. So it is working fine, correct? Now let's move to the evaluate price. Let's try to print the evaluate price, print, and bot1 dot evaluate price. And when we hit shift enter, it gives the buy, because as the condition here, if the latest price is greater than the threshold price, and we know that the latest price is 69190 and threshold we have given the 69170, correct? Means the latest price is greater than the threshold price, and it will return as a buy string. Now we have the main function, which is execute trade. So what we can do here, we can call this also. So print and bot1 dot execute trade, and when we hit shift enter, it returns an error that missing one required positional argument action. So here you can see that in all the other functions we have given only the self as parameter, but here we have given action also, and we know that what is the action? Action is nothing but this evaluate price function call, correct? So what we can do, I can just go here, I can assign action this function, right? So now I'll write here action, and when I hit shift enter, it returns me none. Actually, I have to remove this print from here, and when I hit shift enter, it gives me buy trade has been executed and current position is long. Let's say if I change this threshold to something else, I'll change it to, let's say, 140, or let's say we change it to 70, so that the threshold will be greater than the latest price. So when I hit shift enter, so now let's say we change this to something else. So we know that the condition is evaluate. If latest price is less than threshold price, it will give us a sell. The latest is 69190 and threshold is 69170. So what we can do, we can make it 70, right? So, or let's make it 91. And when we hit shift enter, it gives us a sell trade has been executed and current position is short. So it is working fine. But so far we have just created a simple normal class, correct? But now we want to see that how encapsulation works and how it affects the program. So let's see it. So let me tell you a story. Let's say you are in a company and you are working as a senior programmer, right? Recently a fresh engineer, let's say as junior programmer, has joined your company. So initially you have given him all the KTs, like how your company works and all the normal operations. But after a few days, you observe that he is not taking his task seriously. Like he's just relaxing and not working up to the mark. So one day, you just told him that, Mr. Listen me very carefully. If you're coming in office and between these hours, you have to work sincerely and you have to show me the results. And these words from the senior programmer just hurted the ego of the junior programmer. So what he thought that no matter what happens, I will teach him the lesson of his life. So what he did, okay, give me the work. So the programmer told him that I have created a class with the name trading bot. Now you just have to convert this class to a GUI, right? Generally what happens in a company that a senior programmer writes the class and then a junior programmer just use their class and make the other program, or they can convert that into a GUI. So what he did, he just went and he just saw the senior programmer has created this class with the name auto trading bot. So what he did, he went and he created another object, let's say bot2 auto trading bot, and he provided a threshold value of, let's say, 69. Before that, let me make a small change. That what I'll do, I'll go to the fetch market data, and here I'll change this value a user input value, right? Instead of a default value, we will take this value from the user. So I'll change it to user for the sake of this example. I'll change, and here also I'll assign this value here to, and what I will do, I'll just copy this. So now what is happening, the user has to provide the list value, the price data. So what the junior programmer did, he created this object and then checked that bot2 has these methods: evaluate price, execute trade, fetch market data, and latest price, position, and price data. So what he did, when he given that fetch price data, he need to provide a list here, right? So what he did, like user, let's say I'll go user input data is equals to a list, right? And here we will pass this as an argument. When we hit shift enter, we get this value back. So in order to teach his senior lesson, what he did, he knew that in a list we can have any kind of data type, right? So what he did, he just slightly changed this integer to a string, just a small change. Okay, then what happened, then again he entered shift enter, it's working fine, right? At this point nobody can quickly find out the problem, right? So what he did, then next he, instead of this, he changed the last price to the string. Why? Because to teach his senior lesson. So now what he did, he just shift enter, we are getting the value fine. So now the next function is to fetch the latest price. So what we can do here, bot2, or let me first quickly comment these values. Now bot2 dot latest price, and now when we hit shift enter, we still get the latest price, right? But in a string. Now we have the execute trade function. So now you pause the video and tell me whether this command will work or not. Okay, just pause the video and think, and then answer me in the comments. Let's say hit shift enter, and now you can see that it says missing one required positional argument, that is action. So first, okay, before this execute, we have this evaluate price. So dot evaluate price. Now you can pause the video and comment in the answer whether this command will work or not. So when we hit shift enter, and now what we get, a type error. It says not supported between instances of string and integer. Technically, like if someone sees this code from outside, they cannot quickly judge what is the problem, right? Because he just changed a list item to a string, and it becomes really difficult while debugging sometimes, right? So then what happened, everybody was very stressed that the code is broken and not working fine. Then his senior came and he analyzed the code. His code was correct, but the input values from the user is not correct. That means any user, they can break this code easily. So in order to avoid that issue, what he did, he first made a complaint that this program is not serious and he's purposely trying to break the code and not a good teammate, you can say. So then obviously he was terminated, and now the senior was very cautious and he made some changes to mitigate this issue. So now you let me know what we can do so that a user from the outside cannot make changes here. So now the junior programmer thought to teach him a lesson for his life. So what he did, he just came to his desk and he created an object. So let's say bot equals to the name of the class, and we have to provide the threshold, right? So let's say name of the class, and threshold we can provide is we can see the list, and let's say 69160. So when I hit shift enter, it works fine. And now when we bot3 dot this class has these many functions: evaluate price, execute trade, fetch market data, latest price, position, price data, run threshold, right? And here what we can do, one more thing, we can remove this. As of now, it's not like we are not using this, so I can remove this. Okay, so now what he did, he was trying to break this code anyhow. So what he did, so first of all, he just called the function bot3.fetch market data, and he can see that he has received a list, right, which is okay. Then he tried to access the latest price function, so latest price here, and when he check, he got the value as 69190. So what we will do here, we'll just print all these values so it becomes easier to understand. Print and bot3. Now we can see that we have a list with the market data and then a latest price, that is 69190. And then he called this a method evaluate price. Okay, so print and then bot3 dot evaluate price, and when he hit shift enter, he was given a string with the buy trade, right? Now what he did, he thought that when I checked, I found there is a attribute with the name threshold, right? And he knew that I have given here a integer with the 69160. What if I change this threshold value to a string? So what he did, he simply bot3 threshold equals to, let's say he given a string, then he again tried to access the evaluate price, and when we hit shift enter, it says not supported between instances of integer and string. And with this, he was able to break the code. And now you can see that we have a big problem here. If we create a program and then any outsider, they can come and break this code, right? So it is not a good practice, and we should be always hiding our data, means the attributes. And even if required, we can hide our methods also, which are not useful to the public. We can only display the authorized methods which are required for the user. So the best practice is to always keep your data, which are attributes, hidden. So now you tell me how we can hide this so that the junior programmer cannot access this and cannot change this. Just pause the video and just think and let me know, because we have already learned this concept many times previously in so many languages, right? Let me show you what we can do here. Now we can make these attributes private. So what we will do here, I'll just change this to double underscore will just hide the attributes for the outside public, right? So I'll make it also hidden and this also hidden. And when I hit shift enter, okay, actually we have to now replace all these attributes with this. So I'll just copy this, and here let's change it to threshold. Now let's change the position. The last is the price data, so we will change here also a price data. So now when we hit shift enter, and again let me remove this and hit shift enter. So now we can see that the program is still working, but the most important thing which has happened after this, that we have hidden our valuable data. That is the most important thing in encapsulation. Now when we try to access these attributes bot3, here you can see that the position has been changed to underscore position, and again the price data has also been changed, and all the other attributes which we have made private. So if I try to access this now, okay, when I hit shift enter, it gives me an error that it says auto trading bot object has no attribute underscore position. Correct? This way we can hide our important data. Let me show you this visually. So what we will do, we'll just copy this code, this whole code, and we'll go to the Python tutor, right? So let me open the Python tutor, and here is the code, and I have pasted the whole code. And again, so now when we click on visualize execution, it says it has no attributes. So we'll add it and we'll remove the last one, and we just try to see what is happening internally. We have 28 steps, so let's see one by one. So when we click on next, it creates a global frame, and Again, next, so here you can see that the threshold is passed as an argument and the program goes inside the class. Now, again, next. So now you can see that this Python has converted this self.threshold variable to underscore the class name, again underscore threshold to 69160. Means, let me open the program again. And here I'll show you. Earlier, we were able to access this threshold. So after adding these underscore, when I try to access this, it says me has no attribute, right? If I want, I can still access this attribute. How? Let me show you. So I'll just open this and I'll just copy. And now when I try to execute this, you can see here, it has been executed. We can access this variable, right? So that was the internal Python process, and generally people cannot guess the variable name. But in order to just make you understand, I just showed you how this is happening behind the scenes, right? So this is how you can hide your data, and the same thing you can use with the methods also. It can be used and it will work fine. And whenever you want to encapsulate your data or methods, you should be making them private, right? Now the next concept is reference variables. So let's understand this. So reference variables hold the objects. Yeah, correct. So what happens? For example, this is the class and we want to create an object of this class. What we will do, we'll write a syntax like this. Trade1 is equals to trading strategy, correct? And then we pass all the arguments, right? So what is happening now? Try to understand. This is very subtle concept. So at this point, when we are writing this, an object is created. Object creation, right? Creation. So we can say that even if we don't use this trade1, still the object is created. Means if we just write trading strategy and parenthesis, and inside that we pass all the like symbol and amount. Let me write it clearly. Okay. So what I'll do, I'll write like this: trading strategy, and inside that we have symbol and amount. So for example, symbol I will give BTC, and amount, let's say I give 1.2 BTC. So we can say that when we write this syntax, an object will be created. And whenever there is an object in the memory, an address will be created. For example, when I write this syntax, an object at a location 0x1000 created. Correct. Now, in order to hold the reference of this object, or we can say memory address of this object, what we can say, we have to write a variable name. So I'll write trade1. So means we can say this is just a variable which is holding the reference of this object. It is not mandatory to always write this. Even if you write just this syntax, an object will be created. But if you don't write this, then this object will be lost somewhere in the memory address and we won't be able to use that object again. So to hold that memory address or reference of that object, we have to define a reference variable. So that's why we can say reference variable hold the objects, correct? Then we can create objects without reference variable as well. We'll also see on the example, but for now, just understand this. And the third is an object can have multiple reference variables. Yes, we can have that, and we have also seen that. So for example, I can also write like this: trade2 equals to trading strategy. And here I can pass, let's say, ETH, and amount I can give, for example, 6 Ethereum. So now we have two objects of this class. This is the first object, trade1, and second is trade2. And these both holds different memory address. Means we can have multiple reference variables, right? Then assigning a new reference variable to an existing object doesn't create a new object. For example, I created this trade1 here. So I can write like trade1, and I can write like this also: trade3 equals to trade2. Means this is an existing object and I am assigning this object to this trade3, correct? That's what this line is trying to say. Assigning a new reference variable, new one is this new reference variable, to an existing object. Existing is this one. Doesn't create a new object. Means it will not create a new object, because if the memory address of this object is 0x1000, then the same address will be held by this reference variable. These both the reference variable holds the same memory address. So that is the concept of reference variable. Okay, now let's quickly see the example of that. So what I will do, we can copy and paste the above example. So I will just take this and I'll paste here, and then I just hit shift enter. So what I'll do, I'll just create a new cell here, and here what I will do, let me try to create an object of this. So as we have discussed that we can create an object even without a reference variable. So let's say trader, and here I will give the name input as Kuldeep, and trading style input I'll give scalping. So when I hit shift enter, it gives me an address of the object, right? You can see here 0x10f and 950. So that means an object is created, but in order to hold this address, we have to give some reference variable. So I will give trader1 is equals to this memory address, or we can say this trader1 holds the reference of this object, right? So when I hit shift enter, and now I can access everything from inside the class. You can see greet, name, a trading style. So when I print name, I will receive my name, and that's how we can do that. Next concept is multiple reference variable. So what we will do, I'll write trader2, and this can be, let's say, Sandeep. Okay, and he is a day trading. So day trading. And so when I hit shift enter, and now when I print both the trader1 print trader dot name, and again print trader 2 dot name. So when I hit shift enter, we'll get the name of both the traders, Kuldeep and Sandeep. Okay. Now we have change attribute value with the help of second object, right? So before that, let me show you one thing, that assigning a new reference variable to an existing object doesn't create a new object. So let me first show you the ID of these objects. So what I'll do, I'll just type ID here, and here also I will print the ID of these, right? So now when I hit shift enter, you can see that we have the memory address of both the objects, and that is different, right? Because these are two different objects. But let's say what I did after this, I assigned, let's say, new trader1 is equals to trader1, and again new trader2 is equals to trader2, right? And what we can do here, I will just copy and paste it here. Okay, let me paste it here, so it will be more better. So here let me type new trader dot name, and here also I can print new trader dot name, right? And now let's hit shift enter. So you can see that the memory address of both the trader1 and new trader1 is same, and the memory address of trader2 and new trader2 is same. So that's how you can infer that even when we assign a new reference variable to an existing object, it doesn't create a new object. It just holds the same memory address. Now we have the next concept, which is pass by reference. So what we will do, we'll quickly copy and paste the previous example. So I'll just go and let me take this example. So copy and paste here. Okay. So what I'll do now, I'll just shift enter. It's working fine. Okay. So let's do one thing. I will. Okay. Now what I did, we have a class, and inside that we have a constructor function, and inside that we have two attributes, right? The name and trading style. And now we have another function. So now pay attention that this function is no more inside this class, right? Means it is not a method now. It is a function. So this is a separate class and this is a separate function. Okay. So now what we'll do, we'll just hit shift enter. Okay, now let's create an object of this class. So A is equals to trader, And here we'll provide the input with the name and the trading style. So let's say scalping. Okay. And what we will do, and we will also call this function greet here. So what I'll do here, first I'll try to check the name with this object. So a dot name is printing Kuldeep. That's fine. And again, if I try to print the trading style, so trading style also scalping. So now when you observe that in suggestions you have only attributes, the function is not there because we purposely kept out this function outside of the class. So what I'll do now, I'll try to call the function. So greet, and inside greet, what I'll do, I'll pass the object a. Okay. And here what I will do, I will just change from self to, let's say, we can keep it a also here, not an issue. So a, I'll change all the values a, here also a, and a dot name, a dot name, and a dot name, and the last one is a dot name. Now try to understand that here we are creating an object, and then this is a separate function call. So here what I'm doing, inside the function argument, I'm passing an object. So greet and a. Okay. Then when I hit shift enter, so it says me keep it fast and precise, Kuldeep. So now I hope that you are able to understand the more and more the power and the flexibility of Python, that we are able to pass any object as a reference. And now if you want, you can even return an object as a function return. So what I'll do here, I'll return, before that I'll create an object here. So b is equals to the name of class, which is trader, and let's say I give a name here as Sandeep, and he is a day trader. So I'll give day trading. Okay. And then I will return this object. So return b, correct? So let me try to execute this. So, and again, because this function is returning b to this function call, so I have to assign this to, let's say, c. Okay. So shift enter, shift enter. So first it is printing this value, keep it fast and precise, Kuldeep, this one, correct? Then here I would like to print c. So print c, print c dot name, c dot name. So you can see Sandeep here. So now what we did here, let me quickly explain you. First we create an object here. Okay. And then that object is being passed as an argument in this function, correct? And then this function will execute and it will check that this condition is satisfying here. So it will print that value, correct? This one, keep it fast and precise, Kuldeep. And then inside that function, it is creating a new object b, okay, with the name Sandeep. And then it will return that new object, which is b. And here we are assigning the return value to c, and then we will print the c dot name. So it is a little bit complex, but it's very easy to understand. You try yourself 2 or 3 times and you will be able to understand that. Okay, now let me show you one interesting thing. What I will do here, before returning, I'll print the ID of this b dot name, okay, inside the function. And again, so before returning, I am printing the memory address of this b dot name. And again, here also I will print the memory address of c dot name, correct? So when I hit shift enter, so here you can see that the address of both the b dot name and c dot name is same, which means, so here we can see that we are not passing the object, we are passing the reference of that object, means the memory address of that object. So this is the pass by reference. And so now the next concept is mutability of object. Now we want to check whether the objects created are mutable or immutable. So what we will do, so for that, what we will do, I'll just write here b dot name is equals to Mandeep. Okay. Now you just pause the video and you tell me that we have 2 print statements. One is inside the function and one is outside the function. Now you tell me whether this statement will be able to change this name or not. And if your answer is yes, then comment the print output. And if no, then also comment the print output. So let's pause the video for 2 seconds. And okay, now let me show you. So when I hit shift enter, and again when I hit shift enter, I can see that the name has been changed. Means we can say that the objects created are mutable, correct? So in the previous session, we have seen that how we can make our data private. But if we still want to access, we can easily access, right? which made me more depressed that why we can't do that. Because in the other languages like Java and C++, we can do that, right? We can make our data fully private and nobody can access no matter what happens. But in Python, we can access. So while researching, I found one single line on Stack Overflow, and which made me smile. And I'm sure that when you listen this, you will also smile, which says Python is made for adults. Python is made for 18 plus. That's why nothing is truly private in Python. Because as we have seen previously that Python is so flexible that it doesn't restrict you completely for anything. You have the option to make your data private, but if someone from your company is still trying to access that, then that is the problem of your company culture, not Python's, right? That's why we have the option, but we also have the flexibility to access in case if sometime it is required. So that was one liner. Now let's move to the next topic, which is getter and setter method. So let me share my screen. So when we make our data private, Python automatically converts that to a different name. So here you can see it was underscore class name, then double underscore, and then attribute name. But even after that, you can access the attribute, but you cannot make changes to the private variable. So that was the explanation. Now let's understand one more thing. Let's understand the getter and setter method. So let me open the terminal. You can see here we have made all these attributes as private, and I cannot access with just let me run this, and at here the name is bot3 dot. If I write threshold, then it says if I write like the class name, so auto trading bot, so auto, when I hit shift enter, we get the value, and with the help of this we can even change the value. Let's see if I make it 70,000, so the value will be changed, and when I again access this, it will show me a modified threshold. We can say that we have the flexibility, but we have the drawback also, right? So in order to resolve this issue, we can use getter and setter method. So let me quickly first explain you what are the getter and setter methods. So let's start the example of getter and setter method. So what we will do here, we'll just take this code and paste it here. Okay. So when I hit shift enter and I try to access the data from here. So let's say I'll create another object with the name bot4, and I'll give the class name with the threshold value. So let's say it's 70K. And now when I add another cell here and try to access the attributes from inside, I can see that position, price data, and threshold is still visible. But if I try to access done already, I'll add the class name here. So auto trading bot and hit enter, and it will return me the threshold value. And we don't want to give the direct access to the data to any other person. So what we will do here, we'll use another method, that is getter method. So what I'll do, I'll just write here, define get, I'll give here any name. So let's say what it will do, it will just return the threshold value, right? So it will return the return and self dot, yeah. So now I hit shift enter, and so now when I try to access this, I'll write bot4 dot, and now when I try to access this, so what I'll write bot4 dot, and here in the suggestions you can see we have another method which is get attribute, and I'll select this, close the parenthesis, and now actually we don't want this for now, so I'll just remove this. So I'll just remove, and I'll again shift enter, and now when I run this, we can see that it is returning us the value of the threshold. So with the help of this getter method, we can easily avoid giving the access to our data. We can give a method, with the help of that method they can access the data and they can use it. So now let's say I want to change the value of this, I want to modify. So what I'll do, I'll set another method here, and we can name it as set attribute, and here self, and we can say modified threshold, so or new threshold. So here what it will do, it will just it will return the self dot this one. So now let's try to access this. So I'll just hit Shift Enter, and here I'll take another cell and I'll write bot 4 dot. So here we can see the set attribute also. So here I will change the value from 7,000 to 8,000 or 80. When I hit Shift Enter, it is returning us the 80,000. And if I check here now, it has changed to 80K, right? This is how you can use the getter and setter method. And this is the safest way to give the access of your private data. If the person wanted, what he could have done, he would have just changed this to string. And when we hit Shift Enter, and when we try to access this, and after that, if I have more functionalities like the execution or the comparison, then definitely it will not be able to do that because this is a string. So in order to avoid that, what you can do, we can add a conditional statement here. So if new threshold, so the type of new threshold is equal to str, then it will perform this action. Otherwise, if we try to be over smart, what it will return, don't try to be over smart, right? And now when we hit Shift Enter, it says expected. Yes, it expected here. So now when we try to access this, so I'll just hit Shift Enter and it still returns me the string. So what we can do, I'll just change it to a string, of course. And now when I try to change, so now let's say if the junior programmer wants to make it a string, so what it will be written, don't try to be over smart. And if you're working fine, let's say giving the right value, it will work fine. When we give the right value here, so let's say 8,000, we have to change it to int. If the junior programmer now give any other value than integer, it will be displayed as don't try to be over smart. Let's say if he's giving correct value 8,000, then it will be working fine. So this is the example of get attribute and set attribute, and it will be very useful for you to make your code more safe. Now we have collection of objects. So in this, what we can do, let me take this example again, trading bot, or I'll paste it here. And here what I'll do, I'll just change these values. Let's say it was the threshold, and we can also give the name like the stock name. So let's say stock name, and here stock name, let's say stock name, and I'll remove this one. Okay, so we have two parameters. The first is stock name and second is threshold. I'll hit Shift Enter, and then if I try to create object of this class, so what I'll do, I'll create here. So let's say I'll create capital bot 1 is equals to auto trading bot, and here we will provide two values. The first is the stock name. So let's say I'll give Apple, and threshold we can provide is, let's say 110. We can also have bot 2, which is again equals to auto trading bot, and here we can provide, let's say Microsoft, we can give 150, correct? And let's take two more value. So I'll just copy and paste this again, and I'll quickly change here bot 3, bot 4, and Apple to BTC, and Microsoft to Ethereum. So now what we are doing here, we have created 4 objects, right? So when I hit Shift Enter, so now as we have seen already so many times that in Python, all the data types like integer, string, and this class, functions, all are objects, right? So I'll add these inside the list. So bot 1, then bot 2, and bot 3, and bot 4. And if you can imagine, this is very powerful. Now we can treat the class objects as a normal data type, right? List on these, we can perform dictionary, we can perform any operations which we can do on other data types. So let's say bot1, and if I want to apply for loop, so for I in L, print I, and when I hit shift enter, all the objects will be printed out. This is really powerful, right? Now if I want to access these values, what we can do, we can give the class name, then the attribute name. But let's just, for the sake of simplicity, what we'll do, we'll just make it a normal attribute for now. But make sure you make a habit that whenever you are creating the class, and inside that you make all the data private, always a stroke name or threshold name. So what I'll do here, I'll just give I dot threshold, and now when I hit shift enter, all the threshold is printed out. And if I want, I can also print I dot stroke name, right? And with this, you can imagine the possibility you can perform with Python. Means there is no limit, sky is the limit. You can do whatever you want with the Python. Just your basics need to be very strong. If your fundamentals are strong, then you are the unstoppable. Then again, if we can make list, then of course we can make dictionary also, right? So what we can do here, let's say we have this, I'll go here and I'll type D, and here what I can do, instead of this, I'll change to the curly braces, correct? And here I'll give like P1 and P2, P3 and P4, correct? It says P1 is not defined. Actually, we have to make this a string. So P1 and P2, P3 and P4. So now when I hit shift enter, we can use the for loop. So for I in D and print. So if I want to print the values from the dictionary, what we can do, we can write like the stock name. So when I hit shift enter, it will print all these stock names. And if I want the threshold, so you can do that also, shift enter, and all the threshold will be printed out. So now we are able to like the normal data type, and we can perform all the operations, right? So now we have again one very important concept, which is static variable. So as we have seen that all these are instance variables, because see, and this self.stock name is also an instant variable, because whenever we create the object, it gets executed and we can get the value. But what if I want some variables, for example, in a trading strategy or in a trading application, we want to count the trade number, like we have a trade ID. If I want to apply that counter, that how many trades are being happen here, so whenever we make an object of this, so let's say I'll create a counter here. So self counter plus equals to, and here I'll give the value, the initial value. So we can give it as self dot, or in the starting we can give it. So now let's say we want to apply a counter to this class. So like in a trading exchange, whenever a trade happens, we should be able to count that, right? It should be assigned a trading number. We want to apply counter. So I'll write here self dot counter is equals to 0. So whenever an object is created, this counter gets incremented by 1. So self dot counter plus equals to 1, correct? I dot counter, right? So when I hit shift enter, you can see that we are getting the value 1 for objects, which we don't want. We want to increment it one by one in each trade, right? For that, we need a static variable, because this instance variable will always given a 0 value each time an object is created. So what we can do, we can give a static variable, and for that we have to define this outside of the class. So here I have to write this counter equals to 0. Whenever an attribute is outside of the function, that variable belongs to the class. If I want to access that, I have to write the class name auto trading bot and counter plus equals to 1, correct? So now if I want to access, so I'll just hit shift enter, and here it will be printed out as 8. So we cannot do that. We have to write the class name here to access. So auto trading bot, we have to print it here. So auto trading bot, and then what we'll do, we'll print the, and I'll remove it from here. Doesn't make sense here. So now you can see that we have 1, 2, 3, 4. Each time an object is created, the value of the counter will get incremented. So this is how we can use the static variable, and that is the difference between static and instance variable. Static belongs to the class, and instance belongs to the function, or we can say object. So to access the static variable, we have to use the class name, correct? And to access the instance variable, we have to use the self. This was it for this. And similarly, we can have static methods also. So for that also, the same process applies. We have to use the class name, and with the help of that, we can access that. So here, static attributes are created at class level. Static attributes are object independent. We can access them without creating instance of the class in which they are defined. The value stored in static attribute is shared between all instances of the class in which the static attribute is defined. Means we can use this counter value in all the methods here, right? Because it belongs to the class, not a particular. So that was it for the static variables and static methods. And in the next session, we will cover inheritance, abstraction, and polymorphism. Then we will finish the object-oriented programming. Now we will start with a very simple, very easy, but very important topic, that is aggregation and inheritance. And after that, we will complete polymorphism and abstraction, and then we'll be done with the object-oriented programming. Why I am taking so much of time in this object-oriented programming? Because this is the most important topic, correct? If you understand this properly, then you will be able to create any kind of strategy with the help of this concept. Overall, we can say that this is the last topic of basic of Pythons. So once you learn this properly, I can assure you that you will be able to create any trading bot easily. So what we will do, once we are done with this topic, before starting the advanced Python, we will create a full-fledged trading bot. Because in comments, I saw a person that he was asking, can we create a full-fledged trading bot after completing 100 days? But what I'll say, that you can create a trading bot even after completing this OOPS concept. Means day 13. Means if you have good understanding of these basic fundamentals, you will be definitely having an edge over the others. So if you have any difficulty in these topics, please watch the video again and attempt all the MCQs and tasks, because those all questions are highly researched and curated. So you should be definitely attempting all those questions, right? So let's get started with today's topic, that is aggregation and inheritance. So let's first understand some theory behind this, and then we'll proceed with the examples, right? So what we will do now, as we have already covered encapsulation, and today we'll be covering aggregation and inheritance. So first, let's compare all these three concepts, and then we'll proceed further, right? So in encapsulation, what we can do, we can bundle data and methods that operate on the data within a single unit. So we can say, like within a class, we can bundle a data and methods. Then again, we can restrict direct access to some of the object's components. So with the help of these underscores, we can make our data and methods private, and with that, we can restrict the access, right? So what are the benefits of encapsulation? It protects data integrity. Yes, we can hide them. And again, it increases modularity and maintainability. We have understood this concept in the first session of OOPS, so you can refer that again. So when it comes to the example, class with private attributes and public methods. So in some classes, we have private attributes. Generally, we have to keep all the attributes as private only to make our data more safe, right? And with the help of this syntax, double underscore, we can make our data and methods private. So that is a basic idea behind encapsulation. Then today we have aggregation and inheritance. So let's understand these one by one. So first, in aggregation, what happens? Has a relationship where one class contains reference to another. What happens, like we have a trading bot, and inside that we have multiple strategy. So what we can say, trading bot has a relationship with trading strategy, right? Again, we can say a restaurant has a menu. Means what we can say, whenever there is a has a relationship, it is known as the aggregation. So it allows independent life cycle of a contained objects, right? Again, what are the benefits of this? So reusability of components, and it enhances modularity and flexibility. It is almost same for all the concepts. Again, Like a car has an engine and a wheel, correct? Again, a trading board class containing trading strategy object, that is also an example of aggregation. One more thing I would like to add, that in encapsulation, we can provide controlled access through methods. Right? We have done that in previous session. And again, it simplifies the debugging because it will exactly show us that in which method we have the issue. So we can quickly debug that issue. And again, in aggregation, it promotes separation of concerns and it simplifies code maintenance, right? That's very obvious. Next, we have the inheritance. So this is very, very easy concept because this is not a Python or we can say object-oriented programming concept. This concept is based on real life. So let's see how. This is the mechanism where one class inherits attributes and methods from another, and it enables hierarchical classification and it promotes code reuse. For example, we have a class animal, right? Inside that, we have multiple classes. So let's say we have a class of dog. We have a class of, let's say, cat. We have a class of, let's say, cow. So means what we can say, these all classes, the class dog, class cat, and class cow is inheriting some properties from the class animal. Correct? So that is the concept of inheritance. And again, what is the benefit of inheritance? So reusability of code, it simplifies code maintenance and it facilitates the addition of new features. So when we have an inheritance structure, we can quickly add any new feature. It becomes so easy because we just need to add another class in the main class. Correct? And that is a simple comparison between these three concepts. And now let's quickly see some summary of inheritance. So in that we have few pointers, like a class can inherit from another class. Inheritance improves code reuse, correct? So let's say in a class, we have written some code and that code can be reused again and again in the subclasses, the inherited classes. So we can say inheritance improves code reuse, correct? Then this is very important. Constructor, attributes and methods get inherited to the child class. So when we have a main class and what things will be inherited, so we can say constructor, attributes and methods gets inherited. The next is the parent has no access to the child class. So what we can do right now, so just understand these concepts and take a screenshot, and then when we implement the example, that time you can come back and again see these pointers, and then you will get to know what these pointers meaning, right? So the parent has no access to the child class. We'll see in the example that the parent class cannot access the data and methods of the child class, but a child class can override the attributes or methods. This is called method overriding. We will understand this also, don't worry. Then the last is super function is an inbuilt function which is used to invoke the parent class methods and constructor. So without further ado, let's dive into the example and let's see how these concepts work in the real life. Let's quickly see the example of aggregation. So what we have here, for example, we have a trading bot, and inside the trading bot, we have multiple trading strategy. So what we are doing here, we are asking our trading bot that I want to execute this trading strategy at this particular price. So let's say we have a class my trading bot, correct? And then we have a constructor function. So init, and inside that, okay, let me give the space here. And inside that we have a self, and what parameters we'll be giving to our trading bots. We'll tell that this particular trading strategy means the name of trading strategy, so name, and then we will provide the strategy itself, right? So strategy, correct? Then what we can do here, self.name will be name, and then self.strategy will be the strategy. But we know that this strategy is not a simple entity. It is a complex entity because the strategy itself contains a code and we cannot just pass it like a single name. So for that, we need to create a new class. So let's say I'll go here and create a new class named, let's say, awesome strategy, correct? And this strategy also have its own constructor function. So def and init, and inside that we have self, and in strategy class, what we will provide, we'll provide threshold. What it will check? It will check that whether the current price is greater than the threshold price, then it will execute a buy trade. Otherwise, it will return the sell trade. So let's apply a conditional statement here. So if latest price is greater than the threshold, then it will return by string, else what it will return, it will return a cell string. So cell, correct? Now here we are giving the strategy. So what we will do, we'll create an object of this class. So let's say my bot is equals to my trading bot, and inside that we are passing the name. So the name, let's say, is awesome strategy. So awesome strategy. Then for strategy, we have to pass a strategy here. So for that, we have to create another object for this class, right? This awesome strategy class. So I'll write a strategy is equals to, I'll write awesome strategy, and inside that we have to provide the threshold. So let's say I provide the threshold of 100. So if the latest price is greater than 100, it will execute a buy trade, else it will execute a sell trade. So let's hit shift enter. Then we can see here it says latest price is not defined. So for that, what we can do, we have to define a method here which will execute the trade. So what I'll do here, I'll go and define a method. Let's say define with the name execute we can do, and inside that we can provide the current price. So I'll write price, and then what it will do, it will have a variable action. So it will check. So what we can do, self dot, it will call this strategy. One more thing, what we can do here, we can keep this in another function. Let's say define evaluate for our better understanding, evaluate, and inside that we can pass self and the threshold, and the self is enough for that. And here what we can do, we can give like self dot threshold is equals to threshold, and here also we have to change it to self dot threshold, right? I think now we are good to go, and I'll just so here what it will do, it will call this function. So to call this function, it has to call the object first. So self dot strategy, then the function, the method, we can say evaluate, and it will pass the latest price. So let's say 105. Then it will return a value based on this latest price. We will just provide a variable here, and we will call this function from outside of the class. So let's say if the latest price is greater than the threshold price, it will return a buy, else the sell. So what I can do here, I can return a string, a formatted string. So f, then we can say that the name of the strategy, so self dot name, is executing a action, right? So we can call here action, and then also action, correct? And then what we will do, we will call this function execute from outside of the class. So what we will do, we'll write my bot dot execute, and now we can give the price. So let's say it is 105. So when I hit shift enter, throws an error. It says takes one positional argument but two were given. So we have to give self also here, and now it says object has no attribute strategy. My trading object, we made a spelling mistake. I will change this, and hopefully strategy, let's say this strategy is being passed here, then it will go here, and we will make it this was a mistake. Why? Now it says evaluate takes one positional argument but two were given, so we missed here also. So in evaluate we gave so here we have to give the latest price also, right? Latest price, now it is good. So it says awesome strategy is executing a buy action because we have given 105. If we give 95, then it will return a selection. So this is how the aggregation works. So you can see that this my trading bot has a relationship awesome strategy, means it can have multiple has a classes, and this is known as the aggregation. And one more thing, I wanted to show you the aggregation class diagram. So for that, what I will do, I'll draw. So now as we have already understood the aggregation, So let's start with the aggregation class diagram. So how does it work? In the example, we had two classes. So this is the first class and this one is the second class. The name of the first class was my trading bot. My trading bot. And the name of the second class was awesome strategy, correct? So while drawing the class diagram, you first have to write the class names. Then you have two sections here, first and second. So in the above section, you write attributes. Similarly here also attributes. And in the below section, you write the methods, right? So methods. Similarly here also methods, correct? So now we know that in this example, in trading bot, we had two attributes. The first was name and second was strategy, correct? Similarly, in this we had a method with the name execute, and in awesome strategy class we had an attribute with the name threshold, correct? So I'll just write threshold and a method with the name evaluate. Until now it should be clear, right? Now the most important part of this class diagram is you have to mention the negative sign or the positive sign. So if your attributes are private, you just mention the negative sign. And generally you have to keep all your attributes, or you can say variables, private, and methods you can keep public. So you will write positive sign. So that is how the class diagram works. And when you want to show that this is an example of aggregation, you have to show has a relationship, right? Because we know that this my trading bot class has a relationship with this awesome strategy, correct? Has a relationship. So which means we can represent this class with this symbol. So you have to write diamond, or you can say a rhombus. So whenever you see this kind of diagram, you can directly say that this is the example of aggregation class. Hopefully it should be clear. Now let's start one of the most important topic of the object-oriented programming, that is inheritance. And trust me guys, if you learn how to write code in terms of inheritance, your code will be very simple, easy and readable. Because those programmers who always writes a program in terms of inheritance, their code is so smooth, so awesome to read and understand. So the first question is, what is inheritance? So what we can say, inheritance is not the concept of programming. It is the concept taken from the real world. We can see that any child by default inherits all the property from his parents, right? By law or by societal structure, correct? Similarly, in programming also, child class inherits all the properties like data and methods from the parents class. Let's understand this with the help of an example. So let's say you are creating a trading bot. So means that trading bot consists multiple strategies, right? So what you can do, you can create separate class for every strategy. So let's say you have two strategies. So one strategy is for, let's say, SMA and EMA, simple moving average and exponential moving average. Another strategy you have, that is, let's say, Bollinger Bands. So now you will write the code for this. So in that class, what you will do, first you will write the name, right? Name of the strategy. And then let's say you write the type. Type means whether this strategy is a technical or fundamental, right? Again, then you write some methods. So in methods, you can write the calculation code. So a method to calculate. So a method to calculate first the SMA. And then you can also write another method to calculate EMA. Similarly, for the Bollinger Band strategy, you write the name of strategy in attributes. And again, you write the type, whether it is a technical or fundamental. And similarly, you write a few methods to calculate. So let's say first you calculate the lower Bollinger Band and a method to calculate the upper Bollinger Band, right? These are all methods and these are attributes, right? Now, the problem here is that by writing the code this way, you are violating one of the most fundamental principle of programming, that is dry. And what is dry? Dry stands for don't repeat yourself. And here you are repeating this code. means the name and type will be in all these strategies. Let's say you have a collection of 100 strategies. That means you are writing this code in 100 strategies, and that is not a good practice, right? So in order to resolve that, what you can do, you can take the help of inheritance. So now let's write the same code with the help of inheritance. Now what we will do, we'll write 3 classes instead of 2 classes. So again, we are creating a trading bot. So I'll write trading bot. And inside that, what we will do, we will create 3 classes. So the first class we create with the name, let's say strategy, right? And we can consider this as the parent class. And now we will create 2 another classes, and these will be the child class of this strategy class. So the first will be the same SMA EMA, and second will be the BB class. So I'll write SMA simple moving average and exponential moving average, and this will be Bollinger Bands, correct? So I'll just draw it. Drawing is not good, but I know you are getting my point, what I'm trying to say, right? So now what we will do, we have repeated this code, right? The name and type. So what we will do, we'll just write name and strategy, name and type, right? Name and type here. And then both these classes, right? This one and this one can use this name and type, right? And then the rest, the SMA and EMA calculation. So we can write it here, calculate SMA and then calculate EMA. Similarly, here we are calculating the lower Bollinger Band and upper Bollinger Band. So now we can say that we are completely following the dry principle. Don't repeat your code. And here we have not repeated our code, because only once we are writing the name and type, and then we can use this in multiple strategies. Like let's say every month we are adding another strategy, right? So this can be used in that. So another thing we can add, that inheritance helps us in scaling. We can easily scale our code without any problem. So that is how it works. And okay, now let's check what gets inherited. So for example, this was our parent class. So what gets inherited? The first thing which gets inherited, that is the constructor. So let me just move it here. Constructor. Then second is non-private attributes. I'll write it here, attributes. And third is same non-private methods. If the attributes and methods are private, we cannot inherit them. We have some workaround for that also. I'll show you that also after this. But for now, just understand that we can only inherit the constructor function, the non-private attributes and non-private methods, correct? Now the most important question, that what is the benefit of using inheritance? So just pause the video, and I hope you have understood this example very well. Just think and let me know in the comments that what is the biggest example of this inheritance. I'll just show you this diagram. Just see it and try to understand what is the biggest benefit of the inheritance. Definitely you will get the answer. And if you're able to guess correct, please share this video with your friends who really wants to see this, and like the video if you appreciate this effort, correct? So let me show you what is the biggest benefit. The biggest benefit is code reusability. We can say code reusability, correct? Because see here, if we were writing the code without inheritance, so we had to write this line of code inside every strategy. And let's say we have 1000 strategy. So 1000 multiplied by 2 is 2000. And it is just a single word, but you know that while we code, we have to write multiple lines, and sometimes there is a for loop also and some other functions. So it really consumes a lot of resources, and also it slows down our program. So when we are dealing with HFT, high frequency trading, it really harms our performance and results. And definitely whoever written their code with the help of inheritance, they gets an edge over us. And that's why this is the biggest benefit of inheritance. And similarly, let me show you the class diagram for inheritance. I'll write here inheritance class diagram, right? Okay, now let's see the inheritance class diagram. So suppose we write two classes. So the first class is for the strategy, right? So I'll just draw this, and the second class is for a particular strategy. So let's say this is SMA EMS strategy, and inside that we have written some code, right? Some attributes and some methods, and similarly some attributes and some method. So whenever you see a triangle, you can directly say that this is the child class and this is the parent class. As simple as that. In aggregation, we have the diamond or a rhombus, and in inheritance, we have a triangle. So this is the class diagram for inheritance. And now let's jump on the examples and let me show you how these works. Let's start with the example of inheritance. It's very interesting. Please pay attention. Your all concepts will be clear. I promise that. So let's say we have two classes here. One class is for the base strategy and another class is for the specific strategy, right? So let's write the code. So class my base strategy, and then we will define a constructor function. So init, and inside that we will be having a self, of course, and then in base strategy we'll be having the name of strategy and the strategy type, correct? So now we can type self dot name is equals to name, and again self dot s type is equal to s type, correct? And then we will write the function. So define execute, and here also a self. It will print out that the execute method of the base strategy has been executed. And what else we can do here? Let's print another statement here, and here print that the constructor function of the base strategy has been initialized. Then what we can do, I'll just copy and paste this whole class. I'll paste here. So let's say when we are writing the code for EMS strategy, a long window, a short window. So what we will do, window, and here we can say the constructor function of the my EMS strategy has been initialized, and here we can add another method with the name evaluate self, and we can say method of the my EMS strategy has been executed. So what we need to do now, we need to create object for each of these class, and then with the help of that object we can access the data, right? The attributes and the methods. So what I'll do, I'll create the object class 1. So object my base strategy, and here I'll pass the name. So let's say I'll give the name, we can give my EMS strategy. Also the s type we can give that this is a technical strategy. When I hit shift enter, it says the constructor function of the base strategy has been initialized. Means as soon as we create the object, it will get executed by default and we'll get this printout, and this will get printed out. Now we can also check attributes and methods of this class. Similarly, if I create another object for the second class, so let me do that quickly. Object is equals to my EMS strategy, and inside that we need to pass the long window and short window. So 10 and 20, correct? And when I hit shift enter, the print statement of the EMS strategy class has been executed. That says the constructor function of the my EMS strategy has been initialized, which is expected. And again, now when we check that obj2 dot, we can see only the methods and attributes of this class only. But what is the exact meaning of inheritance? I should be able to use all these attributes and methods from this class. For that, what we can do a simple thing. We just need to add the name of the parent class. So my base strategy. As soon as we do that, and when we hit shift enter, and now when you type here dot, you are able to see all the methods and attributes of that, the execute and the name and as type of the parent class. See here, the two attributes and one method, right? And then one more thing we have seen in the theory, that if the attributes and methods are private, then we cannot access them with the help of inheritance. We need to use something else that we will discuss further. But for now, just understand that we can only access the public attributes and public methods. That's it. If I make it private, let's say, and now when I hit dot, I can see name, but I cannot access this. Let me again change it to public for now. So now we are able to access the data from the parent class, and we can see that with the help of this dot. And now let's do something more interesting. So what I'll do, I'll hit shift enter. It says me the constructor function of the base strategy has been initialized and the constructor function of the EMA has been initialized. Let me remove this one, the first object. We'll just keep the second, because our main goal is to access all the data from this child class, right? And one more thing to keep in mind, that only the child class can inherit from the parent class, which is true in the real life also, right? Only the child can do that. The vice versa is not applicable here. Make sure that you keep that in mind. So let's try to access the data. So what I'll do, I'll write obj2 dot, let's say we try to access the name. So when I hit enter, and now when I hit shift enter, it throws an error. It says my EMS strategy object has no attribute name. Means this is the my EMS strategy. It says it has no attribute name, but we know that we have already implemented the inheritance, and by right we should be able to access. Why we are getting this error? If you are able to guess, then make sure you like the video and share it with your friends who really need this video. Let me show you what is the main issue. So what is happening here, when we create the object of this child class, this constructor function gets initialized, it gets executed, right? So whenever we have a constructor function in both the classes, both the child and parent, the interpreter only execute the child class. So in order to execute the constructor function of the parent class also, we need to use that is known as the super keyword. What we'll do now, I'll just add super simple dot, and then I will type in it. Inside that, we need to write the name and as type, same like above. And if we do that, then also we need to make sure that we also pass these parameters in the child class constructor. So I'll just write the name and as type. So once we do that, and now when I hit shift enter, it says missing two required positional arguments, that is L window and S window. Yes. So when we create object of this class, now we have 4 parameters. So we need to pass 4 parameters. So here we can give the name, let's say new strategy name. We can see that the constructor function of both the classes has been executed, and also we are able to access the name. So this is how we apply the inheritance in object-oriented programming. So now let's try to access this method also. So what we will do, we'll write obj dot, and it will show us the suggestions. So execute, and we'll just hit shift enter. So let me just comment this out, and when I hit shift enter, it prints out that the execute method of the base strategy has been executed. You can see that we are able to access. If you are really able to understand this, able to grasp the concept deeply, then please make sure that you are appreciating us with one function, and you know very well what is that, right? Let's quickly take the example of method overriding. So let me tell you what is it. You just pause the video and understand this example and write down your answer in the comments. So let's first understand this example. Here we have a class with the name trading strategy and another class with the name moving average strategy, right? And here we are inheriting. And now you can observe one thing, that in both the parent and child, we have one common thing, and that is the execute method. And now you tell me that while creating the object of this moving average class, so we are providing the arguments for this constructor function because we have inherited. So now you tell me, when I try to access this method, which will be executed? child class or parent class? Okay, let me tell you, because as we have discussed already, that a child class can access all the public data from the parent class. So here, if we try to access this execute method, the child got more power. Execute method of the child class will be executed. So let's try this, shift enter. So now you can see that we have the output as inside trading strategy constructor, which is this one. And when we call this method and we have this output, executing a moving average strategy means this child class execute function is being executed here, right? So that was the basic concept of method overriding. Now let's quickly understand the types of inheritance. Then what I'll do, meanwhile, add some examples in this notebook you can download from GitHub. And still, if you get any issue, please feel free to leave a comment box and we'll be happy to answer you. So let's understand the types of inheritance. Let's quickly understand the types of inheritance, and then we'll be done with the inheritance, and then we'll proceed with polymorphism and abstraction, and that will be the end of basics of Python. And after that, we'll proceed with the full-fledged algo trading bot with the help of these basics of Python. And you will see that what we can achieve with just the basics. And once we are done with the advanced, and then you'll be doing amazing things. So let's get started with the types of inheritance. So let me write types of inheritance. The first one is the single inheritance, which we have been doing previously. That is single inheritance. And what happens in this? We have a parent class. Let's say we have a parent class, and then another class is derived from the parents. That's a simple one, right? Parent class and child class. Simple. The second is multi-level inheritance. Here what happens, like we have a parent class and then a child class is derived from the parent class, and now this parent class can be derived from a grandparent class. So we can have any number of classes here, and the last class, let's say the child class, can access all the properties from parents and the grandparents, all the above classes. So that's the power of multi-level inheritance, and this kind of inheritance is used mainly in the big applications where we have a really big code, right? Then the third type of inheritance is hierarchical, right? So here, let's say we have a parent class, and these parents are a little bit more romantic, so they have multiple childs, right? So you can say C1, C2, C3, C4. That's it. So this is the hierarchical inheritance. The fourth one is the multiple inheritance. Multiple. In this, what happens? We have multiple classes, right? So you can say parent 1, parent 2, and from these classes, there is a derived child class. This type of inheritance doesn't exist in Java, right? Because Java says this might cause ambiguity, which is correct. But what Java says, that a child cannot have two parents. But what Python says, that yes, the child cannot have two parents, but it can have mother and a father, right? So with that, we are able to have multiple inheritance in Python. The last but not the least is hybrid inheritance. So in this, for example, first we have a multiple. So parent 1, parent 2, and we have a child, right? Child class. Then with this, we have a hierarchical class, right? So let's say this is the base class, and we have C1, then C2, and C3. Correct? And here also we can have multi-level also. Let's say D1 and D2 and D3. So this is the multiple, right? And this one is the hierarchical, and this one is the multi-level. So this is the example of the hybrid inheritance. Let's quickly see some examples, and so then what you can do, you can run all those examples in your system and let me know if you have any doubt. So let's proceed with the examples. This is the example of single inheritance. Child class is inheriting from the parent class. So when we hit shift enter, you can see that we have the 10,000 which is from the parent class and 20 from the child class. Next, we have multi-level inheritance where we have a class with the name trading strategy. Then we have the child class which is moving average strategy, and again we have a grandchild from all the above classes. So here you can see that this grandchild class is accessing the self.capital from the top class, then it is accessing self.short window, and then last accessing from the class itself. So when we try to hit shift enter, we'll see the results, that is 100,000, 20 and 50. Next we have hierarchical inheritance in which we have a parent class which is trading strategy, and then we have two child classes, moving average strategy and momentum strategy, and both are inheriting from the parent class. Let's hit shift enter and we get the result that self.capital in both the classes, and that is true. The next is multiple inheritance. This is a little bit tricky. So here you can see that we have a parent class trading strategy, then we have two child classes which are inheriting from the parent class, correct? Then in the last we have another child class which is inheriting from the topmost class, the fundamental strategy. So here what is happening, that this hybrid strategy class is inheriting from trading strategy class, technical strategy class and the fundamental strategy class. So when we hit shift enter, we get the values 100,000 from the topmost class, then we have RSI, technical strategy class, and then we have P ratio which is from the fundamental strategy class. The last but not the least, we have the hybrid inheritance. So here what is happening, we have parent class trading strategy, then this technical strategy is inheriting from this, so it is a single inheritance, right? Then we have another fundamental strategy class. This hybrid strategy is inheriting from the trading strategy and the fundamental strategy. This is multiple inheritance. When we try to access, we get the output from all of these classes, this 100,000, the RSI and the PE ratio. So this was it for the inheritance, and we have covered extensively, comprehensively each and everything from the inheritance and from the object-oriented programming and from the basics of Python. So what is polymorphism? You know that the meaning of poly is many, and formism means you can say forms, right? Forms, right? So in simple terms, you can say that polymorphism allows a single method to behave differently based on the object it is calling, right? So this polymorphism have three principles. So let's cover them one by one. The first we have is method overriding, which we have covered already. I'll just explain you in a bit. The second is method overloading, and the last is operator overloading. Operator overloading, right? So now we have three principles: method overriding, method overloading, and operator overloading. So let's discuss the first principle, that is method overriding. Let me scroll down, and here we have. So what is method overriding? The official definition is when a subclass provides a specific implementation of a method that is already defined in a superclass. Means we have here two classes. One is parent class, another is child class, because this child class is inheriting from the parent class, right? And here we have two methods with the same name, the execute. So when we create the object of this class EMS strategy and we try to call the method strategy.execute, what will happen? This will get executed because the child class method will override the parent class method. So that is the method overriding, and we have covered this already in the previous session. You can also refer the multiple choice questions on this topic and also tasks, so that your concept building is way better, right? So now let's discuss the second principle, that is method overloading. So what happens in method overloading? Let's create an example for this. Let's say we have a class, and let's give this the name maths. Okay. Inside the maths class, we have two methods. So the first method is define, and let's give it the name area, and it accepts the self, of course, and let's say the radius, correct? And it returns 3.14 multiplied by radius into radius. So it will return the area of circle, right? We can say circle, right? And again, we have another class with the same name, define area. And here the inputs are length and breadth. And what it return length multiplied by breadth, right? And it will be the area of rectangle, correct? So now let's define the method overloading. So what is happening here? We have a single class, and inside that we have two methods with the same name, and both the methods behave differently based on the number of parameters, or we can say based on input, right? So here, if we provide the radius, it will return the area of circle, correct? And again, if we provide the length and breadth, it will return the area of rectangle. But unfortunately, this method overloading doesn't exist in Python. This is the concept of Java. It works perfectly in Java, but it will not work in Python, because Python says that I have given you a more efficient and more smarter way to perform the same operation, right? So if we run this code in Python, it will not run, it will throw an error, and shortly we will see that. So for now, just understand this example. So now what we can do to achieve the same functionality in Python, we have a very smarter way, that is default arguments, or we can say variable length arguments. So what we will do, first we'll define a class. So class maths, right? Inside that we have a function define and area, and inside that we have parameters like self, then let's say argument 1 and argument 2, right? So what we will do here, we'll just make the default value of argument 2 as 0, right? So now we will write a code here, a conditional statement, that if a2 is equals to 0, means if there is only one argument is passed, what we will do, we will return 3.14 multiplied by a1 multiplied by a1, correct? So it will be the area of circle, correct? And what we can write, else if it is not 0, means some value is there. So what we can do, we can return a1 multiplied by a2, and it will be the area of rectangle, correct? So that is the example of method overloading, and shortly we will understand this with the help of an example. So don't worry about that. So the next is operator overloading. If you remember, we have already covered this topic earlier. In the magic methods, we added two class objects, right? The strategy 1 and strategy 2. So what we can say here, the different behavior of any operator based on the situation. Let's say if we have two strings, so operator overloading, right? So the best example of operator overloading is the plus. So what we will do here, let's say we have two strings, right? String 1 and string 2, right? If we add this plus operator here, what it will do, it will concatenate the string, correct? So it will perform the concatenation operation, correct? Because these are the strings. Let's say if we have two integers, right, 1 plus 2, then it will perform the sum of that, addition. So here we can say addition, it will perform. But if we have two lists, let's say 1, 2, 3 and plus 4, 5, 6, what it will do, it will merge the list. So in simple terms, you can say that this positive or the plus operator behaving differently based on the input. So like when we have a string, it will concatenate that, and when we have integer, it will add that, right? And when we have list, it will merge the list. So that is the basic idea of operator overloading, and we'll see some examples of this also, don't worry. So let's see some examples of method overloading in Python. Let's say we have a class as trading strategy, and inside that we have a method as execute, right? And here we have a default argument of times, that is 1. So what will happen here, while creating the object, when we call this method, if we do not pass any argument, it will print executing strategy. But if we pass any argument, it will print the same thing 3 times, right? So it will print the executing strategy 3 times, and it depends on the arguments. If I pass the argument as 5, it will print the executing strategy 5 times. So that is the example of method overloading. And let's see another example. So what is happening here? Here we have a class as trading strategy, and inside that we have method with the name execute, and the default arguments are times equals to 1 and strategy name is default. So if we do not provide any argument while calling this, what will happen? It will take the default argument of times as 1 and strategy name is default. So when we call this method without any argument, what will happen? It will output executing default trading strategy run 1. Correct? If we call this with the argument as 3, it will print the same thing 3 times. Correct? But with the default name. But if we provide both the things, the times means 2 times it will execute and the name of strategy, which is EMA. So it will print out the string executing EMA trading strategy run 1 and then run 2. So these were the few examples of method overloading. You can refer more examples in the MCQ and task. So now let's move to the next, which is operator overloading. And for that, so you can see here, we have a trading strategy, and inside that we have a constructor function and magic method with add and a magic method with str. So here I'm creating two objects, one with the 500 value and second with the 300. So when I try to add the strategies, it will output as the 800. And this is nothing but the operator overloading, which we have covered already. So I don't think you have any issue here. And if you still have, let me know in the comments. We'll discuss this further. Okay. Now let's move to the last topic of the day, which is abstraction. So what is abstraction? Abstraction is a concept in object-oriented programming where you define abstract classes and methods. Pay attention to these words. Where you define abstract classes and methods that are meant to be overridden in derived class. This allows you to define a template for other classes to implement. So what is happening here? Let's see this example. So whenever you see this ABC, it means this is an abstract class. This is the first condition, that it should be inherited from the ABC. Right? The second is it should be having at least a single abstract method. So whenever you define an abstract method, you write this abstract decorator. You can say this is the abstract class, the whole, and inside that we have two abstract methods. And one more thing, you cannot create object of this abstract class. So basically we have three things to remember here. The first thing is it should be inherited from the ABC class. So here it is, we have done. The second is it should be having at least a one abstract method. So we can write one. And then the third is we cannot create object. Now you see here that this was the abstract class and here we have another class. The inheritance is happening here because here we have written the name of the parent class here, right? And then what we can do here, we have to write this abstract, we have to override that, and that becomes an abstract class. Let's quickly go to the computer screen and perform some examples of polymorphism and abstraction. Method overriding. When a subclass provides a specific implementation of a method that is already defined in its superclass. So here what is happening? We have two classes. One is the parent class, that is trading strategy. Another is the EMS strategy, that is the child class, and which is inheriting from the parent class, that is trading strategy, right? And in both the classes, we have the same method with the name execute. And now we create the object, and when we try to call the execute method, this child class method will override the method of the parent class. So let's hit shift enter and you'll see that executing EMS strategy, that is the method overriding. Very simple. Again, we have the example of method overloading. So here what is happening, we have a class with the name trading strategy, and inside that we have a method, and in that we have default parameters of times equals to 1 and strategy name is equals to default. So after creating the object, if we do not provide any parameter, what will happen? It will take these as default and it will print, let's say, shift enter. And now when we call the strategy, if we don't provide any argument, what will happen? It will print executing default trading strategy run 1, right? By default. But let's say if I provide here times equals to 2, so it will print that string 2 times. And let's say default strategy we write as awesome strategy, which we have seen already. Awesome strategy. And when I hit shift enter, it will print the string 2 times. So that is the method overloading. And let's see another example. So here also it is almost same. Here we have default parameter with the value 1, and now we have the second example. So inside that it's almost same again. So the times equals to 1, the default argument. So let's try to create the object and call this execute function. So I'll just comment this out, and first we call without any argument. So when I hit shift enter, it will print only one time because we have default argument as 1. And when we pass an argument with 3, so what will happen? It will get printed out 3 times. So when I hit shift enter, you can see that we have this output 3 times, correct? Okay, now we have another example of operator overloading. As we have previously seen that we can use these magic methods add and str and repr subtraction, and with the help of these magic methods we can perform the various operations on the objects of the class. So here we are performing a addition on this, and we have seen that this operator can behave differently depending on the situation. So here we have 2 objects, so it will just print it out here. But when we have string, it will concatenate, and when we have integer, it will just add them. So we can say that operator behaves differently based on the input, right? So when I hit shift enter, it will just add these and it will print out 800, right? You can see here. Now we have the example of abstract class, and as we have seen that we have few conditions for the abstract class. What is that? First, that this abstract class should inherit from the ABC class, right? Again, this abstract class should have at least one abstract method. So we can decorate the abstract method with the help of this abstract method decorator. So here what is happening? We have a method which prints out connected to the trading server. Then for now, we are just passing these static methods, but here you can implement your security code, right? The code which you don't want to display to other people, or let's say you want to make it hidden, or let's say you want to make it simpler, more readable, right? So that code can be written here, and then in the next class, EMA trading app, and you can see that the inheritance is happening here. This trading app class is being inherited to this EMA trading app, right? And here also we have 3 methods. The one which prints out logged into mobile trading app, and the other which is strategy and execute trade. So these methods will override the abstract method, because we have seen that the abstract method is meant to be overridden with the derived class methods. So these methods will override the abstract method, and when you hit shift enter and try to access these methods, and that is connect from the parent class, the abstract class, and also the mobile login, which is from the child class, strategy and execute trade. One more thing, that you cannot create object of this abstract class. So these are the few conditions for the abstract class, and when you hit shift enter, it will get printed out, right? If I try to create object of this class, what will happen? Let me try to do that. I'll just comment these out and let's try that. So app is equals to the name of this class, which is trading app, correct? And so let's hit shift enter, and it says can't instantiate abstract class trading app with abstract method execute trade and strategy. So it will not work. So this was it for the polymorphism and abstraction. So before we start coding, let me quickly explain you what is our objective and what outcome we are expecting here. So the objective here is to create full-fledged algo trading bot. So algo trading bot, which performs these functions. First, to fetch live market data. So to fetch live market data. And second is generate trading signals based on a strategy, right? Based on a strategy. And the final step is to execute trades in a simulated environment, right? So I'll just write short. So this is our objective, and the outcome we are expecting here is the first is to understand structure and functionality of the algo trading bot, right? So you can just write structure, and second is functionality, correct? Which involves live data fetching. So you can write live data fetching, then strategy implementation, strategy, and last is to execute trades. We can write execute trades. So that is the objective and outcome we are expecting here, right? So now let me quickly explain you the execution flow of this algo trading bot. So the first thing will be to set up an installation, So in this step, we will prepare the environment and all the libraries which we need here. So we'll perform this step. The second will be fetching live market data, right? So we can write like. Then the next is implementing trading strategies, right? So we can write. And the next will be, we will simulate the trading environment. So simulate trading environment, right? Then what we can do, we can integrate different components, right? Different components. So what we will be doing, we will be creating multiple classes. So how we can integrate all those classes and different kind of methods and functions so we can achieve a single function from where we can run our algo trading bot, right? This step will cover that. Then the last will be how we can run our trading bot. So basically these 6 steps run our trading bot. So basically we'll be following these 6 steps, and now let's start coding. Okay, so what you can do here, first you watch the whole video in one go, and in the next step you watch it again, but this time you are also coding with the video. So that's how you can learn the concepts very faster. So let's get started with the coding. So what we will do, we'll write the code step by step, and don't worry if you don't understand anything. I'll explain the whole code again on the notepad. So first of all, we write a base class. So class, and let's give it the name my trading strategy. Then here we define a constructor, self and name. This is the name of the strategy. So we have passed the parameter as a name. Then what we'll do, we'll make it private. And why we make private? We have learned that in the object-oriented programming, right? To implement the encapsulation, correct? So name, so that this cannot be changed outside of the class, right? Then what we'll do, we'll define a method with the name generate signal. And what it will do, we are defining to get it override, right? So what we'll write here, we'll just print that this method is intended to be overridden, right? And here we can give a parameter as, let's say, price data, correct? And what it will return, in case if it gets executed, it will return hold. Hold means like when we are trying to execute any trade, so we have two options, buy and sell. But if somehow this gets executed, means it will print out that we should hold that trade. And why we are defining here this method? Because as we have understood in the object-oriented programming in polymorphism, that whenever we want to instruct any other classes, that you should be enforcing security, or you should be enforcing this kind of rule, or let's say we want to force them to apply some kind of rules. So here what we are doing, we are asking that you should create this method in your future classes, and the name of the method should be generate signal and parameter should be price data, right? And now what we'll do, we'll define a getter method, right? So how we can do that? Define name self, and we can simply return the self dot name, and yeah, that's it. And why we are doing this? Because we have made this private. So in order to make it easy and in order to enforce security, we are creating this getter method, right? So let's try this, and it says invalid syntax. So okay, we have to remove this. Now it's fine, and we'll write like this. Okay, so let's create an object for this class. So let's give my base object, because this is the base class. So we'll create with the name and my trading strategy, and we'll provide the name. So let's say, as usual, our awesome strategy, right? So when we hit shift enter, and now what we can do, we can call this method my generate signal. So my base obj, then generate signal, and when we hit shift enter, it says missing one required positional argument, price data. Okay, we'll just give anything here. Let's say 1, 2, and it says this method is intended to be overridden and hold. So for now it is working fine. And let's check for this also, name. So my base object and dot name and shift enter. So it says me awesome strategy. So for now it is working fine, and we don't want this method to be executed because we want that this method should be overridden in the future classes, right? And the reason behind that is we want to make sure that the future classes implement this particular method with the same name, right? And if you are having any confusion, please watch the previous videos of object-oriented programming and you will get to know. And still you having doubt, please let me know in the comments. I will be happy to answer that. Okay, now we have already tested this. It's working fine. So I'll just add another cell here. And now we'll proceed with the next class. And we can give that the name as class. Let's say my SMA, right? SMA trading strategy. And now what we will do here, we will just inherit the base class. Right, we have inherited this class here. And one more thing I would like to do, that when we want to get this name with this getter method, we have to write name and parentheses, right? So it means we are calling a method. But what if I want that the public should not able to know whether we have a getter method inside or an attribute? So what we can do, instead of this, I'll just write here decorator. And don't worry, we'll read the decorators after 1 or 2 classes. So don't worry about that. I'll just add a decorator with the name property, right? And now when I try to access this, I can simply remove this. And when I hit shift enter, you can see that we have the name awesome strategy. Now you don't need to call this with the function or method name. You can simply call this as an attribute name. So that's how you can use this decorator. And we'll read about it shortly. Okay, let's again start with the second class. So, and here we have created new class, my SMA trading strategy, and we have also inherited this base class here. Now what we'll do here, I'll define a constructor. So def init and again self. And now you think and let me know that while creating a simple moving average trading strategy, what things we need, right? So I think short window and long window, right? So short window and long window. Let me explain you this also. Just give me a minute. What we will do. So what I did here, I randomly searched simple moving average, and let me show you what it is. So let's say we have this, and let me zoom it out a little bit. So hope you are able to see this. So you can see here we have this chart, and inside this chart we have 2 lines. One is blue and another is red. Let's say I define this blue line as short window. Short window and long window means I want to calculate 2 average. Short window, let's say for 3 bars, means it will calculate the previous 3 bars average. So let's say 1, 2, 3, and it will display here. Correct? That is the short window. And for the long window, let's say we have 5 bars. So it will calculate the previous 5 bars, means 1, 2, 3, 4, 5, and it will display that here. And when it happens continuously, it will create a line, right? So that is the short window and long window. And when we have the average of that, so it becomes the short moving average, and this one becomes the long moving. It becomes the short moving average, blue line, and this red line becomes the long moving average, right? So sometimes what happens, if the recent price is higher, then this short moving average becomes greater than the long moving average. And when the recent prices are like dropping, going down, then what happens, the short moving average is less than the long moving average. So that's the basic idea behind this. So while creating this simple moving average trading strategy, we definitely want the short window and long window, right? Now again, what we want, we have already inherited this base class. So we want to initialize this constructor. So how we can do that? With the help of super keyword. We have understood that already, right? So I'll write super, then dot, and again init self. And here also we can provide the name, like we can give the name parameter also, or here we can provide the name also. Like we will be having multiple strategies, one for SMA, one for Bollinger Band. So here I can give the name as, let's say, my SMA trading strategy. And okay. And again, what we can do here, we can make these parameters as private. So how we can do that? Self dot short window is equals to short window, and self dot long window is equals to long window. We have made these 2 variables as private because we don't want that anyone can change the value of these from outside the class, right? If we have made these attributes as private, then we also have to add getter method so that anybody can access easily. So we can do that, right? So I'll add another 2 getter method for these also. So what I'll do, I'll just copy and paste this, right? So I'll go ahead and copy and paste 2 times, and now I can quickly change this one, short window. I can take this short window, and here also short window, and long window, and here also long window. Here we have 2 options. The one is we can create a simple getter method, which we have done previously. But if you want to make like this, that the user doesn't know that whether this is the attribute or a method. So what we can do, we can add this decorator with the name property, and this will make this getter method behave like an attribute, right? So, and this is done. Now what we can do, okay, now let's create a method to calculate the short and long moving average, and then on the basis of that, it will return some signals like sell, buy, or hold. So what we'll do, we'll create a method with the name def, and we can give the name as generate signal, because here in the base class we have already mentioned that we need to create a method with the name generate signal, and that should override this signal. So we'll create with the same name, generate signal, signal, and here we can give the same data like self and price. Okay, let me explain you one more thing. What is the price data? The price is what we get from the exchange. Like when we are creating the bot and we are fetching some price from the exchange, so it will return us some value. And what we can do, we can use that price however we want. We can make that a list, we can make that a dictionary, and we can modify that value as per our requirement. So here what we will do, when we try to fetch the price from the exchange, we'll make that as a list. So just keep in that mind for now. So you can think that this price data will be the price fetched from the exchange, right? Okay. In this method, what we will do, we'll apply a condition, and what the condition will be, if the length of price data, and inside that, what we can write, negative of the long window, right? So for long window, we have to use this as self, right? So long window, and then the indexing, correct? If that is less than the long window, we have to use this again, self, right? Then what it will do, it will return, okay, we have to use this inside, yeah, then it will return hold. Now let me explain you how this line is working here. Okay, so what we'll do, we'll just copy this line from here and paste it somewhere else. So let's go to the next cell. Let me explain you here. So as I explained you already, that this price data will be the price fetched from the exchange, and that will be converted to a list. So let's say, for example, we have, for now, just assume that price data is equals to a list, and inside that list we have 1, 2, 3, 4, 5, right? And let's say, let's make it 6, 7, 8, 9, 9, and 10, correct? So what we are doing here at this place, we have given 2 windows, short window and long window. Means we are calculating the moving average for short window and long window. And let's say we have given short window as 3 and long window as 5. And I have explained you already what is this. Let me again tell you. Okay, let's open the chart again. So let's say the short window is these 3 bars, right? These 3 bars. And here, let me zoom it again. So in the example, what we are asking, that short window will be the 3 and long window will be the 5. So short window means for these 3 bars, 1, 2, 3, and long window will be the 1, 2, 3, 4, 5 bars. And we have fetched the price data for 10 bars. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So until here, we have the price data. So if the price data is less than the 5, then it will not work, right? It will not be able to calculate the short moving average, and it will return a hold. So that was happening here. Let me again explain you. So what is happening here, I'll remove this for now, self here, and this also. Okay. So we have this price window. As window, we want to calculate is 3 and long window is 5. So if this price data, currently we have the length is 10, right? So when we try to check the length of this, let's say length of this will be, length of price data will be 10, right? Because we have 10 items in this list. So let's say if the length of this window, because here it was 5, so I'll write it 5, right? And then again, here it is 5, right? Long window. Now let's try to print this out. So what I'll do, I'll print this, and it says false. Why? Because we know that -5 means we have already understood this in the list part. So it is the negative indexing. So -1, 2, 3, 4, 5. So it will start from here and it will try to calculate this. Let's say if somehow we are not able to fetch the data and we just got the last 4 bars, but we want to calculate the moving average for 5 bars. So in that case, now the length becomes 4. When I hit shift enter, the length is 4 and it becomes true. So means it will not be able to calculate and it will return a hold signal. Correct? So that is the meaning of this code. I tried my best to explain you, and if you still have any issue, you can let me know. Okay. Then after that, if this condition is not true, then what will happen? I'll write the code for short average. So short average is equals to sum of the price data, and we can say, let me copy and paste this price data of this here, and for short it will be short window and divided by the L window. So here it will be self.L window. And similarly for the long average, what will happen? We just change from short to long, and here also will change from S to L, and it will be short here, right? Short window. So I guess it is fine. Okay, if you want me to explain this also, can do that quickly. So what is happening here? Let's say I'll add again these values 1, 1, 2, 3, 4, 5, 6, and 7, right? So 1 to 10. And what we are doing here, we are calculating the short average, right? So I'll add here this formula and I'll remove this self for now, self, and here also self will be removed, right? So this is the average of the short window. How? Because this is a list, right? So it starts from the S window, and S window we have given as 3. So it will start from here 8, 9, 10. It will do the sum of 8, 9, 10. Then it will divide by 3. So 10 plus 9, 19 plus 8, 27. Divided by 3 will be 9. So when I hit shift enter, it gives me 9. Again, if I want to check the long moving average, so what I'll do, I'll just change this window to L, and here also it will be L. So now it will calculate the last 5 prices because we have negative indexing here. So last 5 prices and divide by 5. So when we hit shift enter, we get 8. So here the short moving average is greater than the long moving average, right? So let's write the code here. So what will happen? We give another condition. If short average is greater than the long average, then what we will do? We'll return a by, right? So a by, and let me copy and paste this code again, and again we can give. Okay, so here I'll apply elif and here else, correct, and I'll remove this from the last, and here I'll change the value and it will be cell here, and in the last it will be hold. Okay, let me explain you what is happening here. If short average is greater than the long average, it will return a signal with the by string. If short average is less than the long average, it will return a cell signal. If nothing is true in both the conditions, it will return a hold. Means that is an invalid signal. Let me show you in the chart. Let's say this blue line is the short moving average and this red line is the long moving average. And because we have asked the size of window is 3 in the short and 5 in the long. So here you can see that the short moving average is greater than the long moving average. So it will give a by signal. And here the long moving average is greater than the short moving average. So it will return a cell signal. At this place, both are equal. So it will return a hold signal that time, because it cannot decide whether to go for a sell trade or a buy trade. So that was the basic idea behind that. Okay, let me again open the, okay. Now what we can do, I'll just hit shift enter. Let's try to create an object for this class. So what I'll do here, I'll just comment out the previous one and I'll create a new object. Let's say with the name my or obj strategy, right? Obj strategy is equals to my SMA trading strategy. And here we have to pass the arguments as the short window and long window. So I'll give, let's say 3 and 5, correct? And when I hit shift enter, it says me super object has no attribute my trading strategy in it. Why? Okay, here we forgot this, so we have to add underscore. And when I hit shift enter, okay, now it's working fine. Now, as per the inheritance concept, what should be happening here? This object should be able to access all the public attributes and public methods of this class as well as this class, right? So I try to access obj strategy dot. So I can see the generate signal, which is fine, al window, name, and as window, correct? So what I'll do, I'll access this generate signal, and here we know that we have to provide an argument of the price data. So for now, we have not fetched the prices from the exchange. So what I'll do, I'll just give a demo price here. So I'll provide this list. When I hit shift enter, it gives me a buy signal, right? Because we have seen that this short moving average is greater than the long moving average, correct? So it is working fine. And again, if I want to check these methods with the decorator, so what I can do, I can just give this name of this function or name of this object. So obj strategy dot al window, and I can also give the obj strategy dot short window, right? So when I hit shift enter, it should give me both. I'll just print because in notebook we have to print in order to get all the values. So print, yes, we are getting correct values for both the long and short, and also we can check for the name. So obj strategy dot name, right? What is the name? Name is this one, right? Because here we have already given a, so ideally we should be able to access this also, right? This method also. So when I try to hit shift enter here, so it is working fine. So my SMA trading strategy means so far both these classes are working fine. This base class and this my SMA trading strategy class, and this class is inheriting the base class. So for now, I think you should be good to go. And if you still have any doubt, please watch the video again, and I'm sure that you will be able to understand, because we are explaining each and everything from very basic, right? And you will understand the importance of this basic in future when we learn AI trading, the machine learning trading, and that time you will get to know that how important it is, right? So let's proceed with the next class. Now what we need a class which is able to like record these details, which trade happened at which time. So we can say that a trade management class, right? So what I'll do, I'll just copy and paste these things from here, and I'll add here for now, and here we'll write our new class. So now let's write the class. So class, and give it the name my trade, and now define a constructor, and here. So now you think and let me know that in order to manage the trades, what kind of parameters we need. So first, self, of course, we need that. Then we need a strategy name, right? We should be able to know that this trade was taken with the help of the strategy. So I'll write strategy name. Then again, we should be able to know at which price this trade was taken, right? So price, and we should also have a signal that whether this was a buy signal or a sell signal. So I'll write signal, and also at which price, right? So I'll hit shift enter. Then what I'll do, I'll again make all these data private as per the object oriented programming concept. So self dot strategy name and strategy name, again self dot signal is equals to signal, and self dot price is equals to price, right? Now we'll create an execute method. So define, and we'll give it the name execute self as usual. Then it doesn't need anything for now, I guess. So what it will do, it will just print a formatted string, and what it can print, executed. It can be like sell or buy. So we'll give this signal here, executed, let's say by trade. So I'll write by trade, then with the strategy, and I'll write the name of the strategy. So it will be this, right? And again, at the price, and we can give this attribute here, right? So we have to keep this in the function, right? And actually it will be not the signal, it will be price. And in fact, it will not be the price, it will be the amount, right? For now we don't need the price, so I'll just write the amount here, and I'll change this to also amount, and here also it will be amount. We can write here like with amount, and we can also add like timestamp, right? It's also very important. We should be able to know that when this trade happened. So for that, what we can do, we can write here self dot timestamp, and what it will be. It will be, for this we have to import a library. And how we can do that? You can just go on the top and you can write from date time. Actually it's a markdown, so I have to add self for code. From date time, import date time, right? And just run this cell. Okay, so moving forward, when we learn the pandas and numpy, all those libraries, we always need to use syntax like this, like the name of the module and the name of the method or function inside the module, right? So here we have a module with the name datetime, and inside that we have a method with the name, or you can say class with the name datetime, right? So what we can write here, datetime dot now, and this. So what it will print out? It will print out the current time. Let me show you with the help of an example. So when I print here, it shows me the current time. So it is like 3:59 current time, right? The current time it shows, and this will be the timestamp of that time. So it will stored in timestamp. So we can add one more thing here at the time, and here we can pass self dot timestamp, right? Let me copy and paste here. Yeah. Okay. Then what we can do? Yeah, we are good to go. What else we can do? Yeah, we can also make these attributes as the same, like with the help of decorator, we can make this accessible for the outside public. So what we'll do, I'll just copy and paste these decorators quickly and paste here. So, and again, 4, because we have 4 here. So first is the strategy name. So I'll change these values to strategy, and here also strategy. And again, we have signal. So I'll change it to signal, and again signal. Now we have the amount. So I'll change it to amount, and again amount here. And the last one is the timestamp. So I'll just copy from here, timestamp, and I'll change here the timestamp. Okay, I think now we are good to go. So I'll just hit shift enter, and it works perfectly. Okay, now let's quickly test this class. So first I'll just test these methods. So I'll call this like a attribute. So what I'll do, I'll first comment out these, and let me call the strategy first. So I'll create the object obj my trade. Okay, my trade, and here I have to pass strategy name, correct? Name. I'll show you what I'm doing here. It's now it becomes interesting. The concepts of object oriented programming. Let me show you. Let me first complete this. Then we have the signal, right? So signal, and next we have the amount. So amount we can give here for now, let's say 10,000. So now we need the strategy name here, but we know that in the previous class we already have a strategy name, and we need that only. So how we can access this and we can pass to this object? What we can do, as we have already created the object for this class, so I can just pass the name of object and then the name of this method, right? So what I'll do here, I'll just uncomment here. Okay, actually here. So I'll copy and paste this here, correct? And for now, let me comment out all these because we just want this first, right? So the object of this class should be created, and with the help of that object, we can call this because this class has been inherited to this one. So name of object dot name will give us the strategy name. So let's test this. So first what we will do, we'll test here. Okay, before that. So we know that this is the name of strategy, right? Object name, and then when I give dot name, it gives me the strategy name. Yeah, it is working fine. So what we can do, but we need here, right, at this place. So for that, I can give here like a different name for now, strategy name, and I keep here, right? Again, for signal, what we can do, we know that signal is existing in this class, right? The my smart trading strategy, and we have already created the object of this class. So what we can do, the object name, and then we can call this method here. So here, what we can do, I'll write here signal is equals to obj dot, let me copy here, obj strategy dot execute, right? Should work actually, and we'll see what happens. Not execute, actually this, the generate signal. So we have to pass the price data also here. So I'll just copy here and I'll paste here, and then we can give the demo data for now. So let's say 1 2 3 4 5, right? So when I hit shift enter, oh, it worked fine. Okay, means we are able to create the object of this class and with the help of the object of other classes, right? So now we are able to create the object of this class with the help of passing the argument as an object from the other classes, right? The concept of object-oriented programming. You can refer the previous video for more details. And also I'll explain you in the after this session. So the signal, so now we want to signal. So what we'll do, we'll call this function here. So we have done that, okay. And now write obj trade and dot, I would like to run this, right? We want to know that what is the signal now, the buy, sell or hold. So no. Actually obj my trade, yeah, we want to call this one, and here we do not have any parameter. We can just call this with the help of object and the name of the method. So dot and execute. So when I run this, yeah, it shows me executed by trade with the strategy my SMA trading strategy with amount, this one, at the time, which was here, this timestamp from this timestamp library. And yeah, now you can see the flexibility and power of the Python with the help of object-oriented programming. And so far, we have just done the basics. Imagine what we can achieve once we have covered all the advanced topics. Then we'll move to the AI trading and then machine learning trading. So you can imagine the possibilities with the Python trading, right? So it is working fine. For now, what we can do, we have already tested this or not. We can test these also, right? The strategy name, signal, amount, and timestamp. So let's do it. What we'll do, I'll just obj trade, and here I would like to print all the values. So first what I'll do, I'll write print, and inside that signal, and then the strategy name, and then we have signal, strategy name, then amount and timestamp. So this will be the amount, and next is we have the timestamp. Please refer the previous video if you are having any issue. So when I hit shift enter, it gives me all the things perfectly. So for now, all things are working perfectly fine. Means we have three classes here. One is my trade class. Above we have my SMA trading strategy class, and above that we have a base class, and all are working fine for now. Now the interesting thing. Now we will be fetching the data from the exchange with the help of an API. So we will discuss API separately in a very deep style as we do always. But for now, what we will do, instead of fetching the data from real API, we'll just have a simulated data, right, for now. But don't worry, we'll definitely learn this as we grow in advanced levels. For now, we'll just simulate that process of fetching the prices from the exchange. So let me create another class. So let's create another class for the mock trading API. So what I'll do, I'll just go here, and for now, I'll just clear all these. Okay, it is not needed right now. I'll just hit enter. And for this, we can keep. It might be used for further testing. So I'll just add here. Let me remove this. Okay. So this will be the third class for the mock trading API. So I'll just give a comment, mock trading API. I'll also add an explanation for all these classes in the GitHub repository. You can refer that, right? So you just pause the video and think that what kind of parameters we need when we interact with any exchange, right? Let's say when we interact with any exchange, what kind of things we need to know, right? So first of all, we want to check that whether our account has any balance or not, because if we don't have any balance, we won't be able to execute any trades, right? Again, let's say if we have the balance, then we want to tell the exchange that whether I want to buy anything or sell anything, right? So means we can say trade. So first is balance, second is trade, and then we also want to tell that at which price I want to execute any trade, whether it's buy or sell. So while creating this class, what I'll do, I'll write a class mock trading API, and then as usual, we'll create the constructor, and inside that we'll pass self and the balance, right, as a parameter. Then what we will do, we'll make it private. So balance is equals to balance. And now I want to create another method with the name place order, right? So place order, and inside that I have self, then I have trade, and we have the price. So this trade is the type of trade, whether it's buy or sell. And from where we will get this? We'll get this from this class, right? This will give us whether we should be buying or selling any asset. So now I want the object of this should be passed as an argument to that class. So in that also particularly, I want this method generate signal, so it can pass us the buy, sell or hold signal, right? So what I will do, we have already created the object of this class, right? The my trading strategy. So we have the object here, this one, object strategy, right? And so what I can do here, for now, I can just think that the name of this object is trade only, right? So I'll just change it here. These are just the the testing data, so don't take it seriously. Okay, just think that we have created the object with the name trade. What I'll do here, and then we are passing here and this as a parameter, right? So what I'll do here, trade dot signal, right? If I write like this trade dot signal, I get some return value, right? It can be buy, sell or hold. So let's test this also. So what I'll do here, I write here trade, and let me comment out all the other things and just focus on the present. Okay, and now I write trade dot signal, right? It says, oh, it is my generate signal, not signal. It is, why it is not giving? Okay, it is just generate signal. So I'll go here and write here dot generate signal, right? And if we need to pass anything here or not, when we check, yes, we can pass the price data. So for now, we'll just pass here. We can pass here like any data. So let's say 1, 2, 3, 4, 5. And when I hit shift enter, it gives me a signal, right? Buy. And let's say if I change it to 5, 4, 3, 2, 1, and it gives me sell signal, right? Why? Because now the short moving average is less than the long moving average. So now we can say that when we call this method, it will return as a string with the sell, trade, or hold value, right? So while interacting with the exchange, we can write a condition here that if the trade signal is equal to buy, then what should happen? We have this balance, right? So what we will do? So when we execute any buy trade, some amount will be deducted from our account. So self dot balance underscore balance. Let me copy and paste this itself here. Copy and paste. Negative equals to the trade dot amount multiplied by price, right? Because when you create the object of this class, we can also access this amount attribute with the help of this getter method, right? So trade dot amount multiplied by price. So here you can see that we have passed an object as parameter here, and then we are using that object in the normal functions, right? So it will execute. So it will detect the amount. Then what it will print? It will print out that formatted string executed, or we can say placed, right? So placed by trade at the price. So we can give the variable price, and we can also return the remaining balance, right? So remaining balance as, and then we can pass here as an variable here. So it will return the remaining balance, correct? And if elif, and also we have to make sure that while executing the buy trade, the amount should be, and the balance should be greater than or at least equal to the total amount of the trade, right? Let's say you have only $1,000 in your account and you are trying to execute a trade worth 10,000. Then if you don't apply this condition, the trade will be executed and your account will be shown with a larger amount, even if you don't have balance in your account. So we should be applying this condition also here. And for this sale, what we can do, we can just give here the sell elif, the string is sell, then we can like copy and paste these here, and we can make it positive, because when we sell any asset, the amount gets credited in our account, so it will be added with the plus. And we can say here placed a sell trade at the price and remaining balance is whatever the amount you have been credited, right? And one more thing we can do here is else condition. If both the conditions doesn't meet, then what we can print here, that it might be a case where whether the signal is incorrect or invalid, or you do not have sufficient balance in your account to execute the trade. So we can write here insufficient balance, or you can write invalid signal, correct? So now again, one more thing, that you can also return this attribute with the help of the getter and the decorator. So I'll write here, and I'll change this to balance, and here also balance. Now I think we are good to go. So when I hit shift enter, and when we test this, so what we can do, we can create an object for this class. So let's say we create object of obj mock API and name of the class, and we have to pass the trade signal here. So for that, what we can do, we have to use the signal here, right? So what we can do, I can just copy and paste these here, and let's say I will give it the name as signal for now. So, and we have to also pass the price. So signal, I can give here signal, and price, let's say I want to give 1000. And here, if anything else is required, trade dot amount also required. So for trade dot amount, okay, when we hit shift enter, it says takes 2 positional arguments but 3 were given. We call this, okay, it takes only 1. So for now, what we'll do, we'll just give the mock balance. So I'll pass 10,000 here. And when I hit shift enter, it's run perfectly fine. Now we try to call this method here. What I can do, I can just, and then dot place order. Now we can pass some arguments, that is a trade and price. So for trade, we can pass this signal here, and price, let's say I'll give 1000, right? So when I hit shift enter, it says me str object has no attribute signal. Okay, for now what we do is for testing, I'll just pass this whole object here, and now when I hit shift enter, it says str object has no attribute signal. Okay, actually we just need to pass this trade here, and rest it will be managed automatically. So when I hit shift enter, it says my trading strategy has no attribute signal. Okay, actually, okay, yeah, we have to create the object of this my trade for that. So what I'll do here, I'll create another object. Let's say it is trade one. Then for my trade, I'll create another. So I change it to trade one, and for that, I'll create another object. Let's say trade two, and that my trade. And for that, what we are doing, we have to pass the strategy name, signal, and amount, right? Okay, I'll change it to trade two, and now it is working. Yeah. So what we are doing here, trade one object is the object of the second class, which is this my trading strategy, right? My SMA trading strategy, and trade two is the object of this class. Now we are calling this function, right? Place order, and inside that we are passing an argument trade, which is another object of this class. So here that is trade two. For now we are just testing. So here for now we are just passing some random values, and we are trying to test whether our code is correct or not. So for now it is working fine, and we can say it is correct, right? This is also fine. So next we create another class. So now we have multiple classes. First is the base class with the name my trading strategy. Next we have a class my SMA trading strategy, and which is inheriting from the base class. Then we have my trade, which interact with the exchange, right? And then we have the mock trading API. So no, actually this my trade just keeps a record of the trades, and this mock trading API interacts with the exchange, right? Now we need another class which should be able to integrate all the above classes, and we can say that it should be able to give us a smooth interface, right? So what we can do, let's write the class my trading system, and here what we can do, we can define the constructor function here. So define init, and here self. Now you pause the video and think that what kind of parameters we need here. So first we need the object of this API, right? So we can pass the object of API, let's say API, and what the object of this API class will return us. It can return us the balance, it can return the place order status, right? And yeah, these two things we can get from this API class. Again, we need the object of this, let's say this strategy class, right? So it can give us the signals buy, sell, or hold. So I'll write here the strategy. So let's say this is the object of this strategy class. So strategy, and then we need a symbol, right? That symbol means on which kind of asset we want to perform that trade. So let's say Apple, Microsoft, Nvidia, BTC, Ethereum, right? So we don't need here. Okay, now it is running a little bit slow actually, I don't know why. Okay, now what we can do, we can make these parameters or attributes as private. So let's do that quickly. Self.api is equals to API, then self.strategy is equals to strategy, then self.symbol is equal to symbol. Correct? Okay, now comes the very interesting part, which is to fetch the prices from the live exchange. So here what we will do, we'll take the help of Yahoo Finance. Means Yahoo provides the price data, so we can use that, and let me show you how. So what we'll do here, I'll add here import Y Finance as YF, right? Y Finance is the library, and we are importing that as YF. Don't worry about these. We'll discuss all these in the future lectures. For now, just think that this is a kind of library from the Yahoo, and we are importing that, and we'll use that for the data fetching, right? So how we can fetch the data with the help of that. Now what we can do here, we can define another method. So define fetch price data, and here we can give self, and here what we can do, we can write like data is equals to yf dot download, and in that we have few parameters. So let's say the first is symbol, and we give it as this one. I'll just explain you, don't worry about this. Okay, self dot symbol. Then we have the period, which is let's say 1 day, and then we have the interval, right? So interval, which is let's say 1 minute. Okay, let me show you why we are writing like this, because this is decided by the Yahoo that if you want to fetch the data, the price data from my source, you have to write like this, and this is my function, and you have to pass some arguments like this, then only you'll be able to access the data. So let me show you first how it works. What we'll do, we'll quickly go to the Google, and you can write here, this is the Wi-Finance PyPy. So when you go here, you can open any article, you will get a lot of information, right? So here is the official page. So you can see here that you have to import Wi-Finance as YF. Then you have multiple options. So let me show you what these are. Yeah, you can see here that here we have to provide the ticker. So ticker, it can be like Apple, Microsoft, anything. Then you have to also provide the period. It can be 1 day, 1 month, 1 year. And then we have the interval between the bars. So it can be 1 minute, 5 minutes, and 1 hour. You can like just read this. I'll just give the link this in the description. You can read more. Moreover, we'll read about all these things in future methods. For now, we are just creating a very basic bot with the help of just the object-oriented programming. So just like understand this, and you get my point, right? So let me open the code, and okay, let me first quickly explain you this one, right? How this works. So let me quickly copy and paste this here. And here you can see that we have symbol equals to self dot symbol. So actually here you have to change this to tickers. And now when you hit shift enter, for the sake of this example, we'll change it to Apple. We are directly passing the parameter here for Apple. And now when we hit shift enter, working. Now we try to access the data, and when we hit shift enter, it displays this, and this is known as the data frame, right? So what we can do here, we can access only this table. So for that, what we can do, we can write only the column name. So close, and when we hit shift enter, it will give us only the close table, right? The prices for the close table. And again, here we just want the last price, right? The 190. So what I can do here, I can just go and type iloc. So for now, just write -1. That is same indexing, right? So if I write -1, it will give me the last value. So when I hit shift enter, we get the 190. Correct? So similarly, so what we are doing here in this example, we'll use this here. So data download, and I'll change to tickers. So self symbol will provide while we are executing the whole code. That time you can provide Apple, Microsoft, or whatever you want. 1 month, 1 year, and this can also be changed to 1 minute, 5 minutes, 1 hour, and whatever you want. So when I hit shift enter here, it says me expected colon. So now what we can do, we can write a conditional statement here. So how we can achieve that? If not data.empty, then what we'll do here, we'll take the close and the last row. So for that, iloc, its index location, I'll explain you in the pandas section. Right now, what we can do, we can write data, and here it will be the close, right? The table with the close, and dot iloc, and here I can write -1. I can write here a code for the empty list. So it will be the price data is equals to an empty list, and here I think we are missing one underscore. And after that, what it will do, it will append to this empty list. So self dot. Now what we can do, we can write another conditional statement, that is if the length of this empty list for now, but after like we run the program, the data from the Yahoo will be appended here. So it will print out the long window we have given, right? Then what it will do, it will just pop the value at the, then what it can do, it can print fetched new price data, and then it can give the variable as price, right? This one, the data frame value, right? Else what it can do, it can write else it can print no data fetched, right? Now what we can do, we can write another method, and that will run all the classes. So we will call the method fetch, this one, the fetch price data. So fetch, right? And then what we will do, we'll call this strategy class with this object here. Earlier we were passing the manual list, but here now we have the data from the Yahoo and it will create the list. So we can pass here the list, right? The automatic list, this one, this price data, right? So this list will be here, and we can give it the, it will be the signal, right? Means it will return the buy, sell or hold. Then what it will do, it will print that generated signal, and here you can give the signal, correct? Then now we use the membership operator. So if signal in, and let's give it a list, sell, right? We create a list here, sell by, and we know that this will return a signal. It could be sell, buy or hold. If that string is existing in this string, in this list, then what will happen, it will create the object of the class trade, right? So we have this class here, right? The my trade, this one. So it will create the object for this. So my trade, we write here, then we pass the arguments. So you can check what are the arguments here: strategy name, signal and amount. So this is the strategy name, self.strategy. So we'll pass here, and then we have the signal. So for signal we'll write, and amount for now we can give 1, right? Then what we will do, we will just execute the method execute, and we also call the method self API. So I can just copy this one. So this is also the object, and from here I can call the place order, right? Place order. So here we will pass the object trade, and the price will be the data frame, the last price, right? The last item of this list. So for that we have to write, and then we'll give the negative indexing here, correct? Now what we will do, we'll create the same for these private attributes. We'll create the getter methods. So I'll just go here and I'll copy and paste this quickly. I'll paste here 1, 2, 3 and 4. And now let's take these values as this is the API. So I'll go ahead and change this to API, and this is also API. Again, this is strategy. So add strategy, and now this is symbol. So I'll change it to symbol. Now we just need to call these, and for that you have like multiple options. You can use the if name main function also here. For now we just simply call these and test whether it is working fine or not on the live data, right? So for that what we need to do, now we have to provide these values. The symbol, it can be Apple, it can be Microsoft, it can be Bitcoin, Ethereum. Then we have to create the objects of these classes, the API, the mock trading API class, then the strategy class, and then the trading system class, right? So let's go to another cell and let's do that. So what we will do, I'll just remove all these things for now because not required. So everything will be removed. Let's first run all these cells and check whether it's working fine or not. And yeah, it is working fine. So let's first give the symbol value, right? So what we will do, let's test with the symbol. We'll create the object of the API class. So we know that the API is here, the mock trading API. So what we can do, we can go here and write API, the object name, and then I'll write the class name, and then we can pass the. So what we can do, we can write like balance equals to, we can, let's say 10,000. Then we need to create the object for the class strategy, right? So let's go up, and we know that this is our strategy class, this one, and here we have to pass the short window and long window, right? So I'll just copy this and I'll pass the short window, let's say 3, and long window, let's make it 5, correct? Then the last but not the least we have is the trading system. So for the trading system, I'll create system is equals to, and again go back to the system, and here we need to provide the API strategy and symbol. So I'll just copy here and I'll paste, and we know that we already have all the values here. So for API, I can just pass here API. So I'm passing this object as an argument here. Then we have strategy. So I'll just copy and paste it here. And now we have the symbol. So for symbol, I'll write SYMBOL, right? So now when I hit shift enter, so now what happens in a live system that we are able to continuously fetch the market data from any exchange, and then we are able to process that data also, right? For that, to simulate that, we will write a small for loop here. Let's say for underscore in range. So we use this underscore like when we do not want to give any value, right? And range, let's make it, for now we can make it any, but I just write 3. So 0, 1, 2, right? For underscore in range, let's say we just want 3 times 3 iterations, so 3. Then what I can do, I can run the system dot run method. So you know that we have created this run method here. Inside this trading system, we had this run method and it was integrating all the classes. So we will run this system method 3 times, right? So now we'll just print the, right, in that we had the remaining balance, right? So you can go there, and now we can also give the time dot sleep, like how much time it will wait, and then again we'll run this function. So for now I'm just giving 2 seconds, right? So for this I also need to import the time here. So we'll go here and import time and hit shift enter. Now what we'll do, we'll run all the functions here, and my trading system is the, and we have this symbol here, and now it says, yeah. So you can see here it is running in every 2 seconds, and it will check and it will like say the signal hold, and then remaining balance it will show. So for now it is showing hold. We need to check something inside this, and that's very easy. I'll just post this code on the GitHub, and you can let me know in the comments what could be done to make this work fine. If you're not able to find the issue, we'll discuss this in the future lectures. But for now, this was the basic idea that we have a full-fledged Python trading board, and it's really awesome. With just few basic concepts, we are able to make this. And now you can imagine when we'll be creating the trading system with whole Python concepts, it will be really amazing. Okay, let's see this. File handling in algo trading is vital for managing data, developing strategies, and executing trades. Because whenever we are managing different kinds of data, and while we are developing strategies, and even when we are executing trades, we will be dealing with different kinds of files, right? And for that, we need to have a strong hold on the file handling. So let's see the use case of file handling in algo trading. The first is historical data management. So inside that, we'll be saving data. So downloading and storing historical prices in formats like CSV and JSON. We will be dealing a lot with the CSV and JSON files. So it becomes another use case. Then loading data, so reading historical data for analysis, backtesting, and training models, right? So while like in machine learning models, we'll be using this also. Then we have the trade logging, so recording executions, saving trade details like symbol, price, quantity for record keeping, and maintaining logs. So logging trading activities, errors, and alerts for auditing. So like when we are executing trades, so we need to have a robust system where we are keeping our records, that at which price, at which day, which time, and at which symbol, like everything we need to keep details, right? We cannot just make trades and just forget about that. And again, we also need to maintain logs. Like if we are getting some error, then we need to have a record that which error is coming so that we can debug the issue quickly, correct? So the next is for the configuration storage. So in this, we have storing configuration, so saving algorithm parameters, strategy settings, and API keys in JSON or YAML files. So this is another use case, right? And also then after storing those configuration, we need to load those configuration, right? So reading settings to initialize trading environments and strategies, correct? Then next we have backtesting and simulations. So inside that, we can save results and again we can load the data. And next is data pre-processing. So saving processed data like storing normalized prices, technical indicators, and features, yes, of course. And again loading features. So for that also we can use this. Like this is the part of AI and ML which we will cover after these. So it's like the advanced stage of algo trading. We will cover that also, don't worry about that. And then the last but not the least, report generation. So inside that, we can create reports and we can store reports. So effective file handling ensures data integrity, facilitates efficient processing, and supports robust trading strategies development. So it becomes absolutely essential that we are able to keep the data integrity and then we can support the trading environment. Okay, now let's see what are the different types of modes we can use for file handling. Let's say we have a file with the name trades.csv, right? So in how many ways we can handle this file? How many options we have? So we have many options, but majorly what we do first, we can read this file, right? Read. And next we can write something into this file. So I'll write, and again we can append something to this file. So let's say append. And again, generally we deal with two types of file. So we can perform these operations on two types of files. So I can say these are the modes, right? And here I'll say type of files. So type of files. So what do we have? We have, let's say, majorly we have two type of files, right? So the first is, it could be text file, or we can say, like, let's say instead of text, we can keep it as a Unicode file. Unicode also include the text file. So Unicode, right? And which we have already learned in the previous sessions. You can refer those, the first or second, I guess. Then another type of file we can have is binary. Correct? So in Unicode files, we have like all the day-to-day life files like CSV and text files, JSON files. All those are Unicode files because these have all the Unicode characters. Now, if you are having any issue, you can search what are the Unicode characters and you will find that. So initially we had ASCII characters, and then with the development and with the need, we developed Unicode characters. And then again, so I can write Unicode have which type of files? For example, we have like text.txt file, right? We can also have CSV, we can also have JSON, like there are multiple kinds of file. For now, you can just think of these files, right? And in binary, what we have, so first of all, let's understand what are the binary files. So you know that the meaning of binary is 2, right? So I'll write the files which contains only zeros and ones. Those are binary files because computer only understands the binary code, zeros and ones, right? So binary file includes, let's say, we have video file, right? So let's say MP4, and audio files. So it can be .mp3, and these can be an image also. So let's say all the PNG, like all type of formats. I'm just giving examples here, and we have a big list here, but this is just an understanding. And also there are so many log files or error files we can store in binary mode, like while algo trading. Like we can store in both the log and error files, Unicode or binary, but sometimes we need to store those in binary. So I can say here log files, right? Many of them. So this is the basic idea behind like the modes we can perform on different type of files and the different type of files. So we can say we can perform all these modes on Unicode files also and binary files also. So that's the basic idea behind the file handling theory. And now let's jump to the examples of this file handling. So as we have seen already, the different kind of modes of opening a file, but majorly we read, write and append. So you can also refer this for more information. So let's start with the first, which is how to open a file, right? So let's say we have this file. So what we can do, we can just call the open function. So open, then we can give the name of the file. So let's say trades.csv. Then I can give the mode. So let's say if the file is not existing already, so what I'll do, I'll create the file. So with the W, and it will be in the write mode. Right. So now when I shift enter, and let me show you here also that there is no file with the name. Let me close this, and here you can see that in day 15 there is no file with the name trades.csv. So when I hit shift enter, and let me run it, Anaconda. Okay. Now you can see it says IO text wrapper names trades.csv mode write has been done. Or you can see here we have a file with the name trades.csv. I think you are able to see. When I click here, it is empty because we haven't written anything for now. So let me again open this. Now, as we have already seen in the class that while creating the object, we can do this way also. But if we do not assign any name of the object, it will get lost in memory. Similarly, we can perform the operations like this also. But in order to perform more operations, we will need it again. And for that purpose, we can assign it any variable name. So let's say I'll give it f, right? F is equals to open function. Then I'll give the file name, then comma and the mode. So here we are writing to this file. So this is basically how to open a file. And if the file is not existing, we can create the file with this syntax, correct? And one more thing, that whatever the operation we are performing, read, write, append, all the operations will be done only after we have performed this operation. The opening is must. We can only perform once we have opened the file. It's same like when we use the file with GUI. So if we want to read or write, we have to double click and then open the file. Then only we can read or write anything on the file. Similarly, to perform any operation, first we will open the file with this syntax and then we can perform the other operations. So let's say we have opened the file with the write mode. Then what we can do, we can write something in this. So how we'll do that? So as we have already given this f variable to this, so now we can write like f dot write, and then I can give anything I want to write. So let's say this is the best YouTube channel for algo trading, but I have still not subscribed it. And now when I hit shift enter, it displays a number. It means it has written 79 characters on this file. And then again, you have to close this file. So until and unless you do not close, you will not be able to read it, right? So how we can close? We can write f dot close, and this is it. So now when you go here and check the file trade.csv, you will see that we have something inside it. And that says this is the best YouTube channel for algo trading, but I have still not subscribed it. Is it true? Really? If it is true, then definitely you should consider subscribing us, right? Now let's open the file again. And this was how to open a file and write something and close something. Now, as we have already covered this closing a file, so what I'll do, I'll just copy and paste it here. I'll remove this for now, like for your better understanding when you refer this file from GitHub. And I'll also copy this line. I'll cut this line instead and I'll paste here, writing to a file. Correct? Now, we have done three things: opening a file, closing a file, and writing to a file. Basically, it should be first before closing a file, but you get the point, right? First, you open the file, you do some operations, read or write or append anything, then you have to close the file, right? Otherwise, it will always be in the buffer, or let's say it will always be in the RAM, and it will consume your RAM until unless the garbage collector close it, right? Now we have the next operation, which is reading from a file. So how we can do that? So first we need to make sure that the file is already closed. So what I'll do, I'll just copy and paste the close here, and I'll hit shift enter, and we are just making sure that the file is closed already, right? Now what we can do, let's say we have a file already, right, and with the name trade.csv. So how to read the file? The same process. First we have to open the file. So how we can open? We have seen it previously that just write open function, and inside that you have to write the name of the file, so trade.csv. Then you have to write the mode. So here we are using the read mode, so I'll write read. Then again, it will, like, by doing this will not be able to perform any operation in future, so we have to assign a variable here. So let's say f is equals to open trade csv. Then what we can do, I can write f.read, and that's it. So when I hit shift enter, it says me this is the best YouTube channel for algo trading, but I have still not subscribed it. Very bad, very bad. So now let's see some other case also. So for example, let's say case 1. So let's read this file again. So what I'll do, I'll write same open, then the file name trade.csv, then the mode, which is read, and I'll give a variable name f.open, and then I'll write f.read and the file, then the closing. So it says me the output, right? Now what I'll do, after read also I have to close this file. So f.close, and I have done that. But let's say if you want to directly read this file, right, this trade.csv, you cannot. Let's try it again. f.read, and when you hit shift enter, it says you IO operation on closed file, means the file is already closed and you cannot perform this operation. And to read this file, you have to again open this file. So what I'll do, I'll just go here, and let's say I run this again, shift enter, and now when I try to read this file, I can read. It's very basic, but you should know, right? Similarly, that works for the write operation also. So let me uncomment this, and I go here. For now we were testing for CSV. Similarly, we can also test with the text file also. So let's say we create another file. So open, and I create, let's say, trades.txt, and in the write mode, and you see here, right, this left side. So when I hit shift enter, the file will be created, right, but empty, nothing is there. So assign it to any variable, and let's say it's f is equals to open. Now what I'll do, I'll write something to this. So f dot write, and I'll write yes, we have subscribed this amazing channel, right? And now when I hit shift enter, it displays the number of character. When I click on this, oh, means you have not subscribed it, huh? So now in order to get this data which we have written, we have to close this file. So f.close, and when I close this, and now when I check, it says that yes, we have subscribed this amazing channel. So what we are able to infer from this process means we can say, until unless you do not close this file, the data which you are trying to access is being stored in the RAM, or we can say buffer, right? So we have to close this after performing our operation, right? Again, let me show you one more thing, that let's say as you close this, and now when I again try to write something on this file, I will not be able to. Same like read. So when I try to write directly, it will say me input output operation on closed file, right? Now the next thing we can take, how to write multi-line strings on a file. So let me take this again here, and what I'll do here, we can write multiple lines also in a file, but in order to achieve that, we have to keep the file open, right? If you close this, then we won't be able to do. So what we can do, first step, we open the file. Second step, we write all the lines in the file. So again, I'll write another line of code. So write, and we can say, because all the information on this channel is really helpful, you can say, if you want. And here we have to add something more, that is /n, which we have seen stands for new line, correct? And you can do not give space. And now when I check this, so okay, let me show you again the same. So when I hit shift enter, and now when I check the tray.txt, it shows me nothing because the data is still in the RAM or buffer. Now when I close the file and hit shift enter, now we can see the data here. So that's how we can write multiple lines in a file. So now in the real life scenarios, we'll not be having just a single line of string. We'll be having multiple lines. So in order to manage that efficiently, what we can do, let's say we have a list of strings, and inside that we have like this YouTube channel. This YouTube channel is for algo trading, right? And also you can write the next item as okay with the /n, so it will return in the next line. So enter, and here let's say I open the file again. So what I'll do, I'll write like f is equals to open and the file name, so trades.csv, or you can take text also, not an issue. Then I'll open in write mode because I want to write, right? Then what I'll do, I'll write f dot, and what I will do, I'll just pass this list inside this, and then we will close it as usual. So this is the code to write multiple lines. So multiple lines with the help of list. So when I hit shift enter, it says write argument must be str not list, right? So for this, what we can do, we can change this to write lines, and when I hit enter and when we check the file, it shows us all the data. This YouTube channel is for algo trading. We are learning all the fundamentals first, and then we'll learn all the advanced topic. So that is a problem with write mode, take a list and then write. So for that, you have to use the write lines. Similarly, you can also use the read lines. So for that, we'll create another cell. Inside that, we'll open the file again, same, right? So I'll just copy this code here. Instead of write lines, I'll change it to read lines. So now when I hit shift enter, will not display anything because this time we are reading and we have to print this, right? So print and shift enter, and you can see we get a list again, right? So this is how you can use write lines and read lines, correct? And now let's check that. Let's say we have a very big file, and if I load the file entirely, and let's say the file was of 20 GB, but your RAM is only 8 GB. So if you try to read like this, then your system will be crashed for sure. So for that, what you can do, you can only load the desired number of characters or number of lines. So what you can do here, I'll just add another cell and I'll write this code again here. I can read and close, right? So now when I hit shift enter, it gives us the entire data. So what I can do, I can write 10 and hit shift enter, and it will display only 10 characters. So I'll write here up to n characters. And actually one more thing I would have to explain you, that this is read line, not lines. So when I hit shift enter, but if I just write read line, it will display me only one line. And now let's say we want to see the next line. So what we can do, we can write this statement again. So it will display us 2 lines. Similarly for 3, we have to write 3 times. So it will display all the lines. The problem here is you can see this space, but in original file, the space is not there, right? It is clean. So in order to resolve this issue, we have to first understand this, why it is coming. So what is happening here, we have understood this in the first lecture. We know that when we write multiple print statements, it always gives it always prints in the next line. So the one next line is from the print by default and one is from the read line. So what you can do here, you can just write, and similarly, you can use this in here also. So it will remove with like million number of lines, but you know that is not efficient. So what we will do when we have multiple lines, so what we can do, first of all, we'll open the file as usual. Then what we will do, while loop, and then here what we can do, we can write like data is equals to f dot read line. So when you write read line, it will give us a single line. And we know that we have to print this also. So I'll print it like this. And also we know that we have a space. So for that, we'll use and this one. So now what we will do, we'll write that if data is equal to empty string means we will run a loop, and when the Python detects that there is an empty string means the file is finished already and it will break the loop. So break, correct, else just keep on printing it. So when I hit shift enter, it will be displayed. It is running, means while loop, so we have to interrupt this. If the data is empty, then it will break, else it will keep on running this print line. After it detects the empty string, we will close the file, right? And now when we run, so now it says that IO operation on closed file. So what we'll do, okay, we just have to move this here, and now when we hit shift enter, it displays all the data, but it still keeps on running. Okay, let's interrupt this and change the code a little bit. So what I'll do here, I'll just copy this and I'll remove this from here. What we will do, we will just print here the data. Now let's check whether it works or not. So when we hit shift enter, it works fine, prints, and it's closed properly. This is how you can deal with a big file. Now the issue is that we always have to close the file. If you don't close, then we cannot perform any other operation. So in order to resolve that issue, we have another thing, and that is context manager, and that is with. So it's a good idea to close a file after uses, as it will free up the resources. If you don't close it, garbage collector would close it, and this with keyword closes the file as soon as the usage is over. So how does it work? Let me show you. For example, we have the same file trades.txt, the same syntax with open and then the file name. Let's give it txt for now. And if you want, let me know that how we can write in CSV file here. It is not required now. We just need a basic understanding, because in future we'll be using pandas to handle with the files. But for now, you just need some understanding that how actually the files work. So that's why I'm giving you this example. But in future, we'll be always using mainly pandas while working with the files in algo trading. So with open, and let's say I want to open in read mode, then I can say as context manager. So here f, what we will do, f dot read, and that's it. So if you just compare, earlier we were opening the file and we were giving the variable name f, then we need to perform any operation, let's say read, write, and then we need to close this. But with the help of with keyword, it will automatically close the file once our use has been done. So now when I click shift enter, doesn't show me anything because we have to print this also, and when we print, it displays the whole content. So that's the benefit of using the context manager. Sometimes when you forget, or it might help. And actually most of the people use this only, the with keyword. So it's very simple and easy, and even like a less code than this one, right? So you can consider using this moving forward. Similarly, you can perform the write operation also. So for that, what we'll do, we'll just copy and paste this here. And what we will do, instead of read, we'll open in the write mode. Here I'll write Kuldeep Singh, and now we don't need print here, right? I'll remove this, and when I shift enter, and when we check the file, it says the Kuldeep Singh. So now what happened here, it replaced the existing content. But sometimes we do not want that. We just want to append below the existing content, right? So for that, what we can use another mode, that is append mode, right? So now how we can use the append mode, let me just copy and paste this below. We know that this trades.txt have the content just Kuldeep Singh in one line. So now I want to add below the Kuldeep Singh. So what we will do, I'll just add W, will write A for the append, and then here we can write as Rathod. And now when I hit shift enter, and when we check the file, it says as Kuldeep Singh Rathod without space. So why it happened? Because we have to use here slash. Now when we hit shift enter, it shows us Kuldeep Singh Rathod without space, and then in the next line we have Rathod. So what we can do here, so instead of this, what we will do, so first we will run this again, so it will replace the first line, right? And then we will append in the below, and now when we check, we have Kuldeep Singh Rathod. So that's how you can use read, write, and append, and it's much better if you use this with context manager, right? Now let's take the last example of the day, that is working with CSV files, because we will be dealing a lot with the CSV files in future. So for that, what we need to do, we need to import the CSV module here and hit shift enter. Then, okay, let's check the content of this trade.csv. So this says this is the best YT channel for algo trading, but I have still not subscribed it. So now let's go here and write the same statement with, and we can write open and the name of the file, which is trades.csv. Then the mode will be right, of course. And again, we have to write here new line, and you can give an empty string. Then what you can do, you can write as f, right? Now in the next line, you have to write CSV. You will be using this module here. So in that we have a function CSV dot writer. And here you can write this f because we have opened this file as f, right? So we'll write here f. And now what we'll do, we'll assign this whole syntax to a new variable. And let's say this is writer. Correct? Then what we'll do, we'll go to the next line and we'll write. Now it's very simple. You just have to use this writer dot. Now you have to use another function, that is write row. And inside that you have to provide a list. So let's say the first is symbol. Then the next you can give is, let's say, price. And again, the next item you can say, let's say, quantity. Correct? So this is for the first row. So when you hit shift enter and when you check this trade.csv, so you can see that we have a CSV row here. So now let's go here and again copy and paste this like multiple times. We can do here 2, 3, and just change this symbol to, let's say, first Apple, and second we can give Microsoft, and price you can give like 100 and 200, and quantity, let's say for Apple just 10, and for Microsoft it is 20. And when you hit shift enter and when you check the file trade.csv, you will see the data. So that's how you can deal with the CSV files. It's very easy and it's very simple. So previously we have seen that how we can use context manager to handle the different kind of files, right? And we have also seen that we have used to read and write to the files. So let me quickly show it again. So let's say what we can do, let's create a new file. How we can achieve that? We have to use the with keyword. So with open, and here we'll give the file name. So let's say txt. And here, if the file is not existing, we have to type W for the write mode, and then we can give the file name. So let's say as f.write. Now you can give your text you want to write, right? This session is for file handling. And when I hit shift enter, here you can see that in day 16 there is no file with the name trades.txt. So when I hit shift enter, we have new file here with the name trade.txt, and when I click on that, we have the data inside that, right? Now let's say we want to write multiple lines. So what we can do, we can just copy it, paste here multiple times, and we know that we want all these lines in new lines. So for that, what we can do, we can write /n, and here also /n. And to differentiate between the lines, I'll just give 1, 2, here it could be 3, 4, and 5, right? So when we hit shift enter and check this trades.txt, we have 5 lines inside the file. So now let's do one more thing, that in the next line, what I'll do, I'll try to read this file with the context manager. So what is happening here, this context manager first open the file, and then in the buffer, we can perform our operations. It could be a read operation, it could be write operation, right? And after that, it automatically close the file, right? So let's say I want to read this file. So what I'll do, I'll just write the same with and same the open and the file name. So it's trade.txt. Then here, instead of writing, I'll give a read mode as f. And now I can just give read. And now when I hit shift enter, it doesn't display anything because we have to print this. So I'll just print this, and now we can see the whole content. But the issue we have discussed already, that it loads the whole file, and sometimes we don't want that. So what we can do for that, we can just type the number of characters we want, and now when I hit shift enter, it will just display the 10 characters. So this is another smart method. With the help of that, we can read a very big file. So let's say your RAM is 8 GB, but the file is of 80 GB. So if you try to load without any parameters, it will crash your system, right? So instead of that, what you can do, you can load that file in chunks, right? So what you do, you will just write 10, 10. So the buffer will load the file in the chunk of 10 characters. So now when I hit shift enter, it is loading 10 characters first, then the next 10. So here you might have one question that when you write this code, so why it is not starting from the initial position, right? Ideally it should be happen, but the buffer remembers your position, so it will load from the next index. So let's say after 10 it will load from 11, then again 21, and so on and so forth. Okay, one more thing I'd like to explain you here, that there are two functions. One is tell and another is seek. So with the help of tell, you can know your current position. So let's say if I write here print f dot tell, and when you hit shift enter, it will show you that currently you are at the 10th position. And again, let's say if I write it here and again here, so you can validate your function, right? Hit shift enter, it will show us that first 10, 20, 30, 40. With the help of tell, you can know your current position. So with the help of seek function, you can navigate in your file anywhere. So let's take an example. So while you play any video on YouTube, you can see a cursor in below and you can move that anywhere. So if you want to move from the 1 minute to 5 minute, you can just pick that cursor, or we can say pointer, to 5 minutes. So it will just take you there, and you call that operation as seek. So you are just seeking from the 1 minute position to 5 minute position, right? Similarly, here also you can move from one position to another position. So let's say what I'll do here in the next line, we'll write this. Then again, what we can do, we can print f dot read, and we can load the whole file for now. Okay, now let's check the seek function. So what I'll do, f dot seek, I want to go to the 10th position. When I hit shift enter, it doesn't show anything. I want to go to the 20th position, and now I want to check that where I am, right? So first we'll check with that tell function that where we are. So print and tell. And now after seeking also, we will check our position. When I hit shift enter, it shows me that, okay, so what we can do actually, I'll just remove first, add 10 here. And now when I hit shift enter, you can see that first it printed out 10 characters, then it is showing us our current position, then it will take us to the 20th position. And after that, if I try to again print the 10 characters, what it will do, it will print the next 10 characters. And again, you can print the next 10. So you can see that how we can use the seek and tell function. So this is quite useful sometimes, and have a understanding of this. This was the seek during a read operation. And now let's say I want to use seek during the write operations. So let's take another cell, and inside that, what we will do, we'll write something. So first I'll write f dot, and here let's say I want to write testing seek function. And now when I hit shift enter and check the traits.txt file, it will show us the testing seek function. Now let's say I will write another line here. This is second line, and I'll just change it to, like, I'll add 1, and here the next line, so slash n and 2 dot. So we'll get 2 lines, right? So when I hit shift enter, let's use the seek function here. I'll use seek and I'll give, let's say, 0. Now I will write the second line. So what happens if I write without this? I'll show you again. We'll get 2 lines, and you can see here. Now let's use the seek function here. So what we'll do, I'll add seek. I'll just mention the 0 here. It will write this content, the first line, testing seek function. Then what it will do, currently the cursor is at this position, right? Let's say inside the buffer, but this seek is forcing it back to go here at this line 1, right? And now it will write this line again. What I'll do here, I'll just remove the slash n, and now when I hit shift enter, you will see that this line will be replaced by this one, correct? So let's check this, and it is done. So that is the real use of seek function. Like, you can test this as per your requirement, and let us know if you have any doubt in that. Now let's take another example of this seek. So what I'll do here, instead of 0, I'll add 10. What it means, first it will write this line, and then the seek function will take me to the 10th position, and then it will write this line, correct? So let's hit shift enter and check the file again. So you'll see that first it returned the whole line, then again the seek function take the cursor to this 10th position, and then it will write again the second line. So this is how the seek function works. You can use it as per your requirement. and let us know if you face any issue. Now the issue is that with this kind of operation, we can only deal with this string data type. With the other data types, we cannot use that. Now here we have two issues. First, with this read and write mode, we cannot work with the binary file. The first. Second is that it is only suitable for the string data type. We cannot use tuple dictionary here. So that's a drawback of this. And in order to resolve that issue, what we can do, we have to tweak this a little bit, and let's do that. What we will do here, let me take the screenshot of something. So what I'll do, I'll quickly transfer an image that is binary file, right? So I'll just quickly take a screenshot here. You get the idea, right? This is a screenshot and this is a binary file. Let's go back to the code. We'll try to operate open, and I'll give the file name that is screenshot. Yes, PNG. And okay, now I'll add again with open. Here I'll add the name of the screenshot.png, open in the read mode. As let's say f.read, we can print this, right? Generally we print the read function. I'll print and hit shift and enter, and it says UTF-8 codec cannot decode byte 0x89 in position 01, invalid start byte. So that means with the help of these simple read, we cannot open the binary files. So now what we can do to open this file? For that, what we can do, we have to use another mode. So I'll just copy and paste it on the next line, add a new line of code. And here, instead of read, I'll write here read binary, and I'll remove this for now. And while reading, what we have to do, we have to write also. So with open, and now I'll give a new name to this. So it will be a completely new file. So I'll write here new screenshot dot, and here we are writing, right? Because we are creating a new file. So read binary, and we can give here like as G. It doesn't matter, right? Then what we can do, first we have opened this read binary, right? So we have to read this file. So I'll write f.read, and simultaneously we will write on this also. So I will give here g.write. Hope you are getting my point. First, we have opened this file in the read binary mode. We are reading this file and simultaneously we are writing also, right? So now when I hit shift enter, we can see that we have a new file with the name new screenshot. And when we open this, we have exactly same screenshot. So this is how you can work with the binary files, correct? Hope you are getting my point. And actually you just have to practice this, and in a very short span of time, you will be very good at this. So just give you enough time to practicing Python. Ultimately, it will help you a lot in algo trading. So first we have resolved our first problem that we cannot work with the binary files. So with the help of this read binary and write binary mode, we can perform operations on the binary files. Now, the second problem with this text mode was that we cannot write any other data type except string. Let me show you how. For example, let's take this file and trade.txt. So what we will do, we'll write with open and trade.txt. Let's take in write mode. So then what we'll do, we'll try to write. So okay, here we have to add as f, and let's write f.write, and let's say I'm writing 5 as an integer, right? When I hit shift enter, it shows me type error which says write argument must be string, not int. So forcefully I have to make this integer as string, and when I run this, it works fine. And let's check this file, it says 5. And actually this is not a good way. This is really problematic. Let's say we already have this 5 inside, and if I want to, let's say, perform some action, so 5, let's take in this read mode. Let's say I want to add another integer with this. So when I hit shift enter, and it again says can only concatenate string, not integer. So that's the big problem. So let's try with a dictionary with the name D is equals to, let's say name is equals to Kuldeep, and we can say, and let's say city, Singapore, and we can also write country, I can say Bharat. In bracket you can write India, optional. So seems good. Okay, so when I hit showing me error, invalid syntax, we forgot to add comma here. Okay, let's try to add this dictionary to the file. So what I'll do, I'll open file name trade.txt and write mode as f, and then what I'll do, I'll write f dot write. I'll just pass this dictionary, so D, and now when I hit shift enter, it says same arguments must be string, not dictionary. So that's the problem. So for that, so to write this dictionary, what I need to do, I need to forcefully change my dictionary to a string. So I'll change it to a string, and now when I write, it works, and we can even check this. Let me print it out. So I'll and read, and I'll just remove this not required, and we can print this. So print, and what it says, arguments must be okay. We have to remove this D not required. Yeah, now we can see that we have a dictionary. Now we start with the most important topic of the day, that is serialization and deserialization and pickling. These three topics are really very important, and you will be always using them. And now let me tell you, so what is the purpose and use case of serialization and deserialization? So with the help of this, we can convert any object to a form in which we can easily store these and we can transmit them. So the purpose of serialization and deserialization, to convert objects to a format that can be easily stored or transmitted, and then reconstruct them back into their original form. And the use case of serialization is that saving and loading of trading configuration files, logging trade activities, and transmitting data from different components of a trading system. And now let's discuss the purpose and use case of pickling. So with the help of pickling, we can convert Python objects to a byte stream or vice versa, which is efficient for storing and transmitting binary data. And when it comes to the use case, we can use this in saving and loading of complex objects such as trained models, large datasets, or trading strategies that needs to be preserved across sessions. So enough of talking, and now let's dive into the coding examples. So you can see here that serialization is the process of converting Python data types to JSON format, and deserialization is the process of converting JSON to Python data types. This is the simplest definition, and you just need to know this, nothing else. Means we will simply convert any data type. It can be string, dictionary, list to a JSON format. And again, in the process of deserialization, we'll convert back from that JSON format to our data type, right? So now the question is, what is JSON? JSON is nothing but JavaScript on notation, and it's exactly same, like not exactly, but it's almost similar to the Python dictionaries. You can see here, this is one of the example of JSON, and here we have the key and values, so you can relate it with the Python dictionaries, almost same, right? So you can see here we have this key, then the values inside, and inside that we have the nested dictionaries, right? And also we can have list. It's same, almost same, right? So now we proceed with the next, which says JavaScript on notation. So let's start the serialization using JSON module, correct? Let's say we have a list. So I'll give it L is equals to, and we can say this is a list of dictionaries. So generally in trading, we have this kind of format. So inside that we have the record of two trades. So in the first dictionary, and we can say the first item of list, it is, and the second item, that is second trade, correct? So now what I'll do, I'll just take it below so you can easily understand. So now you can see that we have a list. Inside that we have two items, and those items are dictionaries, and inside the dictionary we have the trading record. So let's say first we have trade ID. So trade ID, and this is the, let's say T 3214, correct? Then we have the symbol. So you can have symbol, let's say it is Apple, so AAPL. Then let me correct this spelling, symbol. And then we can have, let's say price. So for price we have let's say 100, an integer. Then for the volume we can give it, like just for the example, 1 2 3 4, and I think it's enough for example. And same, we can have another trade in this next dictionary, and which is this next item of the list. So I'll just copy and paste, and I'll just increment it to 3, and symbol we can change to Microsoft. Price we can take 110, and volume also we can just change from 1 to 2. Correct? So when I hit shift enter and try to access the list, we have the value, right? Now let's try to convert this to a JSON. So what we can do, the same process. So with open file name. So let's create a new file. So here you can see there is no file with the name JSON, or we can say trade log dot JSON, and the mode will be write, correct? And as f, and here what we can do, we have to use the JSON module here. So for that we need to import here, import JSON, and then when we go here we have to use the JSON module. So JSON dot dump. So whenever you have to convert from your Python data types to JSON, you have to dump, right? You will be dumping your Python content to JSON. So for that you have to use this dump method, and inside that we have two parameters. So the first will be the content. So here we have the list, so L, and then the file name. So file name is F, correct? This one, right? Now just hit shift enter and you will see that you have a new file with the name tradelog.json, and when you open this you will see the content. So that's the power of serialization, correct? And let's try to read this file. So what I'll do, I'll add code cell and then same with open file name. File name here is tradelog.json, and now I'm opening this in read mode. So read as f, and then f dot read, and just hit shift enter, and you have to print this also. So I'll print the read, print, and when you hit shift enter you can see that we have the data. And now the most important part is that previously with the simple text context manager we were able to convert from dictionary to strings, but we cannot get back from the string to dictionary. So here the main thing is that we can convert from a dictionary to a JSON, and again we can convert that back to dictionary. So let's try to check the type of this. So what I'll do, I'll write type here, and when I check it gives me a string. Oh, now we get the string, and yes, we have made a mistake. So when you perform the serialization you are using the dump method, but when you perform the opposite, when you perform the deserialization, means you are converting from a JSON to Python data type, you have to use the load module, right? So what you can do here, simply you just write JSON dot load and the file name, that's it. So I'll just remove this for now, and when you hit shift enter you get nothing because you have to print while performing the read function. So print, you get the list of dictionaries back. And now you can also check the type of this. So when you check the type you will see that this is a list. So that's the biggest benefit of using the JSON module, right? Now let's try the same with the dictionary, and what we can do here, we can just take this because this is a dictionary itself. So I'll just convert it like D is equals to a dictionary, and inside that we will pass this, correct? We can do that, right? We have already read about it previously. So when I hit shift enter it says me, yeah, because for that we have to provide the trade one, the key, right? So I'll give trade one and then a colon, and again for this also it will be like trade 2 and colon, 2 and colon. Now when I hit shift enter and if I try to access this we get the dictionary. So now let's try the same thing with this. So what we'll do, we'll write with open, then we can give a file name, let's say dictionary and dictionary example dot JSON, and we have to write, right? So we'll open in the write mode and as f. Now we need to use the JSON module. So JSON dot dump, and what we are dumping, we are dumping this dictionary which is equals to D. So I'll just write D and then the file name, correct? So when I hit shift enter you observe here that a new file will be created. So let me hit shift enter and this is the file, and when we check this we have the dictionary of dictionary inside that. So let's try to read it from here. I'll add another code cell and the same, I'll just copy this here and in the read mode, and instead of dump now we are loading. So loading, and we'll just change from D to F because we are reading, and we also have to print this. So I'll print it, and when we hit shift enter we can see that we have a dictionary, and we can even check the type of this. So I'll write this and the type of this is the dictionary. And now I think that you are able to understand that what is the importance of JSON. And now actually almost all the APIs are using JSON format, and JSON is understood by almost all the programming languages. So all the APIs mostly are built in the JSON format so that we can easily fetch and dump and load the data. So that's the use of this. And even you can go right now to the Google and check any API, it will be in the JSON format, most of them, right? So you can say that when we use the dump method, it is serialization, and when we use load, it is deserialization, right? Now let's take an example of this tuple. So what happens in the tuple? We have a problem, and for now I don't know why, but we need to find the answer. If you have any answer for that, just let me know why it is happening like this. So let's say we have a tuple, and what I'll do, I'll just convert let's say this dictionary, the same dictionary, to a tuple. Let's take another example for that. So what we'll do here, let's create a tuple. So tuple could be t is equals to, inside that we can have a string. So let's say trade ID, so 1 2 3 4. Then we can have symbol, so it's a string apple, and we can also have the price and the integer, so 100, correct? So this is a tuple, and when I try to access t, we can even check the type of this. So it says it's a tuple. And now let's try to serialize and deserialize tuple. So what we'll do, the same with open the file name, we can give now tuple.json. Then we are writing, so in write mode as f, and we'll write here now json dot load, and no, we are dumping, right? So dump and the content, which is t, and the file name, which is f. So now when we hit shift enter, you will observe here that a new file is created with the name tuple.json. So let me do that, and we have a new file. And now let's try to access this. So what I'll do here, I'll try to read this. So with open, and let's take this here, and instead of write, we have read mode, and here write the file name and just changed from dump to load, and give a print function here. So when we check, we have tuple, but now when we check the type of this type, we have list. So that's the issue, and that's your question, that why we are getting the list when we deserialize a tuple. Okay, that's the question of the day, and let me know in the comments, and we can discuss this further in the next sessions. And now let's move to the next topic, which is serializing and deserializing the custom objects. So far we are using the all inbuilt classes and functions, but now let's say if we create our custom objects from the classes, and when we try to serialize and deserialize them, what happens? Okay, so let's do that. Let's create a class here. So what we'll do, we'll create class and trade. We can give any name. So let's say this is trade system. Okay, and inside that we have a constructor in it, then of course self, and we can have a trade ID. So trade ID, we can have symbol inside that, and also we can have, let's say, price, volume, correct? So let's self dot trade ID is equals to trade ID. Then we have self dot symbol is equals to symbol. Then we have self dot price is equals to price. Then we have self dot volume is equals to volume, correct? So now what I'll do, I'll create an object for this class. So class, and not class, let's give it the name obj for now, obj, and trade, correct? Trade system, and then here we have trade ID. So let's say a string, so t, and then symbol, so we can have apple, then price, let's say 100, and volume, let's say 1000, correct? So when I hit shift enter, it says takes no arguments because we forgot to add underscore here, and now it's working fine, correct? So what we can do here, let me try to access the attribute of this class. So obj trade dot, and let's say price, and when I shift enter, I get the price, and when I check the symbol, I get the symbol, that is apple. So for now it's working fine. But now what if I want to serialize this object? So what we can do here, so for that, as per the process, what we do, I create a new cell here. Let's say first we have to import JSON. So JSON, then with open, and let's give a file name obj.json, and inside that in write mode as correct. Then what we'll do, will json.dump, and we give the object name, that is obj trade, then the file name, right? So now when I hit shift enter, it says object of type trade system is not JSON serializable, but the file is created here. So when we check this, there is nothing. So now how we can resolve this issue? So for that, we cannot directly serialize any object here, at least with this method. So for that, we have to use another method. Very simple, very easy. What we can do here, we need to use another method, and that method is, we just need to tell the Python that I want to display like that it should be showing that the trade ID is like this, a string, the trade ID is, and then the trade ID, correct? Again, with the symbol, you can say with the symbol, and then it will display a symbol and the price and volume. So in that way, the good, beautiful looking string we want to display. So what we will do here, we'll just go here and create a function. So define, and the name we can say show object. We are creating this function for this object, and in that we will tell that how we want to display our class attributes. So now inside that we will pass the object, so obj trade, correct? And then here we will return with the formatted string, and I can just write like the trade IDs inside the function obj trade dot trade ID, correct? Then again with the comma, I can show that for the symbol, and again function and obj trade dot, you can call the symbol, so symbol, and you can give another comma and add the price, and again function obj trade dot, and the volume is, and now few more things we need to add here is that we can say a conditional statement with if is instance. So this checks whether this is an object of this class or not, right? So we'll pass the object here, object, and then the class name. So class name is trade system, correct? And then I'll put inside here. Now simply while dumping this object, you need to write the name of object. So that is object obj trade, then the file name, and now in the last you need to add a parameter, let's default, and then the name of the function. So we need to call the function here. I'll write the show object, and now when you hit shift enter, you can see that it has been done. And when you open this file obj.json, so here it is, and when you check, you can see that it is displaying as we wanted, the trade ID, then the apple, and 100 and 1000. Let's try to again validate this. So what we'll do, we'll go here and change these values, right? This trade ID. So now I'll just make it 87654. Apple we can replace with BTC. This was the price. So price we can easily target this, and then volume, of course, it will be in trillions. So I'll just write a string, and I can say 100 trillion, right? So when I hit shift enter and again I run this, you will see that the data has been changed as we wanted. And now one more thing, you can imagine the possibility with this idea. Let's check the content, and you can see here that it has been changed, the trade ID, BTC, price, and the volume, that is $100 trillion. So this is how you can use this, and it's really amazing. It's really fantastic, so flexible, but so powerful. Now, if you want to deserialize this, what you can do, the same. First, we need to import JSON. Then what we'll do with open, then the file name, which is obj.json, and in the read mode, then as f, correct? And again, json.load, of course. And here you have to give the name of file, right? And then what you can do, you can just print this. So I'll add print function here, and when you print, you have this here. So one more thing you can do here is that, why we are doing this, because now we want to validate that whether we are getting back the object or not, right? So now if I print the type of, now when we shift enter, it says as a string, means the problem is back. Now we are able to serialize the object to a JSON, but we are not able to deserialize. Means we are able to, but we are not getting back the object. So that's the problem. So in order to resolve that issue, we have another super important concept, that is pickling. So pickling is the process whereby a Python object hierarchy is converted into a byte stream. Means we are converting an object into a binary file or a byte stream. So unpickling is the inverse operation, right? Whereby a byte stream, or you can say from a binary file or bytes like object, is converted back into a object hierarchy. So that's the simple definition. So in simple words, you can say we are converting an object into a binary file, and in the unpickling, we are converting back from a binary file to a object of Python. So that's very simple. Let me show you again. So what we'll do here, we'll simply take this class, correct, and I'll paste it here. So let's follow the same process. So what I'll do, I'll just run this cell, shift enter, and now let's write the code for the pickle dump. Import JSON, then with open, and here we can give a file name, let's say pickle and demo, and then the JSON, so JSON, and now we'll write, so in write mode as f, correct. Then what we'll do, we'll just simply dump this object to a JSON binary file. So what we'll do, we'll write JSON dot dump, and similarly the name of object, so I'll write here obj trait, then the file name, that is f, correct. So now you observe at this palette, so when I hit shift enter, you will see that we have an error, but pickle underscore demo.json, and when we check this, it is empty. Now you just pause the video. We made a mistake. You just need to highlight that mistake without seeing the next part. You just have to pause the video and just type in the comment, what is the issue here? What is the mistake you have made here? Let me show you. What we did, we just followed the simple write process, but we know that we are working with the binary file right now. So what we'll do, we'll just add a B here which says write binary. And now when we hit shift enter, it says object of type trait system is not JSON serializable. Now what we can do, we can just import pickle. So instead of JSON, we'll write pickle, and with open the file name. So let's say we'll write a pickle here, a pickle, let's say demo dot pkl. Make sure that you are writing this as .pkl, because in JSON it was .json and here it is .pkl. Then I'll just write w and as p, right? Instead of JSON, I'll just pickle dot dump, and then the name of the object here. So here it is obj trade. So I'll just copy and paste here, and the file name, that is f, correct. So now when I try to run this, so I'll hit shift enter, and it says me write argument must be str not bytes. Now it's your responsibility to pause the video and think that what is the issue happening here. Just think and type your answer in the comments. So what will happen here, that was okay, but now we are dealing with the binary file. So we have to just change this write to write binary. And now when I hit shift enter, you will see that a new file has been created with the name pickle.demo.pkl. If I try to open this file, it will show me a warning that the file is not displayed in the text editor because it is either a binary or uses an unsupported text encoding. So it will not display here. So what we can do, instead of opening the file, we can simply use this. So what I'll do, I'll go here and I'll copy and paste this here, load, and this is a dump code. So I'll just paste it here. Now why I am using this pickle again and again, because in a single file, if you use this once, it is okay. But now this pickle file will be used in some other file or some other system completely different. So that time you will have to use this import pickle, then only it will work, right? So that's why just simple convention. So now as we are reading this file, what I will do, I will just change from write to read, and here from dump to load, same in JSON, and here I'll just remove this here, and I'll just write F because we are going to read the file F. So now when I hit Shift Enter, it doesn't display me anything because it is an object, and to print we have to print. And now when I hit Shift Enter, it displays me the address of the object. So you know that. Now what we can do, we can save this in some other variable. So I'll just save in, like, let's say P is equals to pickle. And now when I hit Shift Enter, now you can use this pickle file same like we use an object. So what I'll do here, when I hit P dot, it will display me all the attributes of the class. So now you just imagine that you have coded a file and you made that file binary, and you transferred that binary file to some other system, so some other server, and there you are able to use the same class which you have written here. And that is the real use case of this pickle file. Okay, first let me show you all the data. So I'll write price, then the symbol, then the trade ID, and then the P dot volume, correct? And we have to print this. So I'll just go here, print, and I'll copy this, print, and again print, correct? So now when I shift enter, it displays me all the value. Now to double check this, what we can do, we can just change this value. So instead of 1 2 3 4, I'll make it 4 3 2 1, and ETH I'll make it BTC, and price I'll make it 125,000, and volume I'll make it $100 trillion. So now when I hit shift enter and run these again, now when I access the value, it is changed. So means it is working fine. And that is how we can create the pickle file. Now the question arises that where should we use pickle and where should we use JSON? So pickle lets the user to store data in binary format, and JSON lets the user store data in human readable text format. So you can say that whenever you want to store the data in text format and in human readable format, you can use JSON. When you're dealing with APIs, so in APIs you have to read the data, so that time you can use JSON. When you want to store your data, transmit somewhere else, you can use pickle. So in like machine learning models, when we run big model and there we are consuming a lot of resources like CPU, memory, and time, and you want that the output should be stored somewhere, right? So what you can do, you can just store that output in your pickle file so that you don't have to use your resources again. We'll be using this pickle a lot when we'll be learning machine learning and AI trading. Let's understand syntax errors. So syntax errors occurs when the Python interpreter encounters a code structure that it doesn't recognize. These errors must be fixed before the program can run. Means, as we considered that if Python is a language, then if we are making any grammatical mistake, it would be considered as a syntax error. Means that Python interpreter will not recognize that structure and it will throw a syntax error. So let's say for printing, we have the syntax, right? Print, and let's say hello. But if somehow we miss this brackets here and we just execute this code, then it will throw a syntax error. Hope you are getting my idea. Don't worry, we'll take so many examples, but for now, just understand the concept. So in the context of algo trading, syntax errors can prevent your trading algorithm from being executed, leading to missed trading opportunities or other issues. So if you make any syntax error, then it might happen that when the opportunity comes and at that time your code throws a syntax error, so it will become a disaster. So make sure that you are not making any syntax error. So the example of a syntax error in algo trading is, let's say, missing colon at the end of the if statement, right? So here we need to have a colon, correct? Most of the time you will be able to like figure out the syntax errors easily because your IDE will show you that there is some error in your code. So you'll be able to find out these errors, not an issue with these. So let's move to the next kind of errors, which are exceptions. What are the exceptions? So exceptions are errors that occur during the execution of a program. They can be caught and handled using try and except. So as we have seen that syntax error happen during the compilation, but sometimes even if you have everything correct, your old syntax is right, and still after the compilation, during the runtime, there might be some unexpected input, right? For example, you have written a code to add two numbers. So instead of an integer, the user might pass a string and it will throw an error, right? So those are the exceptions. So we need to have a strong, robust technique to handle all those errors. So let's proceed. They can be caught and handled using try and except. blocks. So in Python, we have try and except to handle those errors. So in Java, we have try, catch, throw, right? But in Python, we have try, except, and raise. Then allowing the program to continue run or to fail gracefully. So what happens if we use this try and except? Then what will happen? Either the code will run, or even if it fails, it will fail gracefully. It will not throw a very scary error on your screen, and it might sometime harm the user experience, right? And as a programmer, our main motto is to provide as much as convenience to the user, correct? So in algo trading, handling exceptions is crucial to ensure that unexpected events such as network failures, invalid inputs, or market closures do not cause the entire trading system to crash. So we have to make some kind of a mechanism that handle all kind of unexpected events, right? So here we have few common exceptions in algo trading. So the first common exception is runtime error. It is very common. What happens? Let's say we are calling the function get current price and we are passing the argument as string apple, and in return we are getting a 0. Sometime it might happen that due to any reason we are getting price is equals to 0. So what will happen? 10 divided by 0 will throw an error that is known as potential division by 0 if price is 0. So it will throw a 0 division error. Right. The next is the type error. Here what happens? The same example, and here volume is equals to 100, but it is in string. So if we try to find the total cost, so what will happen? Price into a string will throw a type error because it needs to be a string. So we have to convert this to a string and then we can multiply. So it is a type error because the expected type is integer, but here we have a string type. That's why. Next we have is the name error, and in which what happens? It might possible that the quantity name doesn't exist. Right, so it will throw a name error. And for the key error, it generally have in dictionary. So in dictionary we have key and values, and sometimes if the key is not existing and if we still call the key, it will throw a key error. So these are very simple. Next we have attribute error. So in a class we have multiple attributes and we are calling an attribute which is not existing in the class, so it will throw an attribute error. So these are some basic types, and let's quickly move to the coding examples. As we have already seen that there are two stages where error might happen. So the first is during compilation. So whatever the error happens during compilation, these are known as the syntax error. And the second is during execution. So whatever the error happens during execution, these are known as the exceptions. So in syntax error, something in the program is not written according to the program grammar. The second is error is raised by the interpreter or compiler. The third is you can solve it by rectifying the program. So they are simple pointers. So let's take an example of, so we have seen that this is the correct print statement, right? Hello. But somehow if we miss this bracket, which happens during the initial phase of the programming, the beginners make this mistake sometimes. So when we hit shift enter, it will throw an error which says syntax error, missing parenthesis in call to print. Did you mean print? So it will show you that how we can rectify this. And the next we have few more examples of syntax error. So the first is leaving symbols like colon or brackets. For example, if I write if true and colon, then pass, and when we hit shift enter, it will work. But if somehow we forgot this colon, then what will happen? It will throw a syntax error which says expected a colon, right? Next is misspelling a keyword. Let's take the same example. So instead of if I write if I write IFF, then true and pass, it will throw the error for sure. And it will say syntax error, invalid syntax. Next we have is incorrect indentation. So let's take the same example, and if true and below, this is the correct, right? Pass, it will work. But if somehow I miss the indentation and if I pass it here, then it will throw the error and it says expected an indented block after if statement on line 1. So that's how these errors works. Now let's take few more examples of errors. So the first is index error, and the index error is thrown when trying to access an item at an invalid index. So what happens? Let's say we have a list and it contains the items 1, 2, 3. And if I try to access L0, so the next is module not found error. As we have recently seen that we have to import JSON module while working with the JSON files. So let's say I'll type import JSON, then what I'll do with open, and here I can just give the name module.json, and we can give a write mode here, and as f, and let's say I want to write, so f dot write, and I'll write testing module not found error. So when I hit shift enter, a file will be created. But if somehow we missed this JSON, we forgot to add this, so I'll just cut it. And when we hit shift enter, actually it's done already. So if I remove this file for now, delete this, and now when I try to run this again, I think maybe somewhere else in this file it is written. So what I'll do, I'll just try to, let's do one thing, that instead of JSON, I'll just misspell it. Okay, so I'll write, so this JSON is not existing. So when I hit shift enter, it will throw the error that it says no module named error, and this is the module not found error, right? This one. The next we have is key error. So let's say we have a dictionary, and inside that the value is, let's say, stock, and that is apple. And now if I try to access the stock, we can access, but somehow if we like try to access, because stocks doesn't exist in this dictionary, so it will throw a key error. So what happens in type error, let's say I'm trying to add 1 plus 1, so it will give me 2. But somehow if I like try to add 1 plus a string of 1, then it will show me a type error, because it says unsupported operand type as for the plus, integer, and string. So now let's take an example of value error. So what happens here, it says the value error is thrown when a function's argument is of an inappropriate type. So what happens here, let's say I write int, and here we are expecting some other value, but if I type a here, what it will show me, it says value error, which says invalid literal for int with base 10 and a. So this is value error. So the next is name error. The name error is thrown when an object could not be found. So for example, any value, let's say a, so it will show me a is not defined. So for that we have to define the a, and let's say if I type a is equals to 2, then it can print the value. So next we have is the attribute error. So let's say we have a list, and inside that we have few items, 1 2 3 34 4, it's okay. Now we are trying to apply a method which is not existing in this. So when I run this, it says attribute error, because list object has no attribute upper. So that's how you can think of the attribute error. Next we have is the stake trace. So what is stake trace? You can see here that we have this kind of stack. So in this we have the name of the error, then we have a message which says list object has no attribute upper, and above that it is clearly showing us that it is in the cell 55 line 4, and inside that also it is giving us an arrow, and which is displaying the exact place of the error where it is happening. So this whole stack is known as the stack trace. So that's the basic idea of the syntax errors. And now let's move to the next part, which is exceptions. So as we have already understood that syntax error happens during compilation and exceptions happens during the runtime. So let's understand them one by one. Now let's understand the exceptions. So what are the exceptions? If things go wrong during the execution of a program runtime, it generally happens when something unforeseen has happened. So exceptions are raised by Python runtime, and you have to tackle is on the fly, correct? So example, we can take memory overflow and divide by 0, a logical error, and a database error. So what happens, let's say if you are handling large machine learning model, and sometimes because of that memory, you might get a memory overflow error because your memory is not able to handle that amount of data. Divide by 0, we have seen that already, a logical error, because sometime when you try to divide 1 by 0 or any other integer by 0, it will show you a logical error, right? Then again we have database error. So in that what happens, sometime when you are trying to connect with database, and let's say your program is dependent on that database, it might happen that you are getting some unexpected value from the database, and because of that your program might break, or it might show you an error, and because of that it might happen that your code show any exceptions. So let's understand it with the code. So what I'll do here, I'll create a file, and let's say with open, and I create the file with the name, let's say exceptions.txt. Then I'll write something in this f.write, and I'll write simply testing exceptions, and I'll just hit enter. We can see that we have a file here which is having the content, right? But now when we are like reading the file, so I'll create another code cell, and now let's try to read this file. So I'll change from write to read mode, and from here I just have to write the read, and I'll print this also. So now we can see that we have the content. So far everything is okay, but somehow we have misspelled the file name, and instead of exception I have write exceptions. And now when I try to run the program, it will show me file not found error, because there is no syntax error, there is no grammatical error in this code. But this is an exception because it happened because of the input from the user or input from any other source. So these are known as the exceptions. And now let me tell you one more thing, that why it becomes so important to handle these exceptions. Let me show you. So you can see here that it is showing us path, correct? OPT anaconda 3 lib python 3, something like that. So it is clearly showing us a path. And let's say we have a big line of code, and inside that, if he is really smart, what he will do, he will get so much of very important and confidential data. And because of that, he can combine that data later, and he might misuse that vulnerability. These are known as the vulnerabilities, to be very precise. So he might use that and he might hack into your system. So that's why it becomes very important to handle these errors. And the second thing is that generally, if the user is displayed with these kind of scary errors, it will be very unpleasant to the user, and we don't want that, right? It will be a very bad experience in terms of the UI, and definitely it will impact our end goal, that is the sales and marketing. So because of those reasons, we have to handle these kind of exceptions. Now comes the try and except block. In Python, we have try except, and in Java, we have try catch block, and it's like the functionality is same, just the name is different. So let's start with the try and except block. Now let's proceed and see that how we can handle these kind of exceptions. What I'll do, I'll just copy and paste this code in the next cell. So here, now we know that this error was due to this line, correct? So what we can do, we can use here the try and catch demo. So what we do, when we know that which line of code might throw an error, so we keep that line of code in the try block. So I'll keep in this try, and I'll write here except, and I'll print file not found, correct? Now let's first correct this. So we know that this exception.txt is existing here. So when we try to run this code, it will show us the content. But if somehow, if the file is not existing, or if the file name is wrong, so what happened here, this try block tried this code, and if there was any error, that was caught by this except block. So here we know that it is catching all kind of errors. There is no specifications that it should catch which type of error. So means if you want to display that, if the type of error is different, it should display different kind of message. Let's move to the next part, which is catching specific exceptions. So what I'll do, I'll just copy and paste this code. Okay, and we know that this file is not existing, so we'll make it right. And this file is existing. So when we hit shift enter, it will display the content. But now let's try with some other error. So what I'll do here, I'll write here print and ABC, and we know that this ABC doesn't exist here. So A and C also doesn't exist. So when we try to run this, it will show us that testing executions and file not found. So what is happening here, first it will print this because this is existing, and now it will throw an error, and that will be caught by this except. But we know that that is not the file not found error. That is different. That is the name error, because A and C doesn't exist here. So for that, what we can do, we have to define these all except blocks with the specific errors. So this is a file not found error. So what I'll do here, I'll add file not found error, because now this name error is not caught by this file not found error, and it will again show us the scary code, and which is not recommended. So what we will do, we'll add another block of except. We will tell this block that you can expect a name error. So name error, and now we can print name not found, and now when we run this, it will show us the error name not found, correct? Now let's try with something else. So if in this code we have two errors, the first is file not found, and the second is a name error. So we know that the Python interpreter runs line by line. So first it will display the file not found error, and it will print out that only, right? So let's correct this first. Correct this also. What I'll do here, I'll define A and C is equals to 1, let's say, and when we run this, it will show us both the values, testing exceptions and 1. Now let's say we have some another kind of error, and let's say we have a type error. So what I'll do here, I'll add here 1, let's say print 1 and plus string of 1. So we know that this is integer and this is string, so it will not display the value, but it will display an error. So when we run this, it says unsupported operand type for integer and string. So for that, what we can do, we can add another except block, except, and here we can add type error, and now we can print that incorrect type. We can say we can print our desired message, no problem. Okay, now what we'll do, we'll just correct this, and so it will print the correct value, right? Testing executions 1 and 2. And now let's say we have an index error. So what I'll do, I'll just here, I'll define a list. So let's say L is equals to 1, 2, 3, 4. And here what I'm trying to do, I like to print L, and here I'll give 10. So we know that this 10 is not there, the index, and it will show us the index error, list index out of range. So for that also we can add here except index error, and then it can print this value index out of range, right? So it will be handled gracefully. But now let's say we tried our best to add all the except blocks, but still we have missed few of them. So for that, what we can do, we can add a generic block which will catch all the other errors which we have not mentioned here, right? So what we will do here, I'll write except exception as E, and then just print. So let's say if we have here, let's say we have here a 0 division error. So what I can do, I can write 1 divided by 0. So what is happening here, actually we have to correct this because Python runs one by one and it will first display this index error. So let's correct this, and I'll just change it to 1. So now you can see that it executed all the values above, and for the last one, the index out of range, we didn't have any block and we have a generic block. So that's how we can use this except, and you can search a list of errors and you can use in your own code, right? Now let's move to the next part, which is else. So in exceptions also we have else. So what I'll do here, I'll just copy and paste this code. And so what is the use of this? Now we know that this is the problematic code, and if there is any error, that will be coded by this except. Now where we can use the else block. So let's say what I'll do here, I'll just remove this and I'll make it as f is equals to, and print, I'll remove this, and here I'll add another block with the else. So now what is happening here, this is the only problematic code. So if the name of the file is not correct, it will throw the error and that will be coded by the except. And if the issue is not there, then this program will run, right? So let's try this. It says invalid syntax. Where it is, okay, we need to remove this one. And now it says file not found because this is not existing here. So when I remove this, it will show us the testing exceptions. So it is simple. If there is any error, it will be caught by this except block. And if there is no error, then what will happen? This else block will execute and it will execute the code inside the else block. So that's very simple. We can use this else block in so many scenarios, right? Now let's move to the next part, which is finally else. Now next we have is the finally. So let me quickly copy and paste this code, and I'll paste here. And now what we'll do, we'll add this problematic line of code in try block. Then in except block, we have the error, that is print file not found. So what we can do, we can write here file not found error, correct? Then if this error is not existing, then this code will run, correct? So if there is any error, then this code will not run. So let's try both the things. So first I have changed this to like some different name, and when I try to run, it will throw me this except error, correct? And if I correct this name, then it will print out the results. Now what I do, I'll add another block, that is finally block. So I'll add finally, and what it will do, it will run in any condition. Like, so whether there is any error or not, it will run in any case. So let's say finally, I will always execute, we can say, right? And let's say we have an error here. So I will change the name to exceptions. And when I hit shift enter, first it will throw this error, file not found error, then it will run this code. I will always execute. So sometime you might need this also, so you can keep in mind. So next we have is the raise exception. So what happens in this? In Python programming, exceptions are raised when errors occurs at runtime. We can also manually raise exceptions using the raise keyword. So we can optionally pass values to the exception to clarify why that exception was raised. Previously, we have seen that those all exceptions were raised at runtime, but if we want to raise the exceptions manually, we can also do that. So let's raise the exception manually. So what we'll do here, I'll write raise and we can take any error. So for example, file not found error, and we can print a message here. So I was just trying to raise manual exception, right? So when I hit shift enter, it will display file not found error at raise stack, and inside that the message will be I was just trying to raise manual exception. So in your code, you can use these manual exceptions wherever you require, right? Now let's take a simple example of the raise exception. So we have example here. Now you can see that we have a class with the name trading error, and here we are inheriting the exception class. Otherwise it will not work. Make sure that you are inheriting the exception class. Then we have a constructor function here. Inside that we have attribute with the message and a method with handle. Okay, now we have the next class, which is authentication error, and that is also inheriting the exception class. And inside that also we have the constructor function and the handle method, right? So this is how you can use the raise manually in your code if you require. So before we get started, I would like to show you some words of wisdom. So it is only our darkest hours that we may discover the true strength of the brilliant light within ourselves that can never ever be dimmed. So believe in yourself and stay consistent and try to give your best, and rest everything will be okay. So let's start with namespaces. A namespace is a space that holds names, that is identifiers, like the name of functions, the name of class, and the name of variables. Those are the identifiers. So we can say, programmatically speaking, namespace are dictionary of identifiers, that is key, and their objects. So let's say like we have a variable name, variable equals to a. So here in the namespace, it will become a dictionary. Okay, let's make it 2. So in the namespace, it will become a dictionary. So we can write like variable as the key and 2 as the value of this. And let's say again we have a function. So function starts like this, right? So here again, this function is the key, right? The function name is the key, and whatever it returns and whatever it prints, it becomes the value of that, right? So the function return, we can say the value of. So in namespaces, we can say that all these identifiers, the name of variable, the name of function, or the name of class becomes the keys, and the value of those keys becomes the value, obviously, right? So we can say like that, correct? So there are 4 types of namespaces. The first is built-in, second is global, third is enclosing, and fourth is local. Don't worry, we'll learn all these one by one. First theory, and then we'll proceed with the coding examples. So now let's see the scope and LEGB rule. So a scope is a textual region of a Python program where a namespace is directly accessible. So we can say that whenever we execute a program, we have a scope and a namespace. So in order to understand that, I'll show you one screenshot from the Python tutor, and let's see. This is a program. So when we try to visualize with the help of Python tutor, there is 2 scopes created, right? So what happens when we start the execution? What happens? The program goes to the first line right here, and it sees that there is a variable name threshold price is equals to 100. So it will create a global frame, which is this one, right? And inside that we have a variable named threshold price is equals to 100, and it will be inside the global frame. So we can say the scope of this variable is global, right? And again, here the dictionary is created. So the threshold price is the key and 100 is the value of the dictionary. Again, the program next move to the here, and here it sees a function. So as we have already studied that the function name is also a key, so it will mention this here, the key, right? The value is not here as of now. Then it will skip the whole program, correct? And it will move here. So here it will see that there is a variable named current market price is equals to 102. So it will declare that in the global frame. So we can say global frame is the global scope, and there are 3 namespaces, 2 variables. The first is threshold price, second is current market price, and the third key is the name of the function. Hope you are able to understand my explanation. If you have any doubt, let me know in the comments. I'll try my best, and maybe we can discuss it again in any supplementary session. Correct? So now when the program reaches this line number 13, there is a function called check price and trade, and here it will create another frame, and that will be known as the local scope or the local frame, right? So now we have two scopes. One is global and another is local, and inside that we can have different dictionaries. Inside the global frame we have three values, or we can say three key value pairs, right? Threshold price, check price and trade, and the current market price. And inside the local scope, let's see what is there. So when the function call happens, it will again go to here and it will start executing. So here we have a conditional statement. So it will check the current price is greater than threshold price. So here you can see that outside the function, it was the current market price, but inside it becomes current price. So these two are completely different. The Python will consider them completely different, although they have same value, but it will be treated as different. So you can see here it was current market price, but inside the local scope it is current price, but the values are same. So we can say these both are the different keys and values of the dictionary of the global frame and local frame. Right now it will check and it will return none. It will just print out the values whatever the condition is true. So this is the simple explanation, and now let me show you a few more things. So we can see that this was the local namespace, correct? And inside that it has its own keys and value. So you can see this is the key number 1, this is key 2, and these are their respective values, correct? Again, this was the global namespace or global scope, you can say, and inside that also it has its separate keys and values, right? Now the third is the enclosing namespace. So enclosing namespace is nothing but what happens, let's say we have this local namespace. Inside that, if we have any other function, right? So let's say this was the function, correct? And let me just remove this. So let's say this was the function, and inside that we have another function, correct? So what will happen now? Let me write it here. So let's say this is the define check. I'll just write it short. Okay, this is this function, and inside that, let's say it had another function named validate, right? So now what will happen? The inside function, the inner function will become the local namespace, and the outer function, this will become the enclosing namespace, correct? And the rest is same, the global is same, just it got changes. This one becomes the local. If it has another function inside this, it will become the local, and this will become the enclosing. So that is nothing but the enclosing namespace. Don't worry, I'll just show you with a live example. So just wait for a few minutes. And the last is the built-in namespace. For example, we have declared a function here with the name define max, correct? But we know that we have built-in max function. So like we have a list with the values 1, 2, 3, 4, and if I apply max L, it will give me the largest value. So it will give me 4. But if the Python sees that there are two things, one is the max function, which is we have defined, another is the inbuilt max function. So what will happen according to the LEGB rule? So L stands for the local, E stands for enclosing, G stands for global, and B stands for built-in. So we have a program, and inside that, first of all, it will go through the local namespace, or we can say local scope. So whatever inside that, it will give the priority to the local namespace. Then it will go to the enclosing. So we have just understood that what is enclosing. So inside that, if we have a function, so the inner function becomes the local and the outer becomes the enclosing. So the second will be the enclosing. The third will be the global. So global, we have seen that this will, if it has another function, so this will be local, the outer will be the enclosing, and the outermost program will be the global namespace, right? And the last will be the built-in. So if it sees this max anywhere, so this built-in function will have the last priority, right? Hope you are able to understand my explanation. So this is the LEGB rule. This is nothing but the priority order, LEGB. First, local, enclosing, global, and built-in. That's it. So now let's quickly move to the screen and try to understand the theory we have just understood. Okay, now let's create a program. So what we'll do, we'll define a trading capital. This is $10,000, and a function. So define placing trade, and inside that we have trade amount, right? Is, let's say, 1,000. Then what we can do, we can print here, and we can say placing a trade of amount, and here we can give this function variable trade amount out of the total capital we can say, and again we can mention here trading capital, and outside of that function we can print the remaining trading capital is, and whatever it is, trading capital. So now you can see that this is the global variable, right? Trading capital. Inside the function, this trade amount is the local variable, correct? So when we hit shift enter, it will first print, give a function call here, will give placing trade, and now you can see that first it is printing out this last print function. So we can see, and this is local variable inside the placing trade, right? And let's try to understand this in the Python tutor. So what is happening here? Now let's quickly copy and paste this in Python tutor, and let me show you how this works. So here, let me paste it here and click on visualize execution. When I click on next, a global frame will be created because this trading capital is inside the global frame. Also, we can say that this is the dictionary, and inside that trading capital is the key, and 10,000 is the value of that key. And now what happens? The function call happens. So we can say that the function name is also another key. Now another namespace is created, and this placing trade is different from the global namespace. So we have now two spaces. One is global namespace and another is local namespace. So here we have the trading amount, that is 1000, correct? And that is another key and value of this placing trade namespace, that is local. And now it will return nothing. And now we click on next. So this will be gone. If you are able to understand, then what happens when I click next? So you can say that this local namespace will be vanished as soon as the function execution will be completed. So when I click on next, it is vanished, last print statement. So hope you are able to understand that we have separate namespaces, and according to LEGB rule, the first priority is to the local namespace, the second is to the global, third and closing and fourth is the built-in. Again, move to the program, paste it here. So what is happening here, when we have two namespaces or two scopes, global scope and local scope, but in both the scopes we have a same variable name with the same name. So what we'll do here, let me copy and paste it here. Let's change it to 20,000, right? So now if I hit shift enter, so first it will look inside the local scope. So you can see here that it says placing a trade of amount 1000 out of the total capital 20,000, because we have a variable inside the local and it will print that first. So if I comment this out, what will happen? It will then go to the global scope. So you can see here, it has changed to 10,000, right? Hope you are able to understand. It is very easy. You just have to practice a little bit and you are good to go. Next, we have the local doesn't have, but global has. So we have seen that already. Let me copy and paste the same example here. I'll just copy it from here, paste it here. And what we will do, we will remove this also, paste it here, right? So now you can see that we don't have either of the variables inside the local, but still if you run this, it will print, because first it will look into the local scope and then it will goes to the global. So in global, we have these two variables, so it will print that out. Now, one very interesting concept is here that, so if you try to print this, it will work fine, right? So what we will do, we try to write, let's say, both of these here, trading capital, and what I will do, I will just add a plus. And now you just pause the video and let me know in the comments that whether this will work or not. Because earlier we have seen that we are able to access the global variable inside the local scope. But now, as I have changed something, and you have to guess whether this will work or not. So when I hit shift enter, it says cannot access local variable trading capital where it is not associated with a value. We can access the global variable, but we cannot make any changes. Make sure you keep this in mind. We can only access, but we cannot make any changes. But we have seen that Python is so flexible. If you want to make changes, we can do that, but that is not recommended. So how we can do that? Let me show you. In the next line, we just have to mention keyword that is global, and then trading capital, again global. You can see that as soon as I mentioned global, this turned blue, means we can access this and we can edit this. Again, for the global trade amount also, it turned blue, means we can make changes. So now when I hit shift enter, it works perfectly fine and it print out the values. So Python is not stubborn. If we want to make changes, we can do that, but this is not recommended. Make sure, if in any case, if you require, you can use, but not recommended. Next, we have a global created inside local. So how we can do that? Okay, let me remove this, copy and paste it here. So what we want actually, we are creating the variable inside the local and we want to access from the outside. So let's say we have these two variables and these are inside the local, and when you try to access, it works fine. Now the next is global created inside the local. So what happens here? Let me copy and paste the same program here. So now you can see that we are creating from the inside and accessing from outside, right? If I hit shift enter, it is working. Why? Because in this program, we have already declared the variables outside, and this is considering the above examples, right? These one. So that's why it's printing, but technically it doesn't work. Let me change it to, let's say, something other, 1, 1 and 1, everything. I will just add 1. So it will not conflict with the above examples. Now we have changed everything. So when I shift enter, it says name trading capital is not defined, because we cannot access the local variables outside of the function. So for that, what we can do, we can use the same keyword, that is global, right? So I'll write global and trading capital 1, and again global and trade amount. So now when I hit shift enter, it works perfectly fine, but still this is not recommended, right? The global keyword should not be used frequently. You can only use this in case of emergency. In short, you should not be using global keyword. Now what we want to do, we want to pass a parameter here and we check whether that parameter is local or global. So what I'll do, I'll just define a variable here. So let's say outside trade amount, let's say 500, and I'll just pass it here, right? And inside that, I will just give trade amount. So I'll just remove it also. So now you can see that it says placing a trade amount of 500, means we have passed here and it is printing that. But we want to check whether this is local or global. So what we will do, we'll just copy and check on the Python tutor. So, and now click on visualize. And here you can see that I click on next, a global scope is created, and function, it will skip whole and it will go to the next, that is outside trade amount, and it is still inside the global, and the function call is happening. Now it will create another local scope, and you can see that it is again creating trade amount 500, which is local. So we can say that whenever a function call happens and we are passing any parameter, and that parameter will be inside the local scope always, right? This is how it works. And let me again open the code. So let's say I'll just create it as a list. So 1, 2, 3, 4, and inside that, what we will do, we'll just try to max. So if we do this, it will print the max of this list, and this also max, correct? So now what is happening, we have a function named max, and also we are using the max inbuilt function of the Python. So now when we hit shift enter, it says max takes 0 positional arguments, but 1 was given. Why? Because as per the LGB rule here, local, enclosing, global and built-in. So built-in has the last precedence. So same thing is happening here. If we try to write like this max trading capital, it will think that we are calling this function and it will not work. It will throw an error. So for that, what we can do, we can just change it to max 1. And now if I hit shift enter, trading capital. Okay, now let's try to replace max with min, because I think max is defined somewhere else and that is conflicting with this cell. So now when I try to print this minimum, it says minimum takes 0 positional argument, but 1 was given. Means, and this is the custom functions which we have just defined, but still here it will think that we are calling this function and we are passing a argument here. That's why it is showing an error. So if I comment this out, it will show me the minimum. I have to remove this, I guess. And now when I hit shift enter, it still throws an error. I don't know why. Maybe I have to restart this, or max. Also, I think there is some conflict always, right? Because if I restart, and definitely it will work. Now I think some cache or something is there. That's why it's create error. So I'll again try to, yeah, it works fine. And I'll paste it back and I'll remove the comment. So now it is working fine, right? So if I try to print this now, it should throw an error. It is thinking that we are calling this function here. So that's why you can now imagine or you can say visualize that LEGB rule. Keep in mind, that's it. That will be sufficient, right? Now let's see how you can print all the built-in functions. For that, what you can do, you can print, or before that you have to import a module built-ins, and then you can print directory of the built-ins, and you can see that you have all the built-in functions. The arithmetic error, we have seen that already, the warning, the value error, IPython, and all the packages, ASCII, bin, bool, we have understood most of them. The none we have seen already. And again, like we have the tuple type, where this is how you can check the built-in functions. And now next we have the renaming built-in. So what I'll do, I'll just copy and paste the above program here, and same. First we will try to print the minimum of this list, and then we'll call this function. And here also I'll try to print the same here. Now when I shift enter, it again says that minimum takes 0 positional argument but 1 was given. That it is thinking that we are calling this function and it will not execute this, right? For that, you can do one thing, that you can change this minimum to minimum 1 and this. And now if you try to hit shift enter, it says minimum takes 0 positional argument. Yeah, it's same because there is some cache stored. So we have to restart this kernel. And now when I again copy and paste the same program, it will work. And now you can see that it is working fine. And even when we call this function, it is working fine. So this is how you can use the built-in functions, and you have to be extra cautious when you are using the built-in functions. Next, the last topic is the enclosing scope. So we have already understood this in theory part, but let me show you again. So here we know that this is inside the global scope and this trade amount is inside the local scope. But let's say we have another function here, define, and let's say print function, right? And let me move these both inside this function. So now what you can say, that this trade capital is inside the global scope, then this is the innermost scope, right? So it will be considered as the local scope, and outside of this function we have this placing trade, and that is known as the enclosing scope. So what I will do here, let me remove this line first and let's simplify this. So what we will do for now, I'll just write here the global scope and copy and paste inside this, and this is the local scope, and outside this it will be the enclosing scope, correct? So now you pause the video and let me know in the comments that what will be the sequence of printing out these statements. So let me show you. When we hit shift enter, the print function is being called here and it will print this local scope. And then we have a placing trade call here. So it will print the second and third, the global scope. That is very simple and easy, correct? So now I think you are crystal clear that what is local, what is enclosing, and what is global scope. And similarly, let's say I'll just copy and paste it here and I'll just show you the last concept. Same like the global keyword. Let's say this is inside the enclosing scope, right? This is the part of enclosing function. And what I want to do, I want to make some changes here. Let's say trade amount plus equals to 500. We know that this trade amount belongs to the placing trade function. So when we hit shift enter, it shows that cannot access local variable trade amount where it is not associated with the value. But we know that we have used global already, but now we have the enclosing. So for that, what you can do, you can write another keyword that is non-local and trade amount. So now when you hit shift enter, it works fine. So now when you check, it works fine. So when you have enclosing function, For enclosing scope, you use a non-local keyword, and when you have only the global and local, you can do your stuff with the global keyword. Let's first understand what are the decorators. So a decorator in Python is a function that receives another function as input and adds some functionality, that is decoration, to it and returns it. So simply we can say a decorator is a function that receives another function and it adds some decoration, right? And then it returns against the new function. Simple. This can happen only because Python functions are first class citizens. So what are the first class citizens? Which can be stored as a variable, which can be passed as an argument, and which can be returned from a function, and even can be stored in a list, dictionaries, tuples. So those are the first class citizens, right? Similarly, this happens in decorators also because Python functions are first class citizens, right? So now let's see. There are two types of decorators available in Python. The first is built-in decorators like static method, class method, abstract method, and property, which we have already seen somewhere at many places. The second is user-defined decorators that we programmers can create according to our needs. Means the second is custom decorators. Now let's quickly understand the use cases of Python decorators in the algo trading. First, Python decorators can be used in logging. So automatically log function calls and the results, useful for monitoring and debugging trading operations, right? Because with the help of decorators, we can store or log the function calls, and it really helps in the monitoring and the debugging, right? If there is any error comes, we can quickly find out that what is the reason behind that and what functions is causing that error. The second is timing. So we can use the Python decorators to measure the execution time of any program. And again, it is important for ensuring the performance of trading algorithms, because in algo trading, we need to know that which functions is taking how much time to execute, because that decides the profitability, right? Because in HFT, the game is all about the timing. So we have to make sure that our program is taking less time, right? So we can use in logging and timing. The third is a retry mechanism. So automatically retry a function if it raises specific exceptions. So we can code that if it raises a specific exception, it will retry that function. Again, it is useful for handling intermittent network request or database operations. So we can also code that for the intermittent network operations or for the database request, we can use this. The fourth is access control. So it enforces access controls based on user roles or permissions, ensures that only authorized users can perform certain actions. So we can have some conditions in the Python decorator functions so that it can only give access to those people who are authorized. So we can use this in access control. And the last but not the least is resource management. So ensure proper acquisition and release of resources like database connections or files, and helps manage resources efficiently and avoid leaks. So it will definitely help in the resource utilization, because we can monitor the performance with the help of decorators. It will definitely and efficiently help in the resource utilization, right? So these decorators help improve code maintainability, readability, and functionality in algorithmic trading system. So let me quickly show you roughly what are the decorators and what functions they perform. So let's say we have a function which provides the trade details. So I'll write trade details, right? And there can be any code. So that's not the concern here. And we have another function, and that we will be using as decorator. So what this function do, it will, let me give it the name, decorator. So what it will do, it will just add some functionality to this function, right? So what it will do, it will just, let's say, and sometimes we require some patterns, right? So let's say if it is printing out some trade details, so let's say it is printing out some dictionary. Okay, inside that it is giving that the symbol is apple, and let's say price it is also giving, let's say 100. So means when we execute this function, it is printing out these details. But what we want, that these details should be like printed in a good manner. So what we will do, we'll just ask this decorator function that please decorate my this function. So what it will do, it will just print some decoration. So let's say it is printing some stars here. Okay, then it will call this function. So here there will be a function call. So it can call trade details and the function call. And again, below these also it will print some stars so that it looks nice. Simple. What will happen now? First, this will print the stars, right? So the stars will be printed out. And then the function call is happening, right? So when this call happens, it will print this. So this will be printed here, like let's say symbol and price. And again, it will print a star. So I'm sure that you have seen in so many program execution or while installing any program that there is a pattern. It can be a robot, it can be a man, a woman, any design, any star pattern or anything else. So that we can also apply with the help of decorators. So this is just a small example, but now we'll proceed with the real examples and I'll make you understand that how we can use this in the algo trading, right? So without a further ado, let's get started. Okay, let's define a function. So for example, we have function for SMS strategy. So strategy, and inside that we are passing some trade data, right? So it will be definitely a dynamic data. So I'll write trade data. What is happening here? First, let me define a trade data outside. So trade data, it can be a dictionary. So here the key, prices, and the value of key is a list. So let's say it is 10, 20, 30, 40, 50. Very simple, right? And inside that function, what can be the prices? It can be the trade data and the key, which is prices, right? And it will return the simple moving average. So what it will be? The sum of these prices, right? So what we can do, I can just write sum of the prices divide by length of the prices. As simple as that. So now if I go ahead and call this function SMS strategy and pass the trade data, I get 30. So that's a very simple function, correct? Let's suppose we have multiple strategies. Let's say we have around 1000 strategies and we want to have some kind of function which can decorate all these strategies. So we have two options. One option is to go and change all the functions of every strategy. Another option is to just create another function which can handle all those strategies. So what we will do now, I'll go ahead and create another function and let's say I can give it, so what it will do, it can modify any strategy. So modified strategy, and here what I'll do, I'll just pass any strategy. So let's say SMS strategy. So I'll give here the name of parameter. It can be, let's say, base strategy, right? It can be base strategy and the trade data, which is dynamic, right? So I can just write dynamic data, correct? And what it will do, for the sake of this example, I'll just print some stars and I'll say initializing modified strategy, and I'll copy and paste the same number of stars for the symmetry, correct? And again I can print another statement, let's say here, and we can give it name ending modified strategy, correct? And between these we can call this function, right? So we have passed this function as a base strategy here. So I'll write base strategy and the dynamic data. I'll just remove this function call for now. I'll just comment it out. And now what we'll do, we'll be calling this function, right? So modified strategy, and inside that we'll pass the SMS strategy and the trade data, correct? So when we hit shift enter, it is printing out both the values, but not this one. So for that we have to print this. So I'll just write print. When we hit shift enter, it gives us the 30. So now what is the benefit of this? That we can keep this same and we can have another like 1000 strategies like this, and this can be used for every strategy. Let's say I'll quickly go ahead and create another strategy, and it could be like, let's say, Bollinger Band, so BB strategy, just for the example. It is also returning same thing. So I'll just change the values here to, right? So now what I can do, I can just call, instead of SMS strategy, I'll just call BB strategy and it will give me 300. So that is the flexibility of these decorators and the usefulness of these decorators, right? So now let's create another example which can be really used somewhere. So what we will do, I'll just copy and paste this whole here, and I'll just remove this from, and I'll just change this modify strategy. So I'll write here the function name as calculate execution time, correct? And it can be same initializing modified strategy, and here we can print the starting time. So for that, module import date time from date time import date time, and what we can do here, we can print the starting time, right? So in that way, so can be date time dot now, right? And similarly, after the program has finished, we can also print that time also here, right? So date time, and here the formatted string. So now I guess we are good to go, because it will print before the function call and after the function call. And so now what we can do, we can simply call this function. So instead of modified strategy, we have to now call this calculate execution time. And when we hit shift enter, so now you can see that we have the starting time and the end time. Here actually the time difference is very, very less, because a very small program. So for that, you can have like a bigger value, right? So for that, what you will do, go to this BB strategy, and here you can import time also, and for that you can make it sleep. So time dot sleep, and let's say give it 5 seconds. So now when you hit shift enter, it will start at 6:24:19, and then you will be having 6:24 and 24. So means it slept for 5 seconds, and you can calculate the starting time and the end time. So that is very useful really in the algo trading. Just practice few questions, you will realize that how useful this is, right? Now what we can do, we can also run this in the Python tutor. So let's go there and check, because here visualization is very important. You should be having a clear picture in your mind that what is happening here. So I'll just copy and paste this to the Python tutor. Okay, we have the Python tutor here, and so let's click on the visualize execution. It says time not found or not supported. I guess they have blocked this feature because it might hang their website. So what we will do, we'll just remove this from the code for now. Now we click on visualize execution. Now let's click on the next, and we have a global namespace. It will skip the whole function, and it will go to the next variable create data, and now it will go again to the next function. It will skip all the function, and now we have a function call, right? And you can see now that in the global namespace, we have date time, BB strategy, trade data, calculate execution time. These all are the global namespace keys, correct? And this one is the local namespace of the calculate execution time function. So now when we click on next, it will print the initializing modified strategy, correct? And also the time. You can see here. Now it will go to this BB strategy, and you can see here BB strategy and trade data and the value of the dictionary here. Again, next, the function execution will happen here. Next, and it will return 300, right? So it will print out that here. And next, again, the ending modified strategy. So it will print out that execution time, the end time. And so you can think that only the global namespace remains there. Otherwise, all the local namespaces, the function calls vanished as soon as the function execution finishes, right? So this is how it works. Let me again open the Visual Studio Code, proceed with the further examples. So here we can see that this function was working as a decorator. But what if we can simplify this? Because it is a little bit complex process, right? We have to call the function, then again we have to pass the function here, the variable here. So let me make it a little bit simpler. What I'll do here, so I'll create another function inside this, and I'll give it a name wrapper. And generally in decorators, the name is wrapper only. So wrapper, and here this dynamic data can be passed here, and this can be inside this wrapper, and this function will now return this wrapper. So return wrapper. Let's not remove this. I'll just comment it out. So now what is happening? We have decorator function, and we have a base function. This will be the strategy. Like it can be variable. When we have multiple strategies, we can have anything here, but this will be fixed, right? So instead of calling this function like this, what we will do, I'll just go here and add at the rate and the name of the function. So it is calculate execution time, and that's it. So when I hit shift enter, okay, now we are getting the error. So actually what is happening here, we have defined this decorator function here. So we have to write this. Now what we will do, we'll just call this BB strategy and trade data, this function, and it will work like a charm. You can see here, it will just wait for 5 seconds and it will print out that. So this is how we can use decorator, and you have seen that whenever we want to make any function decorator, we have to add the at the rate, and that's it. So like you can create here multiple functions and you can use all those functions with this decorator. So let's try another example. Let's say we have this, instead of BB, we have mean reversion, just the name, and here I'll change the values to 1000, 2000, 3000, 4000, and 5000. Correct? And I'll simply call this function here, and when I hit shift enter, it will wait for 5 seconds, the sleep time, and it will give us the results 3000. Right? So hope you are able to understand what I'm trying to say. And this is really very, very simple, and just have to focus a little bit and you are good to go. Correct? Okay, now let's create a function which can be really used in real life situation. So I'll create a function with the name calculate PNL. Correct? And what it will receive in parameters, it will receive profit, and it will simply print that. So print and a formatted string, and here it can be, let's say, profit, and here it will be the profit. Correct? Similarly, we have another function define, and it will log trades, right? So log trade, so it will receive a symbol here, and similarly it will also print out the symbol name. So symbol SYM, symbol. Correct? So now we should be having a decorator which handles these functions. Now we want to check that we should be having a function which can check whether this is a float or not. So if the parameter is not float, it will raise an error. And similarly in this function, if the parameter is not string, it will raise an error. So what we can do, let's say we have a function with the name sanity check, right? And we are passing a float here, a float. Correct? And here also the same decorator, but here we are passing the sanity check and str. Like you can also create this function first, but for better understanding, what we can do, we can just give it the name here, and we know that when we call this function, we are also passing this float as an argument here, right? And similarly in here it is string. So what we will do now let's create the sanity check. So what we'll do, I'll create sanity check function, and here what we will receive, we will receive the data type, right? So data type. And then we have to create a function, the outer function. So define outer wrapper, and it will receive the function name, right? The func name, and inside that we have another wrapper which can be inner wrapper, and it will receive the args. Correct? Because it can be multiple arguments, so that's why this. And now we check if is instance. Why? Because we are expecting that data type float or string here, and the argument should be the subclass of that. And if you remember, we have already studied this is instance previously. So if you have any doubt, let me know in the comments. Definitely we can again understand in the next classes. So what I'll do here, I'll write args, and is means here args is the subclass of this data type or not, right? If it is true, then what it will do, it will return the func name, and inside that it will return the data type. Simple. If not, else it will raise, print an error. Let's say we can give it the name type error. You can say data type not correct. We can also use the error handling here, no problem. Now what will happen, we'll just return the inner wrapper, and again here also return the outer wrapper. Correct? So one more thing, you need to make sure that you have to define this before this. So I can write it here, and we can write these functions here, right? So when you hit shift enter, it works fine. It will not throw any error. So now what you can do, you can simply call this function. So calculate profit, and here let's give 256. Okay, now we are getting this profit class float. So actually we have made some mistake here, and the mistake was this. So actually we need to return the args, right? So okay, now when we hit shift enter, we get the profit as 256. But let's say if I just pass here a string 256, it will throw an error that data type is not correct. Similarly, for this log trade, what we can do, I can just call log trade, and inside that I can pass a symbol, let's say BTC, and when I hit shift enter, it will return a, okay, I need to change this. Yeah, it will return a symbol, but if I just pass any other, let's say 200, it will throw an error that data type is not correct. So that's how it works, and it's really very easy. So let's start with the first important and fundamental library, that is NumPy. NumPy stands for numerical Python. In short, or in a single line, you can say that NumPy is the fundamental package for scientific computing. And why fundamental? Because all of the advanced packages or the libraries or the modules somehow uses the NumPy. So NumPy is the essential package for scientific computing in Python. It provides support for large multidimensional arrays and matrices, because we can have 1D arrays, 2D arrays, 3D arrays. So that's why you can say it provides support for the large multidimensional arrays. Next, library components. It offers a multidimensional array object, which we have seen already, and it includes derived objects such as masked arrays and matrices. The main highlight, you can say, that is the multidimensional array object, and from that there are so many derived objects also, such as masked arrays and matrices. And it also provides a collection of routines for fast array operations, because we know that other Python sequences like lists, dictionaries, all are slow compared to the NumPy. And let me tell you that why NumPy was introduced. In the infant stage, that time initially people were using MATLAB R for the machine learning operations. But the issue was that the MATLAB and R was a little bit tough to learn, because in machine learning, people were coming from the so many various fields, like from the mathematics, from the science, even from the arts and commerce. So it becomes a little bit hard to learn those languages, right? But everyone knew that Python is simpler, correct? But the issue was that the Python was so slow, and the NumPy solves the biggest problem of Python, that is the slowness. It's somehow able to pace with the other languages in terms of speed. So that's why it was introduced. And next, in the array operations, it can support a wide range of mathematical operations. It can facilitate logical operations on arrays. It also allows for efficient reshaping and resizing of arrays. It also includes functions for sorting and selecting elements, then input-output operations. It also offers tools for performing discrete Fourier transforms. It provides basic linear algebra operations. It includes basic statistical functions, and it facilitates random number generation and simulations. So the core object is the ND array. This is the central feature of NumPy, the ND array object. It encapsulates n-dimensional arrays of homogeneous data types, because we know that list is a heterogeneous data type, because it can contain a string, integer, float, or any other data type. But this ND array encapsulates the homogeneous data types, and because of that, it is way faster than the Python lists. Now let's compare NumPy arrays and Python sequences. Python sequences includes lists, dictionaries, sets, and many more. So let's start. The first point is fixed size. NumPy arrays have a fixed size at creation, unlike Python list, which can grow dynamically. We know that there is no limit on the list number of elements. We can have as much as we want. So NumPy arrays have a fixed size, and because of that, it is faster. Then one more point, that Changing the size of an ND array creates a new array and deletes the original. We cannot extend the original array in order to change the size. What will happen? The original array will be deleted and a new array will be created. The next point is homogeneous data types. We can have all the data types like list, dictionary, string, integer, float, anything. But in NumPy array, all elements must be of the same data type. And because of that, all the elements are of same size. The next is efficiency in operations. NumPy arrays support advanced mathematical and other operations on large data sets. Such operations are typically more efficient and require less code than using Python's built-in sequences. Of course, because of the fixed size and the homogeneous data type, we know that we have to write the less code and it will be more efficient than the Python sequence. The last one is the wide adoption in scientific and mathematical packages. Many scientific and mathematical Python-based packages use NumPy arrays. These packages often support Python sequence input but convert such input to NumPy arrays for processing. They frequently output results as NumPy arrays. So now as we are learning algo trading, we need to know the use cases of NumPy arrays in algo trading. The first use case is the data preparation and cleaning. So inside that we can transform the data, like convert row trading data into structured format for analysis. We can also use NumPy to handle the missing values. So it can fill or interpolate missing data points in price series. Don't worry, we'll learn all these codes in upcoming video. Don't worry. For now, just focus on the theory part. Okay. Next is that technical analysis. So we can use NumPy to calculate indicators. We can use NumPy to analyze the trends, right? The next use case is the portfolio management. So inside that, we can use in the risk management. So it can calculate the covariance matrices and perform risk analysis. And we can also use in the optimization, correct? Next use case is the statistical analysis. So inside that, we can use NumPy for the simulating price paths. It can generate synthetic price data for backtesting, and it can also use in the hypothesis testing. So it can perform statistical tests to validate trading strategies. Don't worry, we'll learn all the code and you will be pro in that. Don't worry. Just now focus on theory. That's it. The last use case is the performance measurement. So we can use NumPy to calculate this Sharpe ratio calculation and also the drawdown analysis. We'll be always using the NumPy, but these are some specific use cases. Okay, so now without further ado, let's dive into the coding part of this NumPy and see the extraordinary usefulness of the NumPy in algo trading. Let's get started and learn how to create NumPy arrays. So first thing first, you need to import the library. So you need to write import NumPy. That's it. But if you want to avoid writing NumPy again and again, you can just write as NP, or you can write whatever you want. But NP is a general convention, so everyone uses NP only, right? So import NumPy as NP. Then what you can do, you can write NP dot array, and inside that you can pass a list. It's that simple. So this is a 1D array, right? But if you want to create 2D and 3D arrays, what you can do, for 2D, you just need to have two lists, right? So I'll just copy it, add another square bracket, will give comma, and again list. Means in 2D we have two lists. So here we can see that we have two brackets opening and closing. So it will be a 2D array. So when I hit shift enter, 2D array will get printed out. Now similarly for 3D, what I can do, I can just copy and paste the same again. Means I'll copy it, then I'll add another bracket, and inside that I'll hit a comma and I'll paste the same thing. Means 3D array is the combination of two 2D arrays. So it's that simple, and when I hit shift enter, we'll get a 3D array. So the next is D type. So it is interesting because if you want to create an array with the data type of your own choice, what you can do, you can simply write let's say np dot array, and let's pass a list 1 2 3 for 1D array, and here after comma you can type D type, and here you can write like int 32. So you will get an array of int 32. Okay, here you have to give np dot int 32. You will get an array of integer 32. If you want, you can also create an array with the string data type. So how you can achieve that? You just have to write str, but this will throw an error. So you have to remove this np dot. So from here, this np dot, and you will get an array with the string data types, right? So the next is np.arange. If you have understood the range function in the list and other data types, then it's very easy. It's exactly the same like range. So how you can use that? You just have to write np.arange, and then you have to give the range. So the first can be the lower range. So let's say 0 up to 12. Similarly, the 0 will be included and 12 will be the excluded, right? So when you hit shift enter, you will get an array from 0 to 11. And also you can use the step size. So let's say 2, then it will give you 6 numbers with the step size of 2. So it is really easy, exactly same like the range function, which we have already studied earlier, right? Next is the reshape, and reshape is generally used with the combination of a range. So let's try it. So what I'll do, I'll just copy and paste the a range here, and here for now I'll just remove this 2, and I'll type reshape and 2 by 6. Why? Because we know that this is from 0 to 11, the 11 number of items, and generally it gives us a 1D array. But if I want to arrange 2D array, so I can use this reshape function, and when I hit shift enter, you will get a 2D array. And similarly, if you want to get a 3D array, what you can do? You can write 2 and 2 by 3. You just have to make sure that this is the number of items should be equal to the numbers here, right? So what is the meaning of this? We will be having two 2D arrays of 2 by 3 in the 3D array, right? So when I hit shift enter, we will get a 3D array which is having 2 items. The first item is the 2D array, and the second item is also a 2D array. Now we have np.ones and np.zeros. So what we can do? We can form a matrix with all the zeros or all the ones. So how we can achieve that? I'll just write np.ones, and inside that I'll pass the size. So 2 by 3 will get a 2D array. If I want 3D array, what I can do? I can write 2 items of 2 by 3 in 3D array, right? So when I hit shift enter, we'll get a 3D array. Similarly, if you just want a 1D array of ones, you can just write any number, let's say 6, and you will get the 6 items with 1D array. Similarly, we can apply this for zeros. So np.zeros, and so let's say I want a matrix of 4 by 3. So 4 by 3, and I have to enclose this in the parenthesis. And when I hit shift enter, I'll get a 3D array of all the zeros. Sometimes it is very useful in the NLP, which we will learn in the later videos. And the next is the np.random. So the name itself signifies that we can get a matrix with any random numbers. So let's say np.random, and here let's say I give 3 by 4. So it says module object is not callable. Okay, actually we have to write again random, and we will get a 2D array of 3 by 4, 3 rows and 4 columns, right? So next is np.linspace. Linspace stands for linear space, or we can say linearly space. So np.linspace. So here we can provide a range of, let's say 1 to 10, and we want 10 numbers of linearly spaced. So when I hit shift enter, we get a 1D array, and all the numbers are linearly spaced. Let's say if I give here 3, so it will give, like on a line, it will give 3 points, and the distance between all those points is linear, the same. So this is how you can use this linear space. And let me give you another example. I want from 1 to 100, let's say 25 numbers, right? So you will get 25 numbers, and all are having a same distance, right, on a line. Next we have is the np.identity. So if you have studied in the mathematics, the identity matrix, which have all the diagonal points as same, the ones, right? So when I write np.identity, and I can give any number, let's say if I give 4, so we'll get a 4 by 4 matrix, and all diagonals are having the same value as 1. Hope it is all clear so far, because these all are very easy. Let's quickly revise this. that we have studied the theory first, then we have learned how to create arrays, 1D, 2D, and 3D arrays. Then we have learned that how we can change the data type of any array. And with the help of D type, we can optimize our array. Because sometimes when you have a very large file, like let's say 10 GB, and if you are optimizing that, if you are converting the integer 64 to integer 32, and then definitely the size of that file will be reduced to half. Because sometimes, let's say, if you are storing the age of any person, right? So age we can just store with the int 32. No need to store with the float. If we convert from float to integer 32, then the size will be reduced to almost half. So that's how you can optimize your files, your code, and that's how your code becomes more efficient, more faster, right? Then we have learned the np.arrange with reshape, and the ones and zeros, sometimes these are used in the initialization. So we have learned 3 ways to initialize any array: the ones, the zeros, and the random. Right. Then we have learned about the linear space. Then we can have the equidistance points on any range. Then in the last, we have learned the np.identity. Right. So far, I think everything should be crystal clear. And if you have any doubt, please let me know in the comments. Now let's quickly move to the array attributes. We have learned in the classes that a class contains 2 things. One is methods and another is attributes, right? So we have the array attributes, the ndim, shape, size, item size, and detail. We have actually more attributes, but for now, these are the most important. And along the way, if you require anything else, we'll learn that, right? So let's say we create 3 arrays here. A1 is equals to np.array. Let's pass a list here, 1, 2, 3. And similarly, I'll just copy and paste this. And I'll make it A2, and this can be a 2D array. So I'll add another bracket. I'll give comma here, and it is a 2D array. And let's create a 3D array similarly. So I'll make it A3, and I'll copy this 2D array because we know that a 3D array is the combination of 2D array. So I'll give another bracket, and with the help of a comma, I'll paste a 2D array, right? We can check with A1, yeah, it's 1D array, A2, 2D, and A3 is 3D, right? Now let's check the ndim. So ndim is the n dimensions. It tells us the dimensions of any array. So when we check the dimension of A1, it gives us 1 because it is 1D array, of course. And when we check of A2, it is 2D. And for A3, it is 3D. Now we have the shape. So it tells us the shape of any array. So let's check for the A1. So for A1, it is 3 because we know that it is a 1D array and it has 3 elements, right? Similarly, for the A2, it is 2 by 3, right? 2 rows and 3 columns. And similarly for A3, it is like 2D arrays of 2 by 3, right? In 3D, what happens? It will tell us that it has 2 items and each have the shape of 2 by 3, 2 rows and 3 columns, right? The next we have is size. So when we check the size of A1, it is 3 because it has 3 elements, correct? And I'm sure that you have guessed about A2 and A3 also the size. So A2 have size of 6 because it has the 6 elements, 1, 2, 3, 1, 2, 3, which is 6. Similarly for A3, what it will be? Yes, you guessed it right. It will be 12. And now the next is item size. So it tells us the size of every item, right? So let's check for A1. So A1 item size. We know that in A1 we have, like by default, we have float here, right? So it is 8. In A1, if I want to change this, I can change with the help of D type. And let's say I make it np int 32. Because we know that we can store these values in 32-bit also, right? So when I hit shift enter here, and again, when I check this item size, it is 4. So that's how you can optimize your code, right? And now when we check for A2 and A3, it will be 8, 8 because all have default is float in the NumPy. So that's why it is 8 bytes, right? Next is data type. We have already studied. We can change the data type of any array. Let's say I'll make it str, and then we will check the size. So when I hit shift enter, and now when I check the size of item size of A1, it is 4, right? Okay, now the next is changing data type. So let's say let's say I have this A3 and I want to change the data type. So what I can do, I can type AS type, and here I can give anything. Let's say if I change to np.int64, I can do that. You have two ways. One is to assign the data type while creating the array. Another is to change with the help of AS type. These are very simple and very easy operations. You can just practice. I'll give some multiple choice questions and the task for you to practice. So please make sure that you are practicing those, and it will really help you. Let's quickly start with some NumPy array operations, right? So in array operations, we have scalar operations and we have vector operations, correct? In scalar, like we have this array of open, high, low, close prices, and when we multiply this with like 2, so what will happen? This array will become like this, like all the elements will be multiplied by 2 and it will become like 200, then 202.1, like this in scalar. And in vector, what happens? Vector means both the values are an array. So because this is also a vector, correct? And this is also a vector. So these both arrays will be multiplied, and this value and this element will be multiplied by this element, and you can say that same position elements will be multiplied. So scalar means just 2 and vector means this whole array, right? So these are the arithmetic operations. Don't worry, we'll just take some examples also. For now, just focus on the concepts, okay? Then we have the relational operations, right? So in relational, what happens? In Python, if there is any element which is non-empty, right? It can be anything, 1, 2, 3, 4. It is always true. And if the element is empty, it is false, right? So if we apply a relational operation on this, what will happen? Let's say OHLC. So the variable name is OHLC data day 1. So what I'll say, if I say OHLC data day 1 is equal to 100. So now what will happen? It will print out a value and all these values will be true and false, right? True, false. So if any element is equal to 100, it will be true. Otherwise, rest will be false. So it will be false, it will be false, it will be false. Again, like all the values will be false, except this first value. So that is the relational operation in Python. Then we have some functions like minimum, maximum, sum, product, and so on. So what happens? If we apply these operations on 1D array, it is straightforward, simple, right? Let's say we have an array 1, 2, 3, and if I apply minimum on this, so let's say it is equals to 1. If I write like minimum of a, what it will be? It will be 1, right? Similarly, if we have a two-dimensional array, let's say if we have this one, so when we apply minimum on this, what will happen? We'll get the smallest value, so which can be, let's say 100, this one. So we'll get this output. Same goes for the maximum, and for whatever the value we provide, it will be multiplied by that, right? Next, we have a very interesting part, which is indexing and slicing, and which we have already learned previously many times. It is exactly the same, but now we have 1D, 2D, and 3D arrays. So it is slightly different, but not difficult. Just you have to focus and we are good to go. Okay, so let's say we have these two arrays. Okay, let me remove this. And first we learn indexing. So before that, what I will do for 1D, it's very simple. Let's say if I have a is equals to 1, 2, and 3, 4. And if I want any value like, let's say 2, what I can do, I can just write a1 and it will print out 2. Now we have this 2D array. We have these two 2D arrays, correct? And let's say if I want to find this value, so what will be the index of that? For that, what you can do, you can just write like, I will not write this whole, I'll just write OHLC, and inside that, see, first we have to write the row number. So it is 0, 1, and 2. So it will be 1. And now we have this column 0, 1, 2, 3. So it is in the first column. So if we write 1 and 1, we will get this value. Simple, right? And now you pause the video and let me know the index of this value. Let me write it. It will be, you can say OHLC. Then we know that this is the second row. So it will be 2. Then the column will be 0, 1, 2, 3. So it will be 3. So this is the index of this value. correct? Now when we go for the slicing of 2D arrays, what I can do, let's say if I want these two values, for that I need to use slicing. So what I can do, I can write OHLC, and inside that, we know that this is the first row, means 0, 1, 2, means it is the 0th row. So I'll write 0. Now I'll give a comma here, and next we have to write the columns. For column, it is 0, 1, 2, 3, and let me write it 0, 1, 2, 3, and I want these two. So for that I need to use slicing. So it will be 1, 2, 3, correct? Because this is included and this is excluded, so it will only give 1 and 2, correct? This is how we'll get this value. Don't worry, we will just attempt all these examples in the code, but for now it is very important to understand the concept right now, so that while coding you will have no issues. Let's say we have this OHLC price data and I want these 4 values, only these. For that, what we can do, I'll just write the index here. So we know that this is 0, 1 and 2. So we want these 1 and 2 column. So what I'll do, I'll write 1 and I can leave like this. So it will cover all the rows, right? Then I can give a comma, and for the columns, it will be 0, 1, 2, 3. So I can start from 2 and just leave it. So 2 and just leave it. It will cover both the columns, correct? And this is how you can get these values. Now we have the little bit tricky part, which is 3D arrays. So 3D arrays are nothing but just the combination of 2D arrays, right? So let me first explain you something. So what is 1D array? 1D array is like this: 1, 2, 3, and 4, correct? 2D array is the combination of 1D array. So how we can make a 2D array? I can just write like 1, 2, 3, 4. And when we have two 1D arrays, it becomes a 2D array. Hope you are getting my point, what I'm trying to say, correct? So this is a 2D array. Similarly, what is a 3D array? It is the combination of 2D arrays. So if I write these 2D arrays twice, what I can do, I can write like 1, 2, 3, 4, and again 1, 2, 3, 4. So this is one item of the 3D array, and again when I write 1, 2, 3, 4, 1, 2, 3, 4, it becomes the second element. And when I write like this, it becomes a 3D array. So that means we can say that 3D array has two elements, right? The first is this 2D array, second is this 2D array, correct? And then both the 2D arrays are of the size of 2 by 4, right? This is 2 by 4, 2 rows and 4 columns. Similarly, this. And now what I'll do, I'll just create a 3D array. And how I can do that? I can just add these 2D arrays. So just for the example, what you can do, you can consider this as a 3D array. This, I'll just draw a line for your understanding. Okay, let me draw it clear so you will not retaliate. Okay, let's say this is my beautiful line and a 3D array, correct? Just consider it. And actually it is, because we have two elements. I'll give a comma here. Now, how can I represent this array? So I can write like this 3D array has two 2D elements, correct? The first is this one, second is this one. Or if you write index wise, we can write like this is 0 and this is 1, right? Then both the elements have 3 rows and 4 columns. That's a basic idea. Now, for the indexing of 3D arrays, how we can index these? So if I just write like, if I take this, like the name of this variable is OHLC, and if I write like OHLC and 0, then what will happen? This whole 2D array will be printed out, correct? But if I want this value, then what I'll write? I'll write like OHLC 0, and we know that this is the 0 row, 1 and 2, and this one is at the first row. Again, the column number will be 0, 1, 2, so it is at the second column. So this is how you can access this element. So this is how we can use the indexing. Again, let's take another example. I would like to access this element. So what I can do, we know that this is the second element of the array. So I'll write 1, this one, right? 1, Then this is the third row, 0, 1, 2. So I'll write 2. And again, this is the last column. So 0, 1, 2, 3. I can write 3. And we will get this value. We will see all these examples in the code. Don't worry about that, right? The last thing is the slicing. Why I'm showing you here? Because it becomes really crucial, a visual picture in your mind. So if you have the mental picture, it becomes so easy to solve all these examples, right? The last thing is the slicing of 3D arrays. So let me just remove all these. Let's say I want this value. How we can get that? So as we considered this a whole 3D array, because this is the combination of two 2D arrays, right? 2D and 2D, correct? And the index of these is, this is 0 and 1. As we want this one, so what I'll do, I'll write OHLC, and inside that we know that this is the first element, first, right? Then we know that we need all 3 rows, so 0, 1, 2. So I can just write like this, as we have learned in the Python previously, right? So it will print out all the columns, all the rows. Then I know that in column I need only these 2 columns, so 0, 1, 2, 3. So I can write like from 1 to 2. So for that I need to write 1 to 3, because this is including and this is excluding, so it will just print out 1 and 2. And this is how you can get this with the help of slicing. This is really simple but very tricky, so make sure you are learning this properly, and then slicing becomes very easy concept for you. Now one more thing I would like to show you in this notepad, that one concept, stacking and splitting. Then we'll move to the code, right? So when we talk about stacking, let's say we have these 2 2D arrays, right? These are 2 2D arrays. And when we talk about stacking, stacking means to keep one thing over the other. So when I want to stack these 2 arrays, so for the horizontal, what will happen? I can just stack like this. So it is the horizontal stacking. Similarly, for the vertical stacking, you can stack like this. I wanted to show you a visual, that's why I'm doing this much effort. This is the vertical stacking. So like when we do the vertical stacking, what will happen? Earlier we had the array of 3 by 4 and this also 3 by 4. So when we do the vertical stacking, what will happen? We get an array of 6 by 4. And when we perform the horizontal stacking, what will happen? As these both are 3 by 4, so it will become 3 by 8 after the H stack, which is horizontal stacking. And the same concept is for the splitting. Splitting, what happens? When we have a big array and we want to split that. So splitting can also happen in horizontally and vertically, same like stacking. So that was the visual representation. And now let's move to the code examples, right? Okay, let's start the examples. So we have 2 2D arrays of the OHLC prices, and let's try to find out the max, min, and sum and prod. So what I'll do, first we have to import. So import NumPy as np. Then what I can do, I can write like np dot max, right? And we can write the variable name. So it is OHLC data day 1, and when I shift enter, it will give me the maximum value, which is 103.0. Correct? Same goes for the minimum. This is 99.5. And when we apply the sum, so np.sum, which gives me the sum of all the values, right? And product means it will multiply all the values. So it is the 1.16 e to the power 24. Okay, let me show you these operations also, the scalar and vector. So what we can do, we can go here and I can write OHLC data day 1 multiplied by 2. So 2 is scalar. So when I write like shift enter, it multiplied all the values with 2, right? Similarly, if I check the relational, so for that what I can do, I can write is equal to, and let's say we have any value, let's say 100. So if I write 100.0, so it will just give true for the one value, because we know 100 is the first value
rest all values are not 100, so it will give the false value for that. Correct. Similarly, for the vector operations, instead of 2, we can have another vector. So let's say OHLC data day 1 multiplied by OHLC data day 2. So when you perform that, it will multiply all the values like from 100 to 200, then again 101.5 to 201.5. So it's like that. It's very easy. It's not difficult actually, the operations. Now we have the mean, median, standard deviation, and variance. So don't worry, we'll learn all these concepts in the statistics part of the future videos, right? So it's very easy. You can just write like np dot mean and OHLC, and it will give you the mean of that. Similarly, if you want to find the median for standard deviation, you will get that also, and for variance, just var. It becomes so easy with the NumPy. Otherwise, we have to write the whole function to calculate the standard deviation. We have to write the formula and so many things, right? But with the help of NumPy functions, it becomes so easy, and we can focus on the main thing, right? And then again, trigonometric functions. Actually, these are not used so much, but still, just for the sake of this example, we can check that. So sine of, let's say, OHLC, we have to write np dot sine, and it will give all the sine values of the 2D array of OHLC data day 1, right? Now we have the dot product. So in dot product, what happens? Like you have two matrices, right? So one should be 3 by 4 and the second should be 4 by 3 or anything. Means the columns of the first matrix should be equal to the rows of the second matrix. Then only it will work. If I try on something else, it will not work. Let me show you something. And don't worry, we'll explain this whole mathematical concept in the mathematics part. So for now, just understand this. So if I write np dot OHLC day 1 and OHLC day 2, and when I shift enter, it will not work because OHLC day 1, it is 3 by 4, and same, it is also 3 by 4. So in order to work this should be at least 4 by 3. What I can do, I can just copy and paste another row here, and I'll just give a comma and shift enter, and now when I run this dot product, it will work. Means column of the first should be equal to the rows of the second, and I'll explain you the whole process in very detail. Don't worry. For now, just understand that the columns of the first matrix should be equal to the rows of the second matrix for the dot product. Okay. Next, we have the logs and exponents. So it is also very easy. We can just like write np exponents and the any matrix. So OHLC, it will give all the exponents value of the matrix, right? Similarly, for the round, floor, and seal, what you can do, you can round off the values. So let's say np dot round and any matrix here. So I can give this, and it will round all the values. Means it will remove all the values after the decimal. So it will just give the round off value. So in floor, what happens? Let me show you. Floor means the below value, and seal means the top value, as the name also signifies the same. So let's say if we apply, let me take this only. So if I apply floor on this, what will happen? It will give me the minimum values. So for this, it will be 100 for sure. This will, it is 0.5. Let me change these values actually to get you more understanding. So this can be 1, and this can be 9, and this can be 3. So okay, now we can apply the floor here. So let's say np dot floor and OHLC day 1. So you can see that it is giving us the lower values, and if I apply here the seal, it will give us the upper values. I hope you are able to understand this. Let me show you. The upper means when it is 100.1. So if I apply floor, it will give the 100. If I apply seal, it will give the 101. Right? Floor means lower and seal means upper. That's it. Very simple. Now we have the indexing and slicing, which we have already understood with the help of some visualization. But let me show you the real examples. So what I can do, I can just copy and paste this again here for the better understanding, right?
And let's try to understand the indexing first. So what I will do, I'll have another 1D array first. So to build the momentum, if I want the value of A5, so I can just write A5 and it will give me the whole value. If I want, let's say, the first value, I can write the index number 0. That's very straightforward. If I want like just 2, 3, 4, how can I write? I can write the slicing. So the slicing of 1D arrays. So 2 is at 1 and 4 is at the 0, 1, 2, 3, 4. So I can write 4 and it will give me 2, 3, 4. Like that's very easy. So we have done the indexing and slicing for the 1D arrays. Now let's move to the 2D arrays. So I'll hit shift enter and I'll use this now. Okay. So now if I just write like this, it will print out the whole array. But let's say only the first row, right? So for that, what you can write like, if you write 0, means this will be, right? And we want all the columns then, right? So for that, you need to write like this. And when you hit shift enter, you get the first row. Hope it's very clear, right? It's not difficult. And let's say if I want this last column, the whole column, for that what you can do, you can write the last column means I want all the rows. So I can write like just a column and the last column will be 0, 1, 2, 3. So I'll just write 3 and it will print out the last column 101, 101.8 and 102.5. Now let's make it more interesting. I want these 4 values 102.9, 100.5, 103.0 and 101.0. So for that, what I can do, first we will check the rows. So 0 not needed. I only need the 1 and 2. So I will write like 1 and rest it will cover the last also. So 1 and 2 the rows. Then I need only these 2 columns. So I'll ignore the first 0 and the last 3. I just want these 2. So for that I can write 1 colon 3, 1 colon 3, and now when I shift enter, it will give me all these 4 values. Hope it's very clear, right? I'll also post some multiple choice questions and task questions. So please make sure to practice all those questions. It will really help you a lot. Okay, now let's move to the 3D arrays. And for that, we will see the indexing and slicing of the 3D arrays. Now let's first create the 3D array. So for that, what I can do, I can just write np.arange and I can give from 0 to 24. And again, I can reshape into a 3D array. So let's say 2, 3 and 4 and it should print out a 3D array. Yeah. So now we know that this is the first element of the 3D array and this is the second element of the 3D array. If I want to print out the element, what I can do, I can write, okay, let me assign it to any variable. Let's say now let me print this. So 3D array and 0. It will give the first element. If I write the 1, it will give me the second element, right? Now, suppose I want only these values, this 5, 6, 9 and 10. So for that, what I can do, first I have to print this one. So I'll just print 0. So it will give me this one, the first 2D matrix. Then the rest is same like the 2D matrix we have already done previously. So I want 5, 6, 9, 10. So we know that this is at the 1 and 2 rows. So I'll write like 1 and for 2 I can leave it blank. Again, I need these columns. So 0, 1, 2, 3. So 1 and 2. So for that I need to write 1 column 3 and it should print out the 5, 6, 9, 10. Correct? Let's take another example. I want this time these 14, 15, 18, 19, 22, 23. Just pause the video and you let me know the answer of this, that how we can print these last 6 values 14, 15, 18, 19, 22 and 23. Okay, just pause the video and meanwhile I'll solve this. So we know that this is the second element, so I have to write 1. Then I need all the 3 rows. So for that I can just leave a column Then I just need the last two columns, right? So 0, 1, and 2. So I can write 2 colon and I can leave it blank and it will print out all the 6 elements. So now let's say I want 2, 3, 10, 11, 18, 19. This is a little bit complex, but not so complex. It can be easier also. Just depends on your thinking. Okay, let me show you. So we know that we need both the elements. So I can just write like this. It will print out both the elements. Now, second, I need the 2, 3, and 10, 11 from the first, right? So for that, so I need to write a step for the first, correct? So it will print the 2, 3, 10, 11, and 14, 15, and 23. I just need 2, 3, 10, 11, and 18, 19. So row also, I just need to print the last ones. 0, 1, from 2, I can print. So it will print 2, 3, 10, 11. For the second element, it will be the 14, 15, and 23 and 23. Actually, we were doing the step. So for step, it is correct actually, right? And if you want the second element, 18 and 19, it becomes a little bit complex. Now let's make it a little bit tricky. It's easy, but tricky. So just pause the video and think that how we can get those values. So I want to print only 2, 3, 10, 11, 14, 15, and 22, 23. Just think, it's very easy, very simple. So now we know that we need both the elements. So for that, I'll just write a colon. It will print both the elements. Then we know that I need the alternate rows. So for that, I'll give a step size 2. So it will give me 2, 3, 10, 11, 14, 15, 22, 23. But I don't want these values. So for that, in the column, what I can do, I can just write 0, 1, 2, 3. So after 2, I can leave it blank and it will print out the 2, 3, 10, 11, 14, 15, and 22, 23. So this is how you can do this. Just perform some questions of MCQ and task and you will be good to go. Right. Okay, now we have the iterations. So iteration also very easy, not difficult. Let's say if I want to print for the like 1D array, it's very easy. A6 equals to 1, 2, 3, which we have seen previously in all the list and everything. So if I write like for I in A6 and if I print I, it will print all the values. But now we have the 2D array. So for 2D array, I can just replace this A6 with the 2D array and it will print the rows here, right? All the rows, the first row, second row, third row. But I want all the elements to get printed out. So for that, we have a very good function in this, and that is np dot. But what I want to print all the elements of this array. So for that, we have a very good function in NumPy, that is np dot nditer. What it will do, it will convert all the elements of any array into a series or into a 1D array. It will convert any array, like it can be a 3D, 4D array. It will convert to a 1D array, and then we can use that in the any operation. So when I hit Shift Enter, it will print all the elements, right? So it becomes easy sometimes. And again, one more thing you can use here, that is Ravel, and that also works exactly the same. np.ravel or np.nditer. I'll show you the difference in future, but for now you can think that Ravel and nditer converts any 3D 4D array to a 1D array. Okay. Next we have the reshape. We have already studied, right? And let me show you again. Let's say we have np.arrange. I'm printing any number from 0 to 24. So it will give me a 1D array, but I want a different shape. Let's say I want a matrix of 4 by 6, a 2D matrix, it will give me. But if I want a 3D matrix of 2 elements of 4 by 3, so I can use that reshape and I'll get a 3D matrix, a 3D array of 2 elements of 4 by 3, right? So that's how we can use the reshape. Next we have the transpose. So for transpose, let me show you. First I'll print OHLC day 1. And if I use the transpose here, np dot transpose, you will see that, let me show you again. Now we have 3 by 4 matrix. If I use np.transpose here, np.transpose, it will convert that 3 by 4 into a 4 by 3. Simple. And if you don't want to use the transpose, you can just use np.capital T, and it should also work as same. Okay, actually for that you don't need this. For that you can just write like transpose, and if you want in a short, so ohlc dot t, and this will also work. So it's up to you. You can use this np.transpose, or you can use this dot capital T. Both will work fine. Let me print it for more clarification. Print, and I can print this also. Now we have the Revel. We have already understood that, right? Revel works as the ND iter. It will convert any 3D array to a 1D array. Let me show you that also. And let's say I have this OHLC, and this is a 2D array. And if I apply np.revel, it will convert that 2D array to a 1D array. Okay, now we have stacking and splitting, and I have already explained you this, that stacking is, we have two types of stacking, horizontal and vertical. Similarly, splitting also horizontal and vertical. So let me show you the horizontal stacking. So how we can achieve that? np.addStack, and you can pass both the 2D arrays. Then, and it says, okay, we have to change the size, right? So because it is 3 by 3 and this is 3 by 4, so I can just remove this one row to make it work, and now it works fine. This was also 3 by 4, and it becomes now 3 by 6. Similarly, we can use the vertical stack, so it will stack like vertically. So for that, you just need to change from H to V, and it will be stacked vertically. Very simple. Now let's do one more thing, that I'll make it, I'll just copy and make another variable here, and let's say A7, correct? And when I print A7, it is like 3 by 8 array, I guess. Now if I want to split it horizontally, I can use this hsplit. So for that, I can write np.hsplit, and I can give A7, and in how many parts you want to split. So I just want 2 parts, so it will give me a splitted value. You can see here it has like split it from here 1, and second starts from 200, correct? Similarly, it goes for the horizontal splitting, but now as we have 3 here, so it will not get splitted. So for that, we need to split this in 3 parts. So let me show you. If I try np.vertical split and A7, and in 2 parts, it will show me that array split doesn't result in an equal division. For that, I need to write here 3, and it will give me 3 1D arrays. So the first difference is the data type consistency. Why? Because we know that the Python list can store elements of different data types, right? This flexibility is useful for certain applications, but it comes at the cost of performance and memory efficiency. We know that Python lists have a flexibility that it can store different type of data types in a list, but that comes at the cost of the performance and the memory efficiency, right? Again, in algo trading, you might end up with lists containing mixed data types, which can lead to unexpected behavior or errors during numerical operations. Because in algo trading, we have large data sets, and inside that, if we have different kind of data types, then sometimes it might behave unexpectedly and it might throw error, and which can lead to so many losses, right? You know that. So let's say we have a list which contains all the integers, but somehow there is a string between that and it can cause the error, correct? Now let's check for the NumPy array. So NumPy array require all elements to be of the same data type, because NumPy forces that all the elements should be of same data type. Because of that, it already knows that it is consisting only single data type, and it no need to worry that it might throw an error, right? So this restriction enables NumPy to perform operations more efficiently because it knows the exact type of each element and can optimize C-based operation. This is very important because we know that NumPy array was created in the C. So it can optimize using the C-based operations, because we know that C is significantly faster than the Python. So it is using that particular advantage of C over the Python list. And this is crucial in algo trading where performance is the key. We know that in algo trading, performance is the key. We need to optimize everything. We need to optimize the code. We need to optimize the servers. We need to optimize the network. We need to optimize the databases, and everything should be optimized to get the best performance of any trading system, right? So integers, and here you can see that we have a NumPy array which consists all the data types of same, and it gives us a performance advantage over the Python list. The next is the performance. Python lists are slower for large scale numerical operations because each element can be of any type, right? And the list itself doesn't support vectorized operations. This means that numerical operations often require explicit loops which are slower in Python, because we know that Python list can have any data type. Like if we have a data from, let's say, a price data of the 7 years of any stock, let's say the price data for the Apple from 2010 to 2024, and it is 14 years, and it becomes a large data set. And when if we are using Python list, we know that it will be slower. Why? Because it might consisting of different data types, or because it is also storing the information of the data type of each element and also the reference, the address of that particular element. So it is definitely slower than the NumPy array. I'll show you all these examples in the program, don't worry. For now, just focus on the theory. That's important. Your concept should be very clear. So you can see that we are creating a list comprehension here, and now we are calculating the time, the start time, and here the end time, and between that we are applying a loop, because in list we have to apply the loops. So what we are doing, we are applying on the 1 million random data, and we are multiplying that with the 1.01. So for that operation we have to use the loop, and loops are always slower. We have already studied that, right? We always want to avoid the loops. And when it comes to the NumPy array, NumPy arrays are designed for numerical operations and support vectorized operation, because we know that NumPy arrays are specially designed in C language, and that is significantly faster. And NumPy arrays can also support the vectorized operations. What is the meaning of vectorized operation? Here we need to use the loops in Python list, but here what it can do, it can directly create an array with any random data sets, right? And after that it can multiply in vectorized operation. That means I'll just show you after this topic, the broadcasting. In that you will understand that how vectorized operation works. But for now, you just understand that it can directly multiply this 1.01 to all the elements of this NumPy array directly, right? So it has become significantly faster than the Python list. We'll just implement this program in the code also. Just wait for a few minutes. First, let's complete the theory. Okay. So the first we have seen data type consistency. Second is performance. Third is memory efficiency. As we already know that the elements of the Python list are stored scatteredly in memory, right? So first the elements are stored, and then the Python list is consisting of the address of those elements from the memory, and also the information of that which type of data the element is. So means it is storing three things: the address of the element or the reference, we can say, and again the information of the data type of that element. But in NumPy array, Python already knows that it is consisting of one data type. It can be anything. So it doesn't need to store the data type information for every element. It can just store for only one variable, or you can say one NumPy array, right? Again, it is directly storing the element into the NumPy array. Unlike in the Python list, it is storing the reference of that element, right? So it becomes significantly less memory consuming. I think you are able to get my point. And this particular concept of list we have already studied in the list. So you can just refer, you can see the I button here and click on that, and you can refer that for detailed information on the list element storage, correct? So when we read this, list uses more memory because they store type information, the first, and pointers, and we can say the reference or the address of for each element, right? This overhead can add up quickly with large data sets, making them less memory efficient for algorithmic trading data. Because in algo trading, we have a large amount of data, and it becomes really, really crucial that we are optimizing the memory. And in that context, Python lists are consuming more memory. We'll just check this program in the coding. Just wait. Now let's read for the NumPy array. NumPy arrays are more memory efficient because they store elements in the contiguous block of memory. We know that the arrays are stored in the contiguous block of memory, correct? Let's say we have 1, 2, 3, 4. These all elements are directly stored in the array. But in Python list, what happens? Let's say we have a Python list, and let's say the list have like 1, 2, 3, 4. So what will happen? Now 1 is stored somewhere, 2 is stored somewhere in the memory, again 3 is stored somewhere, and 4 at some other places. These are stored scattered in the memory. So that place will have a memory address, let's say 0xb2, and it is 0xc3, that is, let's say 0x d4, it might be 0xe5, right? Now what will happen? In memory, here we are storing the addresses, like the address of 1 will be stored here, the address of 2 will be stored here, the address of 3 will be stored here, the address of 4 will be stored here, correct? Then it will also storing the type information, that whether this 1 is integer, string, or what. So it becomes more memory consuming, the list. I hope it's very clear now, right? Now let's move to the next part, and which is mathematical operations. Please make sure that you are having a good understanding of these concepts. Just repeat the videos again if you don't get in one time, but at least have everything in your mind. Make a mind map, and it will definitely help you while you will perform the core algo trading after the libraries, right? So performing mathematical operations on Python list requires explicit loops or list comprehensions, which are less efficient and more verbose. Why? Let's say we have a list of these elements, and if you want to check the daily gains, so we have to first apply a list comprehension here, correct? And then it will find the difference, and after that it will divide by the price of that day. So it is using a list comprehension, and it is kind of a loop, and definitely it will be slower. We know that already, right? But in NumPy arrays support vectorized operations, making mathematical computations concise and much faster. This is particularly useful in trading algorithms where you need to perform complex calculations on large datasets. Because in algo trading, sometimes we need to apply so many strategies, so many different formulas, and we also have a large datasets, right? It might be 10 years, 20 years, or it might be a 1-minute frame, 5-minute frame, 15-minute frame. So it becomes a large data sets, and on those we are applying mathematical operations. So it becomes really, really crucial to optimize all the thing, and we cannot do that with the Python list. If you are going with the Python list, then you will be losing all your money to the others who are using the NumPy arrays. So you can see that in NumPy array we have one function, one single line code, np.difference. So it will calculate the difference by applying vectorized operation. Vectorized means, okay, just wait for now. In the next topic, I'll explain you what is vectorized. And if you remember, I have explained you in the previous video also. But don't worry, I'll explain you again after this. Okay, vectorized means it first converts any element to a vector, and after that, it is applying the element to element, right? Let's say the first element of the first array and the first element of the second array. It will multiply directly. No need to apply the loops and anything. So it becomes way faster, right? So yeah, in NumPy, we have function for almost every mathematical operations. You don't need to write any code. With the just help of one single line, you can perform many complex mathematical operations. Yeah, let's move to the next point. Okay, next we have the built-in functions and operations. So in Python list, let's say we want to calculate the mean with the help of Python list. So for that, first we need to calculate the sum of the list, and then we need to calculate the length, right? So we are using the external functions. Then we need to divide that with the sum over the length. So it will take definitely more time and more storage. But in NumPy array, we have one simple function, that is np.mean, and with the help of that, we can directly find the mean of any large amount of data set. Now, the last but not the least, we have multidimensional data, right? So storing and manipulating multidimensional data, example OHLC. OHLC stands for open, high, low, close. We will read this, don't worry, understand in detail. In Python list requires nested lists, which can be cumbersome and error prone. Like we have already learned that when we want to create 1D, 2D and 3D list, we need to manually write everything, right? List inside list. And sometimes it becomes error prone. Let's say if we forget a comma, then it might throw an error. So we want to avoid that. So we can use the NumPy array. And in NumPy array, we can straightforward create 1D, 2D and 3D arrays simply, faster and conveniently. So that's why we are using NumPy arrays, and these are faster, more memory efficient, and you can say overall the best for the numerical operations. So in algo trading, we'll be using it a lot. So you need to have a clear understanding. Make sure that. So after this video, just go and perform all the multiple choice questions to clear your concepts. Then please perform all the tasks which I have given in the description. Correct? Now let's quickly check the summary. So Python list, flexible with mixed data types, easy to use for non-numerical operations. So when we want to use it for the non-numerical operations, we can use a list, right? But this is slower and less memory efficient for large scale numerical computations. So whenever you have a large data set of any numerical computation, please make sure to use NumPy array only. Next, Python lists require more manual handling for mathematical operations and multi-dimensional data. Whereas in NumPy arrays, it is specifically designed for the numerical computations, right? And it is providing better performance, of course, and a better memory efficiency. And it support extensive mathematical functions and are more suitable for handling large data sets and complex operations common in algo trading, because it by default have so many built-in functions for complex mathematical operations and mathematical computations. So it becomes absolutely easy like butter to perform the mathematical operations. So that's why. So we can say that using NumPy arrays is typically advantageous in algo trading due to their efficiency in numerical computations and ability to handle large data sets seamlessly. So hope it's crystal clear. But if you have any doubt, please let me know. Don't keep it to yourself, so we can discuss in further videos, right? So this was the theory, the difference between the Python list and a NumPy array. Now let's quickly move to the examples and let's check it live. Let's start the coding example. So what we'll do here, we'll create two lists and two arrays, and we will check the time of execution of the addition. So we'll add both the arrays and both the list, and we'll check that which takes less time and which takes more time. So first of all, let's create a list. So A is equals to I4 IN, a range of 1 million. And similarly, we can create another list, and I can just change the name to B, and it can range from 1 million to 2 million, right? Now we'll create another list, an empty list, which can store the values after addition, right? And also we need to check the time before execution and after execution, right? For that, what we can do, we can import a library that is time, and here I can give like start equals to time dot time, and yeah, now we'll run a for loop here for the addition. So for I in length range of len a, right? Because we want to iterate the for loop at the same range as we have the number of items in the list. So then what we can do, we can just append c dot append, and inside that we can give ai plus bi, right? Hope you are able to understand what it will do. It will calculate the first element of both the i's and it will append to this list. So this list will be created with the values added, right? So now what I can do, I can print the execution time. So start minus the current time. So let's say time dot time. So now when I hit shift enter, it says me negative of I have to less from this time to start time, of course. And we are getting 0.07, right? So don't make these kind of mistakes in algo trading, right? It might cost you or your company a lot of money. Then let's check same thing for the NumPy. So in NumPy, it's very simple. Let's create an array with the same name A, and here we can use the A range, right? So np dot A range. Okay, actually we need to import the NumPy library here. So import NumPy. If you want as np, if you want as pn, you can do whatever you want. Then A is equals to np dot A range, and here we can give the range same like the above. So 1 million. And similarly for the B, I can write A range, and it ranges from 1 million to 2 million. And now I'll change it to B, correct? So now what we can do, we can again print the time. So start is equals to time dot time and this, and after that we can simply add A plus B, and again we can print the time. So time dot time minus start. Okay, now when we hit shift enter, we get the time 0.001. The same operation in the list taking 0.07, but in NumPy it is just taking 0.001. And let's say when we increase from 1 million to 10 million, let me increase this to 20 million, and here also 10 to 20 million. Now let's check it again. So for list, shift enter, it is taking 0.69 seconds, and for NumPy it is taking 0.07. And let's check how much time it is efficient. So when I divide the list time by the NumPy array time, it gives me 9.18 times. It is almost 10 times faster. Sometimes when you run it again, it can give you less time. Let's see. You can see here and paste. I think second time it stored the cache value, so that's why it is giving less time. And you can see it is 63 times faster, and it becomes a significant number when you have large data sets. So hope we are able to understand why we are using NumPy arrays in algo trading, right? Now we have checked the speed, which is of course faster for the NumPy arrays. Let's check the memory. Okay, so what I'll do, I'll just copy and paste the same program here. Here it is for list, and this is for the NumPy. Correct. I'll just write here list, and I'll comment it out. And this is for NumPy. Okay. What we will do, we will just remove this. We just want to check the size of this array only, right? So for that, what we can do, we can import another library, that is sys, which can help in getting the size of the arrays or the list. So now when I check the size of this, so get size of, and when I give a, it is whatever it is. Okay. Now let's check for the NumPy arrays. So if I write sys dot get size of a, it is 840112, and which is definitely less than that. And let's check how much less. So for that, what we can do, I can just divide the above number with this. And so now let's shift enter, and it says 1.11 time, which is definitely more memory efficient. But in NumPy, you can make it more memory efficient. How? You can just change this to another data type. So what you can do, you can just write d type, and let's make it integer 32, because by default it is float. So sometimes we know that we can just store these values in integer 64 also. So, and for that you have to write np.int32, and now when you check the memory, it is just the half, right? And it becomes, earlier it was just 1.11, now it becomes 2.22 times more efficient. If you want, you can even make it int8, but sometimes if it is required really, then only use that. So it becomes 8 times more efficient in memory, right? So that's how. So like if your file is of 8 GB, it will reduce to 1 GB, which is really significant difference. You know that, right? So that's how you can optimize the speed and the memory of the NumPy arrays, and that's why it is more efficient, right? And the last is the convenience, which we have checked already, that in NumPy we have a lot of mathematical operations, and with the help of just one line of code, we can achieve those mathematical results. But in list, we have to write the whole code to achieve those results. So that's how you can compare the list and NumPy arrays, and which is really, really useful. So please make sure to understand this thoroughly and attempt all the MCQs and the task questions. Now let's start with another very important topic, that is advanced indexing and broadcasting. In previous session, we have already learned about the indexing and slicing of 1D, 2D, and 3D arrays. And now we'll start with the advanced indexing. This is very interesting and very useful. Let's quickly revise the normal indexing. So what happens in normal indexing? We have a 2D array, which is of size like 3 by 4, correct? And I want to extract this 100.5. So what I'll do, I'll just write the row number. So it is 0, 1, 2. So it is in the first row, 1, and then the column number. So 0, 1, 2, 3, and 2. So with this way, we will get the value of 105, right? And when it comes to the normal slicing, how we can achieve that? Let's say if I want to print out these 4 values. So how I can achieve that? First, we will check for the rows. So it is from 1 to 2. So I'll just write 1 and give a comma. So it will print out both the rows. Then for the column, so it is 1 to 2. So we know that 1 is including and this is excluded. So it will just print 1 and 2. Correct? So with the help of this slicing, we'll be able to print these 4 values. So this is the normal indexing. But now let's perform the same operations with the advanced indexing. So for the same value, let's try with the advanced indexing. So for that, what we can do, first we check for the rows. So in rows, I want to print 1 and 2, right? 0, 1, 2. So in that, I want to print just 1 and 2. So I can just write like this. So at the place of row, I'll just pass a list of rows. So it will be 1 and 2. Correct? So this is for row. Make sure these are for the rows. Then I'll give a comma here. And now let's check for the columns. So I want just 1 and 2 column. So I will again pass a list after the comma 1 and 2. So with the help of this syntax, or we can say advanced indexing, we can get the same results. This becomes convenient because sometimes we are not able to find the values with normal indexing. We cannot find the normal slicing. So let me give you an example. Let's say I want to print these 2 values, and let me take these 2 values and also these values. Okay, these 2 value and this 1 value I want to print. Sorry, both are 1 1, like the column number 0 and column number 3. Correct? I want to print these 4 values. So this we cannot achieve with the normal slicing. Even if we give the step size, we will not be able to achieve that. In that case, we can use the advanced indexing. So for this, how we can get this result? First, we'll check for the rows. So we know that row number 0 is not needed, 1 and 2 needed. So we'll pass a list of rows. So 0 is ignored, then 1 and 2. Correct? Then I'll give a comma here. And now we'll pass a list for the column. So in that, we know that we need only 0 and 3. So I'll just write 0 and 3. And that's how simple it is. And as we discussed already, previously we have learned the normal slicing, and the name of this slicing is the fancy slicing. Just for remembering, you can call it fancy slicing. Okay. Similarly, we have one more slicing that is known as the Boolean slicing. You know the value of a Boolean, the true and false. That's it. So how we can use this? So far we have learned normal indexing or slicing. Then we have learned the fancy indexing and slicing. And now the last one is Boolean indexing and slicing. So how we can do that? So in Boolean, we know that we have true and false values. So let's say from this array, I want only values which are greater than 201.0. Okay. So that cannot be achieved with normal slicing, normal indexing, fancy slicing, fancy indexing. We cannot achieve that. It becomes very difficult. So now comes the Boolean slicing and Boolean indexing. So let's use that. So what I will do, we know that the name of this array is OHLC data day 2. Okay. So instead of it, I'll just write OHLC2 just to make it shorter. OHLC2, right? So what I'll write here, a conditional statement that OHLC2 is greater than 201. Okay, we'll take this value, that whatever the value greater than 2010 will be printed out. So when we apply this, we will get an array of only true and false values. Instead of these values, we'll get true and false. So in this case, what we will get, we know that 201 is at only one place, right? This place. Except here also we have 201. Here also we have. So what we will get the output? We'll get all the false. Here also false, false, false. But here it will be true because we have 201. Again, here also it will be true, and rest will be false. So false, false, and false, false. Here we have true. So I'll just write true here. This is the result we will get. But now we want the values. For that, what we can do, I can just make it a mask and I can pass this here, OHLC. That's it. When I write like this, instead of these values, I will get only these 3 values. These 3 values get print it out in a 1D array, and I will get result like this: 201.0, then comma again 201.0 and 201.0. We'll just check these in code, don't worry. For now, just understand the three very important things: normal slicing and indexing, fancy slicing and indexing, and then Boolean slicing and indexing. So that's very easy and becomes more convenient, and you will be using these in the Pandas more compared to the NumPy. So you have to have a good understanding of these three types of indexing and slicing, right? Now let's move to one of the most confusing part of NumPy, that is broadcasting. Actually, it is very easy, but it becomes sometimes confusing. So if you have a visual understanding, so when you're performing these codes, it will become so easy for you to understand. So let's understand what is broadcasting. So broadcasting is a powerful feature in NumPy that allows arrays of different shapes to be used together in arithmetic operations. Broadcasting eliminates the need for explicitly reshaping arrays or using loops to perform element-wise operation on arrays of different sizes, right? So let me give you an example of that. So, okay, we take the same example which we have used earlier. So what I will do, I'll just remove all these. Now let's understand the broadcasting with the help of these examples. So we know that the dimension of this array is 3 by 4, correct? 3 rows and 4 columns, 0, 1, 2, 0, 1, 2, 3, 3 by 4. Similarly, the dimension of this array is also 3 by 4. So let's say if I consider this as OHLC1 and this as OHLC2, and if I try to add these both the arrays, so I can just write simply OHLC1 plus OHLC2, and it will give me a result which will be having the arrays with the values like this will get added to this, and this will get added to this, and we'll get a result like this 300 and so on and so forth. Correct? It will add the elements of the same position, right? But if I make the dimension of this array as, let's say, I'll add another row here, right? And I'll give some values, random values, let's say 201.9, 201.8, 201.0, 201.0. So now it becomes an array of this size 4 by 4. And now if you try to add this, it will throw an error, because while adding, we need to have few conditions, and that is known as the broadcasting. So let me tell you the conditions. What are the conditions? The first condition is that if the arrays do not have the same number of dimensions, prepend once to the shape of the smaller array until they match. So let's say we have two arrays. So one array is 2 by 4 and another array we have is only 4. So this is 2D array and this is 1D array. So first rule says we need to make this as 2D, right? What I'll do, I'll just add 1 or I'll prepend 1. So I'll make it as 1 by 4. Now it becomes 2D and we can add both these values easily. That's the first rule. And let's take another example of 3D array. Let's say we have an array with the size 2, 2, 4. This is 3D. And we have another array with only like 1D array. So with the first rule, what we can do, we can just make it as 3D array by prepending 1, right? So what I will write 1, 1, 4, and then we can add both these, right? The first rule says if the arrays do not have the same number of dimensions, prepend once to the shape of the smaller array until they match, right? Then the second step is two dimensions are compatible when they are equal or one of them is 1. So what is the second condition of adding two arrays? The first condition is that they should be equal. If let's say I have A equals to 1 by 4 and B equals to 1 by 4, it's fine because both are equal. We can add both the arrays. But if I have A is 1 by 4 and B is 2 by 4, still we can add because one of them is 1. And let's take few more examples to make it more clear. Let's say I have another array and the dimension of that is, let's say 2 by 4 and B we have is 3 by 4. Now what is happening? Neither they are equal, both are different, neither they have 1 in any one of them. So we cannot add this. It will not add it and it will throw an value error. Now let's understand the same with this visual. So what is happening here? We have one array and the shape of this array is 1 by 3, right? 1 by 3. And the shape of this is currently 1 by 1, right? So the condition is matching here because one of them is 1. Here also we have 1, here also we have 1, so we can add this. And so in broadcasting, whenever we have one value, so we can just stretch that like this. Like we have this 5, so I'll just stretch it and I'll make it 1 by 3. We will just understand this all in the coding, don't worry. So now it becomes 1 by 3 and 1 by 3, and we can add both these. Similarly, let's say we have this 3 by 3, a 2D array, 3 by 3, and here it is only 1 by 3, correct? So earlier we stretched from here to here, this side. Now we can stretch this whole like this. So first we check the basic condition. Whether both are equal, we can say it is not equal. Whether any one of them has 1, yes, it has 1, means we can add that and we can just simply stretch. So when we stretch 0, 1, 2, it will become a 3 by 3, and we can add this. Now the last example, we have this as 3 by 1, correct? And this is 1 by 3. Again, the first condition is whether they are equal. No, they are not equal. Second condition is that whether any one of them has 1. Yes, both of them has 1 in common. So we can stretch both the values. So first we'll stretch this. So it will become 3 by 3, and it will become also 3 by 3. And we can simply add them like this. So now let's proceed and solve some examples to get more clarity. Okay, let's quickly start the examples of advanced indexing and broadcasting. So what I'll do, I'll just copy and paste the arrays from the previous example. Yeah, we have 2 data. Let's make it just OHLC1 and this as OHLC2, right? So when I shift enter, okay, now let me show you quickly how the normal indexing and slicing works. So for example, if I want to print this 100.5, what I will do, I will just shift enter, and here I'll write OHLC1, and first I will check the row. So this is 0, 1, and column is 0, 1, 2. So I will just write 1 and 2, and we will get 100.5. And if I want to get all these 4 values, so for that also I will check the row number. So I just want the row number 1 and 2. So here I'll write 1 to 2, and then actually 1, 2, leave it blank, so it will take all the rows. Then also from here it's 0, 1, 2, 3. So from 2 column, just leave it blank, and it will give you all these 4 values. That is the normal slicing and indexing. But now let's go for the fancy indexing, right? So I'll go here and let's take the same example. If I want to print this 100.5, so what I can do, I can write like OHLC, and inside that we have to give another list, and now the row number, that is 0, 1. So I'll give just 1, and then I'll give a comma, and again I'll pass a list and will provide the column number. So that is 0, 1, 2. So only 2. So I'll give here 2 and hit shift enter, and we'll get the value 100.5. Now let's achieve the same result of this with the help of fancy indexing. So what I can do, I can write OHLC1. Then we know that we want these 2 values, right? These 2 values. So we'll start from the row 1 to last row. So for the rows, I'll just give the simple one, and then for the columns, I can give from 0, 1, 2, 3. So I want 2 and 3. So I'll just write 2, 3, a list of columns, and when we hit shift enter, we get the same value, right? So that's how you can achieve fancy indexing, and this becomes also very useful sometimes. And let me show you when it becomes useful. Let's say I want only these 2 values, okay, and these last 2 values. So if I try to achieve with the slicing, I cannot give step size, or even I cannot perform with the slicing this, right? I can get this value and this value easily, but when I want this and the last one, the 0 and 4, it becomes difficult. So with the help of fancy indexing, let's try to achieve this. So what I'll do, I'll add another cell here, and OHLC, this is 2, right? And I want the first one, so the row 0 and 4. So I will just give a list of 0 and 4, then a comma, And now I can give the column number. So I want the column 1 and 2, right? So I will write here 1 and 3. And it says index 4 is 0, 1. Okay, it will be 3 here for sure. And you can see that we have 210.5, which is this one. Then 299.5 we have. Then last 203 and 201. So that's how you can achieve this, and this is really useful and very powerful. Please make sure to practice as much as you can this, and it will be very helpful when you perform the algo trading operations, right? Now let's quickly move to the next, which is Boolean indexing, and I'll copy and paste the same example here also. Boolean means true and false, right? So let's say I'll add another cell here, and let's say if I write I want OHLC, the values were should be greater than 102, and when I hit shift enter I get a Boolean array, false, 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 and I know that only these two values, these three values, true, true, and true, this one, this is greater than 102, and this is also greater than 102. Means only three values we have which is greater than 102. So now I want only these three values, the true values. So what I can do, I can use this as a mask, this condition as a mask. So I'll enclose this in a bracket, and I'll again write OHLC1, and when I shift enter we get only these three values. So it becomes really very, very powerful to perform on a large data sets, and you can easily extract any value, right? So you have to practice this a lot, and once you are done with that, you will never forget it again, and it will become very easy for you while performing any operation in algo trading, right? Let's check another conditions. Let's say if I want values from this OHLC2 and those values are greater than 202, so I will write here greater than 202, right, from OHLC2. So first we will write the condition here OHLC2 and greater than 202, right? And now when I hit shift enter, it will give me the Boolean array, but I only want these value true, true, and these 4 and 5 trues. So for that we need to use this as a mask. So I will mask it, and I will write again OHLC2, and it will give me only these values, the true values, in a 1D array, correct? Similarly, we can achieve the even numbers. So we know the condition for even number, that OHLC1 modulo 2 should be equal to 0, correct? So when I hit shift enter, it gives me all the values are false, and if I write 0.0, then also means in OHLC1 there is not a single value which is even. But let's check in OHLC2, we have one value as true, and we can find that with the mask. So OHLC2, and these two values are even, so it becomes easier. Yeah, next find all the numbers, like we can write anything here and you can perform as per your condition, right? We can even like combine two conditions. Let's say I want a value which is greater than 202 and which is even also. So what we'll do, we'll make few more values as even in this 206. So from this array I want values which are even and which should be greater than 202. Okay, so we have the first condition already, right? And then the next condition what we can have is, I'll just enclose this in a bracket and I'll apply and here, and OHLC should be greater than 202, right? And actually I'll remove this from here and I'll add here, and when I hit shift enter, it says bitwise and not supported for the input types. Okay, you need to make sure that all brackets are correct, and this also I will keep in this. It gives an empty array, means there is no value which is like both the conditions apply for that. Let's check, it should be actually even, and let's first check for this. We have 2 even, and if we check 202, right? Okay, we have to run this also, OHLC2. Yeah, now if you try this, you will get two values which are greater than 204, 202, and also even, right? So you can have like multiple conditions here as much as you want, and you can like play with it and practice, right? Okay, now we have broadcasting, which we have already understood in the theory part, But let's again read some rules here. So the term broadcasting describes how NumPy treats arrays with different shapes during arithmetic operations. The smaller array is broadcast across the larger array so that they have compatible shapes. So what we will do, we'll copy and paste this again here, and let's try to understand the broadcasting here in detail. So first we take the same shape. So here I will remove this and remove this comma. So it becomes a same shape because 3 by 4, 3 by 4, or when we hit shift enter, and when I try to add this OHLC1 plus OHLC2 and hit shift enter, and you will get an array with the values added. This 101 will be added with 200. The same position will be added to same place, right? But if I add another row here, let's copy and paste this here, and we will make it a different shape, and I'll add a comma here. And so now it becomes 3 by 4, the OHLC1, and second becomes 4 by 4, right? So when I hit shift enter here, it throws an error which says operands could not be broadcast together with shapes 3 by 4 and 4 by 4. So that's the issue. So in order to achieve that, we have few rules of broadcasting, and if those rules apply, only then we can perform the broadcasting here. So the first rule is make the two arrays have the same number of dimension, right? Here both the arrays have 2D, so there is no issue in that, right? 2D means the condition satisfies. But the second condition should also be satisfied, which is make each dimension of the two arrays the same size. Now we know that the size of this is 3 by 4 and the size of this is 4 by 4, which is not equal. So if the size of each dimension of the two arrays do not match, dimensions with size 1 are stretched to the size of the other array. We know that in both these, neither of them have 1, because this is 3 by 4, this is 4 by 4, means this condition doesn't satisfy. Second is, if there is a dimension whose size is not 1 in either of the two arrays, it cannot be broadcasted and an error is raised. So let's say I'll copy and paste this below here, and let's try this. This says if the dimension is not 1, so let's make it any one of them as dimension 1. So for that I can remove all these, and now it becomes 1 by 1, 2, 3, 1 by 4, means this is 3 by 4, this is 1 by 4, and when we try this, it will get added, right? How this is happening, you can see this example here. It is 1 by 3, so we have to stretch this like this. If you worked in Excel, we can just click one cell and we can stretch this multiple times. Similarly, here also it was 1 by 4, so I just hold it here and I stretch up to match the dimension of this first array. So here it was 3 by 4, it was 1 by 4, so I stretched it to 3 by 4, means this same value will be here. The same values will be here, means it is not showing us, but the results are same. If I paste it here, when I shift enter, you can see that the results will be exactly same. See, correct? So even if I remove this, it will be exactly same. You can check, it is 300.1 and last is 303.5, and when I shift enter, it is exactly same. So means internally the broadcasting feature is stretching this single array and making it compatible. For that, these conditions should match. Either of them should have 1, and if dimension is not equal, we have to make them equal, right? Okay, let's take few more examples of broadcasting. So what we will do, I'll just copy and paste this. Okay, let's take something different. So what I'll do, I'll create an array, a is equals to np dot a range and 12, and reshape into 3 by 4, correct? And I can even print this, and again I'll create another array, and it can be 12, and I'll make it 4 by 3, and let's make it b, and this also b. Now we know that this array is 3 by 4 and this array is 4 by 3. So if we try to add this a plus b, it will not get added. Why? Because dimensions are equal, both are 2D, but the size is not equal and there is no 1. this is 3 by 4, this is 4 by 3, so it will not work. So to make it work, what we can do, I can just make it like 4 and this 1 and 4. Now we have 1, right? So when I shift enter, and here also shift enter, and now when I try to add, it will get added, right? The rule is simple. First, what is happening here? It was only one dimension, right? So what this Python did internally, it just stretched this to 3 rows. It added this virtual 3 rows more of 0, 1, 2, 3. Same. Actually, we have done that already, right? Previously. So internally, you can think that it is stretching that. It is holding from here. It will stretch up to 3 rows and it will make the same size. And then it will add. So in NumPy, we have seen that we have multiple mathematical functions and we can perform all those functions very easily, very quickly with a very small line of code. So let's say we have this. Let's take the same example here again. So I'll paste here and I want all the sign values of this value. So what I'll do, I'll just write np sign and ohlc1 and hit shift enter. So it will give us all the sign values. Whereas if I wanted to do in some other function like list or something else, we had to write a whole program, a whole function for that. Right? But here with just a simple one line of code, we can perform that. Correct? And let's check very popular function, which is sigmoid. It will be very useful for you when we learn machine learning or AI. So what is sigmoid? So let me show you a formula for this. And let's convert any formula into a NumPy. It's very easy. So let's say you can see the formula for sigmoid here. Sigmoid of x is 1 over 1 plus exponential minus x, right? So now we need to convert this to a sigmoid function in NumPy. It's very easy. You can convert any mathematical formula into NumPy. So let's do this. 1 upon 1 plus e to the power minus x. So let's open again. So let's calculate the sigmoid for this second one, this OHLC2. So how we can do that? I'll just write the formula is 1 over 1 plus, let's enclose this in a bracket, 1 plus np dot exponential, right? And inside that, so negative of OHLC2, correct? So when you hit shift enter, you will get the sigmoid of this one. It's very easy actually. And you can also calculate for 1, it is like, it will give the value of all the, it is from like 0 to 1, the sigmoid is. So it will give the value of 1. Like it will generally use to normalize some values which are higher. We will learn this also, don't worry. For now, just understand that we can convert any complex mathematical formula to the code of the Python code, right? And it's really become useful. And with the help of this, we can perform many complex things and you will see that in future. Now we have mean squared error, right? Let's take this example only. Here, let's check the formula of this. So I'll just open Google. So the formula for mean squared error is this, and let's try to convert this into the Python code. So we'll go to the Visual Code Studio and I will open this and let's try this. So what we are doing here, we are assuming this as the actual value and this is the predicted value. So means what happens in generally when we create some models, the prediction from the model. So we need to find the error, right? That is known as the mean squared error. So how we can achieve that? I'll define a function and let's say define mean squared error. And inside that I'll pass both the values as an parameter. So OHLC1, that is the actual value, and OHLC2, that is the predicted value, right? And that will return mean of actual value, that is OHLC1 minus OHLC2 and squared, correct? All in the bracket. And now we can call this function. So MSE and OHLC1 and OHLC. So when you hit shift enter, it says operands could not be broadcasted together with these shapes. Because the shape is different, we can just make it same shape. Now you hit shift enter and you will get the mean squared error. That is way beyond the limits, but you get my point, right? What I'm trying to say. With the help of NumPy, you can convert any mathematical formula to the Python code. Now we have is the working with missing values. So actually in algo trading, you will be dealing with a lot of missing values because when you fetch some price data from any source, then there is high possibility that some values are missing. And if you directly apply that data set to your program, it might throw an error. So in order to resolve that issue, we have to deal with the missing values, and this dealing with missing value is very significant process in the algo trading, or you can say data science, right? So how we can deal with the missing values? So what we will do, I'll just copy and paste the same code here. Let's take this, the first array OHLC1, and I'll paste here. Now let's make few values as none values. So what I'll do, I'll just write np dot nan, and I can also make this value as np dot nan. And this happens in reality because whenever you fetch some data, there is high possibility of none values, and we have to deal with those efficiently. So now in this array, let's say we have fetched a data set which is very, very large. Let's say 10 years of data of 1 minute time frame, right? So inside that, we cannot manually check every day, right? Every minute time frame that which is missing. We can just apply these kind of functions of NumPy and Pandas to handle with those none values. So let me print this OHLC 1, and you can see that we have these nan values, correct? Now what I will do, I'll use np.isnan, and inside that I can pass OHLC1. So when I hit shift enter, it will give me the Boolean results, the true and false. So wherever it has the none values, it will give us the true result. But what we want to remove the none values. So I can just give the bitwise not operator here. So when I do that, it will reverse the value. So these none value will become false. And in order to get these value, what we can do, we have already learned recently that we can make it as a mask, right? And now I can write OHLC1 and shift enter. And now you can see that we have removed all the NN values, right? And now when I shift enter, you can see that we have removed all the NN values. So it is really very useful. Just practice few questions and you will be good to go. Okay. So what we will do, first we'll create few points. So okay, let me first import the NumPy. Import NumPy as np, right? Then what we can do, I'll np.linspace, and in that I will take 100 equidistance point between -10 and +10, right? So -10 to +10, and I need 100 points, right? And now we'll plot a chart for the x equals to y, and you know that what is x equals to y. So what I'll do, I'll just write y is equal to x. Now we have the data to chart the plot, but one thing is missing, and that thing is charting library, right? So for that, we can use here import matplotlib dot pyplot as plt, right? We'll also learn this completely, but for now, just you have to import this, and after that, you need to use plt dot plot, and inside that you have to pass both the points, so x and y. And when you hit shift enter, you will see that we have a graph for the straight line x equals to y. You know that, right? Now let's try to plot a chart for y is equals to x square. And if you remember, then let me know in the comments that y is equals to x square is for which kind of plots. So let's take the same 100 points. So what I'll do, I'll just copy and paste this here, and here instead of y is equals to x, I'll do y is equals to x square, correct? And now when I hit shift enter, you will see that we have a graph for parabola, because that is the equation for parabola, right? Y is equals to x square. Please let me know if you need to understand this. I'll explain in any other videos completely, right? Now let's try to plot a sine wave. So for that also, I'll take the same points, correct? And instead of y is equals to x, I'll make it sine of x. That's it. And when we hit shift enter, okay, we have to write np.sine. np, that is numpy dot sine of x. And you will see that we have a sine wave, correct? It's very easy, I guess. If you have studied this in your college or your school, then it should not be difficult. Very, very basic equations, right? Now we plot a chart for x log x. So for that also, we'll keep it exactly same. So x multiplied by np dot log of x, right? And now when we hit shift enter, we'll have a logarithmic plot. And last but not the least, we can also plot a chart for sigmoid. And in fact, we can plot a chart for any mathematical operation, right? So I'll just take the same value, and here we will apply the sigmoid formula. And we have seen the sigmoid formula already, and that was 1 over 1 plus exponential of negative x, right? And now when we hit shift enter, you will see that we have a chart for sigmoid. I think we have to keep this inside the bracket. And now when we shift enter, yeah, that is the exact chart for the sigmoid function. And this is how you can plot chart for any mathematical operations. You can try yourself to apply different mathematical formulas and try to plot the chart for them. Now let's start with some important NumPy functions which will be really useful in your algo trading journey, right? So what is happening here? You will see that you have the name of function, and along with that you will be having the documentation link for that function. So if you face any issue, you can just click on the link and see the documentation and proceed, right? So let's start with the np.sort. So actually we have already seen the sort and sorted in the list, but the benefit of np.sort is that you will receive a NumPy array, right? Which can be quite useful sometimes. Okay, so let's try this. Now here we have two arrays. The first is OHLC1, which is a 1D array, and the second is OHLC2, which is a 2D array, right? So let's try to apply this np.sort on these two arrays. So I'll write np.sort, and I'll give OHLC1. So when we hit shift enter, you will see that we have received this array in sorted form, right? And so here, if you want this in a descending order, you have to use the slicing here and -1, and you will receive a descending array, correct? Similarly, let's apply this on the 2D array. So np.sort, and I'll give OHLC2. And when we hit shift enter, okay, now let's try this on the 2D array. So I'll write np.sort and OHLC2, right? So when we hit shift enter, you will receive that we have received an array, and it is sorting by default row wise. So you can see that here we had the 910, which is at the last, and 210, which is at the first, right? And if you want this column wise, what you can do, you can just write axis is equals to 0, and it will be a column wise. Now you can see earlier 9875, and we have 5789. So that's how you can achieve this. And if you make it 1, it will be row wise. It is very simple actually. If you perform some practice questions, you are good to go, right? The next we have is the np.append. So here what happens? It appends values along the mentioned axis at the end of the array. So let's take the same example. So I'll copy and paste it here. Now let's apply this. So np.append and the name of the array and the value. So you can see that the 500 has been appended at the end of the array, right? Okay, now let's apply this np.append on 2D array. So how we can do that? np.append and the name of the array, that is OHLC2, right? Then we have to provide the values of the array. So here what we can do, we can create another array with the shape 4x1, right? So np.arange, and inside that we know that we need an array of 4x1, because here we have 4 rows and we just want to add another column. So 4x1, and then we can reshape. Actually here we have to give the range. So range I will give 4, and reshape I will give in the 4x1, correct? And then in the last you have to give the axis. So axis will be 1, correct, for the column. So when you hit shift enter, you will see that in this array another 0, 1, 2, 3 has been added. So it becomes now 4x5, correct? So that's how you can use the np.append. Let's move to the next function, which is np.concatenate. And with the name also, it signifies that it will be somehow adding some values through the arrays, right? Now next we have the np.concatenate, and the name also signifies that it will somehow can be used for concatenation, right? So let's create another 2 arrays. So I'll write c is equals to np.arange, and I'll give a range up to, let's say, 12, and then we'll reshape to 4x3, correct? Similarly, we'll create another array which will be d. Let's make it also 4x3, correct? And we can make the range from in here 12 to 24. Let's see the arrays. So c is this one, and
this is the D, correct? So we can simply use the function np dot concatenate, and here we'll provide the arrays. So the first is C and second is D. Then we have to give the axis. So axis is equals to 1, and you will see that it has been added, right? Let me show you first the arrays. So this was the print C and print D. So these were the arrays earlier, and after concatenation you can see that it has been added, you can say horizontally, right? Similarly, if you give here the axis as 0, it will be concatenated vertically. So that's how you can use this, and it will be very useful in future because we will be always using this function, right? Next function we have is the np.unique, and with the name signifies that we can find the unique values out of any array. So let's create first an array, np.array, and inside that I'll give some values like 1, 1, then 2, 2, 3, 3, 4, 4, 5, 5, 6, 7, 8, and now when we apply this function np.unique to, let's say it is e is equals to, and here I'll give the value e. So when we hit shift enter, you will see that it will only output the unique values, right? So this is also useful sometimes. Now we have the next function, which is np.expanddims. So means we can use this function to expand the dimensions. So you can read here that, so we can get the expanded dimensions of an array. So let's take this example OHLC1 and apply the shape. We know that it is 1D, right? So if I want to use the np.expanddims, what I can do, I can just write np.expanddims, and I can give the name of the array, that is OHLC1, and we have to give the axis. So let's say I provide axis is equals to 1. So when you hit shift enter, you will see that it has been expanded in the vertical direction. So now when you check the, let's say we apply f equals to this, and now when you check the shape of this f dot shape, it is 12, 1. Earlier it was only 12, means 1D. Now it has become 2D by expanding one dimension. Similarly, you can use axis equals to 0, and when you hit shift enter, you will see that it has been expanded horizontally, right? And even you can see the array. So let's check this, and this is the 2D array, right? So that's how you can use the expand dimension function. It's very easy. Now we have np.where, which will returns the indices of elements in an input array where the given condition is satisfied, right? So let's say we have this array, or let's take the OHLC1. So we have OHLC1, right? And we can apply here the np.where. So np.where, I can give any condition here. Let's say I want to check OHLC, all the values which are greater than 400. So when I write this, it will return the indices of those values. You can check here that this was the OHLC. Let's print these. You can see that at the index 2, 0, 1, 2, we have 499.5, which is greater than 400. And again at the index 4, 5, 6, 7, so 0, 1, 2, 3, 4, 5, 6, 7, and all these indices are greater than 400. That's why we are getting this value. Now we can also use this smartly, and we can replace any value. So let's say I use this function np.where, correct? And here the first I will give the condition. Then if that condition is true, it will replace with 0, and if false, then we will keep the OHLC1, correct? So now when you hit shift enter, you will see that all the values which were greater than 400 is replaced by 0, and remaining are all same. It will also be very useful function a lot of times when we move next further. The next function we have is the np.argmax, right? So it returns the indices of the max element of an array in a particular axis. Let's apply this argmax on the OHLC1. So np.argmax, I'll give the array name, that is OHLC1, and when you hit shift enter, it will return you the index position of the maximum element, which is 0, 1, 2, 3, 4, which is 901.3, correct? Similarly, you can use here the argmin. So let me give it argmin, and it will give us the
index position of the minimum element, that is 0, 1, 2, 3, 101.0. Next function we have is the np.cumSum. CumSum stands for the cumulative sum. So let's take the array again, OHLC1. So what it will do, it will return an array by adding all these elements. So the first element will be 300, the second will be 300 plus 101, the third element will be the sum of all these elements. So it will like add cumulatively. So let's try that. np.cumSum and OHLC1, and you can see that the first we have is 300, second is 401.6, that is the sum of those these two elements. The third is the sum of all these three elements, and the last is the sum of all the elements. So that's how you can use this, and definitely we are using a lot this cumSum. Please make sure to practice this a lot, and it will help you a lot. Similarly, we have the cumulative product. So np.cumProd and the OHLC1, and you can see that it is giving us the value of the cumulative product, right? Okay, next we have is the np.percentile. So print the value of OHLC1 and apply the percentile on this. So np.percentile and OHLC1. So here we can give the value. So let's say if I give 100, because you know that in percentile, whatever the range is, the 100 will be the top and the 0 will be the lowest. It can be like if the range is from 50 to 70, then 70 is the 100 percentile and 50 is the 0 percentile, right? So give it 0, so it will give us the last value. And when we check with the 50, it will give you the middle value. And you can even check with the median also. So let's apply the np.median, and you will see that these both are same. So percentile is very easy concept, and even so many exams we get the percentile values. So this might be useful, right? Okay, next function we have is histogram. So in histogram, what happens, if you have seen the MACD, moving average convergence divergence, in that we have a histogram. So what happens, like we have few values and it will split those values in bins, and then it will show you the frequency of any particular value in that range. So let me show you how. And let's say we have this OHLC1, right? And I'll apply the np.histogram, then I'll give the array name, and now we have to give the bins. So bins, and we'll give a list. So I need that 0 to 500, or let's say 300, then 300 to 600, and then 600 to 999, right? So now when we hit shift enter, you will see that from 0 to 300 bin, we have 4 values. We can check there, and the first, second, and third, and fourth, correct? And then again from 300 to 600, we have 1, 2, and 3, and 4. From 300 to 600, we have 1, 2, 3, and 4, correct? And again from 600 to 999, we have 1, 2, 3, and 4. Yeah, it's true. Means we have 3 bins, and it will show you the frequency of those values inside those bins, right? Next we have is the correlation coefficient. It will tell us the relation between the arrays, right? So let's see that we have the array A. In that we have value 111, 222, 333, and we have an array B. In that we have 321 and 321. So now when we apply this one, and I'll pass the values A and B, and it will show me that it is 1, -1, -1, 1. So it ranges from -1 to +1, and it will tell us the exact relation. So let's say if I make it here 1, here if I make it 10, it will change the value, right? You can see that it has changed the value. And if I make it, let's say 0 and some random value, let's say 20, and again -1 and 300, 0.2, and let's make it 1000. So now you can see that the value has been changed, and you can just hit and try on this. We will again cover this when we start the machine learning trading, because it's very crucial in that, right? So now the last function we have is the np.isIn, and it is same we have done already the membership function, right? So let's say we have this array OHLC1, and we want to check that whether this value 300 is in this or not. So I'll just apply np.isIn, and I'll give the array name here OHLC1 and the value, so 300.1, and it will show me that at which place it is existing, and it is existing at only the first place. And we have already seen that when we want to check the exact value, we have to use this as a mask, and I'll write OHLC1, and you will see that we are only getting this 300. Similarly, like if you want to check for a whole list, let's say we have items, and inside that we have a whole list. So what I'll do, I'll just copy and paste these values inside that items, and I'll write this again here, and instead of this 300, I'll just provide the whole list items, correct? And you will see that we are only getting the list which we wanted, right? So this is how we can use these functions. So as I have mentioned already, that any algo trader or a quant trader gives 70% of their time in data analysis. So you have to be proficient in data analysis, right? So we will give enough time to this Pandas library, and I will make sure that you learn each and everything. And I will also make sure that you understand few of the secret tricks and tips that only few of the expert algo traders knows. And one more thing, that after watching this video, please you decide that what you want. You want me to quickly cover this topic, or you want a deep understanding of this Pandas, right? So with that being said, let's get started. Pandas in algorithmic trading. Pandas is a powerful data manipulation and analysis library for Python. It provides data structures like series and data frame, which are essential for handling and analyzing time series data, such as stock prices in algorithmic trading. So as we have previously learned that in NumPy, we have single major data structure, that is NumPy and the array. Similarly, in Pandas, we have two major data structures, that is series and data frame. And that is absolutely simple. And you've seen those data structures since your childhood. Let me show you how. Okay. So as this line says, it provides data structures like series and data frame. So what is a series and what is a data frame? So simply, if you've seen in the Excel, MS Excel, we have a table, right? And inside that, we have few columns and few rows, right? Let's say the first column is serial number, second is, let's say, price of stock, and third, let's say, symbol of the stock, and it could be the date, right? Now, this is simply a data frame. That's it. A table means a data frame. Table is equals to a data frame. As simple as that. Now, this data frame consists of 4 columns and 5 rows, right? So any single column or a single row is known as the series. That's it. That is a basic definition of series. So let's say if you take this row out of this table, it will become a series. Simple. Similarly, if you take out this row out of this data frame, it will become another series. Means simply a single row or a single column is known as the series. Hopefully it's clear. If you have any doubt, please get it cleared in the comments. Now let's understand some key features in Pandas. The first feature is data structure. So it provides a series that is 1D and data frame that is 2D for structured data, right? We have seen that this is the whole table is 2D and a single row or column is 1D, correct? Then time series analysis. Inbuilt support for handling and manipulating time series data. Because in trading, we have the historical prices or even the live prices, and all those prices are based on the time. So it has an inbuilt support for time series analysis, and that is really very, very important. So we will give enough time in understanding time series analysis, right? Then we have the data cleaning. Guys, please understand this important concept that let's say you have downloaded a data of last 10 years of any stock. Let's say Apple, Bitcoin, anything, right? So in that data of 10 years, if you have any value that is not desired, then it might break your whole code or it might alter all the results. So you might get completely different results from what is your expectations. So it becomes extremely important to clean your data. So it has tools for handling missing data, filtering and aggregating data, right? The fourth point is data alignment. So the Pandas can automatically align data based on labels, making operations intuitive. The fifth one is integration. So it can easily integrate with other libraries like NumPy, Matplotlib, and SciPy. So we will learn few more libraries after the Pandas, and you will see that how it can easily integrate with those libraries. Then the last is I/O tools. So functions for reading and writing data from various formats such as CSV, Excel, SQL, etc. Means we can analyze or we can manipulate any kind of format like CSV, Excel, SQL, and all those. So now when we discuss in SQL, so let me know if you want a session on SQL, because in algo trading you will need to have a good knowledge of SQL also, right? So let me know in comments that if you want a session on SQL or not. Okay, now before moving further, let's compare NumPy and Pandas, right? So as we understood that in Pandas we have two major data structures, that is series, that is 1D, and data frame, that is 2D. Similarly, in NumPy we have n dimensional array, that is ND array, right? Again, Pandas is majorly used for data manipulation and analysis, whereas NumPy is used for numerical computation and operations. So we will be using NumPy also in the Pandas, because in trading the whole game is about the time, right? Because in trading the whole game is about the time. So we have to make sure that we are time efficient. Pandas have excellent support for time series, and that is required in algo trading. And but NumPy has basic support. Again, Pandas have built-in functions for handling missing data, right? Whereas NumPy requires custom handling. Pandas can automatically align the values based on the labels, but in NumPy we do not have the alignment because it is purely positional. Next, Pandas is slower due to additional features. As we know that, and as we have discussed previously, that the more features we have, it will become more slower. That's why ND array have only one thing, and that is only the values, and because of that it is very fast, and also it is based on the C, right? Again, Pandas have robust GroupBy and aggregation methods. So GroupBy is also another object of Pandas, and we will learn that also thoroughly because it is also very important in algo trading. So we'll learn that also. Whereas NumPy has limited grouping capabilities. Again, Pandas integrates well with other data tools, whereas NumPy serves as the computational backbone. And we can easily integrate the Pandas with Matplotlib, whereas NumPy requires external plotting libraries. Again, Pandas have higher memory uses due to metadata, right? Whereas NumPy is more memory efficient for raw numerical data. So that was the basic comparison, and you should be having a good understanding of both the NumPy and Pandas for efficient algo trading operation. Now let's quickly dive into the interesting and let's understand the Pandas with live coding. So the first thing is how to import Pandas. Simply we can write import Pandas as PD. That's it. Okay. But as we know that we will be using NumPy also along with the Pandas, so it's better always to import NumPy along with the Pandas, right? So we'll just write import NumPy as NP. Correct. So when you hit Shift Enter, if it doesn't throw any error, that means you have written anything right, and both of your libraries have been imported. Now let's create a series with list. We know that a series is just a single row or a single column of any table, right? So series from list. So what we will do, we will create a series. So let's say list of string str, correct? Then I can give a strings. So let's say the name of stocks. So Apple, then Microsoft, then let's say Bitcoin and Ethereum, correct? Now you have to write PD dot. This is a series class, and inside that you just have to pass your list. So list str, correct? And that's it. You have your series. So when you hit Shift Enter, you will get the series. But you might be wondering that I have just given the strings, but how come these numbers are here? 0, 1, 2, 3. And that is the default index of any series or any data frame. So whenever you create anything, any series or any data frame, without explicitly giving the index, then this Pandas will assign that index to your series. Okay, now let's move and create a series with integers. So what I'll do, I'll create a list of integers, and let's say the price. So 100, 100, 01, 100, 02, 100, 03, and I can give it the name like list integers, correct? And similarly, you have to write PD series and you have to pass the list. So list integer. And again, when you hit shift enter, you will see that you have your integer series with the default index given by the pandas. Now there are three things to observe. The first is the index, that is the default index by pandas. Second is the values. These are known as the value, right? The value of this series. And the third is the data type. So here it was object and here it is integer 64. So you can say that in pandas, a string is always considered as the object and the numbers can be considered as integer 64, integer 32 or integer 16 or even 8 also. So if you want to optimize your code or you want to reduce your code, you can make it integer 32 if it is possible. You have to consider the situation that if it is possible, then you can convert your numbers from 64 to 32 and your size will be reduced to half, right? Now let's create a series with our own custom index. So before that, the index was given by the pandas. Now we will give our own custom index. So for that, what we can do, we can take these same list. So I'll paste it here, the list of string and again the list of integers, correct? It's also very simple. You just have to write pd.series and you have to give first the list of strings, or first let's give the list of integer. So list of integer, then you can give index equals to list of string. That's it, right? So now when you hit shift enter, you will see that you have your string of list as your index. But one more thing to keep in your mind, that even though here you cannot see the index, but behind the scenes there is always a hidden index, and that is your default index. So if you want to access these values, you can access with this index, your custom index, or you can access with your default index that is behind the scenes. Let me just quickly show you that also. I'll add a code here and I can assign it to any variable. Let's say a series variable, ser, and let's say series cust. Okay. And here, what I'll do, I'll just hit shift enter here and now series cust. And now let's say we want to access the values from the index name. I can just give apple and you will have the value as 100. But if you give 0 here, you will still get the value. But now it says something that series get item treating keys as positions is deprecated, and in a future version, integer keys will always be treated as labels consistent with data frame behavior. To access the value by position, use series.ilog position. Okay, so we will learn this also again. But for now, you just think that it is always having a default index given by the pandas and also a custom index given by us. Okay, and this ilog we will learn. This is also very important. So we'll learn this in the data frame. Okay, and now how do you verify that it is a series or a data frame? So let's just check it with the type. And when you hit shift enter, you will see that it is a series, right? So with the help of type, you can know that whether it's a series or a data frame, right? Now, let's remove this for now, or let's keep it. Maybe if you want to refer it in future, so you can take it from the GitHub and use on your own. Now, okay, now let's take this again and I'll paste it here, setting a name. And here we know that I'll just remove it for now. Now we know that we have done this already. And when we hit shift enter, we get three things. One is custom index, another is the values, and third is the data type. Now, let's say if I want a name here. So for that, what we can do, we can write name equals to a string, and we can say the stock prices of Kuldeep, right? And when you hit shift enter, you will see now four things. One is the custom index, another is the value, third is the name, and fourth is the data type. I'll just show you in a quick, in this session only, that what is the use of this name. Okay, for now, you can just remember that we can also assign a name to a series. Okay, now let's learn how to create a series from a dictionary. So what we will do, we'll just copy and paste this list of string here and we'll make it a dictionary. So instead of list, I'll write here dictionary. Then I'll create a dictionary here. So I'll just remove this square bracket and I will give a curly bracket here. And Apple is 100, Microsoft is 200, Bitcoin is 300, and Ethereum is 400. No, it's not fair, yeah. Bitcoin cannot be 300. Let's make it 3 million. I think now it's fair enough, right? Now, let's repeat the same thing again. So, what we can do, PD series, and just pass the dictionary here, dictionary str, and hit shift enter, and you will see that you have now an index, the values, and the data type. Right? Similarly, you can also give the name here. So I'll just give this same name here also, and I'll just give a comma and the name, and you will see the name also here, right? Okay, now let's understand the series attributes. So if you have understood the object-oriented programming very carefully, then you must know what are the attributes and what are the methods. So we know that in a class we have two things. One is attributes and another is methods. So here the class is series, and now we will be accessing the attributes and methods of the series class. So what we can do, I will just assign it to any value, any variable. So let's say I make it dict series is equals to, and I'll hit shift enter. So now we have created the object of the series class, right? The same, exactly same, right? So that's why I say the basics, the fundamentals are absolutely important. If you are good in your basics, then you will see that you are able to do any complex thing with absolute easiness, right? So now I'll give the object, or we can say dict seed here, and to access any attribute, what we do, we just type a dot, and you will see that you will be having all the attributes of that class. So first we will see the size attribute. So if I write size, it will display all the elements, the number of elements in that particular series. So it is currently showing me 4, and when we calculate that, it is 1, 2, 3, and 4. Means that is correct, right? Next we have is the D type. So again, when I write dict series dot D type, and when you hit shift enter, you will see that it says integer 64, right? It was also shown here also integer 64. So if you want to change, you can change it to any other, right? And when you change, the size of that series will be reduced, or you can say the size of that file will be reduced. Next we have is the name. So again, when I write dict series dot name, it will show us the name of the series which we have given earlier, the stock prices of Kuldeep. Right? Now it's very interesting. It says is unique. So when I write dict is unique, it will give us a Boolean value, true or false. So when I check, it says me true. Why? Because here all the values are unique. So if I make here any value as repeated, let's say Ethereum, I'll just copy here and paste here. And now when I check is unique, it says true. Why? Because here, we have to remove this, and when we check, because dictionary cannot have duplicate keys, right? So for that, you need to change it a little bit, and when you change, we have that, and now when you check is unique, it says false, because the value of both the Ethereum and Ethereum is 400, and it is not unique now. So one more thing to recall, that dictionary cannot have duplicate values. Keep in mind, right? Next we have is the index. So you can simply print the index with index attribute. You can see here, this is the index attribute, and when you check the D type of this object, you will see that it is type of this, it is index object. We will learn this also in future, don't worry. Now we have is the values. So for values, it will just print the values, and the values will be an array. It will be an AND array. So let's check the type of this, and when we check the type, you can see it is NumPy AND array. Why? Because we want to make our program faster, and that's why this Pandas using the integer values as the AND array. At least we have some benefits of the NumPy here. So that's why I told you to import NumPy also along with the Pandas. So sometimes you might need to use the NumPy functions, right? Now I think this was the basic, and you are able to get all the things correct. Okay, now we have a little bit interesting part, that is series using read CSV. So what is CSV? CSV is a comma separated values. So it's same like an Excel file, but the values are separated by a comma. So let's do one thing. Let's create a CSV first, and then we will use that with 1 column and 2 columns. So for that, I will just paste a code here. That is very easy. But for that, you let me know that whether you want to understand the APIs or not. Whether you want to understand the APIs or not. We can cover that in a future video, in a single video. And I'll show you how you can create your own APIs and how you can use those APIs, right? So for now, I'll simply paste the code here so we can fetch the prices from the CoinGecko. Then we will create a data frame. And in short, I'm just creating a simple CSV file. So for you, if you're not getting this, you just think that we have imported a CSV file from anywhere, that's it. But if you are able to understand, it's good enough. And if you still have any doubt, you let me know. We will cover this in a separate video, and it's absolutely simple. If you are able to understand the pandas, you will be able to understand the APIs easily. So it's your call to let me know whether you want to understand the APIs or not, and we can cover that, right? Now I'm pasting this code here, right? So it's very easy. You can see that we are first importing the pandas, then a request. So request is generally for the API connections, and then simply the URL that is given by the CoinGecko itself, and they have a full documentation where you can understand it's very easily. You can just go and copy paste from their website and you can use. So means in algo trading you will be using APIs a lot because all the exchanges provide their APIs and you perform the algo trading with the help of APIs only. So means APIs also becomes crucial to understand, right? Here, what I'll do, you can just think that we have created a data frame df. So when I hit shift enter, we'll see the values, and here I can print it. When I write df, we'll see the whole table, right? So whole table, and this is the data frame. Okay, don't worry. For now, we are just understanding series. We will learn the whole data frame concept in the next lecture. For now, just think that I have imported a simple CSV from any other source. Okay, so it was my way to import. So I could also have downloaded the CSV from Kaggle also, but to make you a little bit more interesting, I just show you here, right? So df, and so what I'll do, I'll just convert it to CSV. So df to CSV, okay, and I'll make a file name. So let's make it. I think it's day 24 of algo trading series, right? And I will give an extension here, CSV, correct? So when you hit shift enter, actually it's day 23. In day 24, we will learn the data frames. Now when I hit shift enter, you will observe here, we have a CSV file with this name. You can observe in this folder, day 24. Actually, this is day 23, but we are working in day 24, and I'll just rename it after the video. So when I hit shift enter, it is saying us that no such file or directory. Why? Because we have to provide the path here. So for that, what we can do, I will just go here and I'll copy this path here, copy path, and I'll provide here. I can also give. So when I hit shift enter, now when you check in this folder, you can see that you have this file, day 23 algo trading CSV. And when you check this, you can see the contents of this, right? So let's again open our file. So now we can see that with this function toCSV, you can convert any data frame to a CSV. And now when you want to read from the CSV, I'll add another column and I'll keep this here only. So it's optional for now. If you want to check, even if you don't understand, don't worry. For now, this is not the scope of this video. We will learn this later and it's very easy. Okay. Now when you want to read the CSV file, like this is a CSV file we have here, which we created right now. So if I want to read this, I need to use the pd dot read CSV function here, and we have to give the name of the file, that is day 23. Let's copy this path and I'll write here the whole path, and when I hit shift enter, we can see that we have the data of that file. So I'll just give it a name, df is equals to. So this whole content of the CSV file now will become a data frame, correct? Previously what we did, we imported the data from the CoinGecko and we stored that in a data frame, and then we converted that data frame to a CSV file. Now we are reversing that. What we are doing, we are importing a CSV file in this, and now we are storing the content of that CSV file to a data frame here, right? So now shift enter, and again, now when I check the data frame here, we have this, right?
here what happened actually, now we have two indexes. So in order to avoid this, what you can do, while exporting to CSV, you can write here index is equals to false, right? So let's check it again. So when you hit shift enter, again when you run this, now what I'll do, I'll just go here, I'll run this code again, and I will export the file again from here, and here the index equals to false. If you want to avoid the duplicated index, you have to give this hidden parameter, that is index equals to false. And when you hit shift enter, you will have the file again. And now again read the file. And now when you check this df, you will see that you have only single index, right? So now let's start with our series. And the topic was understand the series with one column, right? So we have read the CSV, and additionally, I have also shown you how to create a CSV file from the web, right? How you can import the data from the web and you can convert that to a CSV and you can store, and then again you can read the CSV. So for now, we have this as a data frame. So you can check that again. This is a data frame, right? And I want to convert this to a series for now, because now we are reading the series. So how I can achieve that? So for that, what I need to do, I need to just extract only single column from this data frame, and that is a series, right? So what I will do, I will just extract, let's say the name and the current price. So I will just write the name, and I'll just copy here also for now, name, and when I shift enter, we have this series, and when you check this, you will see that this is a series, right? But what I want one more column, and that is the current price. So for that, I will just give here a comma, and I'll write the current price, and it says, okay, we have to give this inside the list, and now we have the name and the current price. And now when you check the type of this, it is a data frame, right? But we want a series. So how we can do that? Just pause the video and think that we have just studied this recently, very recently. So what you can do, you know that this is the default index from the Pandas, but you can make your own custom index. How you can do that? You can just write like this. I will write like df dot set index, or before that, I will store this in df. Okay, now we have the new data frame, that is this, and now I will use the set index function, right? And here I will make this name as the index, correct? And I can again make it a new data frame. And now when you check this, okay, actually it is done already, because now the index is the name, so it will throw error. You can check here the df, and when you check the type of this, you will see that this is a data frame still, because now even if we have a single column, still it's a data frame. That's the problem, right? So what we can do, we can just apply function that is known as the squeeze. So what I'll do here, df dot squeeze, when you hit shift enter, and you can again create a new variable. Let's make it series now, right? And when you hit shift enter, and now when you check this variable and check the type of this, you will see that this is a series, right? I think I have explained it very comprehensively, and it's very easy. You just have to focus and practice just twice or thrice, and you are good to go, right? So now we can also say that we have a series with a single column and with our own custom index, and we have also seen that we can even access these values with custom index, or we want with the default hidden index, right? With the, so let's say if I write 0 here, we will get the value, but that is deprecated. So we will be learning the iloc and loc in future, but for now, just keep that in mind. Okay. Now again, let's understand this output. So here we have 4 things. The first is the name, and that is also the index. Second is the values. Third is the name, that is current price. So it automatically takes the name as the column name, right? We have seen that previously in the CSV file.
the column name, so it will take that name, and we can also give our custom name. And now you can think that when you want to create a CSV file and you are wondering that how we can give the column name, that's how you can give the column name, which we have just learned, right? Then it is giving us the length. Length means the total number of values in that particular column, and then the D type, that is the float 64. Now let me show you one more thing along with this, that how you can optimize your code and how you can reduce the memory footprint of your code. So as we have seen previously, that how to find the memory size. So what I'll do, I'll just have to import the sys library, sys, and then what you can do, you can just write simply sys dot get size of, and you can give that ser series here, and when you hit shift enter, you will get the size of that. You can also print this. So when you print it, it's same, right? So now you can see that this is a float with 64 and the size is 11,507 bytes. But sometimes what happens that you don't want the float value. Let's say if you're storing some kind of age or the simple index from 1 to 100, then the float is not required there. And if you change the data type, definitely the size of that particular file will be reduced. So what you can do, you can just change it from, let's change the type of this. So what I'll do, I'll just write as type, and I can give here as np dot float 32 and shift enter. And now when you check the size of this, you will see that okay, we can store this in another variable. Let's say ASCR, and let's check the size of ASCR. So you can see that it has reduced a little bit. So now you think that when we have a huge database, it can be millions of lines, right? Then it will definitely impact. And let me show you something else. Let's make it integer 32. And now when we check the size of this, it's almost same, but when you make it integer, let's say 8, it is reduced a little bit, right? So, but when you optimize on a bigger data set, it is definitely a significant change, and it can save you a lot of money and make you a little bit smarter within your colleagues. I think we have covered the series with one column. Now let's again print the df here. Okay, now we have series with two columns. So let's again print the df, and df here is this one, and I think this is data frame only. So when I check, yeah, this is data frame. So now when I want to convert this to a series, what we can do, we can just use squeeze, which we have seen previously. And when you change it, and let's assign this to another variable, again series, and you can even check the type of this now, series, and type of this is series, right? So it's simple, nothing difficult. As we have already understood the attributes of series, okay, let's start some important series methods, and which you will be gonna use frequently. So first we have is the head and tail. So before that, let me just print the series here, and let's check it whether it's series or not. Type, yeah, it's series, so we are good to go. Actually, the name is df, and generally we keep the name df of data frame. But for now, just consider this as a series. And actually, a series is nothing but a slice of data frame. It can be a column or it can be a row. So just consider this as a series for now. And actually, it is a series. So let's apply a head. So head simply means the upper part, right? So by default, it will print out the 5 values from the top. And similarly, you can apply the tail, and tail gives the bottom 5 values, right? And if you want your custom values, you can give here the number, whatever you want. Let's say if you want the 20 values from the last, you can just give 20, and you will get the last 20 values. And you can even apply the same custom values on the head, and you will get the 20 values from the head. Next method we have is the sample. And sample means, let's say we have 100 values and we want a sample. So when we apply this sample method, it will randomly select any row and it will print out, right? But if we want a custom value, that also we can get. So let's say we have df and sample. So when we pass without any value, we'll get a single random value, and when you again try to print, you can see that we are getting always a different random value, right? But if you give here, let's say a value and 5, then you will get 5 different values, right? And what is the use of this sample? Let's say you have a large series, and in that the values are sorted. So in top we have the smaller values, and the last we have the larger values. So if you just print the head or tail, you will get a biased value, right? You will not get a clear idea. So when you want to have a bird's eye view of the data, what you can do, you can simply find a sample values. Let's say if the item in your series is like 1000, then you can get a sample of 100 values, and you will get the idea that how the values are there, right? So means you will not get the biased value in sample, right? So next we have is the value counts. The use of value count is it will print the number of times, the frequency of any value in the particular series. When we apply df.value count, it will give us this result, and we know that most of the prices are not repeating, only this one is repeating 3 times. So that's why we are getting 3, else all the values are only once, right? So you can also sort this value as per your need. So by default it's ascending false, so you will get the descending value, and if you make the ascending is true, then you will get the value in ascending order, right? Next we have is the sort values. So if I apply sort values, then what will happen? You know that in this data frame we have 2 things. One is index and second is values. So if you apply sort values, then these values will be sorted, and if you apply the sort index function, then these values will be sorted. So let's try this sort values, and you will see that all the values are sorted, and also you can make it ascending is equals to true, and you will get the values in ascending order, right? And when you make this ascending false, you will get the values in descending order, right? Similarly, you can apply this sort index. One more thing, that if you apply the in place here, in place means the changes or the modifications you make will be permanent, right? If I make it true, then what will happen? The values in the file, the data frame you have, will be changed permanently, right? So make sure when you're applying in place, you are damn sure, right? Because when you are working in production, there will be no chances of mistakes, right? So you should be aware of that. Next we have is the sort index, and which will sort the index values. So let's apply on this sort index, and you will see that the index has been sorted alphabetically, right? And if you make ascending false, then you will get the values in descending order. You can see that we have first the small letter D, then alphabetically all the Z to A. Okay, now we have few mathematical methods which you will be using very frequently. So let's understand them. Okay, now the first mathematical method is the count. So let's apply on our df. So df.count, and you will see that we have the value of 50, because previously we created this series with the head method and we gave the 50 custom value. That's why we are getting the 50 value. And again we have one more attribute here which we have seen already, and let me show you the difference between size and count. So what I'll do, I'll just print both of these, print, and I'll print the size also. So we know that the size is the attribute and count is the method. We know that in a class we have attributes and methods, and here we have the series class, right? So when I hit shift enter, we get both the values as the 50. The main difference is that size will also include the NN values, the none values, but count will exclude those values. But as here we do not have any NN values, that's why we are getting the same value. So in order to understand that, what I will do, I will create a simple series, size and count, and let's understand the difference between size and the count. So let's quickly create a series. So let's say math series, okay? Math series equals to pd dot series, and here we'll provide a list. So let's say 1, 2, 3, and here we'll give a none value. So that is, let's say NaN, small nan, and 4 and 5, right? And when I print this math series, it throws an error, says nan is not defined. Why? Because if you remember in the first video, I have shown you that whenever you import the pandas, please try to also import the
NumPy with that. So why? Because none values are from the NumPy. So we have to write np.nan, and then to make it work, we have to import the NumPy. I guess I have already imported that previously somewhere. That's why it is working. So, but still, let's import it again. And I'll import it here on the top. That's the basic convention. Okay. Now, when I hit Shift Enter, we get the value here, right? With the NaN value. And let's try to apply these functions on this. So what I'll do, I'll just copy and paste this math series here and here also. And I'll remove this. And let's paste this here. And you can see that in count, we are getting the value of 5, but in size, we are getting 6. Means the size always include the NaN values and count exclude the NaN values. So that's the basic difference, and you should be aware of that, right? Now let's move to the next method, which is sum. So as the name suggests, it will sum all the values. So let's take the first series, that is df, and when I apply sum method on this, so sum, and it will give us the sum of all the values, right? Similarly, we have product. So if I apply product, it will multiply all the values and we'll get a large value, that is 1.08 e to the power 45. Now we have some statistical methods, and if you don't know the meaning of these, do not worry. We will cover these methods in detail in our statistics part in future. But for now, just understand that how we can apply these methods. So df dot mean, and it will give us the average of all the values, right? Similarly, median will give the median value. Then we have the mode. Mode is the value which is frequently repeating. Then we have standard deviation, and you will get the standard deviation. And next we have is the variance. So these all methods are very, very important in algo trading. And for that purpose, we have to cover this separately. Okay. But for now, just understand and just remember that we have these methods in Pandas. Next, we have is the min and max, and the name signifies that you will get the max and min values of any series. So df min, and you will get the smallest value, and for the max, you will get the largest value, right? And the last mathematical method we have is the describe. So the describe will give you the overview of any data set. So first of all, so whenever you want to have an overview of the mathematical methods, you can just apply describe to your data set. So let's apply that describe, and it will give you the whole mathematical idea, like the count, mean, standard deviation, the minimum value, the 25 percentile, 50 percentile, 75 percentile, and the max value, right? So this is really important, and you should be applying whenever you want to have an overview of the data. Now we have is the series indexing, and in that the first topic is the integer indexing. So let's print our Pandas series. So for integer indexing, we have to have a series with indexes as integer. So for that, what we will do, we'll go up, and I guess we have created I think this is the series we can use for the integer indexing. So I'll just go and paste it here, right? And let's make it as int series is equals to, right? So now when I print integer, we have a series with integer indexes, right? So here it's same. I'll create another cell here. Let's create this. And here, if you give the integer values, so let's say integer series, same like the previously we have done. So you will get the first value. If you give the negative one, you will get the error. Because when you have the index as the integer, the negative indexing doesn't work. But when you have the label indexes, it will work without any error. So here negative indexing cannot work. Why? Because at this place you have to use the iloc and loc, which I will show you later, right? So for now, you just have to use the 0, 1, 2, the simple indexing, right? Next we have is the negative indexing, and we have seen that it doesn't work when we have the index as the integer. But if you have a series with the index as the labels, as the strings, it will work. So because we have a series df in which we have the indexes as the strings, and if you apply here the negative one, you will see that it is working fine.
1.95. But it's deprecated, so it's better you use the iloc and loc, right? Okay, next we have is this slicing. So slicing is simple, which we have seen earlier also. So let's say we have this series integer indexing, and here you want to print all the values. You just have to put a single column and you'll get all the values. But if you just want the 1 and the second value, so for that you have to give 1 and 3, and in that you know that the 1 will be included and 3 will be excluded, so you will get only 1 and 2. But if you are using on the label index, then the last position will be included. Let me show you. Okay, so I'll print this, and again what I will do, I will print df also, and let's slice that. So let me print it here again so we can have a look at the series. So let's print from BitTorrent to Shiba Inu, right? So I'll write here BitTorrent to Shiba Inu. So what happens here, integer index, what happens? So when we mention this 0, 1, 2 means 0 to 2, it will exclude this and it will print only this starting two values, which happened here. But in label index, if you print from BitTorrent to Shiba Inu, it will include all the three values, and that is the main difference between the integer indexing and the label indexing. So when you hit shift enter, you will see that we have all the three values, right, from BitTorrent to Shiba Inu. But in integer we just have the two values because it always excludes the last position. So that's the basic difference, and you should be knowing that, right? Similarly, we have the negative slicing, which works the same. Integer indexing, then you can do like -3 to -1, and you will get the values. Let's say we have this series with the label indexes, and if you want to use the fancy indexing here, what you can do, you can give the BitTorrent first, and second you can give Pepe. So just give a comma, and then you can give the bonk. All will get printed out here. It says undetermined string literal. Okay, you have to apply here, and now it's fine. It says key of type tuple not found and not a multi-index. Okay, you have to actually use a list here. So just give a list. Now you are good to go. So let's also see the fancy indexing with the integer indexes. So what I'll do, I'll just paste it here and hit shift enter, and here we can use the integer series. So and you give the values like 0 and 2, so you will get the position of 0 and 2. Just practice the multiple choice questions. Those are really good questions, and also the task questions. We have researched a lot on those questions, and it will be really beneficial if you practice those. Now next we have is the editing series. So we can again use the indexing. So let's say we have this series, right? And if you want to edit any value, let's say if you want to edit the index position 2, so you can just write 2 and change the value, let's say from 102 to 122, and when you hit shift enter and again print the integer series, it will be changed. So next we have is the what if an index doesn't exist. So let's say by mistake what you did, let's print it. You know that we have the index from 0 to 3, and by mistake what you did, you went here and instead of 3 you put a 4 here, right? And when you hit shift enter, you will not get any error. So let's do that. So what happened here? Just pause the video, just think what happened here, and if you know the answer, please let me know in the comments, and let's see how many of you are really understanding the concepts. If I print the series again, and you will see that we have another value with the index 4 and the value which we have given. Next we have this slicing. Let's say you want to change multiple values. Let's say I want to change this 1 index and the index 4. So for that, what I can do, I can use the fancy slicing, right? So for fancy slicing, I'll give a list and give 1, 4, and the value also we have to give as a list. So a list, and in which I'll give value, let's say 1000 and 1222, right? And now when you check the integer series, you can see that the value has been changed. Similarly, the fancy indexing is, let's say we have this series. Now let's change some value in the labeled series. So in fancy indexing, what we can do, we can give a list of values. So let's say if I give first the BitTorrent, And second, let's say I give the Pepe. So value of Pepe also 0.000012. So I just make it 1 and 2. Simple. And now when you again print the df, you will see that the value has been changed. You can see 1 and 2, right? So that's how you can use the fancy indexing. Next we have is the using index label. Actually, we have done this. For this also, you can apply any value here. Let's say to change the value of algorand with the label and change it to, let's say, 10001. And now when you check the value of algorand, so you will see that it has been changed. Okay, now we have series with Python functionalities. Here you will see that we can use almost all of the Python functions in Pandas series. So let's apply the length. So length and df, you will get the length. And similarly, if you apply on our custom series, that is integer series, you will get the length as, you have to apply the length. So when you apply the length, you will get the length as 5, right? Okay, now I got some questions that where to use the square bracket and where to use the parenthesis and where not to use anything. So let's say we have these things majorly, the parenthesis and the square bracket, and also let's say we have some functions like length, and inside that we will include the df, right? So let's say df dot count, right? And also we have like df dot size, and also we have somewhere like, and here we are including the df inside the length function. So what is the difference actually? Okay, let me show you. So whenever you see this kind of bracket, this is known as the parenthesis. So you can think that this is a method, right? And when you see without anything, you can consider that as the attribute of any class. If you see like this, then it might be an index for series or a data frame. You can write like series or data frame indexing. Simple, right? And if you see like this, that data frame or any variable of Pandas or Python is inside the any other function, then that is the simple core function, right? So basically in Python, you will see only these 4 types, right? One with the bracket or the parenthesis, and one without anything, and one inside the square bracket where the value itself will be inside any another function. So we have seen that in a class we have 2 things. One is attributes and another is method. And so here you can see that this method is from the series class, right? Also this attribute is from the series class, and this is simple indexing, and this is a normal function, right? So that's the basic difference which I have discussed earlier also, and now also I'm discussing this, right? So you should be aware of that. It's very basic. Next function we have is the type. So you can check type of any Python variable. So let's say check the type of df, it's series. Let's check the type of ent, it's also a series, right? Okay, next we have is the membership operator. So we have seen previously. So what we can do here, let's first print the df and let's try to search Flocky here. So what we'll do, we'll just write Flocky in df. So when you hit shift enter, it says true. That means it is searching only in the index, right? But if you want to search something in the values and index, you know, right? Let me show you. This is the index and this is the value. But if you want to search in the values, and it will be applied in the values, and now it will show as the false. Let me remove this. It will show the false because it doesn't exist there. So in values, what exists? We know that 1.0 exists there, and when you hit shift enter, we get a true value, right? Next we have is the looping. So looping, what we can do, we can just write for I in df and just print I, and when you hit shift enter, you will get all the values. So make sure you know the difference. That so in membership by default it applies on the index, but in loops by default you will get the values. So if you want to apply on the index, you just simply write index and you will get the index value, right? And we know that we can apply any kind of function here in the for, and you can use it as per your requirement. And now I think you are able to understand that why we gave so much emphasis on the basics, the fundamentals, because the devil is in the details, right? And also you can apply any kind of arithmetic operator on the, so let's say you have this series df, and what you did, you just did df plus, let's say, 100, and this is the best example of broadcasting. Means you are applying a scalar here and it will be applied to all the values of the series, right? Similarly, you can also apply the negative, let's say df minus 100, and all the values will be a negative with the 100. Similarly, we have the relational operator. So let's say we have this series. Let's say I apply df greater than 0.1, and when I shift enter, you will get the Boolean values. So if you want to get value, what you will do, you will use this as a mask and df, and you will get all the values which are greater than 0.1, and you will see all those with the examples and in a while. Okay, now let's check few examples of the Boolean indexing, and let's see how we can apply them in the real life. So here we have a question that find values which are greater than 0.1 but less than 0.4. So for that, what we'll do, first we'll print out the data frame and we'll apply the condition, that is greater than 0.1 but less than 0.4. So we have to give the and df less than 0.4, right? And then hit just shift enter and you will get an error, right? So in order to avoid the error, what you can do, you can close these in the brackets like this and now hit enter, and you will see that we get all the values as the Boolean, false and true. And now in order to get the real values, you just have to make these as a mask, pass the df, and you will see that you have all the values which are greater than 0.1 and less than 0.4. And here you can apply as many as conditions you want, and that's how you can use this in your algo trading. Again, we have a question that says find number of values which is exactly equals to 1. So for that, we need to write df is equal to 1, and when you hit shift enter, and you will see that all the values are false except the one value. So let's check df. We have few more values, that is BitTorrent, DAI, Athena, USD, and Starknet. So now you can observe that how powerful this is and what you can achieve with this, right? Now we have some interesting part, and for which you are waiting from a long time. I know that. So let's see how easy it is to plot any chart in the Pandas series. So first what we will do, we'll just print the df, and then you just have to write a simple method that is plot, and just need to hit shift enter, and that's it. You will see that you have a plot. But now it's not looking that good because we have only few values, right? These ones. So for that, what you will do, you will just go back and again initiate the data frame, and now when you come back and plot the value, and now when you shift enter, actually I generally face this issue in Visual Studio Code. I don't know why, and for that I need to restart my kernel. So let's restart again. So now when I shift enter, it will throw an error because again we have to import the data frame. So we'll just go back quickly, see where we imported the file. Okay, here we first importing from the CoinGecko with the API, and now we will export to CSV, and now import to CSV, and I guess now we will be having that. So plot, now we can plot that. So when we plot, because it is plotting the whole data frame, but as we are learning here the series only, so first what we will do, we'll convert the data frame to a series. And I think it will also good for you that you will also learn how to convert a data frame to a series, right? So what I'll do, I'll first print the data frame, and you can see that we have so many columns and the rows, right? 100 rows and 26 columns. So I just need the name as we had previously. So I'll write here the name and write the current price. And when you hit shift enter, you will see that we have only 2 columns, right? And one is with the index. But still we know that this is a data frame. Let's check the type of this, and you will see that this is a data frame. But what we want, we want a series. So for that, what we will do, we'll create a new data frame. Now df dot set index as the name, right? And also in place is equals to true. And meanwhile, I'll just, now let's hit shift enter, and I'll just comment out these values. And now when we check the data frame, you see that we have the index as the labels. And again, when you check the type, it is still a data frame. So for that, we have seen that what we can do, we can simply squeeze it with the method and assign to a new data frame, right? So let's comment this also again. And now when you check the type of data frame, it is a series. So now we are good to go. So what I'll do here, I'll just print the data frame df, and when we plot this, you will see this beautiful plot. So here what is happening, only few values are very large, and because of that we are not getting a good plot. So what we can do, we can just sort that. So we know that by default it is descending. So what I'll do, I'll just print the below 50 values. I'll create a new data frame with that, right? And I'll just comment it out again. And now when I plot, you will see that we have issues. So what we can do, let's give it like explicitly. So now what we can do, we can sort this. So for that, what we will do, we'll write as df dot sort values, and ascending is equals to false. Okay, so let's check this, what we get. You can see that we have the values in descending order. What we can do, we can just get the tail 50 values, and we can create a new data frame. And I think now we can plot this, and we should be getting a good. Actually, let's do this way. Okay, let's just take 20 values, okay, and plot them. And you can see that we have the line chart. And if you want, you can have a different kind of chart, like a pie chart or a bar chart. So for that, you just have to mention here kind equals to, and you will get a pie chart. And if you change it to, then you will get a bar chart. And you can see that we have a bar type and line chart. And this way you can create any kind of chart on any series. You just need to have a basic understanding and you are good to go, right? Okay, now in last we have some important series methods. So we have as type, between, clip, drop duplicates, is null, drop na, fill na, is in, apply and copy. So whenever I have a new data set, I always clean that first and I apply all these functions, all these methods. So let's say we have df here. If I apply as type here, okay, so here actually let's first check the type of this d type. So df dot d type, and you can see that this is a float 64, right? And if you check the size of this sys dot get size of, you will see that it is okay. For that you have to import the library, import sys, and you will see that this is 96, and I think it's very less, so it will not make much difference. So but still let's check this. So I will just convert the data type of the data frame. So df dot as type, and let's say I will give d type equals to np dot int, and let's make it a new data frame here. Or let's just print this. It says np is not defined. We have to import the numpy also as np, and when you check, it is printed out, and d type is integer 16, right? And if you check the size of this now, let's check it. So sys dot get size of, and you can print this also. Actually it's very small, so it will not make much difference, I think. And when you check this, okay, let's store this in something else. On the next line, what I will do here, I will just, let's make it dff, and now when you check the sys dot get size of the DFF, it is 28. So you can see that it has reduced to almost 4 times of the original value. So now you imagine that you have a file of 10 GB, and if you want to reduce the memory footprint, you can use these kind of methods. If you know that we can store this value in some other data type and that can reduce your size, then you can definitely apply that method, right? Next important method we have is the between. So let's first print the series df, and here I'll apply between. I can give the value as 0.3 to 0.5, and when you hit shift enter, you get a boolean result, and in which you will get only the values between 0.3 and 0.5. So sometime it becomes so useful that those relational conditions, right? So you just have to use it as a mask df, and you will get only the values which are between the 0.3 and 0.5. Let me show you what you have to do. You have to first write df should be greater than 0.3, right? And df should be less than 0.5, and you have to close this in a bracket, not this whole in a bracket, and again this also in a bracket. Then you have to use it as a mask, and then you can print, right? So let's print both of these together and check whether we have the same value or not. So print, and let's print this also. So you can see that this between becomes so useful that you don't have to write the code with this, right? Because these are some useful functions and it will really useful and handy. Okay, next we have is the clip method. So in clip method, what happens that if you give a range, so what will happen, all the values of the outside of that range will become same. Let me show you how. So let's first print the series here, and let's give a range like, and a range, let's say 0.6 to 0.7, or let's say 0.4 to 0.7. And when you hit shift enter, you can see that the value above 0.7 becomes all the same, and the value below 0.4 becomes all the same. All are clipped together. You can say that, right? So this is not that useful. You will be using more the between actually, but just still keep in your mind, it might be useful sometime. Next we have the drop duplicates, and it is one of the most important method. You will be using it a lot. Okay, let's say we store this in a new data frame, and let's say df, okay, 2 times. It's a new data frame, and when you print here df, you will get this, correct? So if you apply drop duplicates here, when you hit shift enter, you will see that all the duplicates has been dropped. So it becomes really useful a lot of times, but the issue here is that you will lose your data sometimes. You just don't want to remove the data, but you want to replace the duplicates. We will see that how you can do that, right? Next we have is null. Apply that on this data frame df dot is null, and when you hit shift enter, all value are false because there is no null value. So if you want to test it, what we can do, we can, let's print the integer series here. Let's create a series quickly. So period series, and here we'll give an 1, 2, 3 np dot nan and 4 and 5, and now integer series, and if you apply is null here, it says true at this value because this is a null value, right? And if you want to check the exact value, you can use this also as a mask here, integer series, and you will get the third index as the null value. So this also you can use when you have a large data set and there might be so many values which are missing, and you can use this is null. So let's say you have multiple null values, so I'll make it also as null, nan, correct? And the last also I'll add another value as null. And now when you check, you will see that you have 3 values as null. So here how you can use it. Now when you simply apply is null, you will get a boolean values. But if you want to check how many values are null, you can simply apply sum, and you know that the false are considered as 0 and the true values are considered as the 1. So it will just sum that there are 3 values which are null, and you will get a clear idea that how many values are null in your data set, right? Next we have is the drop NA. So drop NA is a really beautiful function. So you know that there are 3 values which are null. So what you can do, you can simply apply integer series and drop NA and hit shift enter, and you will see that all the null values are removed and you will have a clean data set. Next is fill NA. So what happens, sometimes you just don't want to remove the rows, complete rows. Instead of dropping that, what you will do, let me again print this integer series and apply fill NA, right? So what you will do, you will just fill with some string, let's say missing values, and when you hit shift enter, you will see that instead of NaN, you are getting missing value. But sometimes you also don't want to fill with missing values, but a mean of that series or that data frame. So what you will do, you will just go here and instead of missing values, you will apply function here, and that is integer series and mean, right? And you will see that you have filled the null values with the mean of that series, and that's also useful. So make sure you remember all these functions, all these methods here, right? Next we have is the isIn. So let's print the previous series, that is this one, and just apply isIn, and here you have to pass a list. So let's say we pass the prices, the 0.7, and let's take another price 0.11, and let's take another price 0.027, and when you hit shift enter, you will get a boolean value, and in order to print that, you can use it as a mask and you will get the 2 values. Maybe it was not correct, so you can remove this and you will get the 2 values, right? So with the help of isIn, you can pass a list of your desired value and you can get a boolean value, right? Okay, now next we have the apply, and this is one of the most important function you will be using, and let's check it how you can use that. So in df, you can see that in the values we have all the float values, and let's say you want to round off these values. So just for the example, I'll show you that how you can use the apply method here. So df dot apply, and then you will use a lambda function here. So lambda x, and then you can round these values. So round, and here x, and let's say round it to up to 2 values, right? So now when you hit shift enter, you will see that all your values are rounded up to 2 values. And if you remove this 2, then it will be by default rounded off to a single value, right? And it will become an integer instead of a float. Now the last method is copy, and copy is really useful because always you don't want to make any changes in your real data sets. So let me show you how. Let's say you have this data frame here, correct? And what you did, you just created a new data frame, let's say head, right? And with the name DFF, correct? So now in this DFF, you will be having only the top 5 values. So let's say if you change the value of flow, okay, flow here, you are changing the value in DFF, make sure, right? So let's say you make it as 100, right? So when you hit shift enter, and now when you check the value of DFF, you will see that flow is 100, Athena is the same and remaining the same. But here you made changes in DFF, but now when you go back and check DF, you will see that the original value has also been changed, and this is not good. This is really not good. So when you want to make any changes, make sure you are using the copy method, because here it is not copying the value, but it is giving a view of the original Pandas series. So in order to avoid that mistake, what you can do, instead of just giving this, what you will do, you will create like df dot copy, right? And then you can create a new one. So let's say dfg, and Now when you check DFG, you have this value, and you can make any changes. Let's say I'll make change to Athena, and I'll make it as 200, right? So let me add here. These are the code for the initial charts I have shown you. So if you want, you can use this. I'll keep it in here only, and I'll push to GitHub. So let's say now check the DFG, and the value is okay, Athena. And now when you check, you will see it's 200. But in the original data frame, when you check, it is still the same, right? So that's how you can avoid the mistake by using the copy function here.
So before starting with the coding examples, let me tell you what is OHLC. So OHLC stands for open, high, low, and close. And sometimes we also use V along with OHLC. So V stands for volume. So generally, whenever we fetch data from any source, be it a crypto exchange, a forex exchange, or a traditional stock market, you will always get the same data, and that is OHLCV, right? And that is what needed for your trading or algo trading, right? So as I have used the OHLC data in previous videos, so before going further, let me first clearly explain you how does this OHLC works. Okay, so let's get started with OHLC. So here on the screen, you can see that we have two candles. One is green and another is red, right? So if you can see, it is clearly written that we have a low, a high on the green candle, similarly a low and high on the red candle, right? Similarly, we have an open and a close on green candle, but in red candle, it is different. The open is on the top and the close is on the bottom. So how does we define this OHLCV? So let me show you. So generally, so whenever you see any trading chart, you will see these type of data. It can be a candlestick chart, it can be a bar, or it can be any other type of bar or candlesticks. But more or less, you will have this kind of structure, right? So here, if you can see, you will observe that from here, this place, the price is going up. This phase is known as the manipulation, right? Okay, so along with OHLCV, you will also learn something else. Again, this price will increase from here to here, and this phase is known as the distribution, right? Distribution. And again, here it comes the manipulation. And this will also the distribution, correct? And here you can say it is manipulation, and this little bit phase known as the accumulation, right? Okay, then what else we have in this chart? Okay, let's focus on one candle. So I'll remove this for now. You will see that this one candle dropped from this place to this place, right? So we can say that this candle started from this point and closed at this point, right? So you can say this is known as the open of this red candle and this is the close, correct? Then let's say if this candle was of the 1 hour chart, okay, 1 hour. So means we can say in 1 hour, there were multiple 1 minutes or 5 minutes candles, right? So what happened in that particular 1 hour, this candle reached at this point, the top, this point, right? So you can draw a line here and you can mark it as the high of that particular candle. And also this candle reached the low of this point, right? So you can mark it as the low. Hope now you are able to understand that this candle opened at this point, which is the open, and closed at this, which is known as the close. And in that particular 1 hour, it reached to this highest point, and this lowest point. So these are known as the high and low. So let's give it some value. So opened at 100, right? And closed at 80. And we can consider high as 120 and low as 60, right? Hope it's clear. So this OHLC data is for this red candle, we can say OHLC, and this is the volume. So sometimes we also need a volume also. So we say OHLCV, correct? Similarly, when we check about the green candle,
So what happened here? This green candle opened at this place, this point O, closed at this point, which is C, and in this 1 hour, it reached to the highest point of this, right, and the lowest point of this one. This is lowest, this is highest, correct? So again, you can give some values here. So opened at, let's say, 80 and closed at, let's say, 85, correct? Highest you can give it as 90 and lowest you can give it as, let's say, 75. So this is the OHLC data of this green candle, correct? The only thing you need to notice here is that in red candle, the open is at the top, and in green candle, the open is at the bottom, right? Similarly, in red candle, the close is at the bottom, but the close in green candle is at the top, right? Hope it's clear. And if you still have any doubt, you can let me know in the comments, and I can repeat this again in any other video, right? Okay, now let me compare this with a data frame. So now if you can see on the screen that we have data of 1 day, right? You can see here, this is 1st January 2015, this is 2nd January 2015, right? So let's suppose these all candles are 1 day chart. So let's suppose these all candles are 1 day chart, means each one candle represents a single day, right? So you can say here that open is 101, right? So let me just remove this one first. So now how you can identify from a data frame that whether it's a red candle or a green candle. So for that, what you will do, so you will check whether the open price is greater than the close price or not. If the open price is greater than the close price, so means if the open price is greater than the close price, means that is a red candle, correct? And if the open price is less than the close price, means that is a green candle. As simple as that. Let me show you how again. So let's see on this first row, this one, you can see here open is 101.03 and close is 101.19, means open is less than the close, means that is the green candle. And we can also represent that in a candle. Let's say open means this open is 101, right? Then close is 101. So let's suppose this is the close, correct? So open is below the close, means that is the green candle. Again, let's check on the next row, and here the open is 100 and low is 99, means now the open is greater than the close, right? So we can say means this open is greater than the close, which is here, and this is a red candle. I hope you are able to understand what I'm trying to say. And this volume is this candle, this one, this bar is the volume bar. Don't worry, we will understand this in detail in further videos. But for now, as we are using this OHLCV data, that's why I thought it's important to explain you the OHLCV data, right? Hope it's crystal clear for you now. But if you still have any doubt, please let us know in the comments and we'll be happy to help you. And you can also let us know that which kind of explanation you like and how we can improve the explanation for you and what else you need for your better understanding. So with that being said, let's dive into the coding part. Okay, so let's create a data frame. So we have seen that a data frame is nothing but a combination of multiple series, or we can say a series is nothing but a single column or a single row of a data frame. And we know that the pandas consider a table as a data frame, right? So let's quickly go and create a data frame with the help of a list. So let's say I'll create a 2D list, right? And inside that I'll give some price data. So let's say 1, let's take 100, 200, 3, 400, and 600, right? And inside that I'll pass multiple lists. So what I'll do, I'll just give here a comma, then again a list, comma, then again a list, a comma, and again a list. So means we have a 2D list, right? And now what we can do, we can simply write the PD data frame class, and inside that we can pass this price data list. So when we hit shift enter, it says
PD is not defined. Why? Because we have to run this cell, and we have seen that whenever we import Pandas library, please import NumPy also along with the Pandas. So I'll go here and hit Shift Enter, and now when I run this, you will see that we have a data frame created. So what I'll do here, I will just save it to a, let's say, list df, and so when I check the type of this list data frame, you will see that it is a data frame, right? Similarly, we can create a list with the help of dictionary, and that is slightly easier than the list. So what I'll do here, I'll just copy and paste the same data, and I will try to create a dictionary first. So let's keep the variable as same, and I'll remove this, and I'll add a bracket here, and then I will create some keys and value. So let's keep these value same, and I'll create some keys here. So let's say OHLC, so open, right? And I'll just copy it and paste it here. Open, high, low, and close. I'll just change this high, low, and close. Correct? So similarly, I'll go here and I'll write pd dot data frame, and I'll pass price data here and hit Shift Enter. And you will see that we have a data frame with the dictionary. And here also we can add another column, and let's say give it the name. I'll copy it and paste it here, and let's give the name, and in this name I can give some name of the stock. So let's say, let's keep it Apple, then we can keep it Microsoft, we can keep it as Tesla, and let's keep this as Meta, right? And now when we Shift Enter, you will see that the first column is with the name of the stocks, and then we have the OHLC value of those stocks, right? And also you will observe that we have an index that is a default index, which we have seen previously in the series also, that whenever we create a data frame, we always have an index, default index, right? And if you want, you can even replace this with the column name. So what I'll do here, I'll go and first I will store it as let's say dict df. Let's hit Shift Enter, and now I will change the index. So dict df, and I'll use a function that is set index, which we will read in this lecture. So for now, just remember this, that set index, and here you have to give the name of the column. And so we know that the name is name, right? And now when you hit Shift Enter, it says invalid syntax. Why? Okay, we have to remove this one. Yeah. So now you can see that we have the index, but still it is not permanent. So let's say in the next line, when I check, it is still the default index. So for that, we need to use a hidden parameter that is in place. In place is equals to true. And when you hit Shift Enter, now you will see that we have the permanent index as the name. So we have seen that we can create a data frame with the list and also with the dictionary. Now let's move that how we can create a data frame with the CSV. And actually in the real life scenarios, you will be getting a data frame, maybe in the form of API, or you will get a CSV. And with that, you will have to create a new data frame. You will not create with the list or dictionaries. It was just for the understanding, right? So here I have two CSVs. So to follow along, what you do, you just go to GitHub and download these two data sets, or you can just clone this GitHub repository in your local, and you can use these data sets. Okay, let me show you these data sets. So in this algo trading combined data set, we have multiple types of data like the stocks, crypto data. And in the second data set, we have the fundamental research of the stocks. So in that, we have the sector, the stock name, and like the prices, right? So you can download and you can use it. Okay, so let's import this. So what I'll do here, so to create a data frame with the CSV, what you can do, you can just use the function read CSV, right? And you can import the file. So we have the file with the name algo trading combined dataset. So algo trading combined dataset. And when you hit Shift Enter, you will see that you have the data frame here, and the number of rows are 32,000 and the number of columns are 7, right? So what I'll do, I'll store it in a variable and let's say the variable name is algodf. Okay, algo data frame, and let's import this one also, this fundamental research CSV. So I'll write pd read CSV and the name of the file, that is fundamental research dataset large and CSV. So now when I hit shift enter, you will see that we have the data frame with the 1050 rows and 10 columns. So I will store this also in variable, and we can give it the name as, let's say, funda.df, correct? And hit shift enter here also and here also. And let's print the algodf and the funda.df. Hopefully it's clear. It's very easy. You just have to use the read CSV function, and then you have to give the name of the CSV file, correct? Now we have some data frame attributes and methods, similarly, which we have studied for the series also. So in data frame, the first attribute we have is the shape. So let's check the shape of both the data frames. So algodf.shape, and you will see that it will give us the shape of the data frame, which means the number of rows and the number of columns. Similarly, you can check the shape of the second data frame, that is funda.df, and shape, you will see the shape of the second data frame, that is 1050 rows and 10 columns. Again, in the D types, it will show you the data type of each row, right? So here the date, ticker, open, high, low, close volume, and you will see that object, and rest all are the float 64. And you know that the object is considered as string in data frame, right? Let's check the D type of funda.df, D type, and you can see that we have the 4 columns of object and rest are float 64. Okay, next we have is the index attribute. So let's check the index of algo df, and you will see that we have a range index, right? Start from 0 and stops at 32870 and step 1. So range index is nothing, but we have already studied about this previously, the range function. So in that we get a range. Similarly, here we get a range index, right? And we can check for the funda.df also, funda.df and index, and you will see a range index from 0 to 1050. Next we have is the column attribute. So it will display all the column names of any data frame. So let's check the column of algodf, and it will print out all the column names. It says algodf is not defined. Actually, I restarted this kernel. That's why we have to again run this one. So I'll go here and run this. Actually, I have to run from starting, and now I will again run this cell and this also. Now it should work. So when I run this, we'll get the name of all columns. Similarly, you can check for the funda.df. So funda.df dot columns, and it will give you all the column names. Next is the values. So you know that we have index and values. So with the values, you will get all the value of the particular data frame. So let's check algodf dot values, and it will give you an array, and that will be 2D array, right? And for funda.df also, you can check, and you will get a 2D array, correct? But it's not that useful for us. But sometimes you can use some Python functions, and you can use this. Okay, now let's check some methods of the data frame. First, we have head and tail, which is exactly same like this series. So let's check algodf dot head. It will give you the first 5 rows of the data frame. Similarly, you can use tail here, and it will give you the last 5 rows of the data frame, right? And you can also use the custom values here. Let's say you want last 20 rows. So you can use 20 here and hit shift enter, and you will get the last 20 values, or you can say last 20 rows. Then we have sample, which is also same. So it will randomly select any row of the data frame, and it will print out that. If you run it again, you will get another row. Again, you will get another row, right? And here also you can use custom values. Let's say you want 10 sample values. So it will give you 10 random values from the data frame. You can see here. You can again run this. You can use this method when you have bias in your data, right? Bias means maybe your data is slightly tilted towards any one side, right? So that time you can use the simple method. Next, we have a very useful method, that is info. So if you apply this on the data frame, the info method will give us a lot of information, like
the number of entries, the number of columns, and the non-null values, right? And the data type of that particular column, and again the memory uses of that particular data frame. Correct? Similarly, you can also use this on the funda, df, and info, and you will see that it will give us the output of this, and you can see here it is using 82.2 KB and it has 10 columns and 1050 entries, the number of rows. Next method we have is the describe. Describe gives you the mathematical information of that particular data frame. So it will be applicable only on the numerical columns. So let's apply on the algo df describe, and you will see that it will give you the count, mean, standard deviation, the minimum value, the 25 percentile, 50 percentile, 75 percentile, and the max on all the columns. Next we have is the isNull, and this function is really useful. Let's apply on this algo df isNull, and it will go to every value and it will ask are you null, and if it is true then it will give us a true value, else a false value. So to quickly calculate the number of null values, you can just apply another function, or you can change the method, that is sum, and it will calculate the total number of null values in the data frame. So you can see that in date and ticker we do not have any null value, but in open, high, low, close, and volume we have these many null values. It can quickly calculate that. Why? Because we know that the value of false is 0 and the value of true is 1. So it will quickly calculate all the ones and you will get the answer quickly, right? Similarly, you can also apply this on the funda df. So let's check how many null values are there, and is null, and then you sum it with the method chaining, and you will see that it has these many null values in the market cap, EPS, DE ratio, and so on, so forth. Next method we have is the duplicated, and this is very important because you will be always using this duplicated method. Why? Because you will have to find all the duplicate values from your data set, because those values always create some issue, right, while analyzing. So what we will do here, I'll go tf and we will apply duplicated method, and you will see that it will show you that which row have duplicate value, right? And then you can just apply sum on this also, and you will see that we have 1565 duplicate rows. Okay, let's check the duplicate value in funda df data frame and duplicated. Then we can give a method chaining and sum. So you will get 50 rows are duplicated, right? So that's how you can analyze the data, and you can find the null values, duplicate values, and that is known as the data cleaning, or you can say data preparation. Okay, next method we have is the rename method can modify the name of your columns. So let's say here we have algo df dot columns, right? And let's say you want to change the value of high low to max min. So what you can do, you can just apply a rename here, and then you can give a column, and then you have to provide the dictionary. So here first you will give the original name, that is high, correct, and then the new name. So you want max here, again you will give second one, which is low, and instead of that you want minimum, right? So you will just write min and like this. So now when you hit shift enter, you will see that instead of high and low you have max and min, and if you want this change permanent, you have to apply in place here, right? And when you make it true, it will be changed permanently. So whenever you apply in place, you have to be double sure that you know what you are doing in the production environment, right? Now we have some math methods, right? First we have is this sum. So you know that sum all the values. So when you apply sum, you will get all the values as, and you can see some interesting stuff here that it has even added the strings, the objects, right? You can see here apple, and here also it added all the dates, because these two columns were in the object data type, right? but the rest were floats, so it added like the same usual. Correct. You can also apply on the fundamental data frame, and when you sum that, all the values will be added, including the objects, right? So it will concatenate the strings and it will add the float or integers. And you can also apply all those mathematical methods which we applied in this series, like the mean, median, mode, standard deviation, or variance. You can even check. So let's say I have this algodf, and you can check the mean of that, right? It will take, okay, it says could not convert because it cannot apply mean on the strings. So for that, you have to select a specific column or only the columns with the float or integer values. So let's say we apply the mean on the high column, and when you apply on that, you will get the mean of that column, right? Similarly, you can apply the variance also, funda df. Don't worry, we'll understand all these in the future. The variance you can apply on, let's say, the market cap, and when you apply var, you will get the variance of that. Okay. Okay, now we have selecting columns from a data frame, a single column. So we know that we have this data frame, and inside that we have 7 columns. So if you want to select any column, you just have to give the name of that column. So let's say close, you will get the value of close. You can even get the high, you will get the value of high for this single column. Okay, now if you want to select multiple columns, what you can do, let's say you have this data frame, right? And if you want the sticker and the industry and the market cap, so for that, you have to give a list inside a list, right? Then you will give a ticker, sector, and hit shift enter. And if you want something else also, you can get, let's say, market cap, and you will have the market cap. Actually, I think we are, and check, okay, we have this B also here. So now when you hit shift enter, you will get all the 3 columns, right? So it's, I think, quite easy, nothing difficult in this. And you can easily extract the columns from a data frame, right? Okay, now let's understand how to select rows from a data frame. So here we have 2 options. One is ilock and another is lock. So for simplicity or understanding, you can remember that ilock is for the index and lock is for the labels, right? So let me first print our data frame, that is algodf, and let's say I want this first row. So for that, what I'll do, I'll just write algodf and ilock, because here we are printing the row with the number, the index number. So I'll just write 0 and you will get the first row, right? And let me make it single row, and for the multiple, we'll add another cell, and in that I'll just write multiple. And here what we can do, let's say algodf, and I want to print algodf dot ilock, and I want to print multiple lines. So for that, you can use the same indexing which we have used in list, dictionaries, and all those. So here you can use the, like you want to print from 0 to 4, so you can use 0 to 5, and you will get all the initial 4 rows, right? Similarly, let's say if you want to print from the row number 0 to 9, so for that, what you can do, you can write 0 colon 10, and you will get from 0 to 9. And here you can also use this step which we have used previously. So let's say I want all the alternate rows, right? Let's say I want all the alternate rows. So I'll write 2 and you will get alternate rows, right? 0, 2, 4, 6, 8. The interesting thing is that you can also use fancy indexing here. So for that, what I will do, I'll write algo trading and ilock, and inside that, for the fancy indexing, we have to pass a list. So let's say I want to print the row number 1, then I want to print row number 4, then row number 7, then 9, 10, then 13. So why we use the fancy indexing? Because no consistency, right? And there is no pattern. Because here we had a sequence like from 0 to 10, then we can have a step from like 2, 3, 4. But here there is no pattern. So for that, we need to use fancy indexing. And let's say I want to also print the row number 1300. So there is no pattern. We want to just print a random number. So now let's hit Shift Enter and you will get all the rows which we have mentioned in fancy indexing, right? So now let's understand the LOC, right? So we'll try to print the rows with the label index. So let's print the funda.df here. And what I will do, I will try to print, and you will see that all the rows with the index as apple gets printed out. But we know that there are multiple rows with the same index name, right? So I would like to print few more stock names. So I will check what options are there. We have Google, we have Microsoft. So I'll also add here the Google and also the Microsoft, right? And for that, we have to enclose this in a list. So it will become a fancy indexing with the LOC. And when I Shift Enter, you will see that we have all the rows with the Apple, Google, and Microsoft. Correct? One more interesting thing is that if you want, you can still print with the index positions. It is not visible here, but you have to make sure that it is always there behind the scenes. So for that, what you will do, I'll just copy, or let's write in another cell. So funda.df dot ilog, and here I'll give, let's say, from 0 to 10, and you will see that all the rows from 0 to 10 is printed out. You can also use the indexing here, right? It's same, right? Because the index is there, but it is behind the scenes, right? So hope it's clear to you, the ilog and log. And let's move to the next topic, which is to print both the rows and columns together, right? For that, what I will do, I will write ilog. So first we will check with the ilog. So I'll write ilog. The rows we want from the 0 to 5. So I will write 0 to 4, then a comma, and then again 0, 1, 2, 3. So I have to give 0 to 4, right? And here I want from 4, so I will write 5. And when we hit Shift Enter, you will see that we have only the specific number of rows and columns, right? Similarly, you can also use lock here. So for that, what I'll do here, I'll write funda.df dot loc, and let's say we want to print the rows with the name Apple, and we want to print from company name to market cap. So I'll write company name to market cap. Okay, now if we give here the slicing or step size, then what will happen, as this apple is not unique here, it will give an error, right? If you try to do that, let me show you. Let's say if I want to print from Apple to Tesla, so what I will give here, TSLA, and you will see that we have an error because there is a conflict of indexes. So for that, I can remove it. We can just print this. And now this is the question for you, that how we can print with the LOC from Apple to Tesla, right? Just pause the video and let me know. Actually, we cannot do that. You can try yourself. You can download this dataset and try. If you get the answer, please let me also know, so I can also learn, right? So now let's do that with the different dataset we have, that is AlgoDF. And what I'll do here, I'll first check the content, and then I'll apply LOC. And here I'll give, let's say from 0 to 5, the column number, right? So I'll print, it will get printed 0 to 4. Then for the labels, let's say I want to print from date to the close, right? So I'll just write close. And when I hit Shift Enter, you will see that we have the desired data frame, right? So that's how you can use ilog and lock. We can discuss this further if you have any issue, and please let me know the answer of that issue we got. So next we have is the filtering at data frame. But before that, let me show you how to add a new column, right? So what I'll do here, let's take this AlgoDF. We have date, ticker, open, high, low, close, volume. You can just give a new name, let's say new column. The values you can give anything. Let's say you want to give a string, let's say Kuldeep Singh, right? So when you hit Shift Enter, there is no output, means something has happened permanently. So now if you print that data frame, you will see that we have a new column, that is Kuldeep Singh, right? So that was easy. Let's say you want to add another column from the existing ones. So for that, what you can do, you can write like algodf, and let's print any column here. Let's say the close, right? And what you will do here, you just have to assign a new name to this algodf, and you will say the new close. You will have to do it so many times, new close, because sometime, let's say if I divided this with any number or multiplied this number, I multiplied this with 100, so you will get a new column with the multiplied value. We will do this a lot of times. I'll show you. Now when you check the data frame, you will see that we have another column with the multiplied values. So that's how you can add new columns, a completely new column, or from the existing ones. So as we have seen previously, that how we can convert chart data, the OHLC, open, high, low, close, to a data frame, and then we can convert the data frame, and then we can use that data frame for our algorithm, and then ultimately we can convert that algorithm to some dollars, right? So let me quickly revise the OHLCV again. So previously we have seen that in the red candle, this is the open, this is the close, this is high, and this is low, correct? Similarly, in a green candle, this is the open. Let me show you some another candle. This is the open in a green candle. This is the close, this is the high, and this is the low. And again, this is the volume, right? Basically, you have open, close, high, low, and the volume V. So OHLCV, correct? So that can be converted to a data frame. And why we convert to a data frame? Because in code, we need some series, we need some numbers, we need some integers, and that's why we convert a chart to a data frame. And that can be easily analyzed, that can be easily manipulated, and so on and so forth. So our main agenda for today is that we will learn some functions which are critical, which are important while learning the algo trading. And if you learn these attributes and methods, then I can assure you that it will become a lot easier and simpler for you to create any algorithm, to convert any chart to a code. So what I have done, I have categorized the methods for Pandas Series, the methods for Pandas DataFrame, and the methods which can be applied on both the Pandas Series and Pandas DataFrame, right? If you can see on the screen, then we have these methods for the Pandas Series and these many methods for the Pandas DataFrame, right? And these are the methods which can be applied on both the series and data frame. And many of these functions we have already learned, and remaining we will learn in this session. So what we will do today, we will practice some real life based algo trading scenarios, and you will see that how in real life we convert and how in real life we work on data, how we clean the data, how we analyze the data, and how we can manipulate the data in real life algo trading scenarios. So then, without a further ado, let's get started. Before starting the video, let me tell you something that we have two CSV files, right? So in the first file, we have data of the tradition stock, the crypto data, and in the second file, we have the fundamental research data. So generally, when we want to go long term in any stock, that time we use the fundamental research, and that is also sometimes crucial, right? And one more thing, that this data is synthetic, right? Synthetic means this is not the original data from any source. It was randomly created by the code. So I have shared both the codes for both the data sets, and you can use this code as per your requirements. You can change some values, you can change anything, and you can use it as per your requirement. So I'll push this also to the GitHub. You can clone the repo from there and you can use that, right? Okay, now, as I have already explained you the agenda for today, that what we will do, we have two data sets and we will try to perform various operations which we generally perform in the real life algo trading scenarios, right? So in order to achieve that, first we will clean the data. Then we will analyze the data and finally show you the data. So what I'll do, I'll just import the CSV files here. So pd.read CSV, and I will give the name of the file. The first one is algo trading combined dataset. And what I'll do here, I will give this the name, let's say algo df. Let's make this consistent because we have worked on this dataset previously, so it will be easier for you also to understand, right? The next is pd read CSV, and the name of the file is fundamental research dataset, and let's give this data frame the name as funda df. Let's hit shift enter and try to check out the data. So the first one is algo df, which is this one, and the second one is the funda df. So in the first data frame, algo df, we have 32,870 rows and 7 columns, which is basically a OH LCV data. And the second data frame is the funda df. In that, we have 1,050 rows and 10 columns. So in that data frame, we have the fundamental analysis, the fundamental values, and on which we can do the fundamental research. And again, let me reiterate this, that both of these data frame are randomly generated data, right? So there is no real value here. The first question is identify all the top performing stocks based on their overall return from the start to the end of the data set, right? That means, so let's print the data frame. And what this is saying, that we want to display the top performing stocks, right? From the start to end. So let's first check that how many number of stocks we have in this data frame. So for that, what we can do, we can check with the ticker. So let's print the value of ticker here. And when we do that, you will get 32,000 rows. But we want the unique values. So for that, we can use the function unique, right? And you will get an array of unique values. And so you can see that we have Apple, Google, Microsoft, Amazon, Tesla, Euro USD, GBP USD, USD JPY, AUD USD, USD CAD, BTC USD, ETH USD, XRP USD, LTC, BCHN, and nothing. So means we have a mix of traditional stocks, the forex pairs, and the crypto pairs. Our main goal here is to sort these stocks based on their performance, and we can say in descending order, right? So we have seen that in the algo df data frame, we have the starting date is 1st January 2015 and the end date is 18th of September 2020, right? So if we want to understand this in the chart, we bought a share at this, right? And let me highlight this. And that time date was 2015, 1st January, right? And I sold the stock at this place, right? And we can say that time the date was 2029, 18th of September 2020, right? Means all these values are, these 32,870 rows are all these candles. I think it's clear, right? So now we can calculate on open or close. So generally we select close. So what we will do, we will check that from this date, the first one, to the end, which stock performed very well, right? In this time frame, which stocks performed very well out of the stocks we have just seen in the array, right? So, and we will check and the closing price of this date, whether the stock was in profit or whether it was in loss. Okay, now let's understand with the code. We want to find out the percentage return from the buy and the sale date, right? So what we can do here, we can make this array as a variable. So I'll assign it, let's say, a name, and it can be tickers, right? So at least if I want somewhere, I can use this, and let me print this tickers, and you will get these value. And if you want any particular value, let's say the first value, you will get Apple. If last value, you will get the BCH USD, correct? Then what we can do, we will create an empty list, because in that list, we will store the final values. So let's say I'll give it the name as top the performance. Let's say it can be anything, good or bad, performance, and empty list. Hope it's clear up to this point. Now, let me print it again here. Now what I'll do, I'll run a for loop. So for ticker and tickers, we are running a for loop on this tickers. We have seen the tickers array of all the unique tickers. So let me show you again. Print ticker. So you will get all the tickers, correct? The unique ones. In reality, we have these many rows, but many of the rows have the same ticker. So that's why what we did, we extracted the unique values out of this data frame. Now, what I want to do, I want to print one by one the tickers. So you can print like algo, and then the ticker is equal to ticker. The main thing is here, we want to print one by one. Like the first, we will extract all the values of Apple, then Google, then Microsoft. And once we have all the rows of Apple, then we can perform some operations, the operations which have been asked in the question, and it becomes a little bit easier for us, right? So I can show you this again also on the sideline. So let's print this here. Actually, this is nothing but a filter. So let's say at the place of ticker, we have Apple. And when I hit enter, we will get a Boolean series, right? And we have seen that if I want the filter data frame, what we can do, we can make it as a mask. So I'll make it a mask. And now I'll again write the name algodf, and you will get a filter data frame with only the rows containing Apple, right? So same thing is happening here, right? So for that, what I will do, I will just make it as a mask and I'll write algodf. Hope it's clear up to this point, right? I can give here the name, let's say stock, correct? And then what I will do, I will print stock, the close of Apple. So let me show you here again. So what we will do, let's say I assign it a name, and let's say test stock, and then test stock and only the close column. And let's give it the name as test stock. And let's print the close column of this test stock. So we know that this one is the column, right? Same thing is happening here. And now we want to calculate the performance. So how we can calculate the performance? So we know that, let's say if you bought any stock here, right? So this was the close of this candle and you sold here, right? So both values we are taking the close only. So how we can find the performance? Means the price of the stock here was 100, right? Then it shoot up and here it was 150. So now how you can calculate the performance? You just have to subtract the last price, the final price. You can say here the final price when you sold. So the final minus the initial price when you bought, right? And you will get the 50, correct? And if you want the percentage, then what you can do, you can just divide this by the initial price. So final minus initial upon initial, right? So you will have 50 upon 100 and you will get as 0.5, means 50% you are in profit. Same thing is happening here. What we are doing, let's say we find out that this is the first close price and this is the last close price. So what we will do, we'll just subtract this value to this and we'll divide by the initial price, right? And we'll get the percentage performance of that value. So here, and now to extract the last column, what we will do, we'll apply iloc, right? The index, and we can just do -1, and I'll just copy and paste. We know that the first value you can get from the 0 and the last value we can get with the -1, right? And we have to divide it with the first value. So I will just enclose this in a bracket and I'll divide it with this value. So what you will get as nan. So now you know that what is the issue with the missing values and how we handle them. So let's say I'll change it to Amazon and check with that. And yes, now we have 0.03, means Amazon performed -3%. Means whenever you bought the price and when you sold, your amount was, your value, your net worth was 3% less. Means it didn't perform very well. So same thing we will apply with this loop on all these stocks, right? Start with Apple and end with BCH. Hope it's clear. I tried my best to explain you. Still you have any doubt, please let me know if we need to change our teaching style. Okay? What I will do, I will just copy this and paste it here, and I'll just remove this test because that is the name we are having here, which is stock, right? We can assign a variable here, let's say overall return, right, for each stock. So as we are running a for loop here, so one by one we'll get all the values, right? And let's give this the name stock data. Now what we will do, we will store these value in this empty list, right? So what I will do, I will just append this performance dot append, and I will give here, let's say, so what we can do here, first we can write the ticker name, which is this one, right, ticker. So I'll just write here the ticker. So what we are doing here, we are appending a dictionary, and that we have two values, two key value pairs. The first is ticker and the name of the ticker. So the first will be apple and the respective value of that ticker. So here we have found out the return. So what I'll do here, I'll write as overall return. What will happen here, the ticker name and the return, the overall return will be stored in this empty list. Now what we can do here, we can simply pass this list. So how do we create a data frame with a list? We have seen that previously. PD dot data frame, and then we'll pass this empty list here. So initially it was empty, but now it is not empty, right? And one more thing we can do here is that we can sort the values. That we can do with the ticker name, right? Overall return. This will be a column, right? So we can sort with the return. So we'll get the result in the descending order. So for that, we have to pass it here, and here we can say ascending is equals to false, right? So now when I hit shift enter, you will get the value, and you will see that the topmost performing asset is USD CAD and the lowest is the LTC USD, or you can say these three stocks we're not able to perform because of the missing values, or we can say NN values. It's very straightforward. You just have to focus this time. So once you have understood these 10 questions, I'm sure that in future you will have no issues performing these kind of operations. Correct? So here we can do one more thing, that we can assign to a new data frame, that is return df, and then we can print this one, return df. We can also set the index of this with set index, and we have seen that we have to give the name of column which we want to make the index. So it's the ticker, and now we have a series, right? So for that you have to check that return df, actually here you have to write in place is equals to, and now you have a new data frame, and which is a series. You can check that with the type. One more thing is remaining, that is you have to squeeze it, right, which we have seen previously, and now you will get a series. Correct? And if you want, you can also keep it as data frame also, and here you can also plot this. So let's say plot, and you will have a plot, right, with the top performing asset as the USD, and the last one is the BCH, which is not here because it didn't have any value. So the last one is BTC, right? Now if you want, you can change the kind of this, so you can make it as, and you will get a bar chart. Correct? And for these, the X label, Y label, we will learn in future when we learn about the Matplotlib. And if you want to understand now, then let me know in the comments. So from the next session, what I will do, I'll explain you the Matplotlib along with the pandas, right? Now, one more thing which is missing here, that how to handle these values, because sometime in the real life scenarios, you cannot just missing values or three stocks unattended, right? So you have to do something with these. So for that, what you can do, before starting the analysis, you can clean the data, right? So for that, we have to treat the NN values. For that, what I will do, for now, I'll just comment out this, and I'll print the algo.df again here, and we'll run the function info, and you can see here that we have total 32,870 entries, and we have missing values in these columns, the open, high, low, and close. But for now, we know that we are only dealing with the close column, right? So what we can do, we can just take the close column and let's check the number of NN values here. So what we will do, we'll write is NA and it will give us the Boolean series. And again, what we can do here, we have seen previously that we can write sum here and it will give the total number of missing values, which is 1941. So now we have few options. One option is to remove the NN values and another option is to fill these values with some another value. So generally in algo trading, what we do, we fill these values with something similar to the one value above or one value below. So we have two options, the backfill and the forward fill. So now what we'll do, we'll fill these values. So we'll write fill NA and here we have an option which is forward fill. Here we have a parameter which is method is equals to forward fill and then when we hit shift enter, you will see that all the NN values have been filled with their previous value. You can see here that this NN value is same like this one also is having the same value. So what is the benefit of this? That now we will not get the error which we were getting in previously, that 3 stroke was didn't even able to find any value, right? So here you can see that this method is deprecated. So for that we can find another way. So this is your homework, that you find any alternate way that how we can achieve this result with any other method or function, right? And here in place is equals to true, correct? So when I hit shift enter, now it has been changed, and now when I again check this and is NA and I apply sum here and now it says 0, means now everything is okay. So what I will do, I'll again go here and uncomment this, right? And now when we check, you will see that we have the value of Apple, which was earlier missing. And again, I guess this BCH USD or some other values which were earlier missing, but now we have all the values. And I can show you again with this also. When I remove this plot, you will see that earlier we had 3 NN values. Yeah, that was this for the first question. You let me know if you have any issues, any problem. You can let me know in the comments and we can discuss that again, right? Okay, the next question we have is how many instances of daily price change greater than 5% occurred for each stock, right? So for that, what we will do, first I'll print the data frame, and what we want to know that how many days when this close was greater than the open, right, for every day. And we know that this one row stands for 1 day. So what we will do now, first of all, we have to check the none values and n values. So for that, we know that we can check with info function and it will show us that how many no null values we have. So you can see here that we have many NN values. And if you want to know exactly how many, then you can apply the is NA function and it will show you the Boolean data frame, and then you can apply sum on that and it will give you exact how many values are NAN. So you have to deal with these values, otherwise it will create some problem which we have seen previously. So for that, what we can do, we have just done that recently. We'll just apply the function fill NA, and inside that we can use the method backfill or forward fill. So in forward fill, what will happen? The value with the previous row, it will fill exactly the same. So here I'll apply forward fill, and we can also make it in place true, so it will not create issue again, right? So it's done. So now if I check again the NN values, I'll go df is NA and then I apply sum on that, so it will show me 0, means now we do not have any NN values, right? So now we can proceed comfortably with our question. So the question is the percentage change. So for that, what we can do, we can apply a function that is percentage change, which we have understood recently. So what I will do here, I'll apply PCT change, and we have to apply on particular column actually. So actually here Here, we just want to check the particular column that is close. So I'll apply on this close, and then I can apply PCT change, and it will give me another column with the percentage change. And what it will do, it will compare with the previous day, right? Always. So now what you can do, you can create another column in this data frame, and let's say give it the name as algodf and daily change, right? And I'll hit shift enter, and we have another column. Let me show you this one, right? Daily change. So in that, the first is NaN value. And why? Because for the first day, there was no reference value, right? Because in PCT change, it calculates with the previous value. So the first value, it will always be NaN value, correct? Now we want to check greater than 5%. So for that, what we can do, I can apply a filter on this daily change, and I can write like daily change greater than 0.05, and it will return a Boolean series, and on that I can use that as a mask, and I'll get a data frame which is only having the daily change more than 5%, right? So we can also store this in another column. So let's say I'll make the column name as high change and hit shift enter. And now let's check. And you will see that it says cannot set a data frame with multiple columns to the single column high change. Actually, it is a data frame. So for that, actually for now, what we can do, we can just store the Boolean series as it is. So I'll create a column with the Boolean series itself. High change is equals to this. And now when I check my data frame, we have a new column, right? Now it's very easy. So for that, what we can do, which we have performed in the last step. So we'll find the unique ticker names. So for that, what we'll do, algodf ticker, and we'll get an array with the unique values. So I'll assign it with the new variable that is tickers. And now we can run a for loop on this. So for ticker and tickers and algodf ticker equal to ticker, right? And I'll close this in a parenthesis, and another condition that is daily change. So this should be true for that particular ticker. So I'll also close this in another. And now what we can do, we can make this whole filter as a mask, and I'll apply on the algodf. So now we have only those values with the ticker and having more than 5% change daily. I can store this in another variable, and let's say high change tickers, and also to store this value, we can have another dictionary. So I'll create a dictionary, let's say occurrence, and is equals to an empty dictionary, and here we can store that. So occurrence and the ticker name is equal to the high change tickers, right? Like for the first ticker, Apple, the value, whatever it gets, it will get stored in this. And again, for the next Amazon. So what is happening here? We have an empty dictionary here. Now in the for loop, for each ticker, the value. So here we want the instance. So for that, what we can do, we can apply shape here. And for that also, the first, the number of rows, right? So now let's check and print the occurrence here, and let's see. And you'll see that we have a dictionary with the exact number of times that particular ticker had more than 5% daily change, right? And let me show you this outside for your better understanding. So I can test this on any ticker. So instead of ticker here, we can take Apple. You can see here, these are the number of rows when the change was more than 5%, right? So we can calculate the shape of this. Shape is 37 rows and 9 columns. So then what we want only the number of rows. So I'll apply 0 here, the first item. And when we hit shift enter, we got 37 here. And if you want to check for any other, let's say Tesla, so you can just change here to Tesla, and you will get 33, which is here also, right? You can even check for LTC USD. Let's check this also. This is just to make you understand because here we have multiple tickers, and that's why we have to apply a for loop here. If we had only single ticker, then we could have done that in just a single line, right? Hope it's clear to you. Now what we want to plot a chart of this. So for that, we need to convert this dictionary into a data frame, and we know that this is just a 1D dictionary. So for that, what we will do, we'll just convert these keys to a list. So what I'll do here, I'll write a list and occurrence dot keys. So you will get this list with the keys, and again I'll pass this inside the data frame. So you will get a data frame, right, with just a single column. But we know that we want the values also. So for that, you can just write columns, and inside that you can pass a list, and the first you can have is the value, or you can have the ticker, and second you can have is the, actually here we need to make it as items, not the key, and then you will get a data frame, right? So now let's assign it to a variable, that is df, and now when I print df, you will get this, and you can also set the index as the ticker, and let's set it, and we can make it as permanent. So in place is equals to true, and you will see that it is now permanent. So now when I check df, we'll get this value, right? And now if you want to plot this, you can plot, and you will get a nice and beautiful chart. And but now you can make it a bar chart that will look more meaningful, right? So you can see here we have Apple, Google with all the charts. You can even like sort this. That's completely up to you how you want to manipulate the data. Okay, now let's move to the next question, which is calculate the number of times each stock's price increased in the first quarter, right? Actually, I will not solve all the problems. I'll just solve this third, and again you can solve one or two problems from the different data set, right? And then I'll leave all up to you. So you try to solve, and if you face any issue, then you can let me know in the comments, and we can discuss that in the future, right? So let's understand this problem. It says calculate the number of times each stock's price increased in the first quarter. Now we need only the values from the first quarter. First quarter means only the January, Feb, or March. So for that, you have to think and pause the video and think that how we can achieve that. And then I will discuss the approach. Okay. Okay, let's start this. So first we'll print the data frame algo.df, and inside that, what we want only the first quarter, right? So for that, what you will do, you need to have understanding of time series. And actually, we will dedicatedly learn this time series in the future lectures. But for now, just understand one function, and let me show you. So what we will do, we will convert this date column to a time series index, right? So I'll just write date, correct? And here I can use the function as pd dot to date time, and inside that I can pass this column, and like I'll replace this with the new value. So let me first show you the changes, right? So now if you check the type of this column before applying the function to date time, you will see that this is just a normal series, right? So after converting this, and now if you check this, you will see that it has changed to, okay, we have to make this in place. Now what we want to do, we want to check the data type of all these columns. So for that, you can just write info, and you will see that now this date is just a object data type, right? But we want this date column as the date time data type. So for that, what you can do, you can use the function pd dot to date time, and here you can pass the column here. So algo.df and date, and when you hit shift enter, and now when you check algo.df dot info, you will see that now what we want to convert this. So currently this is object data type, and let me show you how. So when I check date, you will see that the D type is object, but we want in date time. So for that, what you can do, you can just apply the function to date time. So I'll write pd dot to date time, and here I can pass this column name, correct? And also I can replace this old column with the new one. So when I hit shift enter, and now when I check this column, you will see that it has been changed to date time 64, right? And that is exactly what we wanted. So now I will just comment this out for now. Okay, now let's extract only the values from the first quarter, that is January, February, and March. So let's try that. Okay, algodf, and here we can use this dt dot month. This is all the magic of this date time function here, right? And when you hit shift enter, you will see that we have a data frame with only the months. The 1 means January, or the 3 means March. But here we want only the first quarter, that is 1, 2, and 3. So for that, we can use the function isIn, and we can pass a list here that 1, 2, 3. So means it will check whether these rows are 1, 2, or 3, means January, February, or March. If it is true, then it will return us a Boolean series. So let me hit shift enter, and you will see that we have a Boolean series, correct? So now what I will do, I'll just store this in another variable, and let's say we first make this as a mask, and I'll write algodf, and now we have only the values from January, February, and March. And we can even check with a sample. Let me store it in another variable, let's say first quarter, right? And if you check a sample, you can take sample of 20 values. You will see that all the values are only from the January, Feb, and March. You can see here 2, 1, 3, 2, 1, 3, 2, 1, right? Means the first objective is completed. Now we want to check the number of times each stock's price increased in the first quarter. Means every day when was the close was higher than the open, right? So, and also you want to check the number of counts, number of times. So for that, first we have to find only the close values which are more than the open value. So for that, what I will do, I'll write first quarter close is greater than the first quarter open, right? And again, we will get a Boolean series here, and we can make it as a mask, and we can get the values. So only these rows when the close price was greater than the open price, right? Now it becomes very simple. So I'll just, and now what we can do, we can assign it as the variable again, the first quarter. So we'll get a modified first quarter. And now we have only the rows which is from the first quarter, and the close is higher than the open. It means we can say only the values in the first quarter when the stock price was increased, right? From the open to close, correct? And now we just have to count the number of times for each ticker, right? Like for the Apple, how many times, for the BTC USD, how many times. And you know, for that we have a very simple function. So let me show you. I can just check this on ticker, and we can just count value counts here. And when I shift enter, and you will see that we have a nice and beautiful data frame with the number of counts. And this is that simple. Okay, so I can write here the increase counts, and if you want, you can also plot this, and you will have a nice and beautiful chart. But again, here also you go and you will have this bar chart, correct? You can also manipulate this in a preference, the ascending or descending order as per your requirement. So that was it for this data set. And I would say this date time function is really very, very important. So please practice this few more questions. Now that is it for the day. And I will leave this remaining questions for you. So I'll just push this data set and this notebook to the GitHub, so you can clone from there, and please practice. And because these questions are really important, it will build your fundamental. So let's first understand the definition of GroupBy in Pandas. So a GroupBy is a powerful tool in Pandas that is used to split the data. Pay attention to this word, split the data into groups based on some criteria. Once the data is split into groups, you can apply various aggregate functions on these groups. So basically, we can say that we have three steps. So the first step, when we apply a group by on any data frame, what happens? It split that data frame into multiple groups. So it depends on the criteria which we have applied. So it will split that particular data frame into the groups. Then it will apply the functions, the aggregate functions. So whatever we apply, let's say we apply sum, mean, median, whatever. So it will apply on all those groups, and then again, after the application of those aggregate functions on those splitted groups, it will combine back into a data frame and it will give us the results, right? For example, in our stock trading data, we might want to group by the ticker and then calculate the total volume traded for each stock. So let me show you. If you remember, in the last few sessions, we have used this data frame, AlgoDF, right? If you are watching this video first time, please go through the previous videos of the Pandas series or data frame. Then you will be able to understand about this data frame, right? Anyways, if you are new also, then it's very basic. So when we check this AlgoDF data frame, you will get this output, right? And we have around 32,000 rows and 7 columns in that. Basically, we have O, H, L, C, V data of the tickers. And in that, we have traditional stocks like Apple, Microsoft. Then we have Forex, and we also have some crypto pairs, right? So if I apply group by on these, and let's say if I apply with the ticker, right? So we know that for a single ticker, we have multiple rows in this data frame, right? What it will do after application of group by on ticker, what it will do, it will split the whole data frame into multiple groups, right? So here we had like Apple. It created a separate data frame of the Apple, and again the XRP, and remaining, let's say we had this data frame here, right? We applied the group by on ticker. So what it did, it created multiple data frames. Let's say one for the Apple, right? Another for the Amazon. Let's say another for the LTC USD pair, the crypto one, and another for ETH USD, right? It depends on how many unique values you have in this column, and based on that, it will create that number of groups, right? And after that, what it will do, whatever we apply, it depends on us that what aggregate functions we are applying. So here what I did, here instead of applying an aggregate function, I applied simple value counts, right? So then it went to each one of these separate tables, right? And now it is counting the value. So it will give us the number of times that particular row is in that. So in this data frame, the Apple, this particular row is twice, right? Similarly, for all the groups, it will display the results, but here it just truncate and just displays the initial 5 and the last 5 values. So let's say we had this data frame here and we applied group by on this. So what happened? It splitted all these results into 3 data frames, you can say. So the one table with the X ID, another for the Y ID, and the last one is for the Z ID. Correct? Then we applied sum on that, the aggregate function, right? So it applied on this. So we get this result, X is 50. Then we get 70 on this, and then we get 90 on this. And the last step is it combined the values and we got the result back, right? So the basic step is, first we apply the group by here, and then the first step is split. It will split the whole data frame into multiple tables based on the number of unique values in this, right? And then it will apply the aggregate functions which we provide, like it could be sum, mean, median, average, anything. Then it will calculate those functions, and again in the last we will get this is the second step, the application of aggregate function, and the last step is we will get a combined result, right? Split, apply, combine, and that's it. Hope it's more clear now. Don't worry, we'll proceed with live examples after this. Let's say we have another data frame. So it got split in 3 tables. The first is yellow, the second is green, and third is blue. Correct? Then what happened? Then we applied the mean aggregate function on these tables. So what it did, it calculated the mean of every value. So this was the second function, the aggregation function, right? And the last one is it just combined the results and we get a modified data frame. So we can say combined results and we get the modified data frame with the mean values of all the different colors. So if you can imagine, it is really powerful when we have millions of values and we cannot see directly that how many groups are there. It can be 1,000 groups and we want to apply some particular function on that. It becomes so powerful and you will feel that in algo trading, this will be a magic wand. The GroupBy will be a magic wand for you if you perfect this. And I assure you that it is not difficult. You just have to practice few questions which we will provide you absolutely free on the website, the multiple choice questions, and then the GitHub repository task. Right? That's it. If you do that, you will be a magician. Right? And you will realize that how helpful this GroupBy object in your algo trading career. Right? Let's have a look on another example. So here we have a table. In that we are applying GroupBy on this column, the sales representative. The first step was split. So this whole table got splitted into 5 tables. Why? Because we had 5 unique values. The first one is William Taylor, the second is Willie Rao, the third is Sam, the fourth Alvin, and the fifth is Helen. So it got splitted into 5 tables. Then we applied this aggregate function on this. So we can write aggregate, the second step. It will always be only 3 steps: the split, the function, the aggregate function, and the third one is combine. So we applied the aggregate function. So what we did here, we applied size function on the order ID, right? Then we applied sum and mean on this value column. And the last one is we applied sum and mean on the sale column. So it calculated the mathematical values. And then again, the third step is we got the combination of the splitted tables, right? And this is the results. So every time it is same, and don't worry, I'll show you. It is very easy in a bit. And the last example is this one. So here, this is an example of the trades happened on an exchange. So this is the account ID, this is the order ID, and this is the price when the trade executed, right? So when we apply a GroupBy on this, the first step will be split, right? So what is happening here? We have 3 unique account number. The first is this, and second is this, and third is this one. So means these are the values of the particular account ID, right? So we got 3 separate tables, and then we applied this sum function on that. So the second is the aggregation function. It could be sum, mean, median, whatever you want. So it applied the sum on that. So you can see here, it will like add these 3 values, and all these values it will add, and similarly it will add these values. So this is the aggregate function, and the last step is that we will again combine these tables and we'll get this result here. The third one is combine. You can see here we got all these 3 rows, again the sum value on all these 5 rows, and last is the sum value on these 4 rows. So that's how this GroupBy works, and I'm sure that you are able to imagine the possibilities with this GroupBy object. And now let's move and practice some questions on various datasets, and let's see how it goes. Okay, let's start with some examples, and you will see that in real life scenarios also you will be using these kind of datasets only. So what I'm doing here, we are creating a dataset with 1 million rows. It will be a very big dataset, and you can even change as per your requirements, right? Because in real life also we'll be having large datasets, right? Because when we have exchange data, it is always huge. So what I will do here, I'll just run head shift enter. Now let's check the data frame df. So you can see that we have 1 million rows and 7 columns, and even if you want, you can check the info, and you will see that it is almost 53.4 MB. So before that, what we can do, we can just convert this to a CSV file. So what I will do here, I'll write df dot to CSV, and then we can give the name of CSV file. So let's say exchange trade data dot CSV, right? So when we hit shift enter, you will see that we have a new file, this one, and when we click on that, you will see the data here, right? It is huge data. So I'll go back here and let's comment this out for now. So I'll keep this in file only. So if you want, you can take and use as per your requirements. Now what we can do, we can just import this as we were doing previously. So I'll give it a name. Let's say exchange df and pd dot read CSV. We can give the name as exchange trade data dot CSV, right? And let's print it exchange df. And now when you check the info, you will see that it is almost 61 MB, right? With 7 columns and 1 million rows. And also inside that we have integer 64 with the 3 columns and remaining all are objects, that is string, right? So now let's apply head on this. So what we do before performing any actions, we just check what exactly is there, right? So when I apply head, you will see a top 5 columns, and in that we have tickers as Apple, Google, Microsoft, BTC, ETH with the timestamp and the exchange, because whenever we trade on exchanges, we always have a different trade ID. Now let me apply group by on this. So before that, let's also apply sample. So we'll take a sample of, let's say, 30 rows. You will see that we have 6 tickers. You can see here Apple, Google, Microsoft, BTC, ETH and XRP. So randomly it gave us 30 rows, and here we have different exchanges, different tickers, that is 6, and also the price, volume, buy, sell or trade ID. So we get an idea, right? And as this is a synthetic data, so the prices are not like the real life, so just ignore that. This is just for the demonstration, right? Now let's apply the group by on this. So exchange df dot group by, and here we have to mention that on which column we want to apply the group by. So basically we know that we have 2 kinds of data. The one is numerical and another is categorical. So numerical means the price, volume, right? And in categorical, what happens, we have like 6 kind of categories of tickers here, and also we have how many kinds of exchange, 1 2 3 4 5 6, and we also have 6 categories of exchanges, right? So we can say these are categorical data. The ticker, the exchange, or even the buy and sell also is a category, because we only have 2 categories, the buy and sell, right? So it is also a categorical data. So now when we apply group by, so we have to think logically that on which columns we can apply group by. We always apply the group by on categorical data, because there is no sense applying group by on this price, because price might be in every row it is different 1 million, and we'll be having 1 million groups, and that doesn't make any sense, right? So means we can apply the group by on ticker, we can apply on the buy or sell, we can apply on exchange. Means we can have the 6 type of groups here, we can have 2 types of groups here, buy or sell, or we can have 6 type of exchange here. So when we apply group by on this ticker, it will split this data frame into 6 different data frames. Then we can apply any aggregate function, and then again it will combine back and give us the results. Similarly, if we apply the group by on this buy and sell, so it will split this whole data frame into 2 categories, the buy and the sell, 2 data frames you can say, right? And then we can apply our desired functions, and then we will again get a combination of those 2 categories, right? The split, the aggregation function, or and then last is the combine. And again, if we apply group by on this exchange, it will split this whole table into 6 different tables, or we can say 6 different categories, and then we can apply the second step, the aggregation function, and the last is we'll get back the combination of those tables, right? So let's first try on this ticker. So I'll just copy this ticker name, and when I apply, you will get a simple object, the simple group by object. So there is nothing, you cannot see anything here, but now you can apply something on this, right? So we have ticker. So let's say I apply sum on this, right? So what will happen now? We applied GroupBy on ticker. So internally, it has splitted this whole data frame into 6 groups. Means now Python knows that I have 6 groups, and now when I apply sum, so what will happen? All the numerical columns, it will apply sum, and it will give us the result back. So let's check that. So when I hit Shift Enter, it will take some time because we have a huge data. Of course, it is 61 MB of data and 1 million rows. So definitely it will take time. My Mac Mini might be crying right now. It's better if we like applied on any single row. I think it was much better if we applied sum on any single column. Then it would have been much faster. But let's wait and check how much time it takes. It's about to complete a minute. I'll show you that it is applying sum on the whole data frame is not efficient always. So before that, you have to select your column and then you should be applying, because here it was just a single sum function, but sometime we will be applying multiple functions. Let's say sum, min, max, so it will become so difficult. Now what happened actually, it applied like sum on everything. We know that we had 6 categories: Apple, BTC, ETH, Google, Microsoft, and XRP. And what it did, it just like aggregated everything, right? So even the timestamp, it like concatenated, and ticker also XRP plus Google, it did like that. So that's why it took a lot of time. You can see here buy, sell, and even the trade ID. Only the sensible data here is the price and volume, right? Because it was numerical, rest everything is not required. So the efficient way to do that is, I'll just comment it out, is we can select our desired column here. Let's say after creating this object ticker, then what I will do, let's say I wanted the sum of volume only. So I'll just go ahead and write volume, and then I can apply sum on this. So it will be faster and also sensible, right? You can see here we have this sum of the volume of Apple, BTC, ETH, Google, and Microsoft and XRP, right? And also we can use it the traditional way which we were doing previously. So how we can achieve that? Exchange df, then we can apply on volume, and here we can apply sum, right? So actually it will give us the sum of everything. First we will apply on ticker, so we'll get all the tickers, and then actually we have to make a function here, right? Done that already. So first we have to find the unique tickers here, the array, then we have to apply a loop here. So for ticker in, let's make it as tickers, and now we can apply on volumes. So for that, let's also create an dictionary here. So we can say without GroupBy, right? So volume sum and empty dictionary. So now when we apply here exchange df and then ticker equal to ticker, right? And then we can exchange df here, right? And then we can like find the volume here, and now we can apply sum, right? So here we can say sum volume, and then we can store that in the dictionary. So for that I have to write like volume sum and ticker is equal to sum volume, right? In last we can just print out the volume sum, and let me first comment out this. So when I hit shift enter, it will take some time and it will give us the sum of all these stocks, right? So you can see that it was little bit, we can create so many errors also. So now you can see that we have multiple ways, but in algo trading the time matters. So you have to apply the most efficient way, and GroupBy is the most efficient way in the pandas for now, right? So let me show you this again on the next row and compare, and you'll see that it is same, right? The Apple is 16700 and again the XRP is 260. So you can see that the speed of execution is way faster. It took 0.3 seconds, and here it is almost 0.0 seconds, right? So definitely it is faster. Okay, now let's perform few more examples. So let's say we want to count the number of trades per ticker, right? So we have these 6 tickers and we want to check that how many trades happened per ticker. So what I will do, I'll again group by with ticker, right? And one more thing you can do for to save your time, you can just like assign a variable here, let's say tickers, right? And now you can count the number of trades. So for that, what you can do, you know that when you apply size on this, actually it is exactly the same because we applied the function here and it gave us the same number of rows for every ticker. That's why. But you get the idea, right? You can use this in the real life. Now let's check some group by attributes and methods. So first we have is the length. So let's say you want to find, you know that we have this group by object here, right? This one. So I just assigned a tickers variable here. And if you want to calculate the number of groups, so what you will do, you'll just go and apply length on this and you will get the number of groups, correct? So the next is find the items in each group. So we have just done that with the size. So means it will give us the number of rows, you can say, in every group. So it will definitely tell you the number of items, right? And again, we have the first and last. So we can get the first row of every group. So for that, what you will do, you will just, and you will get the first row of every group. You can see here the first row of every group, right? And similarly, you can get the last row. So tickers dot, and you will get the last row of every group, right? And if you want any specific row, so for that, what you can do, you can just use the nth function here and you can give the number of index. Let's say you want the fourth number of row of every group. So you'll write 5 and you will get the fourth number rows from the every group, right? Similarly, we have the get group function. So let's try that. Tickers and get group, and you will see that similarly we have the get group function. Let's say we want to extract a particular group from the data frame. So what we can do, I can write tickers dot get group, and here you have to write the name of the group. Let's say I want to extract the BTC group here. So when I hit shift enter, you will get only the BTC values, right? So it will show you the number of rows, number of columns, and all those. And if you remember, we can perform this with some other techniques also, right? Which we have done previously, that is filtering. Let me show you how we can do that. So let's say we have tickers. We have this data frame exchange df, and we'll use this ticker here. And then we have to apply equals to BTC, correct? And then again, so when we apply this, we'll get a Boolean series, right? And now we can use this as a mask. And when we apply exchange df, you will get all the values. But of course, this is very slow because this group by already have the groups. So it will just have to extract the BTC group and it will give you quickly. But here it has to go through the whole data frame and definitely it will become slower. So it's better to use this one. But as we know that Python is very flexible and you can have multiple ways to perform a single operation, right? So I'll just comment this out for your reference in future, right? Okay, next we have is the groups, and groups is an attribute of this group by object. So for that, first we will write, make sure that this ticker is nothing but this syntax, right? And don't confuse with that. So tickers, and then I can apply groups on this and you will get a dictionary. And what is happening here, that in Apple group, what is the index of the rows? So we know that at the 0th index, we have the first row, right? Let me show you that also. So let me create another cell. And when I apply simple exchange df, 6th row, which is this Apple, is at the 6th index, right? So that's why we are getting the 6, means this group is storing all the index positions of the rows of that particular group. So sometimes it might be handy, but not that useful. So you can see this is a long list of dictionary. Next is describe, sample, and unique. So describe we have seen previously also everywhere. So in series and data frame. So when I apply on tickers describe, we'll get a numerical analysis of every group. You can see here that in the Apple group, it is giving us the count, mean, standard deviation, then the minimum, 25 percentile, 50 percentile, 75 percentile, and the max, right? It's really a large numerical analysis, and it is also useful sometimes. What we can do, we can write 5 here, and you will get 5 values from every group. You can see here from Apple also we have 5 random values, random rows, and again from BTC, ETH, Google, and Microsoft and XRP, right? And the last we have here is the n unique. So let me apply that also, n unique, and you will get the number of unique values, right? As we know that there is no duplicated value, that's why you are getting the number of rows all unique. Okay, next we have is the aggregate method, and here we can apply different functions on different columns. Let me show you how. So first we have one GroupBy object, right? Then let's give aggregate function here, and here we can pass a dictionary. So this is a dictionary here. Now let's say what I will do here, first we have is the volume column. So I'll pass here the volume column, and here I want to apply sum, right? And let's say then we'll try to find out the average price. So I can apply mean here, correct? And now when I hit shift enter, okay, actually we have to give a comma here, of course, and you will get exactly in the same sequence which you passed in the dictionary. So first we'll get the volume with the sum and price with the mean. If you want, you can even give minimum here, and you will get all the minimum values, right? You can even get the maximum. You get the idea that how powerful this is. You can, like, if you have multiple columns here, you can pass a dictionary, and with every column you are applying your desired operation on that. This is absolutely mind-blowing. Okay, now let's move to the next, and similarly we can pass a list. So here we mentioned that on volume I want sum, and on price I want max. But here what is happening, let me show you that we have this exchange.info data frame, and inside that only 3 columns are with the integer 64, and the rest all are objects. So if I simply pass a list, then it will apply all those functions on every column. Like if we pass mean, so it will apply on ticker also, it will apply on volume also, it will apply on by exchange. It might break, the code might break. So for that, in this case, this dictionary is because we are applying only on the numerical columns. So for that, what you can do here, let's try, it might be wrong. We'll first check tickers, and here what we will do, we'll just go for the volume column, correct? And let's also go for the price column. So price. So now first we applied the group by, and then we are selecting only 2 columns. So here we can pass a list, let's say aggregate, and here in the list I will provide 2 functions. First one is, let's say, sum, and then mean. So now it will calculate the sum and mean of only these 2 columns. So when we shift enter, you will see that we have the sum and mean of these 2 columns, right? Hope you are able to understand. So if you want, here you can apply any kind of function, and you can see the power of group by object. It is really absolutely amazing. In previous session, we have understood the group by object in Pandas, and today we will continue with the same, as we have seen that how we can apply aggregate method on the group by object, like how we can pass a dictionary in that, how we can pass a list, and now we'll continue with that, and we'll see that how we can pass the combination of both dictionary and list. Let's say you have this group by object tickers here, which we have seen yesterday. So if you are new to this video, please watch the previous video to understand this better, right? So we have this stickers group by object, and now we want to apply the aggregate method on this, and let's say that on every column I want to apply multiple functions, right? So what I will do here, I'll just copy and paste dictionary here, and now what we can do, we can also pass a list here. So at this place we'll pass a list, and let's say for volume I want sum, Then I also want mean, and I also want standard deviation for the volume. So means here we are passing a dictionary first, and then at the values we are passing a list, so we can have multiple operations on a single column, right? Similarly, for the price also, I want the max price, again I want the minimum price, and I want, let's say, mean of the price, right? So now when I hit shift enter, you will see that we have a data frame with volume and price column, and inside that we have applied multiple functions. So on volume we applied sum, mean and standard deviation, and again on the price we have applied the max, min and mean, right? So that's how you can use this functionality. And actually here the price is not the real, that's why you are getting a little bit different values. Don't worry, once you are finished with this, we'll apply all these things on the live exchange. Okay, and now we have looping on groups, means we can apply loops on the GroupBy object. How? Let me show you. So we know that we have this stickers GroupBy object. So what I will do here, let's say for group and data in tickers, and let's print the group and data. So when I hit shift enter, you can see here we have data frame here, and when I check this, the group is the name of the group and the data is the data frame. Means we can also apply loops on this GroupBy object, and we can like perform various operations. Let's say I want to print the tickers. So what I will do here, I will just remove this, the name of group, and I'll just keep the data. And here we know that we have a ticker column there, and also we can apply, let's say, unique method here. So it will give us only the unique values, right? And we know that we have only 6 unique values in our ticker column, right? Now we have this split, apply and combine, which we have seen in the theoretical part, that how it works. And let me show you again. So we have this tickers object here, GroupBy, and then we can apply any function here, right? This apply is the inbuilt function of the pandas. So here we can pass any function. It will give you the minimum value based on the ASCII value on the objects and numerical value on the columns, right? So you can see here, you can even apply max and you will get all the maximum values. So on objects it will apply the ASCII values, and on the numerical columns it will apply the normal numerical methods. Let's say if you want to apply GroupBy on multiple columns. So we know that this is our original data frame, and we also know that we apply GroupBy on only categorical data. So here we know that this ticker is categorical column, this exchange is also categorical column. So what I'll do here, I'll write GroupBy, and then I'll pass a list here. So first I'll pass ticker. I want this to be grouped by with the tickers. Then what I'll do, I'll write buy and sell, this one. It will show us that on every ticker the different buy and sell groups. So when I hit shift enter, key error tickers, I guess it is ticker, so we have to correct this. And we have this GroupBy object, and now we can get the size of this. So this is the size. You can see here that in Apple we do not have cell column, so that's why it is giving only one value, right? We can also group by with the exchange. So let's say I pass here another column, that is exchange, and now when I check, it will show us that on Apple we have only by, and we did only on NYSE, correct? BTC we have only cell column, and that was done only on Binance, right? In future we will perform all these operations on the live exchanges, so please focus on this and try to understand this completely. Okay, let's say if you want to print particular group, so you know that we have these many groups here, the Apple by NYSE, MSFT by NYSE, XRP cell Coinbase. So let's say I want this ETH by and Bybit. So what I will do here, I'll just copy first this object from here, and then I'll give get group, and here we have to pass a tuple, right? So what I will do here, we have to pass this ETH, and then we have to pass the Bybit here, correct? So when you hit shift enter, you will see that we have a data frame with the particular group which we have mentioned in the command, right? Now we have aggregate on multiple group bys. So for that, what we can do, I'll just go here and I will copy and paste and assign to a different variable. Let's say I'll make it as ticker exchange, the variable name, and then I'll run this cell, right? And here we'll pass a list of functions which we want to apply on this GroupBy object. So I'll write max, I'll write min, and now when I shift enter, you will see that we have a data frame with max and min apply on all the columns, right? You can see here on timestamp, on price, volume, trade ID, and it will show the maximum value and the minimum value, right? Okay, now let's practice some real life questions which we will be doing on day by day operations. So this is our original data frame, right? The first question is how many trades were executed for each ticker. So for that, what we'll do, we'll first group by with the ticker. So we'll get a group by object. It is asking for the number of trades. So for that, we can use count, we can use size, but here we'll be using the size method. It will give us the total number of rows for every ticker, and that means the total number of trades, right? So before that, let me tell you that where we can apply the group by. So whenever you see this each in any question, you can apply group by at that place. Means first we have to find each ticker, and for that we can group by with the ticker, right? Then it is asking the average price, means we can fetch this column from that group by object, and then the average means we can apply the mean method, right? So I'll just copy and paste this group by object from here, and then I can fetch the price column, right? So I'll write price. So you will get a object with the price column, and then we can just simply use the mean method, and you will have the mean price for every ticker, right? Similarly, the next question is what is the total volume traded for each ticker? Means we have to apply the group by object, right? So first we will apply the group by on ticker, and then it is asking the volume, means we'll fetch this column, the volume one, right? And on that it is asking the total, means we can use this sum method. So I'll quickly copy this group by object, and then I can fetch the volume column from this, and now we know that we can apply the sum function, right? And we'll have the total volume of each ticker. Next question is that what is the price of the first trade for each ticker? So means it is asking only the first trade, means the first row. And similarly for each ticker, means first we will group by with the ticker, so means the same group by object, right? Then the question is the price. So again we can fetch with the price column. You just have to understand the question carefully, you will get answer automatically, don't worry about that, right? Then the key here is that it is asking for the first trade, means the first row. And if you remember, we have seen that how we can extract the first row. We can simply apply this first method, and you will get the first row of every ticker, means the first row from the price column, and you will be having the first. Similarly, you can also use the last. Let me show you, and you will get the last price, right? Let me correct it again, and I will keep it first only. Now the next question is what is the total trading volume on each exchange for each hour of the day? I'll copy it from here and I'll paste it here. For now you can see that it is object only. So what I'll do here, I'll simply use the inbuilt object, that is to date time, and here we have to just pass the column. So this is the column, right? The exchange DFN timestamp. And now when I hit shift enter, you will see that it has been changed from object to date time, right? And now we can use the attribute dt.r and we'll get the results in the R. If you remember, we have seen previously when we filtered the data frame in quarter. So we only wanted the first, second and third quarter results, right? Similarly, here we can get the Rs. If you want here, you can even change it to month and you will get all the months, right? But for now, we only need R. So I'll write R. And now we can add a new column to our existing data frame, exchange df, and I'll write the name R, and it will be the new column of our exchange df data frame, right? So now when you check the exchange df, you will see that we have a new column added, right? The R. And the question was, what is the total trading volume on each exchange for each hour of the day? And now it's very simple. We just have to group by with the volume and R. So what I'll do here, I'll write exchange df dot group by, and here I can pass first the volume and then the R, right? And now when I shift enter, we'll get the object with the volume and R group by, and it is asking for the sum, right? The total means we can apply sum here simply, and you will get, we have to wait. Actually here we wanted the volume, so we have to fetch that, and now we'll get the sum of every hour, right? So now the next question is, what is the total buy and sell volume for each ticker? Each ticker means we have to group by with the ticker, and also we have to group by with separate buy and sell. So let's quickly do that. We have this exchange df, and inside that we have this buy and sell, right? First we'll calculate what the buy, so we'll apply a filter equal to buy, and we'll get a Boolean series, right? And here we can again make it as a mask, and we'll get only the buy, right? And here now we have to calculate the volume, right? So I'll group by first with the ticker, because we have to calculate for each ticker. So we'll get a group by object, and then we know that we need to calculate the volume. So I will just fetch the volume, and we'll again get a group by object, and now we can simply calculate this sum. And you will get the sum of Apple, ETH, and Microsoft, because only in these tickers we had the buy. Similarly, for the sell, what you can do, you can just change it to sell, and you will see that we have for BTC, Google, and XRP the sell volume. So if you want, you can just print both the values, or you can assign, let's say, the buy volume and not but it's buy, and again the sell volume. You can simply print buy volume, again the sell volume, and you will be having the buy and sell. You just need a little bit of practice and you will be good to go, right? Now the last question is a little bit advanced, that is calculate the VWAP for each ticker, volume weighted average price. So now if you are able to realize that slowly and gradually we are going into deep algo trading, we'll be understanding various technical terms of algo trading, and you let me know that if you want to have a separate video where we can understand all these kinds of terminologies, right? So to calculate the volume weighted average price, you need to know the formula to calculate the same. So what we can do, you can simply do a Google search. So let me open the Google and let me show you. So this is our Google, and you simply type VWAP. You can see that this is the formula which says sum of volume into price divided by sum of volume, right? So you can just copy it and paste it in your notebook, and let's say here, right? Okay, now we can quickly calculate this. So what we will do, it is asking us the VWAP for each ticker. Each ticker means we have to group by with the ticker. So let me quickly do that. Exchange, okay, it's marked down, we have to have a code. Exchange df dot group by with the ticker, right? So we'll be having a group by object. Then what we can do, we can apply the lambda function here, right? So for that, so we have to apply a lambda function here. So I'll write lambda here, I'll write lambda x, then the formula. So it is the sum of volume into price. So to find first the volume, we'll write the volume, and multiplied by the price. So X and then price, correct? You can again like check here the name of the columns so it doesn't mess up. So you can see here we have the price and the volume, that is correct, right? So we have to find the sum of these, right? So I'll just apply the sum here, sum of volume into price, then divide by the sum of volume. So simply sum of volume. So I can write sum. And now when you hit shift enter, you will get the VWAP, volume weighted average price for each ticker. So let's do that. And you will see that you have the VWAP for each ticker. It's very simple. You can apply any formula. Don't worry. We'll do complex things in upcoming videos. For now, we are just building up the base. These three methods are merge, join, and concatenate. Basically, when we see all these three methods perform almost the same operations, but these three methods have their own use cases. You can use them interchangeably, and also many times a lot of people gets confused between these three methods, that what should we use at which place. So we will clear that confusion today completely, entirely. After this session, you will be not having any confusion that which method you should be using at which place. Okay, so with that being said, let's get started. So the first method is merging. It is similar to joining. So let's understand their definition. It combines two data frames based on the common column or indices, right? It supports different types of joins, inner, outer, left, and right. Then it uses the pd.merge function. So here the takeaways are the merging combines with the common column or indices, and it has four types of joins, inner, outer, left, and right, and it uses the pd.merge function. Okay, now let's understand the use cases in algo trading. So we can use merging for combining the historical data. So merge historical price data from different sources based on a common date column, right? So we'll be doing this a lot. Then again, integrating indicators. So merge technical indicators calculated on the same index or stock using the date or timestamp as the common column. So on the base of that date or timestamp, we can combine multiple data frames. Now, it can be used for enriching data. So merge additional data such as fundamental data, example earnings, dividends, with price data to create more comprehensive data sets for trading algorithms. So sometimes you'll be having the technical data. So you would like to find the mathematical and technical relation between the prices and the fundamental data, right? So actually in trading, you have to find some common thread that why the price is increasing or decreasing. And if you find that even a little bit, you are having an edge. You know that, right? Next. So merging is done, and we can say it is similar to joining. Why? Because you will be able to perform almost all the operations which you can perform with the join function, with the merge. But now let's understand joining also, and after that you will realize that it's almost the same. Now we have joining. Definition. Joining is conceptually similar to merging, but typically refers to the method of combining data frames based on their indices using the join method. So in the merging, we have the common column or indices, but in joining, it has only the indices, right? So we can use the join method. This method also supports inner, outer, left, and right joins. So the similar thing is that in merge and in join, we have the inner, outer, left, and right. The same thing, exactly same. But in merge, we can combine with the common column or common indices, but in join, we can only combine with the common indices, right? So the types are exactly the same, the inner, left, and right, and outer. So don't worry, I'll explain you all these types of joins in a bit, because these are common in both the joining and merging method. So before that, let's understand some use cases in algo trading of joining method. So inner join, it can be used for combining datasets where only common entries are needed, right? For example, combining stock prices with sentimental data where you only care about dates where both data are available, right? For left join, it can be useful when you want to keep all the entries from the main dataset, that is stock prices, and only add supplementary data, example new sentiment if available, right? And in right join, it is useful when the main focus is on the supplementary data and you want to include all its entries, right? And for the outer join, it is useful for combining data sets where you want to retain all data from both the sets, right? And it will having the NN values when it is not common, right? Okay, now let's understand this figure. And with this, you will be able to understand the both the merge and the join method. So let's first understand the inner join. Let's say we have two data frames. One is A, another is B, correct? Because in both the merge and join, we have these four operations. So if you want to apply the inner join, what will happen? It will display only the common columns, right? Let's say in the A data frame, you have date and price, and in the B, you have the date and the ticker name. So when you apply the inner join, it will only display the date column. Rest it will ignore. So we get only the common values from both the data frames. Similarly, in the left join, what happens? It will display all the values from the A data frame, and from the B, it will only display the common value. Means in A, you have date column, and in the B, you have date and ticker. So from A, it will display both, means you will get date and the price, but from the B, you have only the common, which is date. So in the final output, you will be having date and the price, right? And right join is the inverse of left join. So you will get all the values from the B, but from the left, you will get only the common values. Similarly, in the outer join, you get everything, means all values from A and all values from B. And that simple it is. It is very simple. It is just a more practical concept than the technical. If you just close your eyes and just think in your mind that how it is happening, and then when you apply all these concepts in your real life, you will see that how easy it is. It is just a little bit confusing, but it's not difficult. You just have to close your eyes and think in your mind that how it is happening. That's it. Okay. Just now pause the video, close your eyes, and just recall these images in your mind, and you will see that you will never forget this again. Now the last one is concatenating. So the definition is concatenating appends data frames either vertically or horizontally using the pd.concat function. This operation is akin to stacking data frames. In concatenation, we just stack the data frames. Like if you have two data frames, if you want to stack them vertically or if you want to stack them horizontally, right? So you can do that with this pd.concat function, and it is also very useful. So all these three methods are very useful, and you can skip join because you can perform all the operation on the merge, but you have to have an understanding because sometimes you might want that. So basically, we will understand the merge and concatenate in detail in this session. Okay, before we start coding, let me show you some data frames and let me try to explain you how these operations will be applied on the real life algo trading datasets. Now let me quickly explain you the syntax of these functions. So the first is the merge function, and we can use this with the pd.merge. Pd is the pandas, and inside that we can provide the name of the data frame, that is prices, the first data frame. The second is indicators, right? Then we have the next parameter, which is on. So on is the name of the column, which is the common column in both the data frames. Next, we have like how you want to merge the multiple data frames. So here we want to apply the inner join, which we have just understood in the previous figure. And here you have another way perform the merge function. What you can do, you can write first the name of the table or the data frame, then dot merge, and here you can give the second data frame name, indicators, right? And then the rest is goes same. So if you apply left here, it will become the left table, it will be the right table. And if you want to perform the right join, you can just reverse these. Means you can even do with the pd.merge, and if you want, you can do with the name of the table or the data frame and dot merge. Both are right. You can just try and think which gets better with you. Next we have is the join method. So in that also it is exactly the same. You just have to write the name of the table the first, then dot join, and then the name of the second data frame, right? And also you have to pass the how parameter, which we have used in the merge also. It's same, almost same. So means we can say that we can use either this one or this one, but mostly you will be using the merge, and I would recommend that you just master the merge function, and you would not need much to use the join, but still you have to have an understanding of this join also. Sometimes it might be applicable at some places. And the last one is concat. So in that also you have to write like pd.concat, then the name of the data frames. The first is prices, the second is more prices. So here if you want you can use the other methods also, but basically the name of the first data frame here and the second data frame, you have to use a list here for the multiple data frames, and then you have to provide an axis. So 0 is when you want to merge horizontally, the stacking we can also say, and when you want to merge like vertically, right? So you can use the axis equals to 1 and the data frames will be concatenated vertically, right? So this is the axis 1 you can say, and this is axis 0, right? Even like with this type of columns, you can see that it is similar to 1. So you can remember that 1 is vertical and 0 is horizontal. Okay, now let's quickly see some data frames and I'll show you how we can use that. Okay, so here you can see that we have this historical price data frame, and in that we have date, ticker and close columns, and also in fundamental data we have ticker, quarter, earnings and revenue. Means we can merge both these columns based on this ticker column. This is common here, right? So you can apply the merge function and you can perform the merging operation. And if you want to concatenate, you can also do that, but there is no requirement of any common column. You can just straight away concat. Just you need to think that while concatenating horizontally, number of columns should be same, right? And also if you want to merge these two columns, you can see that we have ticker as common and date also common here. So you can see here that here date and ticker is common. So you can merge these two data frames based on the date and ticker column. And similarly, here also we have date and ticker. So you can merge and these two also, and if you want, you can merge all these three, right? And last is volume data. So in volume data also we have date, ticker, and even if you want, you can merge all of these 5 data frames. So that was the basic explanation, and I tried my best to make you understand. And I always consider everyone as a beginner, as a noob, because I was also a beginner sometime, and I know that how much I struggled while learning these things. So let me know if you want to change the way I'm explaining. Please let me know how we can improve this. Your valuable feedback is always appreciated. And now let's jump to the coding part and perform some real life algo trading problems. So here you can see that first we have to install the yfinance package. So you can do that with the exclamation pip install yfinance if you are using the Visual Studio Code or the Jupyter notebook or any other notebook software. And then you have to import with the command import yfinance as yf, and then you can use the yfinance. So yfinance is the Yahoo's finance repository, you can say, right? And here is the theoretical part, so you can just go through if you need. And these are few examples, and this is the code to import the data from the Yahoo Finance, and also for some of the tables, as Yahoo do not have the data, so for that we just created the synthetic data, right? So you can see here that this generate trade orders is synthetic data, and also this signals also synthetic, correct? Okay, now let me quickly show you the data frames. The first is historical price data, you can see here. The second is fundamental data. Third is trade orders. Fourth is strategy signals. Fifth one is the volume data, right? So you can see here, basically in volume we have date, ticker and volume. In signals we have date, ticker and signals. So in trade order we have order ID, date, ticker, quantity and price. And in fundamental data we have ticker, quarter, earnings and revenue. So the data of this quarter is not available in the Yahoo Finance, so that's why it is NN values. And the first is historical price data. So we fetched this data from the Yahoo Finance. So basically you can see here that we have these two columns as almost in all the data frames. So we can perform the merging operation on these basically, right? So let's start. So what we will do here, first we will understand the join and concat, and after that we will deep dive into the concept of merging, because that is the main agenda of today's session, right? So Let me show you quickly. So before that, I'll just note down the name of tables here. So first is, or here we can do, first is historical. Then we have fundamental, volume and trade. Then volume and then trade. So let's say if you want to join this historical price data and this fundamental data. So for that, what you can do, you can just write the name of the first table, that is historical price data, then write join, and inside that you have to provide the right data frame. So here we can say it is fundamental data. So I'll write fundamental data, and then you have to provide how, like what should we perform. So let's say we want to perform the inner join, right? So I'll write inner, and so in inner what happens, we will get only the common values. So when we hit shift enter, you will see that it gives us a, so now you can see that we are getting this error which says column overlap but no suffix specified, right? Index sticker and d type object. So for that, what you can do, we know that, let me show you the, let me remove this and I'll again, first let's check the historical price data, and here this is the data frame which have date, ticker and close, but in the index we have the default index of the data frame. Similarly, in the fundamental data we have ticker, quarter, earning and revenue. So we have to specify that on which column you want to join this data frame. So for that, what you can do, you can simply go here and first set index here. So set index, and in historical price data you can set index as date and ticker. So I'll just write date and ticker. If you remember, when we understood the theoretical part, we have seen that this join merge the data frame based on the indices, right? While merge can do with the column name also and the indices also, right? And here also we have to set the index. So I'll write set index, and here we can give the index as the ticker, right? So I'll just copy here and paste it here. So now when I hit shift enter, you will see that it has been merged, right? And all the common rows is being displayed here, right? So that's how you can use the join. And if you just change here from inner to left, then all the values from the left will be displayed, but from the right, only the common values will be displayed. So when you hit shift enter, you will see the value. You can perform on right also, same, right? You can see here. And also you can perform an outer. So in outer, you will get all the values, right? And you will see that you are getting all the values. So that's how you can use the join method. To be very honest, I prefer to use merge method because the merge can perform the similar operation, but that has the advantage of common column also, right? It can like perform on the column and both the indices. So that's why that is much better, I think. But sometimes you might need this, so just be aware of this function also. Let's understand the concatenate. Now let's understand the concat. So I have told you earlier that, so in concat, you can merge the data frames based on their positions. Like if you want to merge the horizontally or vertically. So for that, what you can do, let's take these again, the historical price data and the fundamental data. So we know that, let me, historical price data and shape is 204 rows and 3 columns. And for the fundamental, we have 6 rows and 4 columns. So if I want to merge these horizontally, so for that, what we can do, I'll write pd.concat, and inside that we can provide historical price data and the fundamental price data, right? So when I shift enter, it says me concat takes 1 positional arguments but 2 were given, right? Actually, we have to provide the name of the data frames in a list. So I'll just give a list, and now when I shift enter, you will see that it has been concatenated, right? Now the rows are 210 and number of columns are 6. And why 210? Because I've shown you earlier that 204 plus 6 is 210, and then again 3 plus 4 is 7, but we have 6 only. Why? Because one column was common. This ticker column was common. So only we have the ticker as only one column. correct? So that's how you can do that. But if you can observe, we have one problem here. The index is repeating. On the top, we have the index of this first data frame, and on the below, we have the index of this second data frame. Sometimes it is only required, and sometimes we don't need this. We need a range index. For that, what you can do, you can simply write here a parameter that is index, that is ignore index is true. By default, it is false. So you can make it true. And when you do that, you will see that we have a range index, right? From 0 to the last row, correct? Okay, now let's say if you want to preserve the index of the original data frame. So for that, what you can do, you can simply, let me copy and paste this command. I'll just remove this ignore index. And here you can give another parameter, that is keys. You can pass a list. Okay, in key, you can give, let's say first hist key, right? And then you can give second one is fundamental key, right? Not key, fundamental data. Historical data and fundamental data. And when you do that, and when you hit shift enter, you will see that we have preserved the original index. You can see here, the first one is historical data. Then again, second one is the fundamental data, right? This key is for the first data frame, and the second key is for the second data frame. That's how you can preserve the index. Actually, if you can see here, it is known as the multi-index. The first index is the keys, and the second index of the original data frame. It is known as the multi-index. Let me write here. Actually, we will learn this whole concept in the next whole session. It will also be a very, very important and useful session. So in the next session, we'll cover the multi-index. Let's say if someone asks you that I want only this data, the fundamental data from this multi-index data frame. So for that, what you can do, you just have to assign it a variable, let's say combined df, okay? And then I'll go here in the next cell and I will use the LOC. We have learned this previously that whenever we have an index in the label form, we can use the LOC, right? Here, I'll give a tuple. So in tuple, I will pass the historical data. So hist data. And now when I hit shift enter, you will see that we have only the first data frame. If I want the fund data, I can just change it from hist to fundamental and you will get the fundamental data. So it's very easy. And also, let's say if you want only the second row, right? So for that, you can just give here the only second row values. Okay. Now let's understand the concat function. So in concat, I have explained you already in the theoretical part that we can concat two data frames horizontally or vertically. So by default, when we do not mention any axis, it is 0. And if you mention 1, then it is merged vertically. So let me show you how. So here we'll take two data frames. First is historical price, which has a shape of 204 rows and 3 columns, and fundamental data, which has a shape of 6 rows and 4 columns. Let me show you. So here you can see that the historical price data, which has 204 rows and 3 columns, right? This one, 3 columns. And again, this fundamental data has 6 rows and 4 columns. So let's understand the concat. So pd.concat, and here you have to provide the name of the data frames. So first is historical price data and the second is fundamental price data. So when you hit shift enter, you will see that you get an error. Why? Because here you have to pass a list. So what I will do, I'll just pass a list here. And now when I hit shift enter, you will see that it has been concatenated. And by default, it is horizontally, correct? You can see here, it is horizontally. Means earlier we had in the first, we had 204 rows and 6. So means it became 210. And again, 3 columns and 4 columns became 6 columns. Why? Because one column was common, the ticker one, correct? So it became 6 columns. Now, if I just change this axis from 0 to 1, you will see that it has been merged vertically. So when I shift enter, so you can see here that the number of rows remains same, but the number of columns becomes 7, right? 1, 2, 3, the first data frame, 3 columns, and then the 4 columns. So means if you keep the axis 0, the rows will be added, and if you keep the axis 1, the columns will be added. Or again, for the simplicity, if vertical means like the 1 and horizontal means 0. So that way you can remember, just remember that 1 is vertically standing. That's it. Okay. Now, one more thing I would like to add here, that I'll just copy and paste it here. And let's say we do not mention any axis. So by default, it is 0. So it will be merged horizontally. And here, if you observe that we have two indexes from 0 to 204, then again 1 to 5. So sometimes it is required, and sometimes what we want, that we want a straight index, like from 0 to last, whatever the number of rows, right? The 210 means from 0 to 209. So for that, what you can do, if you want, you can just add another parameter here, that is ignore index true. So by default, it is false. So when you make it true, you will see that we have a index from 0 to the last row. And sometimes what happens, that you want the original index of the data frame. So for that, what you can do? For that, you have a simple method, that is you can provide keys here. So when you provide keys, you have to pass a list. So the first key, let's say we have the hist data, right? And second key you can give as the fundamental data. So when you hit shift enter, you will see that we have two indexes. In the first index, we have the first data frame, that is historical data. And in the second data frame, we have the fundamental data. So means now we have two indexes. The first is the label index and the second is the integer index. Means we can also name it as the multi-index, which is itself a very big and very important concept of the pandas, which we will study in the next session. We will spend the whole session on the multi-index because that is very, very important. So what I will do here, I'll just write here the multi-index. Okay. Yeah. Okay. Now let's move to the main agenda of the session, that is the merge method, right? Okay. Now let's understand the merge. For the demonstration purpose, what I did, I fetched two data frames. First is historical price data and second is fundamental data from the Yahoo Finance. Okay. So let me show you. This is historical price and this one is the fundamental price data, right? So in historical price, we have 5 columns: date, ticker, close, earning, and revenue. And in fundamental data, we have ticker, quarter, earnings, revenue, and P ratio. So let's say if you want to merge both of these data frames. So for that, we have seen that what we can do, we can simply apply the historical price dot merge method. And then inside we can pass the name of the second data frame, that is fundamental data. Right? Then we have to specify. So what happens when you don't specify? It automatically checks all the common columns and it will merge that. So when I hit shift enter, it says that you are merging on int and float columns where the float values are not equal to their int representation, historical price data.merge. So for that, what we can do, we can actually change this value to like from float to integer or from integer to float. But for now, what I will do, I'll just specifically mention that I want to merge on the column name ticker, right? So for that, you have to mention the name of the column ticker. And now when you hit shift enter, you will see that these data frames have been merged on the column ticker. Here we had 5 columns and in this we had also 5 columns. So now we have total 9 columns. Why? Because the ticker column is common in both the data frames and one column has reduced, right? So here we can say that by default, the merge method performs the inner join operation. Let me take another example. So I'll go here and I'll paste it here. And instead of inner, I'll make it as left. And we have seen that in left, what happens? It will display all the columns from the left table. And from the right, it will only display the common values. So when I shift enter, you will see that we have all the values from the left, right? And from the right, we have only the common values. So you can see that we have 136 rows and 9 columns. And from left, we have all the values. And from right, only the common values, right? Then again, we can perform the right operation. And the right join is the inverse of left. So when I write right, it will display all the values from the right. But from the left, it will display only the common values. So how you can identify here, if you can see here, by default, if both the data frames have common name, the X is for the left data frame and the Y is for the right data frame. So if you want to make it something different, what you can do, you can add here suffixes. So let me show you how. So I'll go here and I'll add suffixes. And here you can give like this. Second is fundamental. So you can add funda. Simple. This means that no suffix for the first data frame value, that is x, and for the second one we'll be having underscore funda suffix at the end. So when I hit shift enter, you will see that for the first, that is the earnings and revenue, there is nothing, but for the second one we have funda at the end. Correct? Because in inner join we have only the common values from both the data frames. Similarly, you can add this at all the operations. Here also, if I add suffixes, so you will see that this x has been removed and this y has been replaced with funda. So when I hit shift enter, you will see that. Correct? Here also we can do that and it will be changed. And the last one is outer. So in outer we'll be having all the values from both the data frames. So when I change it to outer, you will see that we have all the rows, right? It is 138 and 9 columns and all the values we have. Okay, let me first explain you that what is index and what are the column names. So we have seen previously in the series, that is 1D, and data frames, that is 2D. So let me show you. Let's say we have a series and in that we have a default index of 0, 1, 2, right? And values we can have, let's say anything here, let's say 100, 200, 300 and 400. So this is the series, right? And series are generally 1D, not generally, always. Okay, so here this is the index and these are the values. Again, let's say we have a data frame. So in data frame, what happens? It will nothing but it will just change, let's say 0, 1, 2, 3. The values are same, 100, 200, 300 and 400. There will be another column, right? So it can be 500, 600, 700, 800, and you can say this is a price after inflation. Anything it can be. So price inflation, correct? So we have here two columns and all of it becomes the data frame, correct? And when we take any single column, it becomes a series, that is 1D. So here it is 2D. Because in the series, in the 1D, when we want to fetch any value, let's say 100, we just need one information, right? The name of the series, and we just need the index number. So if I just give 0, I will get 100, right? Here it will be the name of series, and when I give the index, I'll get the value. So that means in the 1D, we just need one piece of information to fetch any value. That proves that series are 1D. And now in data frame, we know that data frames are 2D, and to fetch any value, let's say 600, we need two pieces of information, right? If I write the name of data frame, then I have to provide the row number, which is 1. I have to write like 1. Then we have to provide the name of the column. So that is price, and then only we'll be able to fetch this information. And that also proves that data frames are 2D objects. Okay, now let's start with the multi-index. So in multi-index, what happens? Instead of having only one level of index, we have multi-level of index. How? Let me show you. So here you can see that this is the live data which we fetched from the Yahoo Finance, and I will also show you today that how to fetch the data from Yahoo Finance. We'll code, and it's very easy, and I'll show you how you can also do that. So here you can see that we have a date time index here. Then here we have the column name, that is adjacent close and close, and below that we have the name of tickers: Apple, Amazon, Google, Microsoft. So this means in index we have a date time index, and in column we have two level of column, right? So sometimes you might have to convert this kind of table to this kind of table. And here, if you can observe that we have a two level of index, right? So first we have the date, and then we have the ticker name, right? So we can say this is level 0 of multi-index, and this is level 1 of the multi-index. So similarly, here in the column, we have only one level. So let's convert this table to this table. I'll show you how you can also do that. So here we can see that we have a date time index, or here we have two level columns. So in algo trading, you will always want to convert from one dimension to another dimension. And we can say that multi-indexing is generally used to convert higher dimensional data to a lower dimensional data to perform better analysis, because we are comfortable with the 1D or 2D data. And we can also perform better and efficient analysis on the lower dimensional data, that is 1D and 2D. That's why we'll always converting from a higher dimensional to a lower dimensional. It can be any dimension. It can be 8 dimension to 1 dimension. We can easily convert once you understand this concept. It's very easy. You can also convert like this. The columns came in the index, right? So now it becomes very easy to observe. And you can also convert like this date will come first and ticker will come to second level. So you can always easily change the column level, the position of the columns or the indexes. So means once you learn this, you will be able to play with the data very easily. Okay, so now let's understand the multi-index object. Let's see some theoretical part and then we'll proceed for the coding part. So in algorithmic trading, data often comes in nested hierarchical structures. For instance, you might track the performance of multiple trading strategies across different time periods and asset classes. Multi-index objects in Pandas allow you to organize this data hierarchically, making it easier to navigate and analyze. Now let's understand why we use multi-index objects. So the first point is hierarchical data representation. It allows you to represent complex trading data structures such as tracking various strategies across multiple assets and timeframes. Means we might want the data of multiple assets across multiple timeframes. And in that case, we will be always having the data in multi-index form. So it becomes absolutely necessary to learn this concept. Then, efficient data manipulation. It enables efficient slicing, dicing, and aggregation of data, which is crucial for backtesting and analyzing different trading strategies. So means when we fetch multiple assets data in multiple time frames, so then with the help of multi-indexing objects, we can easily navigate, we can easily slice the data, and that is crucial for the backtesting. And the last but not the least, enhanced grouping operations. So it facilitates more detailed GroupBy operations, essential for calculating metrics like strategy performance by asset class or time period. So it becomes absolutely necessary to learn this concept thoroughly, deeply, so that once we start the algo trading, we'll not having any issues. So actually, after this topic, we have few sessions of the advanced pandas, and then we will understand few plotting libraries, which is very crucial for the algo trading because we always want to first analyze and then plot. So it becomes necessary to understand the plotting libraries also. And after that, we'll start the deep concepts of algo trading, and you will see that shortly. Now let's understand the coding part of this multi-indexing because the practical side is more important in the multi-indexing. So without a further ado, let's deep dive in the coding examples of the multi-indexing. So now what we will do today, I'll first show you that how you can extract data from the Yahoo Finance. So for that, so first of all, when you start coding with the pandas, you have to import the library, that is the pandas. So import pandas as PD. And as I told you previously that along with pandas, make a habit of importing NumPy as well, right? So import NumPy as NP. And then for Yahoo Finance, you have to import the library that is YFinance. So import YFinance as YF. Sometimes what happens that it is not installed in your system. So for that, what you can do, you can select any cell and you can write pip install YFinance. Okay, so it will get installed. So when I hit shift enter, you will see that it says requirement already satisfied, means it is already installed. And sometime what happens, it might also not work because for the Python 3, you can use that. But still, if it is not installed, please let me know. I'll help you out in the comments for sure. Or in the Discord or in Telegram or in Instagram, you can connect with us and we'll try to help you out. Okay, so now we are set. So when I hit shift enter, it will show me a tick, means it is all imported, right? Okay, now let me show you a simple process in which we will just import a data of a single ticker. So for that, what you can do, you can just write yf.download. Okay, so inside that, you can see that we have some default parameters. So we have tickers, then we have period, interval, start, and a group by. You can use a lot of parameters, but that is not required a lot of times, right? So what we can do, we'll just use the tickers. Okay, first of all, so I'll just write tickers, and I can just give Apple, right? So when I hit shift enter, it will download the default that is from start to end, right? Then, like if I want to give a specific time interval, so for that you can give, and in start you can mention the date. So let's say if I want to fetch data from 1st January 2024, and in and you can provide date of today. So let's say 2024, and let's make it 1st of June. Okay, so now when you hit shift enter, you will see that instead of these rows, we'll be having less number of rows. So let me hit shift enter, and we just have 105 rows, and we have 6 columns. So if you remember, I have shown you previously that these are the general OHLCV data, that is open, high, low, and close, and volume, and also adjacent close. So if you are having any issue in this concept, please refer my previous videos, and you will find a detailed explanation of this OHLCV concept. Now, when you are performing any analysis, like whenever you analyzing a data, it's always advised and recommended that you create a function to specifically fetch data. So for that, what we can do, we will make a function. So for now, I'll just keep it here only, and I'll assign a variable to this, that is data, correct? And we can define a function here. And for the function, we have done a detailed video. You can find the link in I above. And if you have any issues, please refer that. So define fetch data. You can give like fetch data. And so now it's good. And here also I can return data. So whenever we call this function, it will return data, right? And also we can remove these parameters. So what we can do, we can pass here tickers, then start, and then end, like this. So I'll just remove it from here and this also. Hopefully it's clear, nothing difficult here, which we have studied in detail in previous videos. Now let's do few more things. So as here we want multiple tickers, so for that what I'll do, we can just like give some value here. So we know that we want data for multiple tickers. So what we can do, we can pass a list here, list of tickers, then the start date and the end date. So in tickers, I'll give a list. So let's say Apple. I want for Amazon also. Then let's say Meta and Microsoft. Okay, so I'll just take 4 tickers, enough. Then in start, I'll give a date. So 2024 to 1st January 2024 to, I want data up to 1st of June. Okay, so now all good. So when we call this function and provide these values, it will be printed out. Now what we can do, simply we can assign to a data frame, that is df, right? And we can simply print it. So I think it's all clear. It's very easy. This one we have learned in the previous videos thoroughly. So you can refer that. And now when I hit shift enter, you will see that we have a data frame, right? And which contains 105 rows and 24 columns, right? Means in columns, it is multi-index. We have 2 levels of columns, level 0, adjacent, then close and high. And on the level 1, we have Apple, the ticker names. Here also we have a date time index. Okay. We can also check with the info command here. So let me show you info, and you will see that we have the columns, correct? Then there is no null value and all are float 64, right? And the size is 20.5 KB. So mainly we have 2 kind of data types, that is float and integer. And you can also check the index and columns. So let me show you index. We have datetime index, correct? And in columns, we have this, that is multi-index, right? So now let's begin the session with very basic we'll build up the basics, the fundamentals, and then we'll move to the advanced topics. Okay, so df, we have this data. I'll just keep it, and I can show you also. It is the type. You can see here the type data frame, right? So we'll use this later. So just remember that we have a data frame with the name df, which is the data of Apple, Amazon, Meta, and Microsoft from 1st of January to 1st of June. That's it. Okay. Now, series is 1D and data frames are 2D objects. So why? Let me show you. So if you want to create a 1D series, what we do, we simply use the method that is series, or inside that we can pass a list, we can pass a single number, we can pass a dictionary, and a series will be created, right? We have seen that previously. So let's say if I pass a list of 1, 2, 3, 4, 5, we'll get a series, correct? You can check the type. This is a series, correct? If you use the data frame method or object, you can say, so we will get a data frame, right? And it will look like this. Let me show you. It will look like this, correct? And we have seen that if you want to convert a data frame to a series, we have to use the squeeze function. So this is the basic series and data frame. And let me print both of these so you'll get more clarity. Print, and here also print. So you will see that both looks almost same, like there is not a much difference, but they are still different, series and data frame. So if you want to convert, you can use squeeze. And here, let me show you some of the important things here. So here is the index of series. This is the index of data frame. These are the values of series, and this is the value of data frame, correct? And for now, we know that series are always 1D. Why 1D? Because to access any value of series, we just need one piece of information, right? And to access the data frame, we always need two pieces of information. Let me show you how. I'll just assign some value to these. So let's say series, we assign ser, and for data frame, we will assign, let's say, df. Okay. Now, I'll just add another column here. So series. Okay, let me run this. And now what we'll do, we'll print ser and df both. Let's print, so we'll get a more clarity. Print, and here also print, correct? Now, if I want to access the three value of the data frame, I need to provide an index, and you will get the error, right? Because to access any value from the data frame, we have to provide two pieces of information. So this was the row first, and now we also have to provide the column. Similarly, if you want to access these three from the data frame, and let's say if I write df and 2, but it throws a value error. It says 2 is not in the range. So for that, what we can do, we have to use the iloc, and we have to provide two pieces of information. So when I write iloc, so actually by default, if I shift enter, it will give me the value, that is 3. But when we have multiple columns, we also have to provide the column name. So here we know that it is 0. So I can just give here a comma and 0. So we'll get the same value exactly, right? No difference. So now I hope you are able to understand the difference, the real difference between a series and a data frame, right? So here in both the series and data frame, we had a single index, right? Or even in the column, we had a single level of columns. But if I want to create a multi-index series or multi-index data frame, what I can do, I will go here and I'll just take this only, this list. I'll go here and let's say I'll give an index here, multi-index, and I'll pass a list. And what I will do here, I'll add a tuple. So we can say this is the list of tuples, right? So I'll add some value here. Let's say Apple, and I'll just copy and paste it everywhere. So 2, 3, 4, and 5. Now we can change the values. So from Apple to, it can be Microsoft, it can be Meta, it can be TCS, or it can be IOCL. Okay, and let's change these values also. So to differentiate better, 3, 4, and 5. Just remove this unnecessary comma from here. So now what we will do, we will just pass this index as the index of series and data frame. So I'll go here, I'll write index is equals to the m index, right? That is the list of tuples, right? And here at the values, we can give anything. So in series, let's say we provide a list of values. So it can be 0, or let's say provide from the 1. So 1, 2, 3, 4, or let's give some good values, 100, 200, 300, 400, 500, because we'll not be able to differentiate between the index and values. So now when I hit shift enter, you will see that we have the values, but we don't have, because we made a mistake. We have to change these to M, series, and multi-index data frame. Now when you hit shift enter, you will see that the multi-index series has been changed. Now we have two indexes, that is multi-index and the values of the series. Similarly, we can change for this also. So here what I will do, I'll go again and copy the index, and same process at the index, I'll provide the m index, the same index, and in the values, I can give the similar values, right? I'll go here and I'll provide the similar value. So when I hit shift enter, you will see that it has been changed, correct? So now the values are same exactly, but this is series and this is data frame, because you can see here, we specifically created one series and one data frame. You can even check if you want, right? Okay, now let's access this multi-index series and multi-index data frame, right? So what I'll do here, I'll go here and I will try to access. So we know that to access the multi-index series, that is 1D, we just need a one piece of information, that is M, series, and just the index number. So here we have the index number as, let's say if I try to access with just the apple, let's try what happens. It will throw an error because we have to provide this specific index, the whole one. So I'll just paste it here. And now when I hit shift enter, it says apple not defined. Yes, of course, because we have to make it as a string. Now when we hit shift enter, you will see that we have the value, right? That is 100, correct? Similarly, we can also copy and paste in the data frame. So I'll just change from series to data frame. And now just pause the video and you let me know whether this will work or not. If yes, then how? If no, then also how. You have to understand, you have to pause the video and you let me know it will work or not. And you have to provide that why it will not work or why it will work, right? So, okay, now let me hit shift enter and you will see that it's raise an key error, right? Means we need two pieces of information to access any value from the 2D data frame. So we have to provide the index number and we have to provide the column number. So for that, I'll just remove this, right? I want to access 100. So I'll provide 0, that is the row number, and the column number is also 0. So I'll just give 0 and 0. And when you hit shift enter, you again have a key error because you have to use the iLock here. We have learned that, right, previously. So when you hit shift enter, now you have the value 100. So I think now you are able to understand the real problem. So means, let's say if we fetch the data from any source and we have a 3D, 4D, or even a 5D data, then how you will access? Because it becomes more and more difficult to analyze the data and manipulate it in the higher dimensional data frames. So for that, we need to reduce from higher to lower, and then we can easily perform the operations, right? Here you can also just provide the 0 because it has only one column. So obviously it will give only 100, right? So the problem in this kind of multi-index that we cannot simply access a single index. If I want to access apple only, I cannot do that. Let me try that. So when I provide lock And if I give here only apple and hit shift enter, it will throw an error, key error, right? Here also in series, if I just give apple, it will give me an error. But in reality, sometime we need only apple value, sometime we need only TCS value, sometime we need only IOCL value, right? Now what we can do, we can simply create the multi-index object. So pd dot multi-index, and then we have to give that from. So we can create a multi-index from product, we can create from arrays, we can create from frames, and we can also create from tuples. So for now, we'll just look on how to create a multi-index from tuples, and then we'll look on and how to create a multi-index from products. So from tuples, and we know that we have these tuples, the list of tuples. So what I will do, I'll just pass simply index, and now when I hit shift enter, you will see that we have a multi-index, correct? Now, similarly, you can also create from the product. So for that, what I will do, create a product. So for that, I will do like product index, and I can pass a Cartesian product here. So how you can do that? You can simply remove this, and you have to create a 2D list. So first, let's say we give Apple, and then we can give, let's say, Microsoft, right? And here give a comma, and you can give the values. So what will happen now? This apple will get multiplied with 100, 200, and 300. And again, this Microsoft will get multiplied with 100, 200, and 300. Let's make it 6. So what I'll do here, I'll remove this 300, and here I'll give another, let's say, meta. So I'll just copy and paste here. So we'll be having 3 multiplied by 2 means 6 values. So here also, let's make it 6. So I'll add another value, let's say HPCL, okay? Just for the symmetry, nothing else. Now, if I want to create a multi-index from product, so for that, what I will do, I'll just write pd.multi-index. Then from, we have to select product, right? And here we have to pass the Cartesian product, so p index. Now when I shift enter, you will see that we have a multi-index of 6 values, right? 1, 2, 3, 4, 5, 6 means this apple got multiplied with 100 and 200, then again Microsoft, and then again Meta, right? Now what we will do, we will just assign some values here. Let's say what we can do here, tuple, so t index, and here we can provide it value, let's say p index. Let's change it to something else, pp, just for now, so it will not conflict. Okay, so now we have 2 multi-indexes. One is t index that is made from the tuples, and p index that is made from the products, right? And now we will print this. So print first the t index, and then in the next line we'll print the p index, right? You can see here we have both the indexes, right? All have like 6 values, 6 and 6. Now if I want to check the levels, so what I can do, I can write t index and dot levels. It will show me the frozen list, right? And inside that it will show me both the levels. Let's say if I just want the first level, these tickers, so I can just pass the index 0 and we'll get only the tickers. If I want the numbers, I can give here 1 and we'll get the level 1 index, right? Similarly, you can do in this also. So for p index, I will just change it, and in p, the level 1 is these values 100, 200, right? So when I hit shift enter, you will get the 100 and 200, and for the 0, you will get all the tickers. So hope it's crystal clear, right? Now let's understand that. Let me just copy it, paste it here in the respective columns, right? Now we will create a series and a data frame from the multi-indexes we created. So first let's create the series. So for the series, we know the syntax pd.series, and you have to pass your index. So first we will give, let's say, the tuple index, right? So when you hit shift enter, it says initializing a series from a multi-index is not supported. Means actually we want to use this multi-index as the index. So we have to first give index is equals to multi-index, that is a tuple index. So now when I shift enter, you will get these values. And here we have only the indexes, there is no value because we haven't provided, right? So for the values, you can give here anything. So let's say we pass a list here and the values are 100, 200, 300, 400, 500. The index is 6, so we have to provide the 6 values. If you provide less values, you will get an error, right? It will say length of values 5 doesn't match the length of index. So you have to provide the 6 values. You will get a beautiful series, right, with the multi-indexes. And now our problem has been resolved. Earlier, if you remember, in the above, here we cannot access any value with just a ticker, right? We have to provide the whole index, this. Then only you'll be able to access. Let me show you again. If I provide only the apple, we cannot get the value, right? So to access the value, you have to provide the both the indexes, right? Then only you get the value, correct? The 100. But now the issue has been resolved. And if you want to access the first value, what you can do, let me make it a series. So what I'll do here, I'll give it a name M series, M SER, and just print this here. And now let's say if I want to access the 100, so what I can do, I can simply write M series and give the index number 0. If I want the first index, we can also give here apple and you will get the first value. And now if you want to apply like the iLock, it will work similarly. I can even give iLock apple, it will not work because we have to give the index here. So I will just give the index 0 and you can get the value. So now we have the flexibility with the multi-index object. So the difference is we can create a multi-index series without the multi-index object, but we cannot get that flexibility. So with the multi-index object, we are having a good flexibility, and I'll show you more on this, right? Just wait for a few minutes. Okay, now let's create a data frame. So what I will do, I'll just copy it and paste it here, and I'll change from series to data frame. Okay, from series and here also df, and here series to data frame, correct? Everything is same. And now when I shift enter, you will get the exact value, but now little bit more beautiful in a tabular form. You can see here it is same, little bit better. The only difference is that we have seen previously multiple times that to access as value from a series, we just need a one piece of information. Why? Because series is 1D, but to access the information from data frame, we need two pieces of information because this is a 2D data frame, right? Okay, now let's say if you want to access the 100, what you will do, you can simply go and write apple, right? Which we have done in this series, and you will get an error because we need two pieces of information. So for that, what you will do, you will give here LOC, correct? And now when you hit shift enter, you will get the value. But this is not correct because here only one column. So that's why we are getting the first value. But if we had multiple columns, we would be getting all the values, but we want only the 100. So for that, you can just give a comma here and you can provide the column name also or number. So here, when we give 0, you will get exactly the value of one cell, that is 100, right? Hope until now it should be very clear to you, correct? Similarly, we can use the same things, iLock and lock. So for iLock, you have to provide the indexes in the integer form. So you will give 0, 0 and you will get the value, right? Exactly same like the series, correct? So we have seen that how to fetch the data from a series or from a data frame, correct? So now the logical question arises that what is the use of this? So we can simply create a data frame or a series and we can perform all these things, right? So my answer is that now you have the flexibility or to convert this data frame to a series, and that is done with the help of two amazing functions, that is stack and unstack. Let me first show you the unstack. So we have this series here, small num series, and if I apply unstack here, so what will happen? This level 1 index will be unstacked and it will go to the columns. So when I hit shift enter, you will see that the level 1 index has become the column and it has become a bigger data frame from series. So we can say we have converted this series to a data frame, right? If you again apply this unstack, and now you can also stack this, means you can also bring this value again to the level 1. So for that, you will do stack, and you will see that it has again become the same, right? Okay, now let me show you the same thing for the data frame. So this is the data frame MDF, correct? And when we apply the unstack, the same thing will happen. This level 1 index will go to the columns. So when I hit shift enter, you will see that it has happened. And again, if I apply stack here, it will reverse that, right? Okay, now let's use the real data which we fetched from the Y-Finance. So if you remember, I showed you here, we fetched this data, this DF from the Yahoo Finance, and now we will use this one, right? So I'll just run it again, and we know that we have this data frame, and here we have the multi-indexes. So I'll just go here and just print DF. Okay, and now let's apply the unstack here. So what will happen? This index will go to the here. So when I apply unstack, you will see that the date index has gone to the top and it has become a series, right? If you check the type of this, you will see that this is a series, right? Means we can say we can convert from a series to data frame or from a data frame to series with the help of unstack and stack. So if I just apply again stack, it will become the data frame again, right? It says series object has no attribute stack. Actually, on series, you cannot again apply the stack. First, you have to unstack that. So what we can do, I can show you on something different. Let me show you. So when I hit shift enter here, let it leave here. And what we will do, we will first apply the stack. So let me apply stack. And now what will happen? First, let me show you the original data frame, right? Now what we will do, we'll apply the stack. So what will happen? Here we have this level 0, this adjacent close, close and high. And on level 1, we have the tickers. So if I apply stack, what will happen? This level 1 will come at this index positions, right? So stack, and you will see that this ticker has come to here. And if I again apply stack, this level 0 also will come here and it will become a series. So let me apply stack again. And you will see that the price column also became an index here. And now it became a 3-level index. Level 0, level 1, level 2. And this is the series now, right? So I wanted to show you that we can also unstack this. So first we applied the stack. Okay. And now if I apply again stack, it will become a series, right? Let me show you type series, right? So if I apply again unstack, what will happen? The series will become the data frame, means the inside index will go to the column name. First it will go. So let me apply the unstack, and you will see that it has gone to the upper. And if you now check, it has become the data frame. Let me show you, right? And again, what you can do, you can reverse your changes. So if you want this tickers on the column side, you can apply again the unstack and it will go there. So now it became the original data frame because we first applied 2 stack and again 2 unstack. So it crossed all the changes. And if you again apply unstack, now what will happen? Now this data frame will become the series, correct? Hope it's clear now, crystal clear. And if you have any doubt, please let me know in the comments. We will try to answer that. Okay. Now again, the question, what is the point of multi-index series? So we have seen that dealing with lower dimensional data frame is much easier than the higher dimension. Means we can easily perform any analysis on the 1D series better than the 2D data frame. Let's say if you have multiple 3D data frame, we have a 4D, then it becomes hard and hard. So let's say if we have 4D index, so what we will do, we'll apply twice the unstack and it will become a 2D index, and then we can easily perform. And if you want a 1D, then you can apply 3 times unstack and it will become a 1D index. Then again, you can easily perform the operations. So that's why we use the multi-indexing to convert from any one dimension to another dimension. So you can convert from 1D to 2D, you can convert from 1D to 3D, right? And similarly, we can reverse that. So yeah, that was the explanation. And now let's understand few more things. So now the question is, are columns really different from indexes? No, because this pandas treating both as the same. Means sometimes we can easily convert an index to a column name and a column to a index name. Means for internally, pandas both are same, both are equal. And we have seen that multi-index DF from the column perspective. Let me show you again. So here we have 2-level columns. So if you want to make it 3-level, so you can simply convert from a data frame to series, right? And it will become a 3-level, right? And if you unstack this, then what will happen? The index will become 2D, right? This will become here. And again, if you apply, the column will come in at the indexes. So it was just that we can make like either column also multi-indexes, we can make index also multi-indexes, right? Actually, we have done this also in the above, that we have worked on both the columns and indexes. We made multi columns also, and we made multi-index also, right? Now what we can do, we can work with the multi-index data frames. So let's get some comfortable with the multi-indexes. Okay, now what we can do, let's say we have this data frame, and I will convert this to, I'll make this index as multi-level. So for that, what we can do, we can just apply stack here. So it will become the multi-index. Let's say if I want to access any value, so all will work the head and tail. Let's say if I apply head, so we will get the top 5 values, the top 5 value. For the tail also, we'll get the bottom 5 values. Let's say if you apply the shape on original data frame, 105, 24 means 105 rows and 24 columns, which we fetched from the Yahoo Finance. And if you apply stack here, you will get a different shape, right? 420 rows and 6 columns. And if you apply stack again, you will see that we are getting 2520 rows and 0 column, because now it became a series. So it's very easy, exactly same like which we have seen previously. So for the info also, you will get the same. In info, you will get the 24 columns, right? And if you apply stack, then you will get the info for the multi-index, which explain the column attributes, like how many null values are there, what is the data type of that column. So we can check the duplicated values. So here, if I check duplicated, it will show me like all are false, right? So it's exactly same, no difference. And you have seen that that is the consistency of the Python, right? Now let's say if I want to extract a single row. So let's say we have this data frame and you want to extract a single row. So you can simply write a 0 and you will get the error. Why? Because this is a data frame, and for that you need to use iloc and loc. So when we use iloc, value of the first row, and if you want like from 0 to 5, it's exactly the same, right? And if you apply stack, you will see that it has been changed. And if you want, you can even like save it to another data frame. Let's say SDF and SDF, right? And now let's say if I want the first row, so for that you need to apply the iloc and the index, that is 0, and you will get the value of all the first rows. Now, if I want multiple rows, so for that also, you know that we can use the slices, let's say 0 to 10, and with this step 2. So let me correct this, and you will get the rows with 2 steps. With iloc, we have seen actually already. So I'll just copy and paste it here. And now to extract the columns, we can perform the same thing, that we can give the name of the column, that is adjacent clause, and you will get the whole column, right, with all the rows. And similarly, if you want multiple columns, so for that, you know what you can do. You can give the multiple column names, that is, let's say adjacent clause, and you can give clause also here, and you will get an error because you have to provide another list, and now you will get the value of both the columns, correct? And now let's say if you want only the apple from the adjacent clause, so for that what you will do, you have to provide a tuple. So what we will do, we'll go here and we will provide a tuple, and here, yeah, tuple, and then we can give apple here, and you will get only the adjacent clause and the apple, right? Similarly, like you can perform on all the other columns and rows. Now the interesting thing is that if you want to extract both the columns and rows together, so let's say we have this, how we can extract both the index and the columns. So let's say if I want to access the high of Microsoft on 5th of January. So we know that 5th of January is on the index number 3, that is 0, 1, 2, 3, correct? And the Microsoft is on the index number 0, 1, 2, 3, 4, 5, 6, and 7. Simply, I can go here, I can write iloc and 3 and 7, right? And when you hit shift enter, you will see that you will have this value 367.7 75. Similarly, let's say if you want 24th of May data of Amazon and Microsoft. So for that, what you can do, you can simply write ilog, and you want for the 24th of May. So for that, what you can do, you can simply, like, now you don't know the index of this, right? So let's say you want the data of 3rd of January, right? And you want data of Amazon, Meta, and Microsoft's high of that day. Means the high of Amazon, Meta, and Microsoft on 3rd of January. So it is on the like index 1. So 1. Then you can pass a fancy indexing. So it is 0, 1, 2, 3, 4, and then 5, 6, 7. So you will just write 5, 6, and 7. And when you hit Shift Enter, you will have the value of Amazon, Meta, and Microsoft on the 3rd of January. Very easy and simple. And just practice few questions and you are good to go. Correct? You can also sort the indexes. Let me show you how. df, and if you give here sort index, by default it will sort because it's time series, so it's already sorted. If you make here like ascending false, then you will get the reverse data. Correct? Descending order. Let me show you a few more things. Let's say we have this data frame, and what I'll do, I'll apply a stack here. So what will happen, this column index will come here on the index side. So you can see here we have now two indexes, multi-level at the index side, means this is level 0 and this is level 1. So what I will do, I will first sort this in descending order, and then we will sort this in ascending order, right? So I'll just write sort index, and here we can provide a list. So ascending. So first we want for this descending, so I'll make it false. And for the second one, I want the same ascending, so I'll make it true. And when we hit Shift Enter, you will see that the first index has been sorted, but the level 1 is still in ascending order. If you also want to make it sorted, or you want to reverse this, you can just change the values. So from false to true, and from true to false, right? And when you hit Shift Enter, you will see that the level 0 index is same, but the level 1 index has been sorted in the descending order, right? You also have the option to transpose. Transpose means the index will become the columns and columns will become the indexes. Let me show you how. So if you apply on this transpose, okay, let me first show you the original data frame, right? So here we have two levels in the columns and one level in the index. And if you apply transpose here, you will see that the date time index now becomes the column and both the columns become the index. You can again apply the transpose on this, and now it will again reverse. Correct? So it's very easy, simple. And let me show you a few more examples. Let's say I will stack this first, stack, and what will happen? The level 1 column becomes the level 1 index. And if I apply transpose here, you will see that the indexes becomes columns and column becomes the indexes, right? So let me hit Shift Enter, and it says, okay, actually it is transpose, not the transform, transpose. And you will see that the columns become the index and the index becomes the columns, right? Now, the last one is the swap level. So this is the original index. And if you want to swap the levels, like the level 0, level 1. So if you apply the swap level, the level 1 becomes the level 0 and the level 0 becomes the level 1. So let me apply that swap level and hit Shift Enter. So you will see that it says can only swap levels on the hierarchical index, because on the index we have only one level. So if I apply axis here, axis is equals to 1. Now you will see that on the column side, the levels has been swapped. The tickers is on the top right now and the close and high is on the level 1, right? Similarly, let me show you the last example of this. So earlier we got the error. So for that, what we can do, we can just stack this, and now this index will become the multi-index, right? And now you can apply the swap level here. So by default, it applies on the rows. So now what will happen? This date will come here at the level 1 and this tickers will come at the level 0. So let me hit Shift Enter and you will see that it has been changed. And if you apply on the axis this time, it will throw an error because on the axis we already have only one level. So let's say axis 1, and you will see an error. It says can only swap levels on the hierarchical index. Hierarchical means the same multi-index. So for the swap level, you should be having the hierarchical index, correct? So I think that is it for the day. And remaining topics are the long versus wide data and pivot tables and melt functions, just 2-3 functions. And this is also very important. So before jumping to the melt and the pivot table concepts, we have to understand the long versus wide data format. So let me tell you the difference. If you can see on the screen, wide format is where we have a single row for every data point with multiple columns to hold the values of various attributes. Means in wide format, we have multiple columns, right? Means you can say the number of columns are more than the number of rows in the wide data format, right? Whereas in the long format is where for each data point, we have as many as rows as the number of attributes, and each row contains the value of a particular attribute for a given data point. So in the long format, we have multiple number of rows, right? So here you can say the number of rows are significantly larger than the number of columns, right? This is the long format and this is the wide format. It's like the name also signifies that what is the long and wide format. So sometimes it is not necessary that we will be getting the data in a particular format. We can get data in long format also and wide format also. So in order to deal with that situation, we have to have a good conceptual clarity on the long data format and the wide data format. Okay, now let's first visually understand what is the melt and pivot table function, and then we'll proceed with the examples. So in melt, what happens when we have a wide format data? Let's say we have multiple number of columns, right? It can be from hundreds to thousands, right? The number of columns, and the number of rows will be very less, right? So you can say like this, the number of columns. When we apply the melt function, what will happen? This wide format data will get converted to a long format data, right? So we can say it will become like this. The number of rows will be significantly larger than the number of columns, right? So you can see the definition and the use cases. So the melt function in Pandas is used to transform a data frame from a wide format to a long format. This can be particularly useful in algorithmic trading for normalizing data, making it easier to perform time series analysis or feed it to the machine learning models. So in the next session, we will understand the time series analysis. I would say that is the most important concept of the algo trading, because you have to have a good conceptual clarity on that also. You will also learn this time series analysis concept in the maths also. So by applying the melt function, we make it easier to perform the time series analysis, right? Then the use cases are normalizing the OHLCV data, which we have seen previously, open, high, low, close, and volume. You can refer the video in the I button. So when you have OHLCV data for multiple assets, melt can help consolidate this data into a long format, making it easier to analyze or visualize. Then preparing data for machine learning, converting wide format feature data into a long format suitable for training machine learning models. So when we start the machine learning models, you will see that we are using this melt function a lot, right? So basically, you can simply say in short that melt can convert a wide format data to a long format, or you can say the melt function can melt the wide format to a long format, right? It's that simple. So the next function is pivot. I really like a lot this pivot function because it is really magical. It is awesome to utilize while performing algo trading. Why? Because it can transform your data in any form. Let me show you an example. See, if you can see on the screen, we have this table or a data frame, right? It is tagged. So previously we have learned the GroupBy. It can perform all those GroupBy function with a simple pivot command. Let me show you how. Let's say if I want to make this foo as the index, so I just have to provide that df.pivot, then index is equals to foo, the column name. So here you can see that foo becomes the column name. So inside that we have only two unique values. So 1 and 2 becomes the rows. Then we can also provide that we want bar column as the columns. So you can see here all these unique values becomes the column name. Again, we can also specify that we want values as the bars. So in the bars, these are the values and these becomes the value of the new modified data frame. don't worry, I'll show you shortly that how we can utilize this in the algo trading, but you can imagine that how powerful this function is. Okay, now let's understand the use cases of the pivot in the algo trading. So a pivot table in Pandas is a powerful data summarization tool. It allows you to aggregate and transform data by changing the structure of a data frame. You can completely pivot the data frame to your desired data frame. The use cases: aggregating trading data, summarizing trading data such as average daily returns, volumes, or other metrics across different time frames or assets, creating contingency tables for analyzing the frequency of trading signals or market conditions. I'll show you how, don't worry, exactly how. We'll implement this a lot in the upcoming videos. We can simply transform any data frame to our desired data frame with the help of the pivot table function. Now, the last function we will understand today is vectorized operations on string, and that is the main agenda of the session. So what happens in the vectorized string operations? Let's say we fetch the data from the company's website and it is about the fundamental analysis. So generally what happens, the data is not structured, right? We want to analyze and then compare it with the technical analysis. So in order to do that, we have to structure the data as per our needs. So in order to achieve that function, we will be using vectorized string operations. Actually, in the core Python, it becomes so inefficient to perform these string operations. So that's why the Pandas came with this vectorized operations, and it is based on the NumPy array. So you know that NumPy array is fast and efficient. So that's why we will be using that. And again, let me show you what is vectorized. So let's say we have a table, right? 1, 2, 3, 4. So generally what happens in Python, if you want to print the square of this list, you have to apply for loop, right? In the core Python. But if you apply the NumPy operation on this, what will happen? You just have to give the multiplied by 2, right? And this square will be applied to all the items in the list. And it is known as the vectorized operation. A simple operation is applied on all the items in one go, and that is known as the vectorized operation. We'll learn more about this in the mathematical part, don't worry about that. But for now, just think that we can apply a single operation in one go. So it becomes so faster and efficient. And we know that in algo trading, we need the speed. So now let's jump to the coding part, and I'll show you all these three things: the melt, the pivot table, and the vectorized operations. Okay, now let's start the coding example. So let's build up the base step by step. So what we will do, first we will create a simple data frame. So pd.dataframe, and inside that we'll just pass a simple dictionary. So let's say apple, and the price is, let's say, 100. Okay, so when I hit shift enter, it says if using all scalar values you must pass an index. Okay, actually you have to pass list here. So when you hit shift enter, you will see that we have a one row and one column, and also we have only single value. So if you apply melt on this, you will see that this will get converted to this form, right? It will say variable and value. You can also change these. I'll show you later how, right? Now, let's say you have multiple values. Okay, for that, what you can do, you can you have BTC with the value, let's say 2000. Then you have the Microsoft with the value 3000. And let me remove this for now. So when you hit shift enter, you will get this data frame, right? And now if you apply melt on this, you will see that this wide format data will get converted to the long format data, right? Let me show you again. Earlier it was this, right? We had 3 columns, and when we apply the melt here, what will happen? It will get converted to like this. Means the columns will become the rows. The values of the rows will also come in the column, right? Now, so what is this variable and value? Actually, this is default from the melt. So if you want, you can change these names. So let's say the variable name is ticker. Then if you want to make the value name as the price, so you can do that also. And when you hit shift enter, you will see that it has changed to ticker and price. Now let's take another example. So in which what I'll do, I'll just copy and paste it here. For now, I'll just remove this. Here, what I will do, let's say we have a dictionary. In the first column, we have the tickers. So let me show you. Let's say ticker or tickers. And in that we have a list. So we can have first Apple, then we can have BTC, then we can have, let's say, Microsoft, and we can also have a Meta. Correct. I'll just copy and give a comma here and paste it 4 times. After this, we can give, let's say, price, second column, third can be year, and it can be, let's say, close price. Just for the sake of example. So in price, we can have, let's say, 100, 200, and 300, 400, right? 4 and 300. In year also, you can have and 2021, 2, so 3, 2, and 1. And close, you can have the close prices. So let's say 110, then you can have 120, 130, or 140. So let me change this, make it 220 and 320 and 420, right? So now when I shift enter, we have to give comma here also, here also. Okay, now when you apply melt on this, let me apply, and when you hit shift enter, you will see that everything gets melted. All the columns gets melted, and you get new 2 columns, which is variable and value. But you don't want to melt all the columns. You just want to melt price, year, and close, and you just want to keep this ticker. So for that, what you can do, you can write here ID and then where's, and inside that you can pass that you want to keep the ticker, right? So now when you hit shift enter, okay, we have to make this ID vars, not var. So now you will see that tickers is same as previous, the Apple, BTC, Microsoft, and Meta. Rest all the 3 columns gets melted. So now if you want to make these also customized, so what you can do, you can give here the var name is equals to, let's say, price, and you want to keep this value name as, let's say, capital value, right? So when you hit shift enter, we don't have to pass this list here. You can just give the name in string format. So now when you hit shift enter, you will see that it has been changed to price and value, right? So now let's take some real life example, so in which you will learn that how we can implement this. So let me show you. We import data from the Yahoo Finance first. So what I'll do, I'll just import pandas. Let's write there again, and we can also import the Y Finance as YF, right? Then we can use YF dot download, and here we can first do the tickers. For tickers, we can give, let's say, Apple, and we can also give Amazon. We can also give Microsoft, and also we can give the Meta. Correct? Tickers. Then we can give the start. We can start from 24, 1st Jan 2, and 24 June 30th. Correct? So now when you hit shift enter, you will see that you have the data fetched. It is from the live Yahoo Finance, right? Now, so here you can see that we have the multi-index column. Above we have the close prices, high prices, low price, OHLCV data basically, and below we have the tickers. So if you want to group by, you can apply here the group by also with a ticker, right? So when you hit shift enter, you will see that it has been changed, and now we have the tickers on the top, right? You can also bring these values, these tickers here in the index. So for that, you have to stack, which we have learned in the previous sessions, right? So when you stack this, you will see that
By default, we wanted to bring these stickers in the index, but instead we got these prices OHLC data here. So for that, what we can do, we can provide the level. So it is on the level 0. So you will give here level is equals to 0. By default, what happens, the level 1 index gets stacked. So if you want to customize, you can just give the level is equals to 0, and the top level is 0 always. And here also, the first level is 0 and second is level 1. So now when you hit shift enter, you will see that now this will come here and this will go back to their original position. So let me hit shift enter, and you will see that we have the tickers at the index, right? Or what you can do actually, let me just remove this for now and hit shift enter, and let's save this data to a variable named, let's say, data. Okay, and I'll just copy and paste it here and hit shift enter. And now what we can do, we can apply that function. So I'll apply stack here. So by default, we know that it will get stacked. Let's see that. Right. But we wanted the stickers, so we have to apply level is equals to 0. Correct. So here we are getting the warning, future warning. So to avoid this, for now what you can do, you can write here future stack is equals to true, and this warning will go away for now. Okay, that warning was because it has been deprecated and it might possible that you might get error in the future. So for that, always try to use the updated functions. So here we have just removed temporarily that warning. And now what we can do, we will reset the index. Okay, so reset index, and when we apply this, by default what will happen, the level 0 index will be resetted, but we want the level 1 index. So here we can also provide the level is equals to 1, and you will see that the level 1, which is Meta, Amazon, Microsoft, has been resetted. Right now, I guess we are good to go for the melt. So I'll again reassign to data and I'll print it here. Now our main goal is to melt this, means we want to keep the date and ticker here, and rest all the values we want to like convert from the columns to rows, right? So if you apply melt here, you will see that by default everything gets melted, but we don't want that. We want to keep the date and ticker there. So what I will do now, I have shown you earlier that melt, and here you can give id where's, and inside that you can pass a list. So we want to keep date as it is, and also we want to keep ticker as it is. So now when you shift enter, you will see that it says the following id where's value are not present in the data frame. Let me show you. The issue here is that this date is the index right now. So for that, what you can do, you can apply the reset index here, right? And you will get the default index, right? Now that date becomes the column. So now if you apply the melt, what will happen? These date and ticker columns will remain as it is, and you will see that date and ticker is same, right? And this price and value is new. So for that, what you can do, you can also pass here the var name is equals to, you can say, and also the value you can make it as the capital. So what I will do here, value name is equals to value, capital V value, right? Now when you hit shift enter, what will happen? You will get here the matrix and the value. Now again, in this variable, what you wanted, like which column should be here, right? So for that, what you can do, you can just write here. So let me show you again. What we will do, I'll just first print the data here, and let me show you. So this was the original data, right? So in the value of variables, what you want, O, H, L, C, V, and the last addition close. So for that, what you can do, you can simply go here and write value vars, and then you can pass these values, right? All these. So open, high, low, close, and volume. So I'll go here, I'll pass here, and I'll make this a string. This also, let me give a comma, and this also, and a comma, here also a comma, and the last one is volume, and let's give it a comma. So now what will happen, you will see that you get the modified data frame. So for that, you have to remove this and see the modified data frame, and this is your modified data frame.
So here we have a date, then tickers, then the matrices, that is open, high, low, close, and volume, and then the value. So that's how you can use the melt function. I tried my best to show you. If you still have any doubt, please let me know. We can discuss further on this, right? Okay, now let's understand the pivot table. It is really very useful function for everyone. Okay, so what we'll do, we'll take the real world data set. So if you remember, we have fetched the data from the Yahoo Finance on the initial part of the session. Here, we know that we store the data in that data variable, right? So what I'll do, I'll use the same data here. So when I print this, we have this one, correct? So in index, we have date, and on the columns, we have the ticker OH LCV. Let's also check the info. So we'll get more details. So the ticker here is the object, rest all are float 64, and the volume is integer 64, right? And also we have the index as the date time index. Don't worry, we will understand this date time index in the next session, because it is one of the most important topic on the algo trading. You have to understand this thoroughly. So that's why I'll take whole session for this date time index, right? So now what we can do, let me show you that where we can use the pivot table. So let's say if I want to apply a group by on this, so what I can do, I can apply a simple group by on ticker, right? Then what we can do, we can find the mean of open price, right? So mean, and you will get this value, correct? And if you also want to group by with the date, so then what you can do, you can like group by with the ticker and date, and then you can find the mean. So you will get mean of every day for each ticker. Okay, now let me show you that you can make this series as the data frame, which we have seen previously, that with the unstack, you can make this 1D data to the 2D data frame. So for that, you will be using unstack, and by applying unstack, what will happen here, that this level 1 index will get to the column names. So it will become the column names. And now when I hit shift enter, you will see that we have only 4 rows and 119 columns, right? So we have done this with the help of GroupBy. The same thing we can achieve with the pivot table. Let me show you how. Let's say if I apply pivot table, not df data.pivot table, right? And here you can pass the index. So here the index is tickers. So you can give index as the ticker, right? So when you hit shift enter, you will get this value, right? The index is tickers, and rest by default it calculates the mean value, right? So now we want the 119 columns. So what we can do, at the columns we can give here the value as like columns. I want date, right? So when I hit shift enter, you will see that now we have 4 rows but 714 columns. So what happened here, it has calculated for every matrix like the adjacent, close, open, high, low, close, and volume. But we want only for the open. So in the value, the cell values, these values, you can provide here that you want value as the open, right? And now when you hit shift enter, you will see that we have exactly the same result with the group by. So when you have like a big group by statement, so instead of using group by, you can use pivot table. So it's like a straightforward and very quicker way to transform your data from 1D to 2D or your desired values. Right now, let me show you something. I'll just copy and paste it here. And if I apply aggregate function here and I apply mean, you will see that it has exactly the same value, right? So by default, it applies the mean function. Now what you can do, let's say here, we only use the open, right? Or the open price. If you want to apply pivot table in all the columns, so for that, what you can do, you can just copy from here and paste it here. Just remove this values. So it will apply on everything. So when you hit shift enter, you will see that now we have the adjacent close also, we have the volume also, and the remaining are hidden, so you can't see them. But here you can see the number of columns, that is 714, right? So you can also apply different aggregate function on each matrix, like on close you want to apply something else, on volume you want to apply something else. Let me show you how. So what you can do here, you can pass a dictionary here, and you can give like on open you want to apply mean. So I'll just make it a string mean, Then next is, let's say we have what we have here, data. Let me print it here. So here we have open, high, low, close, and volume. So what I'll do here, on open we applied mean, then on high we can apply, let's say, max. So max. Then on close you can apply minimum, and on volume you can apply this sum, right? So on volume you can apply the sum, right? So now when you hit shift enter, you will see that we have separate aggregate function on every matrix, like the open, high, low, close, and volume. So that's how you can use this, and you can also make it multidimensional. So let me show you how. I'll just copy and paste this here, and now let's say you want to make the multi-index. So what you can do here, you can just pass a list here, and along with the ticker you can also give another column. Let's say you want to make date as the index, and now when you hit shift enter, you will see that we have a multi-index data frame, right? First we have ticker, then we have the date. If you want, you can make date as the level 0 index. So you can just reverse the positions, the index positions, and now when you hit shift enter, you will see that first we have date, then we have ticker, right? Let's make it again so it looks nice. Now the NaN values means at that place we don't have any value, so that's why we are getting the NaN. Next we have is the margins, right? So in margin what happens, let me show you first. So what I'll do, I'll just copy and paste the above here and paste it here, and I'll remove everything from here, and I'll just keep one aggregate function, that is sum, and I'll also remove this column, and I'll keep here, let's say, volume in column, and I'll remove from here the date also. Okay, now when I shift enter, I'll get this value, right? So if we apply the margins here and we make it true, you will see that we get the sum of all the columns, right? You can see here, and also here sum of every value in the row, right? If you remove the column, you will get only the sum of columns. You can see here we have all as the row, and if you make here the column, then you will also get the margins in the rows. You can see here. So that's how you can use the margins. It is sometimes it is useful, right? Now let's move further and let's plot some graphs, right? It is now interesting, right? Because when we have graphs, it becomes really interesting. So what we will do, let's again print the main data frame, that is data, and let's say we want to apply pivot table on this, and we want to make index as the tickers, right? So let's apply the plot here. So when you apply plot, we get some plot, but which is not good. So we can make it as a bar chart. Let's see, kind is equals to bar, and you will see that we have the Apple, Amazon, Meta, Microsoft, and in the prices we have this, but you can make it a little bit more like visible. So for that, what you can do, you can make, let's first print this. So I'll just keep it here. This is just for illustration. Okay, you have to like practice yourself a lot on this. So let's try that. I want column as the date, right? Or let's make date as the index and columns as the ticker, and when we hit shift enter, we get something like this. So we can also make values as the open prices, right? Or if you want, we can make it close also, and you will get this, right? So for this also, let's try to print a plot, and when we hit shift enter, you get a little bit better graph, because generally this is what happens. On the x-axis we have the date, and on the y we have the prices. So you can see here a nice and beautiful plot. And if you want to make it something, let's say a kind, you can make it bar also if it makes sense, right? You can see here, but it doesn't make sense, so it's not a good idea to make it as a bar plot. You can also make it a pie chart, right? But it is saying some error, so let's not do that and make it a simple chart. So now I think you are able to see that this is really very powerful, and you can do many amazing things with the help of pandas.
and the so many amazing functions, right?
Okay, let's start with the vectorized operations on the strings. So before that, let me tell you what is a vectorized function. So let me tell you this with the help of an example. First of all, I'll import pandas and numpy and I'll hit shift enter. Right now, let me add another cell here, and let's say we have a list. So let's say it is a price data. So 100, 200, 300, or 400 and 500. Correct. So now we want to add 10 in all the items of the list. So with the help of Python, what we can do, we can simply run a for loop and we can add 10. So let me tell you how. So for I in price, then we can print I plus 10, right? And we can append in the list. Let's say we create an empty list here. We can say modified price, and this is a list. And now we can print the m price, right? So m price, and this is the modified list. So here it is okay. We are able to perform the desired operation, but the problem is that we know that Python lists are a little bit slower. So when we perform the same operation on a large data set, let's say we have 1 million items, so it will become slower. The first problem. The second problem is that it won't be able to handle the none values, because in the real life scenarios, we import the data or we fetch from somewhere. So we do not know that whether this data is perfect or not. So in that case, if we apply this one, it might break our code. Let's say we had another item here and that was none. So now if I run this code, it says unsupported operand type for a none type, right? So it will definitely break. So that is the problem, right? Again, let me show you one more thing. I'll take the same price. I'll write here, let's say tickers, and here I'll quickly give some tickers. So let's say Apple, we have Microsoft, we have Meta, and let's add a none value here and also add another stock, let's say HPCL. Okay, now what we want to do, we want to, let's say, make these letters lowercase. So for that, what we can do, I can simply go here and I can write I dot lower, right? And I have the modified value. Let me first remove this, and it says, okay, this is ticker. Now you will see that we have all the tickers in the lowercase. Let's say we have a none value here, and definitely while dealing with the real life data, we'll be having some NN values and none values, right? So in that case, we should be able to handle that. Let's say we had here 1,000 tickers, and when we apply these kind of operations, what will happen? It will break the code. So that's the biggest problem. So that's why to resolve this issue, the Pandas came with an idea. Let me first tell you what are the vectorized operations. Let's say we have an array, np.array. Inside that, we have, let's say, 100, 200, 300, and 400, and 500, right? The same list we had here, right? This one, this price. So even we can take this from here and we can use it here. So what I will do, I'll give the price inside the array, correct? So now when you hit shift enter, you will see that we have an NumPy array, and you can make it, let's say, np price. Okay. And now if you want to add something here, what you can do, you can simply write np price plus 10, and you will see that we have added 10 in every item. Means with the help of Python code, the for loops, we were running the loops, and you know the loops are slow. So that is the vectorized operation. Means we are performing any action on all the items in one go, and that makes it very faster. We are not using any loop here because NumPy array is based on the C. So it is way faster, right, than the normal Python loops and lists. Now, again, the problem which we have seen in the Python, right, which is here, let me copy and paste here, that it won't be able to handle the none values, and also it is very slow, right? So now how Pandas solve this issue? Let's understand this. So what I'll do, I'll just copy the ticker list here. Now what we will do, we will create a Pandas series. So pandas dot series, and I'll pass a ticker here. And now when I hit shift enter, we have the Pandas series, right? Now I will just assign it to, let's say, ser, And now we perform the same operation which we were doing here. We were trying to do here. That is, we wanted to make all the letters in small case with the help of a loop in Python. So it was throwing the error. None type object has no attribute lower. So if I want to perform the same operation in Pandas, what I will do, I'll use str. This is known as the string accessor. So whenever you want to perform any string operation in Pandas series or data frame, you have to use the .str string accessor. Then you can apply, let's say, lower, and when you hit shift enter, you will see that all the items are now in the lowercase and the none value is still there and it didn't throw any error. Means it is able to handle that problem very efficiently. Correct? So I hope you are able to understand the basic things here. And I'm also trying my best to make you understand. That's why I'm spending a lot of time in basics, so that when you are dealing with the large amount of data set, you will have no problem, right? Now we know that it is fast and optimized and can handle any kind of data, right? So that's why we will be using the Pandas here. And we know that Pandas is built on the top of NumPy. So that's why it is also fast and efficient and it can solve a lot of problems, right? Okay, now let's import some real world data sets. So what I did, I downloaded the S&P 500 companies data from the Kaggle. So I'll also upload this data set to the GitHub so you can use that. So let me import it. So pd.series pd.read.csv, and you have to provide the name of the file, that is constituents financial CSV. And when you hit shift enter, you will see that we have the data of 505 rows and 14 columns, right? So inside that we have the symbol of the company, the name of the company, the sector, price earnings, dividend yields, and earning share, 52-week low, 52-week high, market cap, EBI, TDA, price sales, price books, and SEC filings, right? So basically here we are dealing with these strings today. So what we'll do today, we'll only use the string columns, right? The object columns. So for that, what I'll do, I'll just save this in a data frame, df, and then let's check the data types. So you can see here, it says invalid syntax, df.info. So now you can see that symbol is object, name object, sector object, and then the last SEC filings is also object. So we'll just fetch these items. So now what can I do? I can just go here and I can pass the values. That is, first is symbol, then we want the name, and then also we want the sector, and the last one is the SEC filings. So I'll just copy from here only. We have to pass inside the list. So now we have the symbol, name, sector, and SEC filings, right? What I'll do here, I'll reassign to something else, df, let's say s, that is strings, right? Now we can access the dfs, that is only the objects. Now we can start with this. So let's understand some common functions in the vectorized string operations, that is lower, upper, capitalize, and title. So what I'll do, I'll write dfs will access the str and we can apply the lower. So you will see that it says data frame has no attribute str because these attributes are for the series. So you have to fetch any single column from here. So let's say we fetch the name of the companies. So I'll access the single column. And now when we apply the lower, now you can see that we have 504 items. And if we perform the same operation with the help of Python list, it will become definitely slower and it will be not able to handle the none value, right? We can also use the upper. So let me show you upper, and you'll see that by default, they were already in uppercase. So doesn't make any difference. You can also use the capitalize. So in capitalize, what happens? It will capitalize the first letter, right? Then you can also use the title. So in title, it will capitalize the first letter of every word. You can see here. Now let's say if you want to find the length of the words. So what you can do, you can apply the length here and you will see the length of all the characters, all the items you can say. And let me show you that how you can use this. So let's say you apply a condition here so that you want to print only the companies which have the name greater than the 12 characters. So I'll apply 12 and now we'll get a Boolean series and you can simply use it as a mask, right? So I'll make it a mask. So these are the companies which have name greater than the 12 characters. You can even make it, let's say 18 and you will see that now we have only 173 companies. Let's say we make it 22. Now we have only 89 companies. And let's make it 40. Do we have any company with that? No, we do not have. With 30, we have few companies. The Alexandria Real Estate, American International, American Waterworks. These all are. So you get the idea that how you can use this. Next, we have is this strip. So in strip, what happens? It will remove the trailing and leading spaces. So let me show you how. You can simply apply strip here, and you will see that if there was any space, the leading or trailing, it will be removed. So what happens sometimes we cannot see directly that whether there is a space or not, and when you perform any operation, it will throw an error, right? Because let's say you have a name and it starts with, let's say, company name. So there is a possibility that you have a space before C, and when you try to access the company column, it will not be accessed. So in that case, it is very helpful, and you should always apply this strip while data cleaning. Definitely you'll be doing that for sure in future, right? Now what we can do, we have another function that is split. So let me show you. It is also very useful. So let's apply split. So split, what we'll do, split will split all the items in a list, and so by default it will split based on the spaces. So if you want to split, let's say, based on the comma, so you can give comma here, and you will see that if there is any comma, then it will split. Otherwise it will give you a whole single item, right? You can like do based on your requirement here, right? And so I'll just make it split. You can use it somewhere like you want to check that in each company how many words are there. So let's say we can apply another function that is len. So it will calculate the length of words in a company's name. So if you directly apply length here, it will throw an error, right? So if you want to apply any function of the string, you always have to use the string accessor here, right? And now let's say you give a condition that I want to just see the name of companies which have more than 4 words. And you can again use it as a mask because we get a Boolean series. And when you apply it, and now you can see that we have only these companies which have more than 4 characters in their company name, right? Hopefully you are able to understand what I'm trying to say. Okay, now we have replace. So let's again take the same company name, and let's say we want to replace this space between the company name with a hyphen, right? So what you can do, first you have to use the str accessor, the string accessor, and then you have to apply the replace function. And here you can give that what you want to replace. So you want to replace this space with what, and now you can pass a hyphen here, and you will see that all these spaces have been replaced with a hyphen, right? You can replace with anything you want. You can replace with a backslash. You can replace with a forward slash. Forward cannot be because this is an escape character. So you have to use something else, which I'll show you in the regular expression, right? Yeah, it's quite useful actually if you want to use. And you can also remove the spaces. So sometimes what happens, you want to just remove the space from any name, right? You just want to have a continuous string. So in that case, you just have to first type the space here and then type a inverted comma without any space or anything. Just type the simply like this. You will get the string without any space, right? So it is also very useful, and you will be always using this with the strip functions we have used earlier and split. Okay, now we have filtering. So let's start with the starts with. So I'll again access the same name of the companies, and we'll use the str accessor, and we can use the function starts with. And let's say you want to filter out all the companies which are starting with the character capital A. So when you type that, and you will see that you will get a Boolean series, and you know that you can simply use it as a mask, and you will be having all the companies starting with the A. There are 63 companies which are starting with the A, right? Similarly, you can use this with, let's say, Z. So for Z, you have just 3 companies, Zimmer, Zions, and Zoetis, correct? You can also use this with the ends with. So let's say you want to check that how many companies are ending with the Z. So I'll change here to ends with. So these are the companies which are ending with A. Right? You can see here. Let's check for B. There are two companies, and you can check. Let's say D. There is no company with ending with D. Let's check for F. No. Let's check for S. We have only one company, ANSYS. Right? Okay. Now let's make a filter that we want to filter only those companies which are starting with A and ending with also A. Right? I'll just copy here the first that starts with, or let's take this only starting with A. Right? And when I hit Shift Enter, we get these companies. So now what we can do, we can enclose this. We can enclose this in a parenthesis, and we can copy and apply an AND operation here. And here we can change it from starts with to ends with. So our main goal is to find the companies which are starting with A and ending with also A. So now when I Shift Enter, we get a Boolean series, and now we want to make this as a mask. So I'll just enclose this in a square bracket, and the two companies which are starting with also A and ending with also A. I hope it's very clear to you, crystal clear, I would say. Okay, now let's check the functions isDigit and isAlpha. So I'll copy and paste the again, and let's apply that str dot isDigit, and when we do that, we get a Boolean series, and let's check and make it a mask, and you will see that there is no digit because all are the strings only here. You can also check for the alphabets that whether this is an alphabet or not. So I will just remove and make it alpha. And when you hit Shift Enter, you will see that we have only the companies which are the pure alphabets. There is no digit inside that, right? So I hope it's clear. And now let's move to the next, which is applying regular expressions. So actually for the regular expression, I wanted to have a separate class. So we'll do that actually in future whenever we think that it is required, right? So for now, we'll just have some basic operations, and I'll show you, and I'm sure that you will be able to understand that also. Very easy. Okay, now let's understand the contents. So what I'll do here, I'll simply go here and copy this series with the company name and hit Shift Enter. Okay, now let's search for the John. So str and apply the contains function, and here we can pass a string with John, and you will see that. Let's apply the mask here, and you will see that there is no company which is having the John. Let's make it capital J. Yeah, we have two companies which is having the John in their name, right? So now if you make it small j, you will see that it shows no results, right? But if you want to like ignore the case, so for that what you can do, you can simply go here and write case is equals to false, and then it will ignore the case and you will get the results. So if you have a little bit knowledge of Unix or Linux, you can relate this with that whenever we grab any string, we can use -i and that will ignore the case. So same function here only, that it will ignore the case and you will get all the results which is having the John, correct? Even if you make it capital John, it will show you the results, right? Okay, now let's make it a little bit more complex. So what we'll do, we'll find that which company has the last name starting with also A and ending with also A, right? So what we can do, let's first print the name of the company. Okay, now we want to access the last name only. So for that, what we can do, we can simply access it with the string accessor. Then we can apply the split function. So we'll get a list, right? So now we want this one, the last. So to access the last element of any list, what we do, we simply use the indexing, and we'll use the reverse indexing, that is -1, and you will get the last name of every company. So now it's very simple. We will just store this in another column of the data frame, and let's give it the name as last name, correct? And hit Shift Enter, and now you can just comment it out for now. And now let's try to check the data frame which we created earlier. So you will see that we have another column with the last name only. So I'll just access this again, or let's copy it from here. Now first task is done. Now our goal was that we wanted to find the last name of the company starting with A and ending with also A. So let's first check for the str and starts with capital A, and you will get a Boolean series. So you can simply make it as a mask, and let's do that. And you will see that we have these many companies starting with the capital A. So now what you can do, we also have to check that it is ending with also A. So for that, what you will do, you will simply copy this and let's give it a parenthesis. And here we'll apply another condition, and that is ends with also A, right? So ends with also A. And now when you hit shift enter, you will see that we have only these companies, 5 companies, which have only capital A. So that's why we are getting this result. So I think you are able to understand that you can perform so many complex operations with this str accessor, the vectorized operations. Okay, now let's change it to small a. Then you will get these companies which are starting with capital A, only this, sorry, the America, starting with capital A and ending with also small a. Actually, this is just the last name. So for the full name, you can access the original data frame, right? Okay, now let me tell you the regular expression. We will have another class for that also definitely someday. But for now, let me tell you the power of the regular expression. It is a little bit complex. It's not that much, but a little bit have the learning curve in this. So let me show you how we can use the regular expression. So let's say we have this, we want to find out the last name of the company starting with the vowel and ending with also a vowel. So for that, str, you will write the contains, and here what you will do, you will give a inverted comma, and then you will give this sign, upper arrow. It means starts with, right? Then you will write the letters, the vowels, that is A-I, A-E-I-O-U. And so when we hit shift enter, you will see that we have no company starting with the vowels, the small ones. So if I apply here the capital ones, you will see that we have few companies, that is 174 companies, starting with the capital I, means starting with the vowel. Then what we'll do, I'll apply a dot here, which represents that it is for the first group, right? Now I will just copy it, the whole string, and I will add a plus, means now we are talking about the next group. So, and I can also give here a dollar. Dollar means the last. This upper arrow means starts with, and dollar means ends with. So we are checking now that, so what are the company's last names starting with the vowels and ending with also vowel. It can be a lowercase or it can be a uppercase. So now when I shift enter, you will see that we have these many companies, only 3, 4, 5, 6, 7 companies, which have the last name as the ending and starting with the vowel. So that is the regular expression, and we'll be using this a lot. So you'll be learning along with that. Okay. Now the last is slicing. So slicing is very easy. Let me show you how. So what I'll do here, I'll take this column and paste it here. And so we have already understood the slicing a lot of times. So what I'll do here, that I'll show you again that, let's say str, and we apply a slicing. So first I'll give just a colon, means it will print all the companies. Now let's say I want to print only the initial 5 characters. So I will give 0 here, and here 5, means it will print from 0, 1, 2, 3 and 4, right? So you will get only the initial 5 characters of any company. Now let's say you want to reverse the name. I know this doesn't make any sense, but let's do that. So you will get all the name of companies in the reverse order, right? So that's how you can use the slicing. So the first plot is the line plot. So first we will cover all the theoretical part, and then we'll proceed with the coding part as usual, right? So definition. A line plot is a type of chart which displays information as a series of data points connected by straight line segments. It is particularly useful for visualizing data changes over time. So we can say the line plot can display the information as a series of data points connected by a straight line segments. Where and why to use the line plots? So we can use the line plots for the trend analysis. We can use the line plots for performance tracking. And let me tell you something first, that generally what happens when we are dealing with the plots, we get confused that which kind of plot I should be using for which kind of data. So in order to resolve that confusion, I have divided all the type of plots in different kind of categories. So you can easily identify that where should we use which kind of plot, right? So generally we have two types of data. The one is numerical and another is categorical, right? So the line plot can be used for numerical data, particularly time series data. So right after this Matplotlib library, we'll start with the time series, in which we will understand the time series analysis and the time series forecasting. Line plot can be used for the numerical data, and also we have three types of analysis. The first is univariate, the second is bivariate, and the third is multivariate. So univariate means when we are trying to observe or find the trend or the changes between a single variable, or we can say a single column in a data frame. Bivariate means when we are trying to observe the changes or the trend between two variables, or we can say two columns in a data frame. And multivariate means when we are trying to observe a trend or a change in multiple columns, or we can say multiple variables, right? So that is the basic information. So now what we will do, we'll divide all the 5 plots and we will understand that which kind of plot should be used in which kind of data and which kind of analysis, right? So this line plot can be used on numerical data, and also it can be used on univariate analysis and the multivariate analysis, right? Next, let's understand few examples. So line plot can be used to plot stock price movements over a month, which is here, right? You can see here that it is starting from the 1st of June to 1st of July, and these are all the points, and these all points are connected with the line. So that's why we call it as a line plot, correct? And here is the daily closing price for the month of June 23. And it can be also used to track the price or volume of stocks over time. This helps in trend analysis and moving average based strategy development. I hope it's clear. The line plot is very straightforward, very easy. Next we have is the scatter plot. So a scatter plot uses dots to represent values obtained for two different variables, one plotted along the x-axis and the other plotted along the y-axis, right? So we can say the line plot uses the lines and the scatter plot uses the dots, right? Where and why we should be using the scatter plot. We can use the scatter plot for the correlation analysis. It is useful for spotting correlation between two variables such as price and volume or returns on two assets. It can be used for outlier detection. It can help in identifying outliers or anomalies in financial data. Now, on which kind of data we can use the scatter plot? So straightforward, we can only use the scatter plot on numerical type of data. We cannot use this on categorical data, right? Now, the type of analysis. So we can use this for the bivariate analysis and for the multivariate analysis, right? Primarily used to find relationships or correlation between two numerical values. Each axis represents one variable, allowing for observation of pattern or clusters. Next, multivariate analysis. It can be extended to multivariate by using color, shape, and size of dots to represent additional variables. Here is example, visualizing the correlation between returns of two stocks. You can see here stock A and stock B, and these are all the dots, right? It is ideal for exploring the relationship between the stock price movements of two companies to identify potential pairs trading opportunities. We will be using this a lot in the machine learning part, but now you get the idea, right? The bar plot. A bar plot or a bar chart represents data with rectangular bars with lengths proportional to the values that they represent. Where and why to use. So in line plot, we connect the dots with the lines. In scatter plot, we have the dots, and in the bar plot, we have the rectangular bars, right? And the length is proportional to the values that they represent. We can use bar plot for the comparative analysis. We can use bar plot for the quantitative metrics, right? Now, on which type of data we can use the bar plots? So we can use on the categorical and numerical data. Categorical data labels each bar, and numerical data determines the bar's height or length. And also we can perform both the univariate and bivariate analysis on this. So let me show you. You can see here we are comparing the monthly trading volumes. This is the months from Jan to April, and this is the trading volume in thousands. And also we can use it to compare the performance of different assets or to show the frequency of trades by category. Example, long versus short positions. We will be also using this a lot in the upcoming videos. Pie chart. A pie chart is a circular statistical graphic which is divided into slices to illustrate numerical proportion. Right? You can see here, this is the pie chart. Where and why to use? We can use the pie chart for the portfolio composition. We can use the pie chart for the simplistic representation, and also we can use the pie chart on the categorical data, where each category represents a part of a whole. And also the type of analysis. We can use it for the univariate analysis, right? So let's look at some examples. So you can see here, it is the composition of a trading portfolio in which the stocks is 50%, the futures, the options, the bonds, right? So generally it is used on a single column of a pie chart. Now the last one for today's session is the histogram. I'm sure that you have seen histogram a lot of times if you trade, right? So let me show you what it is. So a histogram is a type of bar plot that represents the distribution of numerical data by dividing the data into bins or intervals. It helps to give an idea of where values are concentrated, variation, and outliers. So what it does, it helps to represents the distribution of data by dividing the data into bins or intervals, right? So where and why to use the histogram? So we can use histogram for the distribution analysis, right? And we can also use it for the outlier detection, right? Which we will learn in the future. We can also use histogram for the volatility measurement, and the type of data on which we can use the histogram is the only numerical data. The pie chart is only for the categorical data, while the histogram is only for the numerical data, right? And the type of analysis we can perform is the only univariate analysis. Now let's see some examples. So it is quite useful to analyze the distribution of daily returns of a stock to understand its volatility and risk profile. You can see here, this is the daily returns and this is the frequency. It has divided the data into bins. You can see here the bins, and then we can easily have an idea of the frequency of the data. So this was the theoretical part, and now let's understand some coding examples, right? Okay, so first of all, we have to import the library. So for that, what you will do, you will first import the pandas as usual. Import along with panda, always import the numpy as np. And for the matplotlib, you have the library import matplotlib, right? So here we are importing on the pyplot for now as plt, right? So when you shift enter, it says no module name because it is pandas. So yeah, we have seen that the line plot is for the bivariate analysis, right? It can be used on categorical and numerical. So basically it is used for the time series data. So let me show you something simple. So what we will do, let's say we have a list of prices. So prices from, let's say, 2000, 3000, 4000, 5000. Okay, again we have years. So for that, let's say from 2020 to 2021, 2022, 2023, 24, from 2020 to 2024, right? Now let me plot this simple chart. So plt dot plot, and first you have to pass the time on the x-axis, right? So it is year, and on the y you have the prices, right? So when you hit shift enter, you will get a simple straight line, right? Because we have given the straight line. So let's say if you change it something, let's say from 5 to again it came to 1000, and back to 3000, back to 2500, back to 6000, and again drop to 4000, correct? And you can give here again the time. So 2024 up to 5, 6, 7, 8. Let me change the values. 5, 6, 7, and 8. Yeah. Okay, actually, we need to add another year here. And when you hit Shift Enter, you will see that we have a nice plot, right? A beautiful plot, which is telling us that what was the price and in which year. So on X, we have the time, and on the Y, we have the prices, right? And here on the screen, you can see some text or numbers. So for that, what you can do, you can simply write plot plt dot show, and it will be gone. You can see that it is gone. Actually, when you are writing this code on like PyCharm or any other code editor, you have to use the plt.show. Otherwise, it will not plot, right? So in the Jupyter environment, it is okay to run the code without the plt.show. But if you are running this code on any other IDE, you have to use the plt.show, right? Okay, now let's understand the line plot on a real world dataset. So what we'll do, we'll import some CSV here from our previous sessions. So I'll just go and let's check where we have a CSV. So I guess on like day 32 we had. So let me copy and paste this here and check whether it works or not. The name of CSV is Constituents Financial CSV. So I'll just go here and import the CSV file. So pd.read CSV, and the name of file, that is Constituents Financials. When I shift enter, I'll get the values. So what we will do, actually there is no time in this. It will be not a good example for the line plot. So for that, what I will do, I'll let me check some other. Okay, we have exchange trade data. So it is the perfect example. So let me copy and paste it here. Exchange trade data. Okay, now let's perform this. So I'll just remove this for now. If required, we'll use this again. So okay, now let's pd.read CSV and exchange trade data CSV. Now we have timestamp and prices. So for that, what I'll do, let's quickly perform some operations on this. So what I'll do, and from the column I want is from 0, 1, 2 to rest. It says, okay, we have to provide the iLock here. Now it's okay. Actually, we have missed the date also we wanted, right? The timestamp. So 0, 1. So we have to use the 1 from 1 to. Okay, now it's fine, I guess. So I'll reassign this to the data frame, and now let's check it. We can do one more thing. We can set the timestamp as the index. So set index and timestamp, and let me make in place is equals to true, right? So yeah, it's done, I guess. Now let me add another cell and let's check the df. Okay, now it's good, I guess. So let's take only 60 rows, right? So 2-1 data. So what I'll do now, I'll take from 0 to 60. I'll use iLock here again. Yeah, for now I'll just use this only. So df. Now we can plot this. So what we can do, I can simply use the price here, right? And how you can plot this, you can simply write plt plot and this series here, and when you hit shift enter, now what happened here, it is plotting for all the tickers, but we need only for a few tickers. And actually I have also seen that this is the synthetic data and it will not give us the good results. For that, I copied a code from the previous session and we will import data from the Yahoo Finance. So let me quickly do that. So instead of this, I'll just remove this code for now, and we will import the data from the Yahoo Finance. You can check from my previous sessions, we have used this code. So here, I'll just remove everything. So you will get this data, right? Or you can, for now, you can just take the data for only Apple, right? And it's enough for now. Okay, so we are good to go. So now what we'll do, we'll plot for only, let's say, open. So open, let's run this. So yeah, actually for a simple thing, we had to do a lot of hidden trials.
but I wanted to show you the real data, right? So that's why it took a lot of time. So now when we hit Shift Enter, you will see that we have a real data from the Yahoo Finance. So this is how you can plot. And if you want to remove this stuff, you can simply dot show, and it will be gone. Right? Let me remove this. It will be gone. Correct. Now let me tell you few important things, I would say. So now let's say if you also want to plot the close prices on the same plot. So for that, what you can do, you can simply go here and copy and paste this again, and you just need to give here the close prices, and you will see that you have another plot of the close price, right? Sometime what happens, you want to check the high and low, right, along with the open or close prices. So for that, what I'll do, I'll remove the close and I'll change it to high and hit Shift Enter, and you will see that we have the high prices, and also we can plot the close prices. Means in a single plot you can have multiple values, but how do we differentiate? Right now we do not have any information, right, that what is happening here. So for that we have to give few more details, right? Okay, so for that what you can do, you can add another line and you can say title, right? So this is the price of apple. You can say open, high and low price comparison. It can be anything, just for the sake of example, right? So when you hit Shift Enter, you will see that you have a title here, and now it is more expressive, correct? You can also mention that what is at the axis and what is at the y-axis. So for that, you have to write plot dot x label, and here you can give, let's say, time, right? And when you hit Shift Enter, you will see a time here. And similarly, you can also give here on the y-axis, it is the prices. So just copy and paste here and change from time to price. And here it is the y label. So now time, price and the title, correct? So I'll just copy and paste it here. This was for the label title. Now you can also change the color. If you not like the color, now let's say you want to change color of any line here. So let me first remove any one line here because it is becoming so confusing. So I'll just remove the close and we'll keep only two lines here. Now it's fine. Let's say you want to change the color of the open line. So for that, what you will do, you will write color is equals to green, and when you Shift Enter, you will see that the line for the open prices is now green. Similarly, for the high also you can change, and let me copy and paste it here again, and let's make it red, right? So red. So now the line for the high price is become the red line. Again, if you want any other color, you can give here the hex code, and you can find the hex code from the web, right? And let me show you how. You can just search on Google hex code finder, and let me show you on the screen. You can take anything here, let's say this W3 schools, and here you want any color. So let's say you want this blue color. So for blue color, you have this hex code. Just copy and paste in your code here. So let's say for open, we have this hex code. So when we Shift Enter, it says it is not valid because you have to add a hash here, and now it's fine, right? So that's how you can use the color. And okay, now let's say you want to change the line style. So for that, what you can do, you can simply go here and write line style, and you can give here, let's say, dashed. So you will see that actually we have mistyped here, line style, not style. So now you can see that we have the open prices as the dash line, right? Similarly, you can also have dotted style also. Like you have multiple things here. So for that, so now you can see that we have the dotted line for the high prices. So you can go through the documentation and you can find more options. There are multiple options. I'm just showing you very few, right? Now let's say you want to change the line width. So for now, I'll just make it default. So I'll just remove, or let's paste it here in this code here, and I'll remove this line style from here. Okay, now let's say you want to change the line width also, right? So for that also you have the option here. So line width,
and you can give any value, let's say 3, you will see that the line of the open prices is the width is increased, right? And similarly, you can give here also, if you want, you can give here the width, let's say 1, and it will be also changed to 1, right? So actually, until this timestamp, my mic goes away, so it might possible that there might little bit less sound. We'll try to enhance this, but still there might be a voice problem before this. Now it will be fine, don't worry. Okay, now if you want to change the legends or the marker here, we can do that also. So for that, I'll again copy it and paste it here, and for now I'll remove this from here, this also, and let's say you want the marker as D, right, for the open prices, and you will see that it has changed to D, right? You can change it to like something different also. Let's say a big O. Big O is not here. You have to type a small o, I guess. Yeah, small o is there, and like D is for the diamond. Okay, and here you can type the marker, let's say, so for the high you can have a marker as, let's say, a diamond, right? And you will see that it has changed. And also you can change the marker size, so you can go here and you can write marker size, and you can reduce it to, let's say, 3, and here also you can reduce it, let's say, to 1, so it will change to smaller size, right? So you have many options here, use as per your requirements. You can also display the legends. So let me show you. You have the option plot.legend, and when you hit shift enter, you will see that it is here in the right. So here, like, we do not have the multiple values. So if I want it here, data.index, and here also data.index. Now you have also the option to display the legends here. So for that, what you can do, you can simply go here and you can write label, and it is for the open prices, right? So you will write open, and this is for the high prices. So you will write label as the high prices, correct? And now you can simply hit shift enter, and you will not see anything for now. But if you write here plot.legend, you will see that you have a legend here. So it will show you that for the open, it is the blue line, and for the high, it is the red line with the marker. For the high, we have diamond, and for the open, we have the small dot, right? You can also change the location of this legend. You can move it anywhere on the upper right, on the lower right, or on the bottom left. So it's up to you. You have the options. You can give here the parameters you want. Let's say if you want it somewhere else. So what you will do, you will write LOC, location is, let's say, upper right, and when you shift enter, you will see that it has changed to upper right, right? You can even have like lower right, and it will come to lower right. So it's up to you. It's your requirement. Okay, next we have is the limiting axis. So let's say if you have a very large value, an outlier in any axis, so it will like flatten out all the other values, all the smaller values. So let me show you how. Let's say you have the price, and it's going like simple 10, 20, 30, 40, 50, right? And here you can give, let's say, time. So time is, let's say, in the first month, second month, third month, fourth month, and fifth month. So it's simple. You can like quickly plot this plt.plot, and you can give first time and then the prices. So you will get a simple straight line. So actually you can reverse this also. Let's say 50, 10, 20, and 10 again, or let's say 40 again. And here also you can give few more values, 6, 7, 8, 6, 7, 8, and 9, right? So now you have double bottom, right? So what I'll do, in the 10th month, what happened? The price spiked, right? Someone pumped the prices. So what happened here? The price went up from 50 to 5,000 in the 10th month, right? So now you can see that the remaining prices are all flattened out. So we cannot see anything here. So in that case, what you can do, you have the option to limit this. So what you will do, you'll go here and write plt dot first x limit. So if in x limit you have anything, then you can limit. But for now, we only have the while limit. So in while limit, you can limit it to, let's say, from 50 to 150, right? So from 50 to 150. So now what will happen? No, actually not from 50. You have to limit it from 10 to 150. So now what will happen? It will trim above 150. So at least your graph will not be flattened out and you will have the good values, right? Similarly, you can do it for the time also, or it can be any other value also, right? So let's say it shoot from 10 to 1000. So what happened? It is gone completely, right? Okay, actually we have to add another value here. Let's say 500. So now what is happening? So in the time also, it went from 0 to 1000. So you can also limit this. So you can limit this with the help of X limit, and you can give, let's say, 1 to 15. So now your x-axis will go up to only 15. So this is how you can limit the x and y-axis, right? You have option of the grid also. Let me show you how. So let's copy and paste the above example again here, and I'll remove this. And let's say you want to have a grid. So for that, you can simply write grid and you will get the grid. You can see here, right? So it might require some time, right? And also the last one is show. So show, I have shown you already that it is mainly for when you are programming in any IDE like Python charm or any other script you are writing. So for that, you have to write this show, otherwise it will not work. The chart will not be displayed on the screen, right? So let me show you this again also. Let's hit shift enter. Now it's all good. But if you remove this show, you will see that nothing is there, because let's remove all these things from here, and you will see that you have some strings here, right? So in order to remove this, you just have to type plot.show and it will be removed. So this is how you can use the show. So let's now understand about the scatter plots. So we have seen that we can plot the scatter plots for the bivariate analysis, right? And scatter plots is for the numerical versus numerical. It can be used to find the correlation between the two values. Let me show you how. So for the scatter plots, what we will do, we'll use the existing data set. Let me show you, which we have seen previously. That is the constituents financials, right? So let's use that. First, import the CSV file, and you will see that we have the S&P 500 data in this. So I'll store this in the df1, and let's try to find out the relation between the price and earning. So what I'll do here, I'll go ahead and write plt.scatter, and here we can provide the series. First, the series for the price, and second is the series for the earnings and share, or we can say the columns. So I'll go here and I'll write price and df earnings. Let me copy and paste, because sometimes what happens if we have space, then it might also create issue. I'll show you how to clean the data in the future videos. Okay, so now when we run this, we get df is not defined. So what we can do, we can just write 1, because we assign df1, and now you get a scatter plot. And here you can see that on the x-axis we have the price, and on the y we have the earnings, right? So this way you can find the correlation. You can see here, right, clearly. Let me improve this plot. So for that, what we can do, we can simply write plt.figure, and here you can provide the figure size, that is fig size, and you can give, let's say, 10 by 6, and you will see that it has improved, right? Then you can also give, let's say, what is the name of this plot, right? Because it has to be understandable, right? So plot.title, and you can provide, let's say, relation between price and earnings, right? And when you run this, you will see the title here. Again, you can also write the plt.x label, which is price, and for the y label, you can write the earnings, right? So, and you will see that you have price and earnings on the x and y axis, right? And similarly, here is a technical text. So for that, we have already seen in the previous session that we can just write plot.show and it will go away, correct? I guess it is done. And one more thing I would like to tell you, that these dots are nothing. In the 2D line, we have seen that when we connect these dots, it becomes a line plot, right? So it's the same almost, but here you can find the relation between the two values easily, right? Okay, now let's quickly move to the bar chart. Okay, so bar chart is also for the bivariate analysis, and it is plotted between the numerical versus categorical, right? And the use case of bar chart is the aggregate analysis on the groups, right? Okay, now let's say we take the same example. So I'll print the df here, right? And what we will do, we'll try to draw the bar chart for the name of the companies and their market cap, right? So here we are drawing the bar chart between a categorical value and a numerical value. So let's do that. So what I'll do, I'll quickly go ahead and we'll write plot.bar, and here we can pass both the columns. So the first is df, that is the name of the companies, on the x-axis, and then df market cap, right? That is on the y-axis. So when you hit shift enter, you will see that it says df is not defined. Yes, because it is df1. And now you will see that we have a bar chart, and that is absolutely ridiculous. So let's improve this. So how we can do that? We have multiple options. The first option is here we can just take the 50 values, right? I'll just copy and paste this here. And now you will see that, so instead of 50, we'll take only 25 values. And now you will see that it is a little bit better. And now let's make it more appealing, right? So for that, what we can do, first of all, we'll write plot.figure, and here we'll again give the fig size, right? And you will see that it has a little bit improved. Now you can also give plot dot. So I'll just go here and copy these values, right? These are same. So in title we can say market cap of various companies, or we can say market cap of S&P 500. When you run this, you will see that here we have the name of the company and here is the market cap. But here we cannot see the name of company. We have to make it better, right? So for that, what you can do, you can simply write plot.x ticks. These are all ticks on the x-axis, right? So x ticks, and now you can write rotation is equals to 45, right? And now when you run this, you will see that it has been rotated 45 degrees. Let's rotate this a little bit more. So I'll just make it, let's say 70. Yeah, now it's much better. And let me make it 90. Yeah, in 90 it is fine. It is visible clearly. So this is how you can plot the bar chart, and it is also very useful. So now there is one problem, that here you have multiple companies. Let's say if it was increased from 25 to 50, then what you will do? Let me make it 50. So I'll just change from 25 to 50, and you will see that now like it is not that much appealing. So for that, what you can do, generally when you have more values in the x-axis, what you do, you just rotate the graph. Means these values will go to the y-axis, or you can say that you will create a horizontal chart, right? And for that, it is absolutely simple. You can just go here, and instead of bar, you just have to write bar h, right? And when you hit shift enter, and you will see that now the chart is horizontal. And for now, let me comment out this. Let's increase the figure. So let's say from 10 to we can make it 20, and here also from 6 to we can make it 12, 20 by 12. Yeah, now it is much better, right, than that. This is how you can make vertical and horizontal bar charts. It depends on you that when you have more quantities on the x-axis, you just make a horizontal bar chart. Okay, now you can also control the color and labels. Let me show you how. So let's say we have this chart here. I'll just copy and paste it here. And here what I'll do, in the bar h, I'll change the color. Now it is blue, let's say, to red. And when you run this, you will see that the values has been changed from blue to red. So it's very easy. Like it's same for almost all the charts, all the bar, all type of bars. And you just need to change like from bar to pie or plot or histogram. Basically, this value will be changed. Rest all remains almost same. Next we have is the histogram. So for histogram, if you do trading, then you know that. So generally when we apply MACD, moving average, convergence, divergence, that time we have a histogram. Like you can see a signal line, you can see a MACD line, and then on the bottom you have a histogram, right? Let me show you how. So in histogram, we have only univariate analysis. right? And it can be applied on only on the numerical columns. And the use case is the frequency count, right? Let me show you how. So this is the formula for the MACD. I have already written it here. I'll show you in the future how to calculate all these kind of technical indicators like MACD and all of the rest signals. Will understand them thoroughly in the future. So for now, I have already done that on the data frame. If you remember, we fetched this data from the Yahoo Finance. Let me show you. I'll just print the data here. In the above section, we have done that previously, yesterday. So here we have the open, high, low, close, adjacent, close, and volume, which we fetched. And these columns I created EMA 12 with this, EMA 26, MACD, signal line, and the MACD histogram. And so now we want to print the histogram. So that is easy, absolutely. So for that, what we can do, I can simply go here and write plots.hist, and here you can pass this histogram column. So histogram is nothing but the difference between the MACD and the signal line. If you're not understanding, don't worry, you will not get it right now. We are just understanding how to draw a histogram. In future, we will understand all the technicalities inside that. So hist, and you have to pass inside the data, right? And when you run this, you will see that we have a histogram. And here you can also control the bins. Let's say I write here bins means it will divide the data into bins. So when I write 20, so here we divided that data into 20 bins, right? You can make it more better as always. Like you can give the title name, you can give the X label, you can give the Y label. Okay, next we have is the pie chart. So pie chart is for both the univariate and bivariate analysis, and it is generally used for the categorical versus numerical data. And the use case is to find the contribution on a standard scale. Like you will be having a circle, and inside that you can represent the percentage of every categories. So let's again draw. Let's say we have DF1. So what we will do, we'll try to find out the sectors. So sector is a categorical column, right? So what we'll do, I'll just write sector here, and we have this series, correct? And here what we can do, we can find the value counts. So you will see that we have these values means, so here what you can say that we have 84 companies in the consumer discretionary sector, then we have 70 companies in the information technology, and then 68 in the financial, and so on and so forth. So now we want to create a pie chart which displays that what is the percentage of every sector, right? So what we will do, I'll just assign a new variable to this, let's say sector, right? And then I can write like plot, plt dot plot, and I can pass sector here, right? And when you shift enter, okay, not plot, actually it is pie, my bad. So you will see that you have a pie chart, right? But now there are so many unnecessary things. So for that, what you can do, you have multiple options. So let's understand them one by one. Okay, so first of all, we will remove these details. I have already shown you how we can do that. You can just write plot.show, it will be gone. Then you can also like display the labels here. So for that, what you will do, you will write labels and then sector dot index, and it says index object is not available. I have to remove this parenthesis from here, and now you will see that we have the labels for each category. You can also display the percentage of each category, because now we are not able to identify that which category is how much percentage. So for that, you can write auto percentage, and here you have to give a weird syntax, that is 1.1 f. You can give anything, any value here, it's up to you. And now when you hit shift enter, you will see that you have percentage for each category, right? You can see here 13.9 for the IT, 16.6 is for the consumer, 13.5 is for the financials. Okay, now you can also change the colors of this. So for that, what you need to do, let me copy and paste this here. So here you have to pass the color in a list, right? So here we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have to pass a list with the 11 colors. If you want to change, you can do that. So what you need to do, you can just write colors and you can pass a list with all the colors, right? It's very easy. I'm not wasting time on this for now. And sometimes you might have seen the pie charts in which a single slice is a little bit in outer side. So for that, you can use the explode, right? So how you can do that? So for that, what you can do, you can simply write, let's say, explode list. Here also you have to pass a list. So for that, I'll go here. So we have 11 categories here, right? So what I'll do, I can just write like, let's say 0.3 for the first category, and remaining you can give, let's say 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 and 11, right? And here I'll just copy and paste it here, and here in the explode I'll write, and I can pass that list, right? So explode list, and when you would shift enter, you will see that it has been exploded. It has been a little bit outer side. Similarly, you can give for the other values also. Let's say you want to explode 0.1 this second category, you can do that. And if you want to do, let's say 1 for the last one, so it will be completely like exploded, right? 1, it means the percentage. So the meaning of 0.3 and 1 is the range from 0 to 1, how much you want to explode from the center, you can say, right? So this is how you can create many beautiful pie charts and all the rest of the charts, right? And you can also change the styles here. Let me show you how. So like if you write here plt dot styles and available, you can see that these many styles you have, and you can apply those styles as per your need, right? Let's say you want to use the MPL gallery. So what you will do, you will just go and copy this one, and here you can write plot dot style and use, and here you can pass that, and when you would shift enter, you will see that now it has been changed. And when you run it again, you can say it is a kind of template which will change all the charts and plots, right? So it depends on you that what kind of style you want to use, and you can use that, right? Now we have also option to save the figure. Let's say if you want to send this figure to someone else, so for that what you can do, you can save it. Let me show you how. So what I will do, I'll just copy and paste this code here, and when I display this, it is the figure. And to save the figure, you don't have to use the show, you have to use the save fig, and you can give the name, right? So let's say the industries.png, and you can see in the left side that there will be an image created, a PNG image. You can see here, this is the industries.png file, and when you open this, you can see here, right? So that's how you can see, and you can send to anyone. This is cropped because of this style, so you can change as in the figure size, and you have so many options to change that also, right? So, and last but not the least, you have to check the documentation. Always, for no matter for which library, for which code, please try to explore the official documentation, because you will find so many things there. And here also, we cannot cover everything. We will be covering only a small portion in this limited time. So if you want to explore, you can go on the website and you can do that. And here also, we'll try to cover those things which are frequently used, which are most required, right? So we cover almost 80 to 90 important functions, important parameters, but rest also you might require, and you can refer to the official documentation, right? So this video will be divided into two parts. In the first part, I'll show you how to use the trading view, and then how you can import the data from the trading view to your Python. And in the next part, I'll show you how to specifically fetch the option chain data from the other sources, right? So let's start with the trading view first. So if you can see on the screen, I have this trading view website, and here if you click on search, you will see that you have many options. The first is all, then you have stocks, funds, futures, forex, crypto, indices, bonds, economy, and options. Okay, now let's say we want to fetch data of Bitcoin. So what I'll do, I'll just go and type here Bitcoin, and let's say I want the futures data. When I click on here you will see many exchanges, right? You can see here CME, Binance, BitMEX, Kraken, then we have Bybit, HTX, Deribit. So various exchanges, right? Now it's up to you that on which exchange you are trading. So let's say I want the data of Binance, right? When I click, it will launch the chart. So if you can see here, the chart will be launched, and this is the chart of Bitcoin. Currently it is 1 minute. So I'll make it to, let's say, 1 hour, and you can see okay, let me make it a little bit visible to you guys. Actually, I have made it gray and black because sometimes red and green affects our emotions, right? So that's why I always use this neutral color. So let's say we want this data, this exact data in the Python. So for that, we have an awesome library, and that is this TV data feed. If you can see here, trading view data feed. I'll post the link in description so you can refer that. Okay, now let me show you the documentation of this. So you can see here that to install this library, you have to perform this command pip install upgrade, then no cache, and then this link. So I'll just copy and I'll open my. Okay, let me run this. So it's already installed. If you are installing package on your code editor, let's say Visual Studio Code or Jupyter Notebook, you have to use this exclamation sign, and when you hit shift enter, it says requirement already satisfied, right? So now what I'll do, I'll just remove this for now, and I'll go back to the page, the documentation page of this package. So I'll open this, and here you can see that to use this, we have to import this from import TV data feed and interval. So I'll just copy and paste this in my Visual Studio Code, and here you have two options. If you have the trading view user account, it's well and good. If you do not have, no need to worry. You can just leave it blank, and I'll just remove this from here, and I'll run this, right? So it says you are using no login method and data you access may be limited. So it's okay for now. But if you want more data, if you want that your session should be extended, then you have to use this username and password of TradingView. So here what happened? We created this TV instance of the TradingView data feed of the TV data feed class. Now let's open the document again. And okay, now it says to download the data, use tv.getHist method. This is the method getHist. We have to use this, and it accepts following arguments. It accepts symbol, it accepts exchange, and both are strings, right? Then it accepts the interval. So in interval, we can say daily, by minutes, by hours, and then again number of bars. So number of bars are integer. You have to provide that how many bars you want. The bar means, let me show you the trading view. Bar means these bar, right? 1, 2, 3, 4, 5, 6 means how many these candles you want in your Python, right? So that is the number of bars. So now what we'll do, I'll just copy. Okay, let me quickly copy this whole code, and let's open the code and I'll paste it here. And let's say I'll comment it out the last 3 lines, and we'll just work on this one. So I'll change it to Nifty to Bitcoin. Let's say Bitcoin data, right? And I'll change the symbol from Nifty to BTC for now. And let's say exchange is Binance. Okay, so now when I run this, let's wait, it says no data, please check the exchange and symbol. Yeah, let's check exchange and symbol. I'll open the trading view first. Here I'll search BTC. Let me select the exchange. So crypto. Here we have Binance, right? And let's first understand the spot one. So here the symbol is BTC USDT, right? And exchange is Binance. So we'll just go and check here, and I'll change from BTC to BTC USDT. This pair should be correct, right? And when I run this, now it's running. So when I check the data frame, you will see that we have the OHLCV data, right? And here also, when you check, it is 13th of July, 9 AM. And currently in Singapore, it's 9 AM. So and the last bar is 57,827.99, and that is the close price. So let's go again and check launch chart. And if you check here, the candle of 9 is running currently, right? So we'll check the second last candle, right? That is this one. That is also 8 a.m. And at 8 a.m., you can see here the close price is 57,835.58, right? Here you will see the close price. So the close, let me zoom it a little bit. So here is the second last candle, and close price is here. So when I hover on this, you will see that it is 57,835.58. So when I open the Code Studio, here you will see that the close price of second last candle is 57,835.58. And in trading also, we'll always use the second last candle for the analysis. Okay, so let's say I want to plot the simple moving average of this close. So what I'll do, I'll simply go and Bitcoin data, and here I'll just print the close, which is this one, and here we can use the rolling period, right? So rolling, and I can give 20, right? And when you run this, you will get this, and then you can find the mean of this. So mean is okay. So now you can see that when we print the initial 20 candles, you will see that initial 90 candles are NaN values, because we are calculating for the last 20 candles, right? So if you check for the tail 20, these all are fine, right? So now you can simply go and plot this. Like for this, you can use various libraries. You can use Matplotlib, you can use SNS, you can use Plotly. And if you want me to cover more on the libraries of the plotting libraries, please let me know. We can cover that, right? So here we have the simple moving average of Bitcoin of the last 20 candles, right? It's very easy. Just you have to practice and it will be okay. There might be some error. I'll check later what is this. But for now, we are able to print the simple moving average of the Bitcoin for the 13th of July, right? Now, let me show you a few more things. So, okay, let me keep the code here only. So I'll push on the GitHub and you can clone this, right? Okay, let's open the document of library again. And here, let's see. So for the next, we have future continuous contract. So let's open some future data. So for that, I'll again go to trading view, and here, okay, so let's print this option here. So I'll click here, and this is the Bank Nifty index options for 16th of July, right? So let me show you for the Bank Nifty. So when you go here and you can search here as the Bank Nifty, and you will see many symbols. So when you click here, you will see that you have Bank Nifty 1, you have Bank Nifty 2, then Bank Nifty N2024, then Bank Nifty Q2024. So let's say you want to see the chart of this. So you'll click on this and it will be opened. And here, if you want this in Python, you have to use this symbol, right? So what you will do, you will copy it and you will go and you just copy and paste here, Bank Nifty 1, and you change from Binance to NSE. And when you run this, you will get the data. And when you check here, you can see that we have the data of Bank Nifty, right? The option data, correct? Now, like you have multiple options in this, you can explore more if you want, and you can plot the open, high, low, close, volume, all the data. And let me show you a few more things of this library. So you will see that if you want, like you can open this code here, the data feed. And if you want to explore more, please go and read all the code here, the main file, the data feed file, the consumer and SEIS file. Here you have like a search symbol, you have live feed also. You can even create the new SEIS, right? That is the symbol exchange interval set. And like you have multiple options here. You can make it automated, right? So this was for the trading view. And in the next video, I'll show you that how you can extract data from various other sources, right? Web scraping means getting some data, extracting some data from any source. Okay, let me build it brick by brick. So let's say we all have our Windows system, and in that we have my computer. Let's say in that we have two folders. One is data 1, another is data 2. If I want to simply copy and paste data from this folder to this folder, it is very easy. I can easily do that, right? Simply. But let's say my friend who come to my house, then if he have the access to my system, means if he knows the password, then he can also log in and copy and paste data from these folders. That's a simple analogy. But let's say if some of my friend who lives in another city, I'll write here another city, and if he wants to access the data, what he can do? I have some options. I can send him an email, or if the data is bigger, then we also have the option of FTP, File Transfer Protocol. But FTP is like simply File Transfer Protocol, right? And it is only for like limited amount of people. It cannot handle a lot of traffic. Okay, now let's say if we have multiple person who wants to access the same data. So for that, it is not feasible for me or for them to send or to receive the file one by one. So in that case, what I can do, I can simply take this data and host it on a public web server, right? Let's say web server. Web server is nothing but, let's say it's your system is hosted on a public server, so that anybody who has the right privilege can access the server simply. So now as the data is on public server, anybody who has the right address and the right privilege, they can access this one. So to access the public server, what we need the access and the address. So now what is web scraping? So web scraping is nothing but to extract the data from these public servers. It can be public, it can be private. If it's private, then we should be having the access, right access, the username, password, or the API keys. And if it is public, then we just need the address and the right methods to access or extract this data simply. So in order to extract this data, we have few options. So one of them in Python is Beautiful Soup. It's a library, and with the help of that library, we can easily scrap the data. But for that also, we need to have some knowledge of that, how the data is being stored and how the data is being accessed. So whenever we want to access the data, what we need to request it, right? So let's say this is web server. Okay, I'll write it here. So let's say this is a web server, or let's say this is Yahoo Finance, right? Finance.yahoo. So this is server. I want data, means I am the client. So I'll write here Kuldeep, which is a client. So now in order to access the data, I need to request it. So I will request. So that is known as the GET request, because I want the data. Or let's say in some case, if Yahoo Finance allows me to change some data, or they ask me to maintain the data, so what I can do then I can make a post request, right? In post request, we can modify the data of server if we have the right access or the privilege. But now in web scraping, mostly we deal with the GET request only. So I'll remove this post for now, and I'll talk about only GET request. So whenever we make any request, a GET request, or in general in our real life, so when we request anything from anyone, there are only two possibilities. One, the other person will grant the access. Second, they will deny the access. So let's say here, if the Kuldeep client is making a GET request to Yahoo Finance that I want some data. So now Yahoo Finance have two options. What are those options? Let's say I'll write it here, GET request from Yahoo, and Yahoo has two options, right? Whether they will grant the access or they will deny the access. If they grant, then I will be able to extract the data from Yahoo Finance, then I cannot. So if they grant the access, means I can get data. If they deny the access, means I cannot get the data. So whenever there are these kind of requests, there are some codes which tells us that this request was granted or denied. So whenever we get this response code, status code 200, it means our request is granted. If we get any other, let's say 403, 501, there are multiple codes, and for now we are not concerned with them. We just want to see that if our response code, when we made the request and in return the response code was 200, means it's all good. We are good to go. So we'll focus only on GET request. In that also we'll focus only on 200, which is a response code which tells us that your data access has been granted and you can take data from this place. Okay, now again, to get the data, we have two options. One is simply we open the browser, we enter the address of any website, and we can see the data. The other option is to access the same website from our code, right? So in code, we receive kind of codes. And so let me show you in browser, or let's say Python, right? We have two options. So when we make a request, a GET request from browser, the Yahoo Finance automatically detects that it is from a browser, so it can easily queue without any issue. But when we access from Python, it will think that it is from an automated source and I cannot give this. So it will detect that it is from Python and I will deny it. So in that case, what we will do, we will pretend that this request from Python is also coming from the browser, right? And for that, what we can do, we can pretend, right? So for that, we have to change the headers. Headers are nothing but the part of a HTML page. Let's say, let me show you. This is a HTML page. So in all websites, the data is stored in some or other form of the HTML. And in HTML, there are two parts mainly. The top part is header and the below part is body. In header, there is information about that this request is coming from which place, which kind of device, which kind of the time zone and everything, right? So it tells the server that it is coming from a browser, or it is a bot or a automated request, or from a code. And this body consists of the content. So if we make a GET request, in response, we will receive a HTML code, which also consists of header and body. And in body, will have the data simply, right? So when we make request from Python, we will just change this header to any other proxy, let's say a Chrome, or let's say a Mozilla, and then the Yahoo Finance will think that it is coming from a browser. Okay, so let me show you. It is a very practical thing. Let me show you. So now, in order to send or receive any request, we have an awesome library in Python, and that is request. So first of all, we have to import the library. So I'll just go in code editor and import request, right? And I'll run this cell. And it's working fine, means we have successfully imported the library. Now we'll make some GET requests to any random URL. So the best URL is Google, right? So I'll write URL, and here I'll declare https www.google.com, and now I'll run this and add another cell, and here I can use request.get, and here I can pass the URL. So when I run this, you will see that we have a response code 200, means it is working fine, and Google is successfully allowing us to make a GET request, right? So similarly, what happens if I change this URL to some other URL? So let's say I'll go to Google, and let me show you. So this is any random URL, and I'll quickly go and copy and paste this URL. So I'll copy it here, and I'll declare another variable. So let's say it is URL2, and here I'll pass this Amazon URL in a string. Okay. Now I'll go again here, request.get, and here I'll pass URL2, right? And when I run this, you will see that it says URL2 is not defined. And why? Because we have not run this cell. So I'll just run, and I'll come back and run this again. And now you'll see that we have a response code 503. And that is a problem, right? So because whenever we want to scrap the data, first we check the URL, if it is allowing us or not. So in this case, Amazon URL is not allowing us, right? So, and we have to resolve this issue. So first of all, let me show you a few more things. That what are other things? So we have request or content. So what I will do, I'll store these responses in some variables. So let's say it is Google response, so it will be G response, and I can make this as a response, right? And run this cell, and now G response dot content, you will see that we have a HTML page, and we know that on web almost all the websites have HTML by default, right? Whenever they make any website, there is an index.html, and there are multiple things which use always HTML, right? Now, if I check for a response.content, it is also somewhat similar, not exact same, but it is almost similar, right? Because HTML is always there for sure. Now, we also have headers. So I'll go and check gresponse.headers, and you will see that this is a dictionary. It is not clearly like visible. So for that, what we can do, I can simply, we know that we can write items in dictionary, and we can run a for loop on that. So for key value in this dictionary, and I can print that with the help of formatted string. So F, and here it will be K, and then we have V, correct? So when I run this, we can see this in a beautified response, right? The date, expires, cache control, content, and these are all this is known as metadata. On the basis of this, it decides that whether we should allow this request or not, right? Now I'll show you a few more things, that is status code. So for status code, what you can do, you can check. We have done that already actually. Status code, it is 200, and for Amazon it is 503. So to resolve this, we have the user agent. And what is user agent? So whenever we make any request, let me show you, gresponse dot request dot headers, and you will see that there is a dictionary, and here user agent is Python request, means they are able to know that the request is coming from a Python and it could be a bot. So in order to avoid that, in order to get congested the traffic, they always want to avoid these kind of requests. From browser it's okay, but from bot they always try to avoid that. So that's why we are not able to access that, right? So for that, what we can do, we can make them full, right? We can pretend that the request is coming from a browser, and for that you need to know a crucial thing, and that is your user agent, right? So currently it is Python, and if you want to change this, what you will do, you will go to Google and you ask him that what is my user agent, right? So you can just open this and search on Google that show my user agent, and you will see that you have a response, Mozilla, and you can use this as your user agent in the Python. So I'll open the Python, and what you can do, you can quickly go and declare anywhere your user agent. So I'll write here user agent, and I'll pass here, right, and run this. Now what we'll do, we know that this request library gives an option to pass an argument with the header. So what you will do, I'll just go here and copy this whole content. So here there was no header, user agent. So I'll paste it here, and here you can pass a header. So in header equals to user agent. Actually in gresponse there was no issue, so no need of this header. We had issue only in the Amazon. So I'll run this here, and it gives an error which says str object has no attribute items, because we have seen that user agent is in a dictionary. So we have to declare a dictionary, and what we did, we just declared a string. So I'll just make it a dictionary key value pair, and here I'll pass a key which is user agent and run this. Now when you go back here and run this, it runs, and now let's check the response. So a response, and it is 200. So earlier when I remove this header, it is giving me 503, and when I add this back, it is giving me response 200. Means we are able to make them feel that this request is coming from a Safari browser. So that's how we do this. This was the basic explanation of get request. So now what we will do, with the help of request and beautiful soup, we'll try to sum financial data from the websites, right? So let's do that. So now let's understand what is beautiful soup. So beautiful soup is a Python package which helps to extract or scrap data from the websites, and it creates a parse tree, right? And what is parse tree? Let me show you. Okay, let me open this, and HTML parse tree, right? And you can see here in the images that this is known as a parse tree. Let me zoom it out. If you can see here, so what is a parse tree? Parse tree is nothing but a hierarchy of any document. So first of all, we have a document, and inside that the HTML page is the root element. And we know that in HTML we have head and we have body. So we can say that the document is the parent of this root element HTML, and then these are the childrens, the head and body. Means this is parent, then HTML is the child of this document, then we have another two childs, head and body, and these head and body are the siblings, right? Then we have multiple elements, the title and text of head. Then again in the body also we have different kinds of links, we can have paragraphs, so many things.
These are basic HTML details you can like quickly see on Google, and then you'll be able to understand that. So what does Beautiful Soup do? So it will create a HTML parse tree, and we have to make use of that. Okay, let me open it again and let me show you. Okay, so first of all, we have to import the Beautiful Soup. So what I'll do, I'll go at the top and I'll write from bs4 import Beautiful Soup, correct? And I'll run this and it is imported. Now we already have two URLs, URL1 and URL2. But for the sake of this example, so I take any other website. So what you can do, we can simply open Google and here let's search Yahoo Finance. Let's open it and choose any stock. Let's open any crypto. It's been long since we have seen that. So, okay, cryptocurrencies. And here, let's say BTC USDT. So I'll click on this. So now what we'll do, we'll try to fetch this data into our Python. So I'll copy this URL from here and let's open our Python, correct? And here I'll declare a URL, that is URL3. Here I'll declare URL, that is URL3, and here I'll pass this URL and run this. Now we already imported this Beautiful Soup, so I'll create another cell and here I'll try to send a request. So request dot get, and I'll pass this URL3 and let's say what happens. We are getting a response code of 200, means it is working fine, correct? So I'll save it and let's say Y response, because Yahoo, so Y response. Now I'll check the status code again. So Y response dot status code, and it is 200, means it is working fine. So Yahoo is not blocking us for now. Now when I run Yahoo response dot content, you will see that we have the content, but it's not clearly visible, right? It's like a very messy code and we cannot fetch any useful information from this content. So for that, what we'll do, I'll just use the response text. So here what you can do, you can also use the response text here also, Y response dot text, and you will see that we have this HTML code, but it's not that useful. So now what we will do, we will try to create a soup object. So for that, I'll write Beautiful Soup, and here I'll pass the response, this one, right? So I'll go here and I'll write Y response, and you have to also mention the HTML parser, right? HTML parser, and when you run this, you will see that it says it has no length because you have to pass here content, and then you get a web page in your Python, but still it's not that beautiful. So for that, what you will do, you will write here soup, run this cell, go to next cell, and we'll try to little bit prettify it. So soup dot prettify and print this. Okay, print this, and you will see that, and you get a little bit better HTML page, which is a little bit beautified. You can see here we have a proper title, we have the meta content, then all the links, then HTML body and rest. Now if you want to print this title, this one, what you can do, you can simply go to the next line. Now what you will do, you will write soup dot title, and you will run this and you will get this title. So this is how you can print the page in a controlled manner. So first of all, you have to understand this page. So this is sg.finance.yahoo.com, and here we have BTC USDT. You can see here. So if I change from BTC to ETH, it will displays the price of Ethereum, right? And if I change from ETH to let's say XRP, it will display the prices of Ripple, correct? And if I change from XRP to BNB, it will show me the price of BNB. So we can say that only this string is changing, the symbol BNB, except that everything remains same. So now we have an idea that if we can manage this symbol,
then we'll be able to fetch any price, right? So when you go here in markets, when you click on cryptocurrencies, so there are thousands of cryptocurrencies listed, right? You can see here BTC, ETH, USDT, BNB, Sol, ST, ETH, XRP, Doge. So it's up to you that which currency you want to display. So now let's start. So I'll click on the first BTC. So what we will do, we will just analyze one cryptocurrency and then we will replicate the same process on all the other cryptocurrencies, right? So let's start with the BTC USD. So I'll click on BTC USDT and I'll right click and you have to select the inspect. So when you click on that, you will see a code in the right side and here it is the web page. So when you select this option, this hover, so when you hover, the code will be displayed. So when I click here, then I can see that it is somewhere here. So now I will navigate here. I'll go up. So means I can say that this is the section I need to analyze, right? This one. The class is this random strings, and then there is this fin streamer. So we have to extract this and let's see what happens. So I'll open my Visual Studio Code and let's start. So first of all, you have to import Pandas, of course, and NumPy as we always do, and you just hit Shift Enter, right? Now, first of all, you have to copy and paste the URL. So I'll go back and just copy this URL and I'll come back to Visual Code Studio and I'll declare a variable URL equals to. Okay, fine. Now I'll run this. Now, first of all, we try to send a request. So for the request, we have to import the library, that is import request, and we will check that whether this URL is allowing us or not. So I'll just write request dot get, means we are sending a get request. Then we have to pass the URL here, and I'll run this, and it says me 200, means we are good. We don't need the user agent. But let me show you what is this. Sometimes what happens on few URLs, you will be displayed this code like 403, 404. So in that case, you have to use the user agent. And what is user agent? You can go to your Google and just search here, show my user agent, and it will be displayed. And you have to declare this in a dictionary. So I'll quickly go here and here I'll write header. I'll pass a key value pair user agent, and this one is the user agent. So I'll run this cell. So now if you want, what you can do, I'll copy it here. Now what you can do, when you send a request, a get request, you can just pass it here, header equals to header. So what it will do, it will disguise as a browser. In reality, we are sending a request from Python, but it will disguise that I am sending a request from browser. So there are millions of user agents and you can use any one of them. And sometimes what happens, even after using the headers, you might get blocked. So in that case, you have to rotate your headers, right? So now I'll just run this and we get a response of 200. So means we are good. So I'll just declare this as R, correct? Now I'll run this again and I'll check the status code first. So R dot status code, and it is 200, so we are good. Now what we will do, we will try to fetch this HTML code. Let me show you this. When you click on view page source, you will be shown this code. So what we can do, we can import this code in our Python. So for that, what you can do, you can go into your Visual Code Studio and you just have to write r.text and let's print this, and all the HTML code will be displayed here, right? But it's not readable. So to make it readable, what you can do, you can simply call the beautiful soup, right? So this is a library, and I have discussed about this previously in last session. So for that, what you will do, you will just go here and you will write import bs4, means beautiful soup version 4, and you have to write from bs4 import beautiful soup, right? And you run this. So it's working fine. Then what you will do, you will go here and you will write beautiful soup, then r.text, means this text HTML code will be displayed here. So when you hit shift enter, it will be displayed here. And one more thing you can do, you can pass here the HTML parser, right? Now you can see that it is a little bit better, and now you can play with this code because of this beautiful soup. So what you will do, you will just declare this as a variable soup, and now let's print this with the text. And so when you run this, it will be displayed, and you can print this actually. So you can see here Bitcoin USD means it will only display the text of that page, right? No code, only text. Now if you want to print the title of the page, so for that what you can do, you will just go to your web page and you will see that what is the title of this page. So if you go here and you hover here, so you will see that it is showing Bitcoin USD price, value, news and history. So this is the title, right? So now you go back here, and so now what you will do, you will just write here title dot text, and when you run this, it will be displayed. So actually you have to remove this text, and now when you run this, only the title will be displayed here. So I think until this, it's very easy, nothing to worry. You can just practice and it will be like a smooth journey. Now the important part comes. We have to find the price and the price change. So for that, you have to go back to the web page and you have to click on inspect, and you just click here. So when you hover here, you will see that the text on right will get selected. So when you hover here and click, and now when you navigate here, go up, again go up, means this will be selecting the whole bar. Then this will select the price along with the change and along with the percentage, and this also same. Now this is the section which can display only the price, right? So what I'll do, I'll check that this name of this tag is FinStreamer and class is this random text. So what I'll do, I'll just copy this text from here, the class name, and I'll go back to Visual Studio Code, and here we'll write soup dot find. Now we have already checked that it was a FinStreamer, so I'll write here FinStreamer. Then the class was this, which I have copied, and I'll paste here. And when I run this, we can see that there is some data, and in data there is somewhere I can see BTC USD, then the value, price, right? So I just need this one, the value. So for that, what you will do, you have to write here text and run this. So now only the Bitcoin price is visible, correct? Okay, so you can just print this. Let me do that. What happens? This quote will be gone, and we have clean text with the price. So for that, what you will do, you will just assign it a variable. Let's say the price, right? Now what we need the change, that how much it has changed. So for that also you have to open the web page again. Now we need this one, right? This plus 1692. So for that also you click here and inspect element, and then you will see that there is some text selected on the right side. So you go there, and now you navigate here. So when you go up, it is selected. When you again go up, so it is not our requirement. We just need this one. So here also, this is FinStreamer and the class is this one. So I'll copy the class name and come back to Visual Studio Code, and I'll write here soup.find. Again, it was FinStreamer. So I'll write here FinStreamer. Then for class, you have to write the class, and then you have to give the value which we have copied from a web page. So now I'll run this, and we can see that we have some data, and let's check whether we have the change or not. So BTC USD symbol, then we have the value which seems like the change. So to display it correctly, I have to write again text, and we'll have the text data. And similarly, we can print this and you will get the clean data string. So now I'll assign it a variable that is change, and it will be the change in the price. Now we have the price, now we have the change, and if you want, you can also have the percentage change. So for that, what you will do, you'll go back here and you'll click here and inspect. Then it will be selected. You go here, navigate here, and you select the whole box, means this is the class, and you will copy the class name, and you will see here that it is the tag is the FinStreamer. So you go back to your Visual Studio Code, and you again write soup.find. Tag is same FinStreamer, and here in the class you have to write the class name. So I'll paste the class name, and I'll select the text only, and when I run this, it is not showing me the percentage p start 8 pix. Actually it seems that I again copied the same class. Let me go back and check again. It was this class, and it seems that p start means both have this same class name. It seems this is 8 pixel. Okay, so for this we need to have some specific data, and we can say that, so what we can do here, so whenever we have same data, so it will print only the first occurrence. So to print the second occurrence, we have to use the index number. So let's go and check how we can do. Let's hit and try and see whether this will work or not. So I'll go back here and I'll try to give the index number, let's say 0. Okay, let me remove the text first, and 0. So it says, okay, FinStreamer, p start. Do we have the percentage change here? No, here we do not have. Okay, we can use the find all instead of find only. So I think it will display all the FinStreamer tags. So you can see here that now we have 2 tags, and in the second one we have the percentage, and this is inside the list, right? So means we can use the index here, and I want the second item of the list, so I can use the index here. I'll write 1, and now we have only the percentage, right? BTC USDT, and the value is 2.73%. So I'll write text here, and we'll be having only the percentage change, and I'll write here percentage change, or let's make it PCT change, right? So now we have the price, the change, and the percentage change. So now what we can do, we can make it as a function. So for that, what I'll do, I'll copy all the data. Okay, I'll copy from here. So I'll start I'll create function. So I'll combine all the codes in single line. So first I have copied already this one. Then I'll take this request, which is R, and then I can take this soup, right? Soup line. So I'll copy this and paste it here. And again, I can copy and paste this price change and percentage change here. Now, you'll just create a function. So let's say I'll create define. You can say crypto prices, and here we can pass a symbol. So let me show you how you can do that. I'll just indent this inside the function. So I'll hit a tab, and it will be inside a function. Now what we need that whenever we pass a symbol, so it could be, let's say BTC, it could be ETH. So we want that they should be flexible, right? We should be able to change this. So for that, what we can do, I can quickly make it a formatted string, right? And now I can give here the symbol variable, right? So now if I pass a symbol here, it will be changed here. Now, and what we want the price change and percentage change of any symbol we are passing to this function. So for that, what you will do, you'll write here, let's say details, and in details you can pass a dictionary. So for that, you'll write first of all, it will be symbol. So in symbol, it will be the symbol which we have passed. So I'll write here symbol. Then you can print the price, and here you can print the price. So price. Then again, I'll pass another key value, which is change. And in change, I'll be having the change, of course. And next, and the last we have is the percentage change. So I'll give here percentage change, and the value is PCT change, right? And simply we can return this. So I'll write return and details. That's it. So let's try this. So I'll run this code, and I'll add another cell. And here what I can do, I can call this function. So let's say crypto prices, and I can pass first BTC. So let's check that, what happens. So when I run this, it will display me the BTC price change and percentage change, right? And also now if I pass here ETH, it should be able to print the price of ETH, which is fine. Like it's working like a charm. And if I pass, let's say Ripple, so it should display the price of Ripple and the percentage change. Means it is working absolutely fine. But now we have to automate this. Like for multiple currencies, we don't want to enter the prices. Let's say you want to print the price of only 5 currencies. So what you can do, you can create a list of the symbols. So we will go here and I'll write here my cryptos, and here I can pass a list and I'll open the web page, and you will see that when I go here in the market and in the cryptocurrencies, here we can select, let's say, top 5 cryptos. So it will be BTC, ETH, USDT, BNB, and Sol, right? So I'll quickly go here and I'll pass a list, and inside that we will be having the list. So the first item is BTC, second is ETH, third is XRP, and fourth you can select, let's say, BNB. You can also have Sol. It's up to you that how many currencies you want. It will be able to handle. Okay, now let's understand this also. So what I will do for the output also, I can have the data. So I can say crypto data, and I can pass an empty list here, right? So empty list, and let me run this. Okay, now what we can do, we can run a for loop on this, right? So for symbol on my crypto, and on is not in the Python, I guess, so far. So it will be in. Now what we will do, as we have the empty list, so I can append all the outputs, these outputs, to the list. So here I'll write crypto data dot append, and here I can call the function. So function is this one, crypto prices. So I'll copy and write here, correct? And then I can print that getting prices of awesome cryptos, and then I can like print here the symbols. So I'll write here symbol, and then outside of the loop we can print the whole list. So it will be this crypto list, right? The crypto data. So I'll write here. Now let's try to run this and see what happens. So we have these 5 symbols and we want to print these in one go. So I'll run this, and it says string object is not callable. So we have made some mistake somewhere, and let me check where. For symbol in my crypto, okay, dot append crypto prices and then symbol. Okay, it will be print. Why price? Print. Okay, now let's try. So getting price of BTC, ETH, XRP, BNB, Sol, and now we have the list. You can see here, and in the list we have the dictionaries. So we have the list of dictionaries, right? And you can see here the symbol BTC. We have BTC 2 times in the list. BTC, ETH, XRP. Why 2 times? See here, should happen, right? Should not happen actually. Let's run it again, and BTC, ETH. We are printing. Something is wrong here actually. Let me see what is wrong. Okay, let me run all these again. Maybe something happened, I don't know. Now let's check what happens. BTC, ETH. Okay, now it's fine. I don't know what happened, but something happened. So now we are good. We have the list of the prices and it's working fine. Okay, now let's say if you want to automate this. So for that, what you can do, there are multiple ways, but I'll tell you the simplest way, and that is a while loop, right? So, or you have also cron job. If you know the Linux or Mac OS, then we can apply a cron job, and there are multiple things. You can apply a script. So I'll tell you the simplest thing. So just for the sake of this example, do not use this in production. It will definitely harm you, this type of things. You have to work on yourself, that how you can improve your system. So let's say what I'll do here, I'll write a while true, then I'll just copy and paste this here, this whole function. Okay, while true, then what I'll do, I'll simply call this function here, fetch prices, and then I'll write here time dot sleep, and here 5 seconds. So you have to make sure that you are importing the time here, right? Import time. Then when you run this, it should work. Okay, so it says it's working fine. BTC, ETH, XRP, bin, and let's wait and check. Okay, it is not printing the prices right now. So let me check what is happening here. If I call this, it returns the crypto data. It should print actually. Okay, so what we can do, we can print this here, and let's try it again. So getting price of awesome data. Okay, it is printing now. So it's 60, 80, 20, and it will wait for 5 seconds and it will run again, right? So this is how you can automate your systems. And currently it is showing me the same price every 5 seconds. So I think it's some issue for the caching. So for that also, I'll show you in the future. But for now, this is the basic things. You can take this as a base and you can build your own systems, right?